geometry, is that what you said? I don't think
Yeah,
they weren't dealing with stuff like that.
yeah, they did. They dealt with self-symmetry, um, divine proportionality.
Come on. That's where the
Um,
pentagram comes from.
well,
Geometry, is
it's
that what you
been
said? I don't think
misrepresented. Yeah,
they weren't
pentagram, but
dealing with
it's
stuff.
just the isosceles triangle and triplicate. Um, but this is what's seen in that triplicate forms of the Pythagorean pentagram is the geometry for likewise the water molecule, which is the dipole antenna for life to exist to begin with. But the incommensurable geometry of self-similar or fractal manifestation is the proportion and ratio of the one to itself, just as light to illumination, in its attribute. And in the case for incommensurable aristos, just as in the case of polarity, indicated in many diagrams on the magnetic field, there's no place or location in a bar magnet that contains the north or south pole. So if a bar magnet were to be cut in a million times, there's no polaric run, even if you cut it a trillion times. Even down to the atomic level, you couldn't isolate the north from south pole. This polarity is the field pressure abstraction, which is incommensurable. Um,
Can't they break the charge up into thirds with like quarks and stuff?
well, I'm talking about what you would coin the north from south pole. But that point in being is that we can't philosophically or logically or rationally give definition or mark to what is without coordination. Um, Only two things can be marked, one being the unreal masses and magnitudes, which are measured and reckoned by empirical math, and the unmarkable but abductively and rationally unknown unity or principle of all, the whole. So by application of wisdom, knowing that cutting a magnet in half will not isolate either pole, rather create two new magnets, tells a lot to someone with their minds turned on. But
Kind of.
this means that polarity is a mirage with no locus. There's no
Right,
north here
keep
or
going.
south there. Rather, polarity is the expression of force to itself, which is a three-dimensional vector, and the
It's hard to
center of
respond to you,
which.
man.
Well, I'm not looking for your response. I'm trying to
I know,
explain
but
what
I'm trying to respond to you,
incommensurability is,
but you just keep
because
Well, I
going.
have a
you guys were
conversation.
trying to postulate what was so fancy about the Pythagoreans,
Well,
and
we
I'm
have a
telling you what it
conversation.
is, and you're looking for a debate where I'm not trying to have a debate. I'm just sharing something
No, I'm
with
trying to
you.
respond to what you said. That's it, man. You're still going though. But I was just saying, I forget. Oh, right, what you were saying about the dividing them up and everything. Uh, one of those like one of the halves of that charge, like the electron that has the negative charge, it can't be broken up any further. So, uh, yeah, I don't know. There is no north and south on an electron, right?
I'm just saying, dude. The whole is found complete in the parts, and the parts contain the image of the whole. This is, in short, the holographic paradigm. It's
So
it's
it's
essentially
impossible to actually that
it's essentially incommensurable
research.
nature of conjugate fields to each other, which is the secret of incommensurability. However, this explanation is abstruse and hard to understand for most, but incommensurability is the foundation of emanationism, i.e., Neoplatonism and Pythagoreanism, and as such, that it represents the true image of nature and the one, and it cannot be any surprise that magnetism follows this field incommensurability with simplex perfection without deviation. It's a mathematical fact that phi is to 1 as 1 is to phi, but
It's not true.
it is true.
One is not to phi is to one. It's not
Yes,
true.
this is why we see this within the Fibonacci sequence. It's the infinite dyad. The second one in the Fibonacci sequence
No.
refers to the extrinsic attribute of the absolute.
I know what you're meaning to
So
say is what you mean is one over phi to one is as one is to phi.
no, 1
Not
over
phi is to
phi to
one
the
is one is
power
to
of
phi.
-3, which is the infinite dyad, which is phi to the power of -3, also known as 0.23606, which is likewise, again, the second one in the Fibonacci sequence, which is likewise the infinite dyad, which is the fundamental premise of Platonic monism, which dismisses any first cause or original sin ideations of creationism.
Listen, man, I'm
Anyhow,
gonna respond. I'm responding to what you're saying, and hopefully you can we respond to each other because, like I said, what you said about 1 is phi is to 1. It's not true. Phi is equal to 1.618. Some other numbers, and so if 1 is to phi, is you have to multiply it by that number to get that. Then phi multiplied by phi does not give you 1. It gives you phi squared. Or no, it doesn't give you phi squared. It gives you 2 phi at that point. But regardless, it's not the same. Well, it's true though that 1/phi is to 1. That is, if you multiply 1/phi by phi, you'll get 1. If you multiply phi by 1, you'll get phi again. That's true. And that's also one of the knowledges that Pythagoras brought us.
So looking into all that crazy shit, all that shit that Dice depicted, right? Is it possible that they started to begin to understand the nature of the reality different, so much so that their behavior started to change?
it's basically just summed up to be all about first principles. That's whole understanding of really when you get into metaphysics is about. It's the study of first principles in and of counter space, essentially. Like these guys were, ether proponents. So
My whole thing is that yeah, it's all fascinating. Trust me, all of that shit that you said is very fascinating. But it's one thing to just read about it. And it's another to live, to be in it, right? To be the people doing the research. And what I'm saying is, this research is so fascinating, so riveting that it would alter their minds, right? Because the way they see reality would have to change, and it would have to adapt to this new information.
Oh yeah, absolutely. I think that's part of the reason why we probably have to have a better description of, like, I think Einstein's description of relativity and gravity is probably not complete. And that's because if you think about it, we're kind of we're kind of subjected to his idea of his conceptualization of it, and it's like none of us had the novel uh, thought of it, so we have to use his description of it, and it could be possible that through his mad mind that thought of that stuff, there's just it's just not the exact correct way of looking at it, perhaps.
Bro, you just hit a key point in all this, right? A very important thing in these conversations, right? That we're doing is trying to describe reality with somebody else's, like, with somebody else's framework, right? Which is also very limiting because it might not actually match reality. So maybe it is upon us to come up with some sort of system or better way, right? Because who else could do
Yeah,
it?
but that's the reason we're stuck with it. That's the reason why, even though it bothers us, we're stuck with it, is because it does match reality, and because it matches reality, and it was his crazy novel idea. We have no choice but to try to wrap the rest wrap the universe around that model, and it seems to work for the most part. And yeah, if it didn't do that, if his crazy idea was actually incompatible with everything else and observation, then we would just discard it. But it seems to be compatible with most things.
But are you saying that those systems and things that he observed? Are you correlating that with the way the world works, like like how supposedly we're moving and around the? Are you trying to correlate that to that?
Right, to all the observations, all the tests, people trying to disprove him, tests to go against both those theories. Yeah, all our observations regarding any of that stuff it seems to corroborate his description.
Dude, dude, that could, bro. How could it when we have a system? Like it's like some sort of clock or something. Like the stars do the same thing all the time, right? So I don't understand. How is it that we're constantly moving from multiple sets of stars, but we somehow have like, come on, bro, it doesn't make any sense. You saying it works, right? But it doesn't work, bro. Like
Yeah, but that's
if you put it out on paper, it might sound good, but in reality, it doesn't match up to what we're supposed to be experiencing.
that, that's my point, though, is exactly what you just said about the clockwork and all that kind of stuff. Those were the two first proofs that were used to substantiate his general theory. Because just like you said, it works like clockwork. You should be able to predict when Mercury's gonna, how it's gonna orbit the sun, and the same way you should be able to predict, knowing where the stars always are in the sky. You should be able to predict which ones the sun is going to be behind during an eclipse. And yeah, both those descriptions were actually better explained through Einstein's theory than any other theory of the sky, that being a clock or anything. So
You don't need any
his
theory. You don't need any theories for that. That you're saying Einstein proves the reification story of a galaxy and all that far, far away. You don't need any of that. In terms of the sky clock, what you just mentioned, like the eclipses, position of Mercury, those are all cyclical in nature. Their frequency isn't cyclical. You don't need any Einstein at all to understand, the positions and movements of the eclipses and the positions of the celestial objects.
That's my point. Is that you're right to a certain extent. That most of the sky is like clockwork, and which we can predict what's going to be regularly. However, there are things that were not explained by any other theory and couldn't be predicted by anybody until he came up with that theory, in which it did predict this thing that doesn't go like clockwork, like Mercury. Like you can't predict what it's going to do because it's behaving differently than it's supposed to, because it's going so fast. It's like special relativity, or maybe it's the gravitational relativity. But either way, and same with the gravitational lensing. Like all the stars, it moves like clockwork. They're all supposed to be in the correct position in relationship to each other. So it shouldn't be the case that the sun is going to, warp.
Yeah, there is no warping.
Doesn't that Mercury story debunk that whole every like planet having like a weird orbit and we go for like? Doesn't that story just debunk that whole thing if it's unpredictable?
No, it's not. It's not unpredictable. It's just that the same equations that were used to find Neptune, for instance, and like all the planets, they're moving based on Newton's theory. And so, using Newton's theory, you can predict all of their movement, but you can't use it to predict Mercury's orbits and its future positions.
What's the ladder? Do you have the other object doing the opposite? The control, you gotta have the control, the opposite. You gotta have white, you gotta have black to demonstrate the show.
White and black what? I'm not just
Yeah, but even if we all were to say Einstein was wrong, because let's say we found out later in the future he's wrong, it's still not, it's still justifiable for everybody. It's still justifiable that everybody agrees with his explanation of it, because his description of it is better than anybody else's so far. Nobody else can make predictions more accurately than his.
You mean reality? You mean just look outside and don't make anything up? Then you can outdo that? You're telling me you can go in a lab and outdo physics? Not making up stories.
That's not what I'm telling you.
You can't. Oh, okay.
I'm telling you that when you leave work tonight, Demak, there's no way of you knowing exactly what you're going to see when you open the door to leave wherever you are, right? There's no way of you knowing that. But if you were to predict exactly the scene that was going to be happening out there, like the color of the cars, the you know, interactions between people, whatever. You were to predict that, I would say that you had some sort of knowledge that must
I'm
be.
not predicting anything. I wouldn't predict anything. I just see what happens, and I'd say, "Look what happened, Coach O," and we can go from there.
Yeah, I know, but in this case, he made the predictions beforehand, and they came true.
Why are you predicting it? Who are you predicting it for? Why are you saying one thing over 100 million things that could possibly happen that you couldn't fathom as a human if you don't have the comprehension of it yet? Why are you picking one thing? That seems pretty weird to me when it could be a million different shapes or sizes of things. But you guys pick one. Why is that? How can that be?
Well, because we're not supernatural in nature, at least not most of us. When someone makes predictions,
The
novel
sphere is
predictions,
supernatural.
when someone's capable of making correct novel predictions, we actually hold that as high regard, and it's important to take a closer look into how they did that.
A sphere is the only shape you don't see in nature. It's supernatural. You only see it in a bubble of electricity leaving the
I see
water.
spheres. Yeah, I see spheres in nature.
So, Kosha, what are these things that you think is predicted? Like you're talking about the sky, like the position of Mercury or whatever it may be. What are these things that you think that Einsteinian whatever does that in some special way? What is that in particular? And what equipment are you using? Like, are you just proving the thing that someone made up, or is it actually doing anything in reality in terms of the position of the lights?
I heard a cricket.
Sorry, I'm in the middle of doing something. But you said what?
Yeah, we can look at the positions of these objects and we can view their position. So well, I was asking, what do you think Einstein's relativity did that actually predicted something that you think is mind-blowing or groundbreaking that actually is different than what we observe?
Well, I told you the precession of Mercury. That's one, and the other one was these are the first two examples, but the second one was um,
What's the
the
experiment
stars.
did?
The stars. Hold on, Democ. The stars that were meant to be out of position in relationship to the stars near them during the eclipse in 1919.
You're cutting out.
Yeah, it doesn't sound very interesting anyway.
No, I said the precession. I mean, the precession of Mercury was the first one.
All right, let's start there.
That wasn't.
What is that? What is the precession of Mercury?
Well,
Retrograde?
no, the predictions of
Yeah,
the predictions of its movement in the sky over. I forget how the errors that Newton gave you. I think it was like 3 arc seconds off after like I don't know a long time, a million orbits or something. I don't know how many orbits it was. Very long time. His and Kepler's mechanics, they actually give you they don't give you the observation of where Mercury actually is, so you can't use it to accurately predict where Mercury's going to be. But Newton's idea when he
I don't get why you would need
A
that.
Newtonian
Mercury
mechanic.
moves in a cycle. It's like a frequency. So why do you need to predict it? That's just like the hands of the clock move in a way. You could predict it's going to be 12 noon, 6 hours later or whatever. It doesn't mean you're predicting it. So what are you talking about?
well, no, not quite. You can't predict. For instance, like I think what you're saying is like you can predict how often the moon's gonna intersect the ecliptic and all that kind of stuff and the orbital node. But that's not the same thing as knowing exactly how far the moon's going to be, what parts of the Earth's going to be covered up. Same thing with Mercury.
So
You
these
might
are
be
the
able to.
reifications I was referring to. These are reifications.
Yeah, but the transits of Mercury across the sun were not able to be predicted. Just like the
Where's the
ones for
Mercury
Mercury, the
experiment?
ones for Venus.
it moves in a regular cycle. It does its retrogrades regularly. It makes its 88-day cycle. These are regular cycles. So I'm still
Yeah,
not sure what you're talking about.
the transiting the sun though.
It's a
Transiting the sun.
conjunction. There's a point at which the sun conjoins Mercury in terms of their celestial positions. That
Right, and
also is regular and on a cycle.
yeah. Well, I mean, you weren't able to predict when it was. I mean, the predictions were always off.
It's not hard to. What prediction was off? That's what I'm getting at. What are you talking about?
Uh,
The
I
cycle.
told you that.
That's like knowing if the hands of the clock make one full cycle every 12 hours. You can extrapolate that in far into the future and the far in the past as you want. So Mercury makes its cycles, and it will conjoin the sun, and it will separate. It will apply to the sun. It will conjoin the sun, and then it will separate from the sun in its celestial position. So that can be known, and you could call it prediction if you want into the past and future. So I'm still not understanding what you're getting at in terms of what you're claiming to have predicted with relativity.
Yeah, but I'm not sure if I know the transit of Venus.
Where did you see a Newtonian physics happen in a lab?
What?
I don't know.
Where are
Just
the
try to
Newtonian
just
physics
respond.
in a lab?
My point is, Coach,
Physics
is that what they've
material.
done, they claim that Mercury is a ball and a sphere, and then they claim that's the reification. And then they're claiming that there's, gravity lensing and all this stuff that they're adding in, and then claiming that they're proving that with their theories. But in reality, they're not proving anything because the position of the celestial objects is just as we observe them, and they're in cycles.
Well,
Like they'll make claims like, oh, when there's a conjunction, there's a gravity wave that warps and bends, and we predict that. But it's like that's literally just a massive reification built upon something that isn't even built in reality, and then using a fabricated theory to try to prove or predict the fabricated concept of the gravitational wave in the first place.
hold on one sec.
Coach, are you Googling?
Or just give me one sec.
Unless
No,
Newton was
I'm
God.
busy. I'm busy. I'm busy. I was looking at something a second ago. I'll tell you what I saw, but just give me.
Unless Newton was God, they're not Newtonian physics. That doesn't even make any sense. Do you comprehend that sentence?
It's like the entire heliocentric model is like the biggest begging the question plus reification fallacy known to man. They created an entire universe based upon that. And a simulation of a model, which is simulated on the sky, but isn't necessarily linked to the reality of the sky.
All right, I'm sorry, Mr. Geo. Remind me wherever you said we're talking about the precession, transits, precession. Um, yeah, I think that you're right about the regular transits. Okay, because I guess what would probably make more sense would it's not really something that it was something only predicted that was only predicted by Newton's description of what's happening. So using Newton's description of gravity, the precession of Mercury was not predictable, as it is with Einstein's though. Einstein's gets it exactly correct, where Newton's gets it off by I forget what the number of years. It's like a shit ton of years, like three arc seconds or something like that.
Well, but I could tell you, like, I could tell you every point into the past, present, and future of when Mercury will conjoin the sun based upon its cycle. Now, obviously, I mean, you know, if you're talking about 10,000 years ago, if we're not alive then, it'd be hard to verify that and so on. But I'm saying in terms of the cycle, or I could go forward in time right now and tell you when the next conjunction will be. So those are like gears on a clock, like they're cyclical. So why do you need Einstein or Newton or any of those guys to describe those cycles like that?
Well, it's because if you use Newton's and Kepler's and you use any of the other orbiting bodies, like let's say Mars, and you do a two-body prob with Mars, but then you also do the undulations that would happen from the other masses acting on Mars, you can, predict its, how its orbit is going to
There is no orbit.
precess in the future. Whereas Mercury's was the only orbit where using Newton's description would give you a value that wasn't the same as the value that we have
It's
observed.
called recording, not predicting.
Well,
It's
the
called
reporting
saying,
it,
"Oh, look,
them
that happened."
reporting it showed that Newton's was wrong.
Recording. No, you're looking. Newton didn't. What Newton? Newton's not God, buddy. There are no Newton physics. That doesn't even make any sense. How could that possibly make sense to you?
Well, Newton
All he
did have a
does is looks
description.
up. So if
He
we
did
look
have a
at a duck,
description.
if we look at a duck, we see what a duck does. Really
Yeah,
cool.
but he
So
did
what
have
are
a
those duck
description of.
Newtonian duck physics now? Because we saw a duck swim. That doesn't make any sense, dude.
I agree with you. That didn't make much sense at all. But I don't remember where we were now. Oh, right, yeah. No, Newton's idea of gravity worked very well. He did have a description for it and an equation for it. It worked with all the other relationships with all the other planets. Uh, that's what I'm saying. It didn't. It was missing something in the case of Mercury. It wasn't able to predict the precession exactly correct. I agree, though. You're right, though, Gio. You could probably look back the 10,000 years or so and see that the
Predict something today, right now. We can all see live happen right now. Me and you, right now. You do it with this same math. Do it right now. Something that's never happened before in the history of time. Predict it, and let's all watch it happen tomorrow. I'll wait.
I did that with the ISS.
Well, I still don't even get what you mean by a prediction of a precession. You're just talking because I mean Mercury's on a cycle. It's like a gear in a
Yeah,
clock.
I know, but that's why I'm trying to make a distinction. It's not exactly that it's not exactly that it's a prediction in itself that was like predicting something new or novel. It's just that the description that Newton gave of gravity was, was matching what was happening in space with the other planets.
Right. So they're taking positions of celestial objects and then applying a theory to it and then claiming that they're predicting something based within their reified theory.
Okay, sorry, I'm in the middle of this. No, I'm not. Okay, what I'm saying is it's not trying to make a prediction that's completely, going to predict something brand new is going to happen. It's trying to explain the observations that we see. So that's what I'm saying. Is like you can completely dissect what's happening in the sky with the other planets using Newton's theory, Newton's equation, right? It just doesn't explain that thing. I'm not trying to say that they predicted something that, because they already knew the observation, so that was the problem. Their observations did match what his description was saying.
So if they were blind, could they predict the same Newtonian physics? If Newton was blind and you gave him some math, he knew how to do the math, you taught him Braille, could he make the same predictions on planets that he's never seen? Would that happen? I don't think so.
Hey, DeMarc, are you allowed to smoke weed at work? Most of my jobs I actually was allowed to.
Are you suggesting he needs to be high or not high?
No, I'm suggesting that he is high and that he is at work. That's what I'm suggesting. That's not important.
Rational deduction.
Regardless, though, yeah, G, I just want to make it clear because I see why they're like. I guess I use prediction, and in the case of the Eddington eclipse, that was a prediction. However, with the precession of Mercury, that's more of like a mathematical description that explains what's happening. So they would have already known the precession that they need to be looking out for. You know, that wouldn't need to be predicted. But it's just saying his equation fits what we observe. Because actually, I was reading. I thought that there was something about the transit also, but I guess not, because who was it? Who's that famous astronomer? No, maybe not. There's some dude who predicted both the transits of Mercury and Venus. So
Yeah, I just don't really see what there's anything being predicted. I mean, since way before Newton ever existed, if he even existed, and definitely way before Einstein existed, since the dawn of time, humans have used the celestial clock for all kinds of different purposes to understand astrologically what's going on, the correlations to human events, all of these particularities. And so the cycles of these things are well known in terms of the clockwork. So if Newton came along and came up with theories, why does that matter? Like at the end of the day, why is that? Now I understand that the idea, that these are spheres and they're in a vacuum and all this stuff. If you're going to reify an entire model and then start using theories to reify that model or to back that model, but that would sort of be like if I came up with a theory that said, that, invisible fairies are pushing the hands around the face of the clock. And then I said, the wingspan of the fairies is 4 inches by 2 inches, started coming up with all of these theories. And I say, I can predict the movement of the hands on the clock because I can say that the two fairies' wings are the right size, that they're going to move the thing around at that speed. But it's like, at the end of the day, you could just say, no, dude, I can see the clock. It's moving the way it is. Like, I don't really need your theories about fairies to explain it.
yeah, but that's not the nature of his predictions. His predictions aren't being used to show exactly what we already knew we would see. His equations and descriptions were literally used to explain what we were seeing. Like we had an explanation. We had an explanation.
It's a matter of precision.
I know. What's the thing you're seeing? The position of the object?
The position of the objects, the relationship to each other. Yeah. This
Mathematical descriptions are not explanations.
They're not mathematical descriptions.
You already
they're
said it
actual
yourself. You said it yourself 5 minutes ago.
I'm telling you actual descriptions of what's happening, like giving a description
Right,
of the interactions
descriptions
that
are
are
not
going on.
explanations.
That's compelling these things to do that.
No,
One second.
that's not at all accurate.
The cycles that you mentioned, like they're not straightforward. They're quite complicated. And
Yeah, it's
just
always so
figuring out
complicated
how
or
often
so
things happen.
delicate.
Just figuring out how often things happen. I don't think that's precise enough.
They're actually
For
not really
example,
that complicated. I mean, they all move. If we're talking about the quote unquote planets or the wandering stars, Mercury, Venus, Mars, etc., they all move between the tropics in declination, meaning when we're on the ground, we look up, the declination changes from the Tropic of Cancer to the equator, the Tropic of Capricorn. Their speed is in a particular cyclical speed, and the rate at which they go between the tropics is unique. And then also they have unique retrograde cycles. I'm not saying it's simple. It is somewhat complicated, but it's actually fairly straightforward. Like they progress
I
through the
understand
zodiac in position of the fixed stars at a certain rate. That's the same rate by which they go between the tropics, and then they all have their own unique retrograde cycle.
right, but just knowing the cycle, does that give you the same precision as a modeling as a heliocentric model?
You don't need the heliocentric model for anything. That's why it's the new guy in town. It's a new fandangled thing that nobody
not what I
has
asked.
ever needed ever to understand the
That's
sky.
not what I asked. I asked if you just using those cycles, if you can predict their position with the same accuracy that heliocentric model can.
Yes, even more so, because the heliocentric model, I just said, it's not needed for anything. I can predict them precisely upon their retrograde cyclical nature and the speed at which they move between the tropics and the speed by which they progress in relation to the fixed stars. You don't need the heliocentric model for anything at all.
Can you demonstrate that?
I could tell you the cyclical process of each of them, and
I understand. We're talking about matter of precision, so I think some examples would be useful if you're saying that those cycles can make more precise predictions than heliocentric model.
I'm not even. What I'm saying is, you don't need to compare it to that. They're like gears of a clock. They move in their own unique ways. You don't need heliocentrism for anything.
Well, that's what you're saying. I would like to see if that's actually the case. For example, just take eclipses. For like we know a cycle of like an amount of days that they repeat. They don't repeat
No, you
the same at the
No,
same.
you don't.
They don't.
You
They
can't
don't
produce
repeat.
it in a lab. You cannot produce any eclipse in a lab to scale actual
What are you talking about?
measurement. Millimeters.
It's just besides the point. Let me just finish.
Like nobody else is doing that.
Yeah, so if
What?
you can't when a solar eclipse happens, there's a certain amount of days in which a similar eclipse is going to happen, right? That's a cycle, but that doesn't tell you where it's going to happen, and it's not exactly the same eclipse. It's going to be a little different.
Take a look at my screen.
That's the precision. Okay,
Bacon.
that's what I'm saying. Knowing cycles.
All right. Do you want to?
Okay, I'm joining. 1 second.
Yeah, I'm sharing my screen. This is a software called SolarFire. It's used in astrological work, but essentially it has all of the cyclical natures within the chart. So I can animate this thing day by day, just like this. I can animate it day by day, hour by hour, minute by minute. And the positions of all of these luminaries, these wandering stars, are all in their cyclical nature. Up in the upper left at about the 10, 11 o'clock position, that's the south node. 180 degrees from that's the north node. Those are the nodes of the moon. And eclipses will occur if a full moon or a new moon aligns on those nodes. And then we've got the moon, Pluto, Saturn, Neptune, etc. These are all in cycles. They're in cyclical. So yes, this can be predicted. And this is a geocentric layout of a chart. The outer rim is the fixed star constellations. So Sagittarius, Scorpio, etc. So it's obviously just put into a pictorial here, so it's not the actual stars, but those are the constellations. Each of the wandering stars is amongst the backdrop of those constellations. So like Saturn, let's say, is in Aquarius right now. So that would be in Aquarius, the 25 degrees, 10 minutes in Aquarius. And yeah, they're like gears in a clock. They all move differently at their different paces, but I can move this through day by day, hour by hour, whatever you may need. They continue making their geometric alignments with each other. And you can go into the past, present, and future. You don't need heliocentrism at all in any way, shape, or form to understand how the gears of this work.
Okay, so those are all those symbols. They move in a constant speed around the center of the circles. Is that how it
No,
happens?
here,
Because
now I have it going fast. No, they're all
yeah,
moving
I
at
can see
different
Leo,
rates.
for example. Yeah, I mean they're going back and forth, right? They're not making like a very predictable motion. Like how can I replicate this and then predict where eclipses are going to happen, for example, and where? So you said there when those two symbols are opposite, or is that the
Yeah,
case? When
I just happened to stop it on an eclipse, or at least close to one here. See over here on the about the 3 o'clock position, there's the circle with the dot in the middle. That's the sun. The one above it is the north node, and then the moon. So that's a new moon on the nodes. Like I said, these nodes at the 9 o'clock position and the 3 o'clock, the little looks like a horseshoe and an upside down horseshoe. Those are the lunar nodes. So anytime a new moon or a full moon, this is a new moon because the sun and the moon are conjoining each other. Whenever those line up on those nodes, there's going to be an eclipse, and it's going to be a partial or a total eclipse depending on how tight degree-wise. See, all these are the degrees. So this is at 0 degrees. Taurus is the sun. 4 degrees currently is the north node, and then 11 degrees is the moon in this case. So this looks like an eclipse.
I'm curious on why some of those symbols like they retrograde, right, during the motion around the circle. Like the circle alone isn't telling me when they're going to retrograde. I'm trying to understand how I could replicate this diagram and get to the same eclipses prediction that I can with heliocentrism.
You don't need heliocentrism. That's the thing, dude. Okay,
I'm not saying that.
Each of these 12 on the outer rim, each of those 12, the signs, as it were, those are the star constellations. So let's just say Aquarius right here. So if we looked up in the sky, you can see the constellation of Aquarius. And if you split the sky into these 12 sections, you can get these 12 signs, and then they're 30 degrees each. So that's just a way of measuring where they are in the grand circle. If you put this thing over an AE map, like if you literally took this thing and put it over an AE map, then you could say the North Pole's in the middle. You have all the continents going out. Now, the only thing is that this wouldn't be showing the position between the tropics and all that. Like it's not showing that vector, but it is showing their geometric relationships in their circle. So yes, they do move in their retrograde cycles. As it progresses forward, see if I move this thing forward, see how the moon is going counterclockwise? It's because the moon's going slower than the fixed stars. Therefore, it's going counterclockwise. When these things go retrograde, they pick up speed and they go faster than the fixed stars. So all they're doing when they're going retrograde is they're just picking up speed and going faster than the fixed stars. And then they go back to going slower than the fixed stars, which means they're progressing. It's called direct motion, which is a counterclockwise motion if you're looking at it.
Okay, so how isn't this just a plotting of what's going on in the sky? Because how those symbols are behaving are not very predictable. So this doesn't seem to be an actual model. This seems to be
they're precisely predictable because they're all like gears of a clock. They're not just randomly moving around.
Yeah, I heard that, but I'm trying to see how I would be able to predict it because I see some symbols retrograding, and it's not clear to me when they should do so. Right?
They retrograde in their own cyclical nature as well. But I could put right now we're in January 7th, 2023. I could go to any year you want in the past, present, or future. So if you want to talk about a prediction, I can skim through this and we can say, okay, Mars will be conjoining Mercury in whatever year it may be. You can predict it if you want to call that a prediction, but it's just gears of a clock.
I don't doubt that. But the thing is, the fact that this is being plotted in the circle and then you can go back and forth in time and see where things are going to happen isn't telling me how it's doing that. It's just plotting it at some different moments of time. It doesn't tell me anything about how it works.
But that's what we observe. There is no way to know how it works other than observing it, because unless you can go up in the sky and take measurements or open up the control panel behind the sky and try to look at what's going on, all we can do is observe the positions of these things. And this chart shows the positions. Heliocentrism uses. Okay, you're interrupting. If you need to speak, go ahead.
That's because you misunderstood me. I wasn't talking about how the sky works. I was talking about how this tool works. Like this isn't telling me how this tool works. That's what I'm interested in knowing. That's what I meant.
How the what works?
This tool, this software.
Oh, tool. Okay, I couldn't understand that word.
That's fine.
Well, there's something
So-
called an ephemeris. An ephemeris is a book. It's a thick book that is essentially shows the position of each of these celestial objects in their position in the zodiac. So if you were to look up an ephemeris and just pull open some random day, like let's say this day right here, let's see, Mercury, it's in retrograde. Here, I'll actually go to the chart, today's chart, because Mercury is also.
I know, Jim, but I think Bacon's saying what I was saying, that I agree that the observations can be made. When you say, "Oh, this is happening on this day," the sun goes up, it comes up, goes down, it comes up the next day. What I'm saying though is that the description, that's what was so. One of the reason why we revere Newton's explanations, because his explanation gave his description gave an explanation for what was happening, and that explanation also matched why things were falling on Earth. He was able to tie those two things together.
Right, but it's a
And it
reification because, well, what I was going to say before, an ephemeris, let me finish that. An ephemeris just shows the degree of each position of these celestial objects. So all I was saying is that this software is just a visual representation of an ephemeris. Was my only point. So the data from this comes from an ephemeris, and an ephemeris is from thousands of years of mapping and watching how these things move and their cycles. So the cycles are well known. In terms of Newton predicting, but that's no different. Like, okay, what we actually observe is the positions of them, and then we can put them in a pictorial graph like this. But you could come up with any explanation for it. Like I could say that it's, purple fairies, and the fairies, like I said before, they all have different wing sizes. And so the fairies that are pushing Mercury have a smaller wings than the ones that's pushing Pluto, but just because you could come up with an entire model like that and say that it quote unquote represents what we observe doesn't mean that model you've made up is actually the cause of what we observe.
Yeah, but
I know.
the case of
Go ahead.
fairies, right? So you can just pick up, you come up with that explanation that fairies are doing that, and then try to use that to get when's the next solar eclipse going to happen using this explanation that fairies are doing this.
Yeah, because I could say that the fairies have different size wings and they push these things in different ways. And then the fairies also have retrograde cycles where they get really excited and they start pushing these things faster than they normally go. So it pushes them into retrograde, and then they kind of slow down a little bit and they go back into their normal mode. And then I could use that whole prediction with the sizes of their wings and their retrograde, propensities to then create a model by which I could predict, quote unquote, when the eclipses are going to happen. It doesn't mean the fairies doing that.
If you turn that into a model, I don't think the fairies are going to play any role in that. I mean, if you're just saying that's what the fairies are doing, but you can describe the motion of the celestial bodies precisely, the description of how they are moving is your model, not the fairies. The fairies is just something you're saying, but it's not actually there doing anything. Okay, go on.
No, I was just gonna say that the big difference is that it's obvious. It's obvious that the Saros cycle. We all know the Saros cycle, and so if you could sit in a classroom and mathematically predict the next eclipse using the Saros cycle, and that's a given. But what we're saying here is that this is a different explanation that is not using that. So I did a similar prediction with the ISS. Like I know the ISS paths are marked online and stuff like that, but I use a different method, just looking at the current position and then looking at the Great Circle Bout and then Coriolis. I was able to predict where it's going to be, even though that prediction is already out there. So it's just saying, like, using, of course, those cyclical predictions are already existing, but that's not what was being used to predict their movement.
Hold on. So let me get this straight. Somebody already recorded reality, and then you said, okay, I see what you recorded. That works great. I have to, for some reason, make up something else that says the same thing. So what's that help you do?
You can record reality and still not explain. It doesn't explain what's happening. And then you can try to create a model, and then Democ,
that's what you're doing right
now. That's not the answer. That's not the complete answer. That's not the complete answer yet, Democ. So it's frustrating because I got to start over what I was saying. But what was this? Oh yeah, right. When you fuck, Democ. What was wrong with what I said, Democ, real quick?
Well, just getting back to the main thing, what do you need heliocentrism for to quote unquote predict the positions of these gears in the sky, these positions?
Yeah, but that's my point, though. It's one thing to predict what's going to happen based on recording what happened in the past and seeing that it kind of repeats itself. But it's another thing to create a model for why that happens and then make predictions based on that model and see that those predictions from that model match exactly the observations you've always known.
You don't have a
that
model. You don't have any model. There's no such thing. You saying the word model does not make that material, and it doesn't make any sense. So if I want to say, just like Geo was saying, tooth fairies are doing it, so is your model right or my tooth fairy model right? Who's right?
Yeah, well,
What I think's
yeah,
right is what happened in the first place, which was reality. If we went and didn't know anything and we just recorded what happened and we said this should happen again, and lo and behold it does, and look, it happens and it happens, I don't think you need any tooth fairy stories. I think you're
I
doing
get your
just
point,
fine.
man. I
You,
get your
you do
point,
if you
man.
want
But
to
that's
know where that's gonna happen.
go ahead.
But all you need to know is the cycles. Like if you know that the hour hand makes one cycle every 60 minutes, you could claim that you're predicting it, that 60 minutes later, I know exactly that the hour hand of the clock is going to be in that position. I wouldn't really call that a prediction. Maybe a post-diction. It's not a prediction. It's just being
Yeah, but
aware.
if you
Just being
I like
aware
this-
of how it's moving, and then in 60 minutes, it's going to be all the way around the clock. Just like with
Right.
Mercury, like Mercury's retrograde right now.
Right.
Which is a 3-week cycle that we're in right now. Does that mean that somebody predicted that Mercury was going to go retrograde? No, we knew it was going to happen because of its cyclical nature, and indeed it went retrograde.
Before you jump in, Red Cloud, I was just
correct.
go ahead, man. I was
Thank
going to
you.
say
I
one.
appreciate it. Yeah, someone correct me if I'm wrong, but doesn't. Yeah, we can use models to predict things. We can use cyclical calculations to predict things, which they've done for years and years. So the conceptual question is, why do we need the heliocentric model? Someone correct me if I'm wrong, but the heliocentric model, or the study thereof, seeks to explain why the things happen, not just that they happen. And I'll give you the example of the clock. So the clock goes, the hour hand goes round, but the minute hand goes faster. But if you know the workings of the clock, that's the difference between one and the other. So just seeing the things
disagree
in the
with you.
sky, and then, but not understanding it, and seeing the hands on the
I
clock, but not
disagree with you.
understanding
It's
it,
funny.
and then
It's
pulling
funny.
apart, and then I'm sorry, I'll be almost done, and then pulling apart the clock and finding out why the hour hand and the minute hand go at the different speeds.
I was going to say that's
Because
exactly
of a
what
motor.
I was about to give that
Because of
exact
a
same.
physical motor.
uh,
Hold on. That's
description.
not true at all. That's not true at all. They work because of a physical motor. And saying geo and ball and all that doesn't tell you how anything works. It doesn't tell you how it
Right.
works. When the same people that you're speaking of, right, didn't understand electricity, they didn't understand fields, they didn't understand magnetism, they didn't understand certain frequencies.
Yeah, they did a great
So how
job.
could they? Huh?
Yeah, they
Newton,
did amazing.
Newton knew
Considering
about
they did.
magnetism and electricity.
No, he didn't.
What
But that
experiments did Newton do?
No.
Magnetism and electricity.
I'm agreeing with you, man.
So
I'm
if you
agreeing
don't
with
know
you.
about magnetism and electricity, what everything are made of, and
I'm
how they
agreeing with you.
work, high to low and hot to cold, how could you ever go from there and say anything? That would be absurd.
I'm agreeing with you. I'm agreeing. They didn't know much
I'm
about
honestly.
anything, but they managed to be able to predict the motions of the stars and planets. I agree with you.
No, they didn't. They watched them. They watched them happen, like me watching a movie and then writing an essay on what I saw in the movie. That's not a prediction. Stop saying that word.
Okay, but this
So
is
Hugh, are you
recording.
suggesting that the heliocentric model, like we're talking about the way that these move, these cyclical natures of these wandering luminaries and how they align and their retrograde cycles and so on, are you claiming that heliocentrism is akin to going up in the sky, opening the control panel, looking behind the control panel, and getting some kind of godlike understanding of how it's working? Is that what you're claiming it is?
I wouldn't disparage it by saying it's godlike. It's just observation. If observation may be godlike, but you're just looking at things.
A rainbow.
Yeah, and you're trying to. So how does a rainbow? In the past, you didn't know what caused a rainbow. Now we know what causes a rainbow. In the past, we didn't know what caused a bunch of things. Right? Rain. They didn't even know what caused rain. Well, now we know what causes rain.
Well, what's
et cetera,
water?
et cetera.
Hold on. Let me make a
back to
point.
the planets, the wandering stars and the planets. As you guys call them, planets. What we observe is simply what we observe. The declination between, let's say, Mercury. Mercury moves between the Tropic of Cancer, the equator, Tropic of Capricorn, and throughout that, it will change its declination as it moves between them. It also has its cycle of how how long it takes because it's moving slower than the fixed star. So how many days it takes for it to get all the way around back to, let's say, starting at 1 degree of Aries, how long does it take to get all the way one whole 360-degree circle back to Aries? That's what they call the orbit in the heliocentric model.
Right.
And then they all have their retrograde cycle. Hold on, let me just finish. So what I'm saying is that that's what we actually observe. We look up in the sky, we see those positions. And we don't know exactly why they're doing what they do because they're up in the sky. We can't get up there and tangibly, get a sample or go up there and do anything. We can just see them from here. So at what point those heliocentric theories of orbits and or claims that there's spheres out there actually help in any way us to understand this anything further other than that just being a reified model and an assertion?
I can answer.
It's way worse than that. It's way worse than that. Their model is this. Hold on, I'll make this so quick. Okay, so their model is they're saying they predicted, okay? That's like their model and their gravity and all that's predicting the second hand and the minute hand, okay? But the hour hand's all fucked. The hour hand's fucked up by 95%. Okay, so just because their model, they're acting like they can predict shit. They can't predict the heavens. Their shit's off by fucking getting to 120th. So they can predict the minute hand and the second hand, but they can't predict the hour hand. Their shit don't work.
It works. All right, hey, Brian, it works just fine because if the stars and the planets move and they're very, very predictable, then
no, they're not.
What about?
Where's your globe clock?
Dude,
no, you got galaxies.
You just said they were predictable, and now you're saying they're not.
No, they're not.
Well, I would call it more of like a post-diction. It's not necessarily a prediction. If anything, it's a post-diction. Like I said, there's a book called The Ephemeris. An ephemeris is a book that literally just lists, it's just data, just numbers. It lists the position. So let's say Mercury. On any date you want to look at, it'll tell you Mercury and every, minute by minute, hour by hour, the position of Mercury. So like right now, Mercury is at, it's retrograde and it's at 0 degrees Gemini, 35 minutes. I have it pulled up right now on the chart. 0 degrees in Gemini. So 0 degrees, 35 minutes. So it's right at the beginning of Gemini. It's only half a degree, 35 minutes. There's 60 minutes in each degree, 30 degrees in each sign, and then there's 12 signs total. So Mercury is 0 degrees of Gemini, and it's retrograde. That's in the ephemeris. And we could look next year in the ephemeris, next year, and we could look the years before. So it's not really a prediction. It's, if anything, it's a post-diction. It's just understanding the cycle and how the timing and the cyclical nature, and then just putting that into the past, present, and future.
Real quick, I wanted to put a bookend on what I was saying before, because the last thing I'm going to say about it. But it was along with what Red Cloud was. He actually said the same thing I was about to say, but I was about to tell you that with the clock, you can use that same analogy as the clock, and let's pretend like we don't know how it works. Of course, we know how clocks work. We know how the watch works. But if you don't know how it works, if people are coming up with different ideas, like, oh, there's fairies' hands moving them around in there, that's one thing. But if someone were to show you gears moving these hands in a small model, working the same way that the clock works up there, that gives you that gives it the strength that shows you that it works in one
small model.
It works in reality. Like you can make it work.
You don't have a model in reality. You don't have physics. Material physics is what you need to demonstrate. You need to demonstrate a heat source 93 million millimeters away from an Earth that's 24,000 millimeters in circumference, and you in a lab or outside or wherever you can do that, right, in a scientific setting, and show us how this heat source and this globe do exactly what you just claimed for timing. Just those two, please.
No, we don't really need to do that.
You don't need to have a physical model, a material thing that backs what you just said. Okay, cool.
You don't need to. You can't make a physical model of the Earth.
So you don't have science to back
for example,
stuff.
you don't need to. You can't make
physics.
You can't make a model. Okay, you can't make a model in a lab
You can't, huh?
You get.
What do you mean?
Hold on. Wait.
Mark, you're making this conversation really hard.
Hold on. You can't make a model.
Just give me a second.
What do you guys keep saying? What do you guys keep saying says something? A model, right?
Okay, you can't.
So that's what we're looking for, the real model. The one that actually matches to scale. So if you can't, then what are you talking about? Then what are you coming? Where are you coming from then? If in a lab you don't have a scientific model,
someone has to contain the model.
I'm asking you. Hold on, dude. Let me finish my sentence.
I just want to make one point. You can't make a model of something like the water table on the Earth. It's too
I didn't
big.
ask
You
you
can't
about
put that in
that.
the
That's
lab
not
and
what
make
we're
a model.
talking about. We're not talking about, dude, stay on topic. We're
I
talking
am
about
on topic.
a little ball you call Earth that can only happen a round way, with a little sun that can only happen a round way, that goes around a geocentric ball, right? That happens a certain way at a certain distance. Now, the only way you can demonstrate the distance in my mind is 93 million millimeters. That's the smallest we can give you. So you can go outside or in a lab, your choice, and the sun has to be 24,000 millimeters to match. There's your scale.
That's
Demonstrate. We're ready.
that's one of the things that science deniers do is make unrealistic demands.
We ask for.
So that's one of the characteristics of science denialism is making unrealistic demands.
Do any of the ballers here want to respond to just a simple question? When the model heliocentrism was made, it was done by studying how the planets and stars and everything move, right?
What heliocentrism does or purports to do, if you want to say that,
To
is
even have
explain why the things
heliocentrism,
holy free.
the first thing y'all needed to do.
Hold on, Brian.
Mid-sentence.
I got a
Okay.
follow-up question. Just let me go back and forth a little
Hello,
bit, please.
can you hear me? Can you hear me?
I can hear you.
What thank you very much. What heliocentrism purports to do is explain not just what the things do, because you can just look at what they do, but also explain how they do what they do, akin to looking at a clock and pulling the clock apart. No, we can't literally pull the universe apart, but we can come up with explanations for the things that match what we see
theories.
in reality. Theories, yes. Yes.
Right, but like we were
And
saying
theories
before,
for magnetism, theories for gravity, yes.
no, I hear you. But if we're on the ground and we're looking up at the positions of these light orbs of light, Mercury, Venus, etc., and we're saying, okay, wow, that one in its position and it looks to go retrograde and this and that, that's cool. We can do that. But if I came up with a story, like I said before, that that there's fairies that are pushing those things around, and the different wing sizes of the fairies mean that they're going to push them faster or slower, and came up with a whole complicated thing, and then I had a buddy of mine named, Booton instead of Newtons, whatever. I had a guy's name that I wanted to say that came up with this fairy theory of gravity, whatever it may be, and I come up with a whole explanation. Does that really help us to get to the core of reality, or is it just another story and an explanation?
That idea is just as unfalsifiable as his point.
Okay, so that's the point with the fairies thing is you could come up with that. Absolutely, you could come up with that. But realistically,
No,
realistically
is a subjective term.
Here's
What do you mean? What do you mean?
At least let him finish what he's saying. At least just let him finish what he's saying.
Thank you.
Go ahead. No, realistically is a subjective claim, but make it more
let's
precise.
not get into semantics. That just
You guys, but just let him say what he's going to say, and then someone can respond. But if he's interrupted, we don't even know what he's saying.
I don't even know what I was saying now.
You were saying realistically, but realistically and theoretically are not necessarily the same thing. They're kind of mutually exclusive in a way.
Here's what we've got. What we've got right now is we have scientists who are looking at the stars and studying the stars, and whether you disagree or agree with what they're doing or how they're doing it, they're doing the best they can to understand what's going on. So there's that going on. But on the other side,
Hey, don't interrupt him, please.
Okay. So you said understanding. No, understanding.
Hey, don't interrupt him. Whoever it is, please.
Thank you. I appreciate it. So it is hard for me to get thoughts out. I appreciate your patience, guys. So on the other side, we don't have any other explanations. There aren't any other explanations being offered. So for lack of a better explanation, that's what we've got. If someone comes along and says, no, the hour hand of the clock isn't working because of fairies, then you could pull the clock apart and look for fairies. But if you just say fairies but don't test for fairies, then that's not the original model and the original ideas are going to stand. Let
me follow up. The reason I asked hold on, wait a minute. I'm following up with the other question I wanted to ask. The reason I asked how is it they came up with the model is, and my question was, do they do it by studying the stars? And of course they did, right? They saw how the stars moved and they came up with a model that fits that, right? So why is that then prediction? Because it's just as Gio is saying, they study the cycles and then they make a model based on those cycles. So you can't really, even in your own explanation, call them predictions. They're only post predictions because you're studying how things work and then making it fit a model. And there's several cosmologies, cosmogonies. There's several cosmogonies. I mean, there's not just one cosmogony that is the front runner. It was decided to be, but it's not like that's the only explanation offered and everyone else is just saying fairies.
Someone needs to look up if post-diction is a word. It's a good word if it isn't.
No, I mean, you know what I mean.
Can I?
I know.
I think it.
It needs
I
to
think
be a
it's
word
a.
if it isn't a word.
I think it is a word.
Okay, cool.
Yeah. So the reference to the whole fairies thing, right? It's an equivalence to your theory because it's the same thing. You're not bringing something that's testable. What
It's
you,
not.
you claim that it's testable, but let me test your claim. Give me the test. Like, how do I
Sure.
test your claim?
Well, you could
walk me through it.
You could look at the theory of gravity, right? And you can look at all the predictions that gravity purports to be able to, all the things that gravity purports to be able to predict, and then test if it can indeed predict those things.
No, it's not about the prediction because the prediction is based on the observation. We all agree we observe X. Now, your explanation of X is not a prediction.
Well, but
I mean, it's an explanation. You already said it. You already said it's an explanation, not a prediction. There's a difference between both terms, right? And the way to test an explanation, right? How do you test your, let's say, you mentioned gravity, right? So how do you test gravity, for example? How do you test the claim of gravity?
You use a gravimeter, or I mean, there's Cavendish, there's a bunch of different things. But leaving that aside, if you look up at the stars and you see a light, and the light's moving differently from other things, you can study it and you can come up with theories as to why it's moving in that way and what it actually is. That is all that science is looking at something and coming up with explanations for what the thing is and why it's doing what it's doing. That's all that science is. Now, the problem is if you, well, it's not really a problem, but if you have a certain set of explanations for what is in the sky, the only way to, if you want to pull down those explanations or refute those explanations, is come up with better explanations.
No. Actually, your explanations must be falsifiable. Like, do you agree? Like, if you're going to make a claim that's scientific, it must be falsifiable, i.e. someone must have the ability to falsify your claim. Otherwise, it's unfalsifiable, therefore it must not be scientific. If it's unfalsifiable, i.e. fairies, if I make a claim of fairies, right? And that's the, like, how this all began, right? We're making reference to fairies, which are...
Well, you look for fairies. You look for fairies, and if there aren't any, then you falsified it.
Yep.
Yeah, but that's not. There's something that's being missed here, though. If those fairies aren't being used, outside of the knowing the cyclical nature of whatever event you're talking about, you have to be able to use those fairies without using that cyclical nature and come to the same conclusion. So it's not just saying fairies did it. You have to be able to, without even calculating the predicting positions, knowing what you know now about where the positions of everything is, and then using the theory that you came up with. If it's giving you the same prediction as those cyclical observations gave you, then you're onto something. But it's not.
No,
it's not just. You can't just use an ad hoc.
Wait, hold on. The cyclical observations have nothing to do with the explanation itself. I mean, we all observe the sun to rise in the east and set in the west. That's the observation, but the explanation for it can vary in so many different ways. I mean,
there's a couple.
Hold on. Let me finish. The explanation, let's say, globe Earth compared to flat Earth, is so much drastic from one another.
What's
But
the
yet
flat
there are
Earth?
two
What's the flat Earth prediction?
that the
Flat
sun
Earth prediction
is
is
doing the
cold up.
moving. Okay, let me simplify it. The sun is doing the moving versus the Earth doing the moving
No.
on the globe Earth.
How does
Yeah,
the
and
flat
would
Earth?
be
How does the
Let
flat
me
Earth
tell you how.
explain sunsets? How does the flat Earth explain a sunset?
Oh, fuck.
by the
You're going
sun
back to
moving.
that is
By
another
the sun
topic.
moving. That's
I wanted to
I
say one
just
thing in terms
I
of like comparing like the idea that the wandering stars are moving because of fairies versus like the heliocentric model. The one difference that I suppose the heliocentric explanation has, that these things are spheres and they're all out there, is essentially government agencies like NASA. They claim that they're out there, they're probing it.
Oh, we can see them.
That would be similar to
they're
if we had a
suns.
government agency that said that they're going up there and measuring the wings of the fairies.
Geo, I see them. I saw them myself.
Yeah, you see that they're not as big as suns either. You assume that they're suns, and the first assumption for the whole heliocentric model to even start was that little tiny light in the sky was the same size as the Earth. It all started from that major assumption. So, I mean, we could just make up some shit like there. Since we know it's cold up,
I didn't make anything up. I didn't make anything up.
Since we know it's real cold up there, we could just say it's little discs that are quantum locked and actually demonstrate it in a lab. You know what I'm saying?
Brenda, you said you didn't make anything up. How do you get the distance to a star?
So I, as far as them being globes, I have.
No. I asked you a specific question. How do you get the
and
distance?
if you don't allow me to talk, I'll just stop.
Yeah, you see circles of light. You see circles of light, but let's not interrupt Brenda. Go ahead.
I don't see circles of light. I personally. Hey, Brian, shut your fucking mouth.
Sorry, Brenda. Go ahead.
So, growing up, I had a telescope. I saw the rings around Saturn. I saw Jupiter. I saw Mars. I saw mountains on the moon.
Remember my question, Brenda?
Yeah, it was whether or not they were round or not.
No, the distance. How do you establish the distance to these objects? That was my question.
I didn't. Other people have.
Oh, so okay. How did they do it?
Usually through trigonometry and timing. I think in some cases radar.
No, they tried to use radar on the planets, and the whole fucking none of them matched.
The sun is
I can give you a citation for that. The radar didn't work on planets.
It works on the moon.
You can get a rough estimate of moon's distance using parallax.
Yeah,
how so? Walk me
that's
through it.
true.
Walk me
That's
through
true.
it. I'm listening.
Oh, you establish a baseline, right, with the Earth, and then you measure the angle at two different times.
Yeah, measure an angle. You said.
Yeah. So
what's the baseline? What's
the baseline would be one good way would be the Earth's orbit is 1 year, so you take it at 6 months, so you have that very long baseline.
Well, why would that be a baseline? 6 months.
Because there's a line. There's a line between, in the orbit, right, that would bisect.
What
that would
orbit?
go from the orbit of Earth around.
Orbit?
We've already
Well,
determined. We've already determined that. We've already determined.
How?
You're asking about the distance to planets.
Yeah, but you made a claim of orbit.
Yeah, we already know.
No, how do we know that? How do we know
that's
an
a
orbit?
different question. Are you changing the question?
No, it's still within the question. You're
No,
trying to
it's not.
explain the answer, but
No.
you went into a different, making a different claim of orbits.
Look, it's a different question. We know, given that we know that the Earth
No, you
rotates.
can't answer my question.
I'm trying
Love
to.
interrupting, Egypt. Please, just for one second.
Given that we know that the Earth revolves around the sun, you can compute a baseline between summer and winter. That's half of the orbit. That's a very long baseline. And then you measure angles to the planets at those different times, and you do some trigonometry, and you can figure out how far away they are.
Great, but your baseline is assumed rather than measured.
No, it's known. It's not assumed. It's known.
That was my question. How do you know that? How do you know?
So that's a different question, isn't it?
Well, you want to? Is that the problem? Like, if I'm asking a different question, does it all end? Like, you can't answer it because
think
it's
the
a different
problem.
question.
I think the problem
I can
is
answer it. Let me
that
clarify this real quick.
Give Brenda the time to answer
Well,
my question.
huge anus. What? You picked the name, buddy.
It's a great name.
You go ahead because you were going to answer it. I don't want to dominate the
Let me say
time.
this.
I don't want
Did
to.
the
I don't want to
radar.
dominate.
I misspoke earlier.
the problem
I
is
misspoke. They got readings from the planets, y'all. With the radar, they did get readings from the planets. They were just wrong. That's what I wanted to clarify that.
okay. So the entire problem, and I'm going to get in trouble with Geo for this, but the entire problem is that from top to bottom, it's essentially everything that we've found out about what the universe is, the solar system specifically, is being denied. Is no, this is not right. No, that is not right, etc.
Well, was the radar wrong or was the model wrong?
When we come up with explanations for what the
It's
things
being
are,
questioned. It's being
Well,
questioned.
my question is, was the radar
And you
wrong or
can't
was
answer the
the model
question.
wrong?
That's the problem. Hold on.
We can't.
Janus.
There's no hold on. If he's not giving you the space to speak and he's not finished, you let him
No,
finish.
but listen, if they calibrate the radar to fucking get the right distance from the moon bounce, and then they apply it to the planets, and they get the wrong fucking, every one of them shows the wrong distance, is the model wrong or is the radar wrong? Which is it?
I don't know if
That's
that's
what
true.
I'll post a
Can you
video.
provide a
I'll post a
citation?
video. I'll post a video.
Not a video.
How about you post a paper published in a reputable journal or a textbook
This is one of the guys who helped model it. So you can argue with the guy who helped model it, or fucking you can argue with me. I'll post a video.
What also would be lovely is your own estimates according to your own science.
Okay, my estimates are this: the fucking planets are way, way, way fucking smaller than you said. They're still huge. They're probably like 10, 20 miles, maybe even 50 or 100 miles in size and diameter. Still bigger than any city we've ever lived in.
That's great, Brian. That's great.
The stars are probably a little bit. The stars are probably in the same region.
Fairies.
The stars are in the same region. They're fucking. They probably all have their own charge, and which is light. And they we can show these vortexes here on Earth with electrically. All the stuff that we predict is stuff we can show. We kind of guess at it.
Brian, how did you determine the size of the planets?
Observation.
What observations? I'd like to see your data, please.
Just observation.
No, I'd like to see your data. What's your data?
I think what's going on is
triangulation.
in this conversation long enough that at this point we should be starting to see data from you.
Okay, you know what the problem is that person is making the same claim as you are.
No, he's claiming.
Which I'm challenging. Okay, but
he's claiming.
What my claim is.
You guys, there's so many interruptions. I guess if you interrupt, you'll be temporarily muted. So just please try not to interrupt so we can hear what people are saying. So go ahead.
Yeah, one person at a time. One person at a time.
Just try to let someone speak, and then when they're finished, give it a second or two. And I know someone always wants to jump in, but when it's complete interruptions, then what you're saying can't be heard, and what they're saying can't be heard, and the audience can't hear what's being said. So basically, everybody loses when there's interruptions.
I'm terrible at doing that, so I'm sorry.
Well, when we triangulate planets,
can go quick back and forth. So sometimes it's okay where someone says something, someone does a quick response, but when there's just blatant, completely someone just doesn't care that someone was speaking, or they're triggered and they just want to talk over everybody, then it just makes it hard to follow.
Yeah,
when we triangulate planets and stuff,
Brian, hold on, come on, Brian.
You're interrupting already. We just started. You're already interrupted. She asked me a question. So when we triangulate planets and stars and the sun and all that stuff, we don't get these magnificent numbers y'all come up with. Triangulation and mathematics give us way more down to earth answers. Okay.
Could I see that? Could I see those numbers and could I see your analysis?
Yeah, just do the math.
No, you did it. You're the one.
I already did it. Yeah,
no, show it to me. Show it me. Show it me.
I'll show it you. Okay? I'll show it you.
Brian, like I said, we're at the point now in this conversation. It's been going along quite a long time. Some of this stuff we should start by now. I think people are expecting to start to see data rather than just saying the moon is closer, the sun is closer.
Not only have I already modeled it, Steve Torrance and them guys modeled the fucking. They modeled it with a computer, but I modeled my own model with triangulation from I'll post it.
Yeah, I can't post my man next in your DMs too. So
Can I say something? Can I just make
yes, you can. Yes, you can.
just make my position clear, because I don't hold Brian's position. To me, Brian is just another Glober. I mean, he's making a claim just as much as you guys are making a claim, which is
He's a flat earther.
unfalsifiable.
No. I got tired of hearing their questions about
let me
angles of
finish.
Polaris. I made
Oh
a
my
little model,
God.
bro.
Okay, I'm
Call
gonna
me a
shut
Glober
up.
if you want,
Let
bro.
him finish, Brian.
That's
Let
an
him
insult.
finish. You can rag on him after. Let him finish.
Sorry, Brian. I didn't mean to call you a Glober, but what I'm saying, your claim is just as, to me, this is my own 2 cents. To me, it's just as much as a Glober claim. Wait, that's why they're holding you to data, right? They want your data. They want to see your calculation, your observations, and so on. But in the end of the day, simply their model is based on assumptions, right? We all observe the same thing. I'm never going to deny an observation because it's observable, right? But the explanation behind it and that so-called calculation and the model behind it, I mean, that's why it's called a model. You need to model things that cannot be, like, you're trying to explain these things in a mathematical fashion, and you have some sort of assumption behind it, but it's not.
Yeah, but at some point, bro, you got to get tired of hearing them. How does the sun set? Or can you explain angles to Polaris? At some point, you got to get tired of that. And so, yeah, I'm not claiming that I know all this shit, but I just made a fucking simple little refraction model to explain the math. You know, just so they quit fucking this. So they quit asking that dumb shit.
Well, okay,
well,
but
you
problem is that
what
you're
I'm
fighting-
hold on. Let me just finish my sentence. You don't need to fall into their same trap and try to explain it in the way they do it, and that's fine. But just destroy their claim by showing they have no testable data or testable experiment for their explanation.
Yeah, go ahead and do that.
Yeah, please. Do
no,
that.
that's
Show
on
us
you.
possible, and then-
No, it's on you.
It's not on us.
Describing a
Okay.
It's not on us. There are hundreds of people all claiming different things.
Okay,
There
so
are
you
hundreds of
claim to have
theories.
a distance to the sun, right? That's known, correct? That's a known fact.
It's measured, yes.
Yes.
You measured, yeah.
Yep.
Okay, so
those cursed measurements. Ugh.
yeah, can you walk me through how it was measured?
No. No.
Great. So you have no claim.
I don't want to be rude. I'm sorry. That sounds rude. I don't need to be rude and dismissive. But no.
Yeah,
Go and do your own research and find out how that was done.
I
Okay?
did.
It's
I
not,
did, and it wasn't done.
It's not that. Then you didn't.
it wasn't done.
In that case, you didn't.
Is
do
that
because-
is that it?
Yeah.
Is that your claim? That
there's
that's my claim.
out there on how
okay.
they measure.
Great. You have
know
no
why?
claim though.
You know why? Because every time I get in this, I'm not mad. I'm just talking fast. Every time I get in this sort of conversation, someone says, "I looked for the evidence, I couldn't find any." I go and look for the evidence and find it within 2 minutes every single time.
2
Someone
minutes.
said yesterday,
I'll give you 30.
I'm not
30 minutes.
No, that's
Yeah,
why.
you
that's why
find
I'm not doing
stories,
it.
brother. You find stories.
Someone came in here and said, for example, and please let's not get on this topic, but for example, I'm a photographer. Someone came in here saying that the moon landing was fake because they couldn't find evidence that the film that they took to the moon could survive the rigors of going to the moon, the heat and the radiation, etc., etc.
That's a red herring.
A red herring. Let me finish. I looked for about 3 minutes for the evidence and found it. Where they said
red herring.
I've looked and looked and looked and I've never found any evidence.
Red herring.
That's not a red herring. That's an example.
No,
it's an analogy. It's not a red herring, for pity's sake. It's
well,
just
we're not talking about the moon landings. An analogy. Yeah, how can you? How do you?
No, he can't understand an analogy.
No,
Can
I
you?
understand analogies, but
Well,
how
what's
does
an
it tie
analogy
into
then?
this one?
Yeah,
Holy smokes, dude!
How does it tie into this one?
That's what an analogy is.
I just asked you, how does it tie into this one?
The way it ties in is that when someone says to us, like if a flat earther says to a glober, okay, I looked for the evidence and I couldn't find any. then what happens, and Brenda can back me up, and anyone in a Glober in this room can back me up, but any time that we then go and look for that same evidence, we find it immediately.
Okay, so show your evidence then.
Yeah, but we show you older evidence before it was revised, showing that they use regular Hasselblad cameras and regular film. It wasn't modified. Then y'all come up with new information that it's modified. Yeah, you're right.
To make your point, you need to actually show the evidence for you to like. No, you don't need to show evidence to make your point.
The answer is if it's dismissal, if it's just dismissal with just like with no basis, then there is no reason to show evidence.
But you're making an assertion with no basis.
Contrary evidence, then you can have the evidences, both set of data and evidences battle it out. But if you just say no, it isn't, then there's no need to provide evidence in that case.
Actually, no. The onus is on the person making the claim. I did not claim to have a distance to the sun. Do you claim to have a distance to the sun? Because I don't. I say I don't know the distance. That's my claim.
Well, you're also making another claim. You're also claiming that we don't know either. That's a claim.
No, I'm challenging your claim and trying to let you provide your evidence, which you seem to not like have a reason to. Like you're saying, I don't need to show my evidence because it's out there.
Yeah.
Someone else figured it out, so it's fine. I don't give a fuck what you say. Yeah, exactly.
Yeah, no, that is totally fine. So for the example given, I looked for the evidence. I found it immediately. And so apparently the evidence was not forthcoming. No one could find it. It was impossible to find. I've been looking for years. That's what I've been told. I've been told that repeatedly by different people. I've looked for the evidence, found it immediately, and now we're back to the same thing. And
why are you falling back to your? Why are you talking about past experiences when I'm having a conversation?
Of now. It's just it's just an illustration.
No, but to you,
problems now.
You could be just repeating your same mistakes over and over. But try to stick. Yeah,
my mistakes are looking for the evidence. Is that a mistake?
Well, show me the evidence. Is that so hard?
That's a mistake. That would be the mistake.
All right, here, this is pretty straightforward, dude. You've come into this community and into this particular platform, and you're here seemingly wanting to either convince or assert a position. And meaning if you don't want to, if you just want to share your philosophy on life, that's one thing. But if you want to assert a position, people are going to ask you for backing to that position. So then it would make sense for you to bring that, and then it can be looked at. If you don't want to assert a position and you're not here to convince anybody, then I guess we'll just consider everything you say your philosophy and we'll move on.
Well, that's
exactly.
Gio, no, that's completely reasonable. But isn't everyone just giving a philosophy? If you say
no,
if I say the distance to the moon has been checked, Brenda said as well. Is Brenda providing evidence? No. So if I say that the distance to the sun has been measured, and you say no, it hasn't, then
I didn't say that. Nobody said that.
Run around and then find out that it hasn't.
Only if
people are asking you for your evidence.
Yeah, if you want to convince others or assert a position that has any validity, then yeah, you would have to do that.
Exactly. I wouldn't go on your word.
Bad influence.
All right. So,
because you say it's been established and it's out there, it's on Google. Just Google it. I'm not going to Google it. I mean, it's your claim. I'm not going to do your work for you. You want to prove your claim? Go ahead and do it. But otherwise, it's an empty claim.
It's the same. It's the same thing. But we're on equal footing as well, even though it's annoying.
No.
It is annoying that we're on equal footing.
Why are you putting me on equal? I never made a claim. What claim did I make?
You made a claim.
What was my claim?
Okay, your claim, the claim that I'm hearing, whether you made it or not, is that you don't know the distance to the sun.
No, I didn't make that claim. I asked you. You said you know
the distance.
Right?
I didn't say I knew it. I said the distance to the sun has been measured. So
it's been measured. That's your claim.
Okay. Yeah.
So show your working. Show your working.
Yeah. If somebody says they don't know the distance of something, that's not a claim.
I always say,
then
I don't know. It's unknown. Like distance to the sun for me is unknown. Is that clear enough for you? Like, do I have to say 3 more times? I already said it.
But then what? So what we were talking about earlier was the difference in the heliocentric model and flat Earth. In flat Earth, you can look at the objects in the sky and you can make predictions and you can, or post-dictions about what they are, or rather what they are doing. But at no point can that explain what they are and why they're doing what they're doing. So what science does is it seeks to explain and give explanations for what the things, not just what they're doing, which is demonstrable, but also what they are and why they're doing what they're doing. That's all that science is.
Yeah, exactly.
Let me
But
use this
science needs to
analogy for you.
be testable, and it must be empirical. It's not just something you come up with.
No,
So,
he's
like,
talking about he's talking about pseudoscience, bro. He ain't talking about
like that's why the reference was made to fairies. I mean, you can come up with any explanation. Just because you have an
Guys, hold on.
explanation doesn't make it scientific, correct?
Observe and declare. That's their science.
Oh, let me use this analogy for you, Hugh. Pretend there's a clock on the wall, right? And we can see the hands turn, but none of us can ever see behind the clock. You could come up with all kinds of ideas on why the hands move. I could come up with all kinds of ideas on why the hands move. And in the end, they're just going to be our ideas on why the hands move, because we can never see if there's gears in there, is there midgets turning the clock? Is it a pendulum? Like, what's going on? We don't know.
Right. Well, I tell you what, I agree with. What I don't agree with is that when we say we have done things, for example, various probes and various objects have been sent to the moon. And so we do know its distance, and it's also laser ranged. So we do know its distance. How do you deal with that?
Well,
we show you that bunny. We show you the idiots bumbling around the fucking moon and show you 1960s fucking footage of fake backdrops. And if you believe that,
right, so you crap on it. Okay.
Yeah. Hold on.
It's embarrassing to fucking watch, bro.
That's fair enough. If the competing evidence is we've done this science and your evidence is crapping on it, then that's it. That's what it is.
Oh, well, hold on a second. As far as the laser ranging and shit, the medium would be dependent upon how far it is. So you'd have to know the medium the laser's going through to know how fast the light went. We know light, even in a vacuum, light doesn't travel at a constant speed. And as far as going to the moon, I mean, you'd have to just believe that. There's been so much evidence against the moon landing. It's
not the moon landing. I said
up pretty high.
Yeah, sorry to jump in too fast. No, but multiple nations have sent things to the moon, including China, India, although they crashed rather than landed. So multiple sets of people have all sent things to the moon.
I sent something to the moon too, bro.
Rather than just crapping on the NASA's
I sent something to the moon, bro. It's only 3,000 miles away, bro. I didn't tell you I sent something to the moon. Yeah, me too. It's about 4,000 miles away.
We can deal with it. There's been many pieces of fakery going on when it comes to sending shit to the moon. The LRO had shit faked in it. The Apollo missions, obviously, that's the evidence is stacking up high. These people. What's up, Left Lane?
No, I just mumbling. I don't know. It's just kind of frustrating to call everything fake.
Bro, just look at them hopping around like bumbling idiots on the fucking moon.
No, you look.
When we see evidence of fakery, it's pretty easy to call it. Claim it's fake.
If all you're looking for is evidence of fakery, then all you're going to find is evidence of fakery.
All I had to see was a guy's left leg get snatched up to his ass. Right there, just what snatched his left leg up. That's all I had to see, but I could tell you 100 other things that all I had to see was that. The point is, it's fucking downright embarrassing. Fucking looking at that shit being an American. It's fucking embarrassing.
No, never mind. I'm not going to say.
Are you guys upset that people think things are fake? Because it seems like you'll often be like, "Oh, you're calling everything fake." Like, what's the problem with someone thinking someone's fake? Do you have some there's a problem with that in your mind that you have to be mad that someone thinks that?
Yeah. So, Gio, we can get into that now because I sent you a long DM message. It's kind of it is frustrating. It is annoying and it's insulting. And it's
really annoying. We're trying to get closure. We're trying to. Sorry, go ahead. I thought you was done.
Thanks, Brian.
He wasn't even close to being done. He was in the middle of the sentence.
All right. So yeah, I mean, I'm doing my best here. Okay, Gio and I, you know, we've sort of butted heads a little bit today, and we did yesterday as well. So mostly my fault. Anyway, yeah, I mean, if you, as flat earthers, you guys have to understand that for us, it's insulting, and it's in, if you just say that everything is fake, and please don't take, you know what I mean by that, okay? You just say, well, the moon landing, well, that's fake, and then satellites, etc., etc.
Can I
You just
tell
say
you
everything
something
is
else?
fake.
Annoying?
Yeah, it is kind of how most people can't deal with this conversation.
Can I tell you something else that's annoying real quick? It's annoying that we're trying to get disclosure. We're trying to put pressure on like NASA, the government, and everything, and we're trying to get people to join in because we've debunked that shit 10 times over. And we got people who don't even know nothing about it, who can't prove it, who wasn't been there, defending it to the death. And we're like, guys, look at this shit. Here's this problem, that problem. You know, the Van Allen belts, the film. I don't care what they say about the vacuum. If you went through a radar or a metal detector at the airport, you ruined the film, bro. And they talk about the Van Allen belts. That's just one of millions of things, bro. And we're trying to get disclosure from these government agencies, and y'all are defending them in the blind to the death. It's weird.
Hey, yes. Hey, Brian, did you see where he said he was insulted when you said about the fake moon landings? He said he's insulted. Like that was one of the last things he. Why would you?
Hugh, let me ask you that. Let me ask you in terms of that, Hugh. Let me ask you this: if the moon landing was faked, okay, let's say that's the truth, okay. For this, if it was fake, then people saying it's fake would be correct, right?
Sure, we can.
All right. So for you to, if that's the case, so if that's the case, if you're being insulted or whatever you were saying about the fact that people think it's fake, wouldn't that then mean that there's something within yourself that you're resisting that? I'm saying if that's the case. If we're wrong and it's not fake, then who cares? We're just someone that was wrong.
Okay. But
that doesn't really matter. Hey, you're defending something that you're not even a part of. Like you didn't contribute anything to the moon landing. It's only a belief system and your identity that you're defending. You're defending nothing more than just the team you root for because you're simply just tribal. You know not what you do. Though. I just wanted,
Flat Earth is one of the most tribal things I've ever encountered in my life.
That's insane, bro. We have different ideas.
There you go in defense mode. No, there he goes in defense mode again. It's ridiculous.
Bro, we all have different ideas. There's no leader. We have different ideas across the board, bro.
Very, very tribal. I've been to 24/7. I've been to Gems. It's very, very tribal.
Yeah.
So
just admitted that you're insulted, dude.
Yeah, maybe with 1,000 tribes, bro. We're all our own tribe, bro. We all have different ideas. You know, it's not like y'all are stuck on a script, bro.
For the moon landings, you weren't even alive then. Dude, it's just an idea that you're defending.
We're philosophers, bro. We're philosophers, man.
Okay,
we all got
bro.
Okay.
All right.
I was born in 1963.
Well, I would say definitely everybody is their own unique. Everyone's their own unique person. The term flat Earth generally refers to the concept that the Earth is planar in nature and stationary. I mean, that term, there's even deeper roots to that term because when they told us the Earth was a globe, they linked it with this term. Oh, the ancient desert wandering people used to think it was a flat Earth. Ha ha ha! Isn't that funny?
Archaic ideas, yeah.
Yeah, so there's even a deeper like psyop to that term flat Earth. I personally have never called myself a flat earther. I've never identified with that term, even from way back in the early,
See that? We even have flat earthers that aren't flat earthers.
It's never been verified. Like nobody's seen the extent of the flat Earth to verify that it is a flat Earth. So
there's a whole tribe
name as well. No,
hold
on. Hold on. Whitsitt earlier said you can't falsify. Falsification does not equivocate replacement, right? Something like that along those lines. But you guys are doing the same things. You're saying if no globe Earth, thus must be flat Earth. But that's not the case because this could be something else. Like we can't. This place that we're on, it could be a fucking teeter-totter for all we know, and it's just stable as fuck. We don't know. We've never verified it.
So
My only point, Hugh, is that labeling this thing flat earther and trying to like put people into that group that might not even say they're in that group, and then trying to label it with all those things, I just think is not a very accurate way to go about it. That is a term that, like I said, it was originally kind of implanted with the globe thing. And then in general, it does mean, like, if you want to label it, that people who would say the earth is planar, or, you know, if you want to use the word flat, in nature and stationary. But it doesn't mean that everybody who thinks that the earth isn't a globe and or thinks it's a stationary flat planar surface all of a sudden is lumped into some group that you can then generalize.
Should I say globe denier? Because I don't like to be negative. I'm a pro.
Yeah,
I'm
yeah,
pro-life.
that's fair. That's fair. Because we're all skeptical. We're the modern day scientists. That's fair.
So
no, that's fair. Globe skeptics, man. Because we're all one thing. We all are, and a lot of us are even skeptical about flat. Like, I mean, look, I mean,
I'll say globe skeptic.
Globe skeptics is fair. Just the point is it's model affliction. Some people call it. Some flat earthers say it's model affliction. You know, like I just got called a glober for giving a celestial model. You know, just like that. But here's the thing: we're the modern. I'm almost done. We're the modern day philosophers, man. We all throw out different ideas and possibilities, and wherever science is at, you know, and whatever people read about new shit, we try and like point that toward the heavens and possibilities and all that. We just ain't locked in on no one thing, man. It's refreshing, man, to not be locked into.
You know why you're not locked in? Hey, you know why you're not locked in, Brian? Because you don't know, dude. Like Whitsitt said it earlier. We don't know. Like about 6 hours earlier, he said we don't know what we live on. He's true. He's saying the truth. We don't know.
That's the only honest
Gio
stance. That's
doesn't
the
know.
only.
Like
That's the only 100% honest
Gio
stance.
and Don and Nathan, they've never verified with the tape measure or say like a theodolite or whatever sort of measuring device you would be happy with and consider it suffice for you. You've never measured it. Nobody has. You've never measured the flat Earth in its entirety, if it's even flat. So how can you even call it flat?
Well, to speak back to Gio again, just for a second, just to reiterate, and I apologize for just saying the same thing again, but the reason, the fact, let's just say that the fact is that people are insulted by flat Earth and the notion of flat Earth, etc., etc., or globe skepticism. Okay, people find it insulting. Okay, so what I would give us my perspective as someone who's trying to understand it is to accept that fact and act accordingly. That's all I'm saying. So realize that when someone comes in and is annoyed by flat Earth or annoyed by the claims, annoyed by the claims that moon landing was faked, etc., then recognize.
Can I
real quick. Right after this.
No,
People don't like. Some
Brian,
people don't like progression. That's my whole comment. People don't like progression. Mostly older people.
Okay.
I'm kind of old, but people don't like progression. People don't like change. But it always happens, bro.
Hey, dude. So I think what you're saying is, look, the Globers have invested all this time and energy, resources, intellectual, like intrinsic intellectual work put on all this, right? And you're saying, how dare you criticize or what's the word I'm looking for? Like lessen the work of disparage. Yes, there you go. Disparage any of their work that they did, right? I get it, but that's one thing I will give the Globers is there's more globe science than there is flat Earth science. And hold on, let me just be clear. I don't agree with most of the globe science because it's all theories. Most of it's theories like gravity's a theory, all the other theories, rocket science theory, space theories, sun distance theories. They're all fucking theories because you've never verified them. Just like we haven't verified the flat Earth. So we do the same thing.
That's pseudoscience, bro.
About that?
Pseudoscience is basically philosophy.
Hey, I want Egg to respond to that, not just hear what he said and like, okay, now I want to talk about something else. Like, really talk about that, dude.
Yeah. So
Can you respond to it?
yeah. So as I've looked at this, for example, I'll give you one good example: rockets in space. It took me several days, and I didn't apply too much of my brain power, such as it is, to that. But it took me when I was trying to figure out, because someone flat earther said rockets don't work in space. So I said, well, rockets work in space because wait a minute, how do rockets work? And I wasn't sure. So I looked it up and I did some study. It took a couple of days before it really sunk in my head, and then I got it. All right. So from my perspective, it's, and maybe others have this sort of issue as well. I don't understand why, after trying to figure it out, it's still unfathomable. For me, it's not unfathomable. It's actually quite straighthtforward. And that's,
we don't know.
Okay.
We can't leave low Earth orbit, bro. We can't.
So there was
We can't leave low Earth orbit. How would we know if they work?
There was look.
Younger.
They needed a rocket, right, to fly to the moon, right? And then when they flew to the moon, they landed the LEM. But here's the thing: have you ever seen like pictures of the moon landing and how close the nozzle is? That heat shield. I guess it's a nozzle. The nozzle was to the floor, and there was no it didn't displace
Glass
any
crater.
dirt or anything.
Glass.
Do you guys know what I'm talking about?
I know.
I can show you what I'm talking about, or you know? Okay.
Yeah.
What do you got to say about that, bro?
Okay. Well, I can't address that directly because it's been it's been so long since I looked at the moon thing. But what I can say is generally what I found is that in my experience, for example, I give you the rockets because it's one where I remember I didn't understand it, and then I understood it and I figured it out all by myself. Good for me. Okay.
Hey, this rocket though,
I feel
Go ahead.
what I feel is, and what I've observed is, from my perspective, is I don't have all the information. Let's say the rocket's proximity, the nozzle, right? So I don't have all the information. So what I've done is, when I have gathered all the information, the information checks out. If I don't gather all the information I need, it just remains a question. I would and have for the longest time encouraged people on both sides to pick one topic, and because there's so many different things you could look at, but if you pick one topic, study it intently for 2 years, and then continue. If you still believe then it's impossible or implausible, then by all means, but find one topic. And I picked moon distance. It was one of my things was moon distance. And when I studied it, I found the distance to the moon checks out. So pick one topic and then really study it really, really crazy.
All you had to do is triangulate the moon, bro. You just could have went out and triangulated it and got the distance to the moon, bro. It's about a little under 4,000 miles, man. It's easy.
So okay, all right. I'd like to see your work on that. The distance, for example, the distance of the moon being radio ranged and then laser ranged, would
I said distance to the sun. I never said anything about distance to the moon.
The distance to the sun is trickier, right? Because it's further away and it's a big light and everything. So that's
Well,
tricky. The
it's
moon's an easy
changed
one because it's
multiple
relatively
times.
close.
It's changed. Yeah. Can you acknowledge that it's been changed multiple times before you start going on a monologue?
Am I monologuing? I'm sorry. Yeah.
Every one of them.
I'm trying to be polite.
All right.
Every one of them changes came with friction too. Everything always updates and changes and progresses.
Yeah.
And there's always people who are scared of that change and don't want to progress. But no matter what, everything keeps moving forward, and that's what's happening now.
Most of the time.
Hey, he trusts that the science that they use to get that number. He trusts always, but then look, when it was 3 million, he trusted, but then they changed it, and now it's 8 million. Then he trusts it. He just trusts to.
Wasn't it 3 million 2,500 years ago?
Yeah, but
when was it that close?
Yeah, when you said
Newton said it was 1 million.
So the distance to the moon checks out. How did you check it out? How was that verified by you?
Well, there are two ways you can do it. You can do it the hard way, which is to go and do it yourself. Right? You can do that. Or what you can also do is that you can look at the methodology used, and then using what little or great amount of scientific knowledge you have up to that point, and see if it violates any of those principles. Okay, if it does, then it's probably wrong. That's why I don't think that rockets going into orbit is impossible. Bansel Bennett and I chatted about this. We didn't agree, but
Oh, dude, we could go into low Earth orbit, bro. But the 10 to the negative 17 tour out past the moon where the atmosphere ends, you know, and a lot of people don't even believe we can go into low Earth orbit, but that's as far as they've claimed to go, man. And we see the rockets take off, turn at a little bit higher than the planes travel, you know, maybe a little bit higher than even the spy planes travel. That, and then they go sideways. You see them go down, you know, whether they're going away and down. You know,
down. Nobody's ever seen one go down unless it crashed off the launch.
I got one going parallel with my wires out front, and I'm at the front door, and the wires are right to left, and you see it pretty much. You know, it's definitely not going up. Let's say that.
To be clear, then, so when you said you verified it, so you said there's two ways to do it, and you picked the one where you just sort of think about it and make sure it doesn't conflict with any other ideas you've thought about.
Well, I mean, right. So if you have a basic understanding of how rocks, right, the weight of rocks, and you have a basic scientific understanding what rocks are made of and how much they weigh, and then someone says, you know, a rock fell off my house onto my car and didn't leave a scratch, and it was the rock was 1 foot across, you would know they're telling you a story because you have a basic understanding of what rocks are. And the same thing about, you know, the various other topics. Not everyone's going to study them.
That's how we feel about the heliocentric model, bro.
Accept that few people are going to do that sort of level of research. Just
you gave a perfect example of how we feel about the heliocentric model. There's no demonstration at all. It has nothing to do with real life. When we look at vacuums, we know there's nothing around it with pressure. You know, try and make a freaking pressurized ball in the middle of the Ohio Sandusky vacuum chamber, and that ain't near as big as the universe claims to be. I mean, it's just all kinds of stuff y'all can't verify and demonstrate.
You're already begging the question. Like, you're already arguing for the fact that space and then all of the stuff that they claim that you think that you have a basic understanding on, you're claiming all that to be true without actually verifying it in the first place, and then using that assumption of basic understanding.
That's hilarious.
Well,
hey, Fuzzy, when you're talking, I hear crickets.
Yeah, I'm walking the dog.
I said crickets. Sorry, that usually means. Never mind. Was that a criticism? Yeah, I mean, you can go with what you kind of understand and what you think is reasonable, and then plot it out from there.
Okay, but how is that verification? What you believe is reasonable is something different than what someone else believes is reasonable. So when you say you verify something, just because you find it to be reasonable is not suitable justification for any kind of claim of verification. What are you talking about?
Well, it goes both ways. So we discussed this a couple of days ago, or even yesterday, I don't remember. But the suggestion was made that globe skeptics charter a rocket of some kind and send something up to high altitude and see what's up there. If there's any detectable ether or whatever, what the atmosphere is like, and put sensors on it and figure out what's up there and send it as far as you're allowed to, you know, spend as much money as you possibly can.
We did that, bro, with balloons, bro. We did that with balloons. See the eclipse and prove there's no penumbra. The way the globe claims there has to be a penumbra, and we showed with various footage. And Globebuster set the balloon up. There's supposed to be this big giant penumbra the size of the moon, and it wasn't there, bro.
All right. There's no distance you're not allowed to go, by the way. But also, what you're saying?
Yeah. Something about the penumbra. I don't know what he's talking about.
I don't know what that was.
But again, so you don't have actual verification.
I'll tell you what I could do. I could go and verify it.
Well, no,
and
but that's
that would be very easy to do. But then, but what would change?
You said you said you can go as far as you're allowed to, meaning that someone else already has done this information in your mind and is allowing you or disallowing you to go into certain places. How is
You
that?
can't just willy-nilly send up a rocket.
Yeah, but you can go as far.
But that's the problem, is that, right?
Is it a problem?
Well, that's part of it, because if I wanted to go verify something myself and they say, oh, you can't, you have to go through us in order to do that. Well, wait a sec. Aren't you the ones that are telling me? So they are both they have a monopoly on the information and the ability to test that information.
You can go as far as you want. If you're going to send a rocket into the airspace, big enough rocket,
Yeah.
you're going to need to let the FAA know, or sort of the local, airports or something like that. Because you're going to be in the airspace that's a lot of other people are moving through. So you can't just go up with a big enough rocket unannounced. You're going to raise some flags. But there's no what if you were allowed to launch your rocket, like you can launch that, and you weren't going in orbit around places that people don't want you to go to. There's no limit to how far you're allowed to go. You can go as far as you.
Right.
You have a
We
rocket,
don't
go all
need
the
to
way
send up rockets, Coach. We looked at the Soundly rockets, the Go Fast and the Amateur, and at 70 miles, which is as far as they've been able to make it, right around 60, 70 miles, and the temperature was negative 471 Fahrenheit, man, which is right near absolute zero, which is right where helium turns into a superfluid. Helium's a gas that goes up, and we wonder what happens with other things, what with other temperatures. What happens to hydrogen at absolute zero? But I'm just saying, once you get up there, shit, they can't go no higher. So how can I think I could get a rocket higher than that if they can't get no higher?
Go ahead, left lane. I think left lane's going to say something. I
Oh,
guess
you would say negative 400 and something degrees Fahrenheit. That don't sound right.
I'm sorry, it's negative 271 Celsius, and it's right by absolute zero. Yeah.
Regardless, though, that temperature for the superfluid, I think it depends on the pressure. You can't just get it at any pressure.
Yeah, you got to have a damn near perfect vacuum, bro. Damn near perfect vacuum.
It has to be capable of turning into a liquid first, which I don't even think it's going to do at those pressures. So
you got to have a near perfect vacuum to even get that cold of a temperature to begin with, and that's what's up there. A low pressure, but I don't think the pressure ever goes lower than that, bro.
You don't have to have those temperatures.
Yeah, gases will liquefy under pressure, not under vacuum.
Yeah, we'll look it up. That McToon argued the same thing until his own guy corrected him during the debate. So look it up.
For them to get helium to go to a superfluid, they have to continuously squirt it out of a spray. So because it's gonna cool down as it's going to that spray, and then they do that until it is liquid, and then they do that even more until it turns to a superfluid. But that's in our atmosphere. I'm not sure if it works the same way in a vacuum.
That you have to have a damn near perfect vacuum to even get them low temperatures. And listen, that's what they're trying to reach. Every year they get a little bit closer, hitting another decimal place at a perfect vacuum and a perfect absolute zero and shit. And but how could they ever hit an absolute zero if it just keeps getting more and more exponential, man? You can never get to zero if it just keeps cutting in half. They get half that gas, half that gas. I'm just saying.
Kind of gotten off track a little.
It's fact. Well, superconductors are pretty cool things, though. And I've seen plenty of superconductors. I know some of them can be in a vacuum, but most of them they're not in a vacuum. They exist also not in a vacuum. So neither of them have to be in a vacuum. I don't think a superfluid like helium would work.
How would you confirm that it's a superfluid up there?
Here's another funny thing. Well, it's just what happens at them pressures and temperatures, and we know how helium. A lot of it gets mixed in, but we know a lot of it floats up the highest, and what's up there the highest that's the temperatures we've seen with actual amateur rockets with real information. That nobody was trying to hide or that's what was up there. And it's just a speculation, man. I'm just saying, this is what I've seen in the lab, and this is what I've seen up there. So, just kind of a speculation. It's frictionless. So, and like Rakia mentioned, he brought up a paper where they're saying that space it might be a superfluid. It's
Yeah, but
frictionless. It's zero viscosity, so it would be the same as like your vacuum in that aspect anyway.
there isn't a paper that says that. It's a hypothesis that's worked on by a handful of dudes, like literally a handful, a couple dudes, and these dudes also don't have a description of what what the substance is that is actually a superfluid. So it's not really it's not a complete idea even.
Well, according to relativity, like they did the Einstein or the Higgs boson or the Higgs Einstein condensate, and that was like for a microscopic amount of superfluid. They predicted it, but they didn't predict it. I mean, come to find out, we can make it on a big scale with more reachable, realistic temperatures. It's not the crazy fucking pressures that they were talking about, and to get microscopic amounts. They're making this shit in the lab nowadays. It's shit's progressing, man.
Yeah, I know.
So to
I made a superconductor in school with like a magnet, and it's pretty cool, but it's not. It doesn't allow for the things that you're describing. But
Just the nitrogen itself is cool, man. It's like as long as you keep air away from it, it'll stay fucking frozen or whatever you want to call it. It's super cold temperatures. It's the air. It ain't even. You could have it hot. I mean, you could have it in a pretty warm container. As long as you keep the air away from it, it'll stay fucking that cold, dude. I mean, ain't that neat in itself, man? It seems like a whole different kind of physics to me.
that's not true though.
No, they keep them
It is true, Kosho, because we fucking tax the shit.
Wait, so but we're a little bit we're kind of we're a little bit in the weeds here, right? The whole point was this: so you can't verify the distance to the moon by yourself. You haven't done that. You just did a thought experiment based on what you think.
It's something that
based on what they told you.
Yeah, no, it's
Well,
they, but civilians have done it. And then the other thing is, I could personally do it, but the question would be, what would that change?
Yeah, Kosho said he did it.
I've done it in two different ways.
Triangulate it. Just use parallax and triangulate it. It's a few thousand miles away, man. Anybody can do it.
It doesn't make sense to do that.
Told to you and actually going and laying a tape to actually verify it is different than someone else just following the same footsteps of someone else's assumption.
That's an extraordinary requirement.
Yeah, we don't even do that with distances on Earth, but with the distance to the moon though, I used the eclipse in 2019, and I got I forget, I think it was like a couple thousand miles off. It was actually pretty close.
How did you know? How did you get the right answer to know that you were off by a couple thousand?
Because I got the answer that just like I told you before, the predictions that I wasn't using the numbers I already knew. I knew the distance. I was starting from scratch and using the eclipse and the time.
You just said, I know. I heard all of what you said. You said you were off by a few thousand miles or whatever you said, and I'm wondering how you know you were off by what's the correct answer? How do we know what the correct answer is?
I of course knew the right answer, but I didn't use that in calculating.
That's what I'm saying. How do you know what the right answer is? What is the right answer, and how do we know that's the right answer?
You found the laser up.
Yeah, if you use multiple different methods and they all come up with basically the same answer, then it's more than likely that those answers, if they agree, are probably true. Now they still
just your common sense, bro.
They could
look
be
if you just look at Aristarchus crater, man. Sorry, I thought you did.
Okay, sorry. Thanks, Brian. If they all conflict, then you've got an issue. But if they all agree, then it's more than likely. And they could all be wrong, but it's more than likely.
Well, but more than likely, that's not how science works.
Yeah,
I try to time it out when I think someone's almost done. I'll try to time it out, to kind of jump in right when they're ending to give a quick little comment.
Somebody else gets to talk, and it's frustrating.
Yeah, but when I get used to somebody, if I'm not used to them, I'll quickly back away, man, and hopefully not upset them. But
it's difficult in here because you can't see people. You're blind. You can't see when someone's about to talk. You can't see when someone's about to push the button. It's just difficult all around. So doing the best we can.
You get used to people though, man. But I just wanted to make one point, Kosho. Like Aristarchus crater, if you do the math, okay, by the distance you give me, I do the math and it comes out to like 0.011 something but we can see it with the naked eye, Kosho. So your calculations can't be right just based on Aristarchus crater being able to be seen with the naked eye, man.
Yeah,
Isn't that right
0.01.
within the limit? Yeah, that's. Go ahead, Les.
No, I'd say 0.01 is within our limit. It's not outside the Rayleigh criterion, right?
That's
Yeah,
exactly like that. There's a range to like the best people, the best site, and also it changes from morning to night also. But regardless, there's a range, and that number you just gave is right within that. It's like either at the limit for some people's range or right within some people's range. So it's not an impossible limit. The
it's
number.
outside of the range, man. It's not way outside the range, but it's outside the range.
But not everyone has the same eyesight, and you don't have the same eyesight from morning to night. So the range is actually fairly big, even you go to the most extremes, and it's not beyond the most extremes. It's maybe outside of some people's range in some parts of the day, because some people they say it's only 0.002 or 0.02.
That's how they should grade our vision, bro. Instead of 20/20 vision, we should have like you got 0.02 vision, man. You got perfect vision. You can see all the way to the Rayleigh criterion, 0.02, 0.02.
Well, that's different though, because that's just based on your pupils dilating.
I'm just joking anyway, man.
Yeah, but that's why it changes from morning to night, just because depending on your lighting and stuff, you higher or lower.
Anything under 0.02 though is almost nothing at all. The human eye can't distinguish without aid.
That's at the edge of our limits, but that's not the impossibility, and neither is the number right below that. It's also within the limits of certainly some people. Just like there's probably some people who can't make that distinction. Aristarchus. Points like that aren't really. I don't think they're good points because they're right on the cusp of either of us could be right at that point. My internet's bad right now. I don't know if you guys should stop talking or not, but I'm gonna assume you did for a
I was
second.
wondering the same thing, dude. But now I think everybody's.
No, dude. Hey, hold on. No, we just don't believe you, dude, because you do coke.
I was only.
No, hold on.
I was only saying that.
We don't believe you,
hold
dude,
on,
because
man.
you do
I
coke
was
with
only
fat-
saying that. I was
fat
only
guys.
saying that to as a precursor to what I was about to say. I was like, okay, well, I'm gonna use this opportunity to ask this question because I was thinking about it before. I've never heard this before. Maybe you guys could think about it and tell me what you think. But back when they were trying to figure out the distance to Jupiter, for instance, if you know Kepler's laws, and you know Newton's law, then if you see the orbits going around Jupiter and you see the time it takes for them to go around there, then you should be able to get the general distance for all those moons from Jupiter, and then you could just use that and extend that to how far Jupiter is from us. I was wondering. I never
Yeah,
heard
like
anybody
nobody
do that.
else has ever thought about that, bro. Dude, you're over there doing freaking coke off a fat bald guy's freaking cock. Come on, bro. We can't take you serious.
What?
Yeah, I'm not
Yeah,
sure.
dude, you didn't hear? Tell him about your story, dude. It's your story, man.
Yeah, I don't find it easy to argue with someone who might be intoxicated right now. But what did you think about what I had just said, though? About measuring it that way? You think anyone's ever done it like that? I've never heard anybody
with
measure.
fat, white, bald, old guys, dude. And doing cocaine. Sorry, never done that, dude.
Well, what's going on here?
Well, why don't you let Kosho tell you all about it?
Well, we don't.
I've heard Kosher. That I'll stick up for Kosher. I've heard his voice, man. I think he's more of a Xanax guy, man. I got to stick up for him.
I mean, anyhow, do you guys see what I'm saying though about the distance? Because if you're traveling, if an orbital period is the same, so it doesn't matter what your mass is. If your orbital period is the same, you're gonna always be at the same distance from that object, depending on its mass. So any object on Earth that's orbiting the same rate, like every 90 minutes, if it orbits the Earth in 92 minutes, then it's the same height as ISS.
Man, come the fuck on, dude. Gee, man.
Yeah, dude, how can we take you serious? You're over here trying to compete on who has more saws than God's scalpel. And you're trying to show all, like, dude, like, we already know your angle, dude. You're just trying to present whatever thing is going to be as most credible and most believable, and you want everybody just to believe you, dude. But based off of the things about doing cocaine with a fat, bald white guy, we can't accept anything you say anymore.
The funny thing is, every other day I get so confused because I can't remember if the other day you came in as a flat earther or a glober. I feel like half the days you come in as a flat earther, and the other half of the days you come in as a glober. I don't know if that's just me getting that confusion.
Is that your comeback, Kosho? Is that the best you can
It's not.
do?
It's not a comeback because I don't understand what his angle is right now. What I don't understand where he's coming from, and that's kind of my point. Is I don't really know what his motivations are when he just says anything he says.
Well, everything you try and present for like globe proofs, like, don't you think if we looked at the orbits of Jupiter and we timed it with the amount of time it takes for the orbits to complete, wouldn't that tell you? Like, no, we can't take you seriously because you do cocaine off the asshole of a fat, bald white guy's hairy butt.
Right.
Yeah.
So I wasn't using it as a globe proof.
No, I muted the guy. I don't know what he's attacking you over or why he's saying all that shit, but I don't think that's welcome tactics here.
That's all good. In Canada, I started drinking a little earlier, but it's not important anyways. Yeah, I wasn't using that as a proof. It was just something I was thinking about during our discussion. Because we always talk about like the measurements, how we got the measurements to certain objects like the sun originally or Venus originally. But I would think that just based on observing Jupiter and its moons long enough, and then also the orbits, the orbit of Jupiter as well, you'd be able to tell its distance just based on the size of the things. I mean, the distance of the things that are orbiting in.
Well, how so?
Like I said, things will orbit at the same distance. If they're orbiting, if it's going around Saturn every 14 hours, two objects, then they're actually both the same distance from Saturn.
No, how so? How do you reach that conclusion? Is there no other No, that's how you're dictating it to work.
That's if you're using gravity, man, and Kepler's laws in gravity. If you prescribe to that, you could make that claim. But that's a hell of a claim. I mean, I guess within your model. But even within your model, there's probably like the angular size of Saturn, like when it's on the other side of the orbits. They're at distances where you try and call like stars point sources, and you even try and throw in that argument a little bit with planets and shit, man. It's like, I mean, you got a good mind, you got a machine head. You should be able to fucking challenge some of these fucking claims, man. You need to get some telescope time, Kosho.
Where are these anomalies cropping about? I haven't heard of any of these anomalies that Brian's talking
Really,
about.
I just said one, bro. Aristarchus. Okay, the human eye cannot detect anything under 0.02. Okay, especially not 0.01111. Dude, that's beyond the capability of the human eye, and you can see Aristarchus crater with the naked eye.
That's not true, though. You invented that.
Bro, you cannot
not the limit of
see
human.
something 0.01 degree and with it. Oh my god, dude. Why are you acting like it's just perfectly within normal vision? It's not, bro.
That's right about the limit, and that's from measurement from testing people. So they've tested people. People don't have the same range. So this is a general. So they're saying on average, this is about as the lowest resolution your eye can see. They're not saying that this is the absolute lowest resolution your eye can see, because there's going to be people outside of those norms. There's going to be people who can see significantly less, and people who can see a little bit more. So
there's nobody who
it's
can
not
see.
impossible. It's not impossible to see something smaller than 0.02 or to get better resolution.
Yes, it is, man.
I could show you those. I saw those. I read those papers a while ago, but I think we've probably all seen them. I don't know. But in that paper, it shows that there's people who could see better than other people, like better than 0.02. I think that's just the mean, like that's the average.
Yeah, that's based on 20/20 vision, right?
Some people have better vision than that.
20/20 vision was that.
Yeah, but Kosher, we could all see Aristarchus greater. Anybody with decent vision.
Are you sure about that?
Anybody with decent vision, yeah. Anybody with decent vision. It's that fucking crazy looking circle right by the dome.
Yes. Yeah, clear vision, you know? By cutting the lines into troops, like a digging like a hole or something, you know? So it's like you're like, for example, your Amazon rainforest, a bunch of light, you cut the rainforest up. It's a bunch of lights, the rainforest,
Okay.
Water, the ocean, yeah. For that.
Hey, I'll say the moon is weird, y'all, though, dude. I've spent a lot of time looking at the moon, it's so weird, dude. You look at one side of it, and you're like, man, that bitch that's a disc, or even looks kind of concave. You look at the other side, that bitch look just like a ball, dude. It's crazy, dude. From one half to the other, it's always the same too. Like no matter where it's at or where I'm at, orientation. That one side, dude. You look at the edges of it, man. You swear it's flat or concave. You look at that other side, it's unmistakably a ball, man. It's something else, man. I don't believe that, like
The
in my opinion.
Well, yeah, your mic's like, so it's their frequency because we're telling the truth. So
I don't know. I would say the moon for me is one of the examples that destroys the heliocentric model. The observations of the moon, like the moon phases, for example.
The moon's a model killer, period. Not just heliocentric model. The moon's a model killer for every model.
Yeah,
elaborate on what you're saying about the phases.
I spent years. I spent years actually observing the moon for myself, and I've seen crescents when I wasn't supposed to, according to your guys' model. And I've seen full moons that would be impossible to observe according to the globe model.
Have you tried to catalog these anomalies?
Have I tried what?
Catalog the anomalies.
Catalog them, as in
view them and
document them.
I did view them
and photograph, and then
they've been cataloged.
I photographed, some of them. Yeah,
if you were, bird watching or something.
I heard the Royal Astronomy. The Royal.
Hey, Egypt. You said something about the moon, right? What was it again? I missed it. Would you mind
I was going to say
repeating
I said something about the moon, but the Royal Academy is documented seeing stars twice through the crescent moon, and look at all the other countries' flags to back that up. Anybody who doubts that, look at all the countries with flags showing the crescent moon with a star. That's like that's an old. I don't know, man.
Hey, you know what? One planet that might represent like a sphere or like globular objects would be Saturn. Have you
So
ever
the
looked at Saturn?
It looks
so
fake
on
to me,
the
man. I look at that bitch
on
and it looks fake. It's like it's equally bright.
Saturn
Even
looks
the rings
flat.
are the same brightness. It
How
looks
can
like a light
Saturn be
bulb.
flat?
Looks like a deformed light bulb to
Saturn is
me.
not flat.
it's
Dude,
I didn't
there's an orb with a ring
Oh, I
around
said it
it.
looked
Come
fake.
on,
I said it
dude.
looked fake, bro, not flat.
Who said Saturn
Oh,
is flat?
fake. Oh, I got it. Ah, I get it. When they can't explain something, they just call it fake news.
Who
No, no,
claimed
no. It looks.
I
This
can't
is
tell
what I
right
mean
now.
by
Saturn is
that.
flat?
This is what I mean by that, bro. It's all uniformly lit, even the rings, and it looks like a light bulb, like a fucking deformed light bulb. They don't even look like rings, but you could say they're rings, you know. But it's
I never
uniformly
seen
lit
it.
in a weird way, is why I say fake.
It's
But
not
it's there. I
uniformly
don't think it's
lit.
fake. I'm seeing it. It's there.
I don't think it's uniformly lit, man.
Okay, well look,
Well,
its
Maybe
moons.
it's
Its moons are
is.
brighter than Saturn. Its moons are brighter than Saturn. They're little pinpricks of real bright
Yeah,
light.
mine's brighter.
Same thing with Jupiter, man. They're little pinpricks of real super bright light, and Jupiter itself is like a dull looking fucking. It's bigger, so obviously it's brighter. But
right.
I'm like the phase of light.
Yeah,
It
it's
just
like
the little polka
But doesn't
dotted
that make
moons look
sense?
brighter to me.
You just kind of explained
it's
it, though.
brighter.
You just said why that happens.
Yeah, maybe
It's
so.
obviously not brighter than Jupiter, as you just said, but because of its size, in comparison to Jupiter or Saturn, for
And
that matter,
hotness.
it's going to
Yeah,
appear to
you
be
know what I mean.
brighter.
Yeah, you're
It's going
right.
to appear
But
to be
they look
brighter,
like kind of like
but you just said it. It's not brighter.
Yeah, I did kind of explain it, but they look like little super bright stars, like little sparks or little tiny stars. The
Yes.
moons. I see them there, but they do look different. I'll say that.
so on the moon, if someone wants to really study it and then provide some, cataloged information about
I
what we
got
propose is going wrong with the moon or isn't
got
consistent with our model, and I would like to see that.
Well, the two things.
Yeah, I
Okay.
got
So
confidence.
can I ask? How do you think the moon phases are caused? What's the cause of moon phase? Why do you observe a crescent moon versus a full moon versus a half on a globe model? What causes that?
I think it's like my crazy theories like my own opinion, I think it's like this the yeah, like I'm a little crazy. I think there's a second sun and under Earth because I'm starting by a lot there's a second sun. It's like so and like it started with World War II, so I don't want any like
Okay
things.
then.
Yeah. I need to stop.
I hope he's a Glober.
No.
I'm not Glover, dude. I'm not Glover.
That was
I
funny.
study physics, okay?
So
I know
it's
physics, okay? So
it's
water
how
physics.
how the moon is lit by the sun. It's the sun lighting the moon.
Well, I was going to tell you, Red.
If you want to hear a problem with the moon and why it's a model killer, I'll tell you one if you want. Let me know.
Well, I was just gonna say, I'm not gonna not say very long, but I was gonna tell Red Cloud that it's funny, the two uh observations that he just described, and not as he called them anomalies, those are two well-known I guess you'd call them illusions. And one of them, I guess you'd call them illusions, really. But
Yeah,
then there's
World War
another
II and the Black Sun. Yeah, I agree with him. Everything he said.
Oh,
To be honest.
no. The two things you mentioned about not you. Whoever
Joking,
mentioned
bro.
yeah, whoever said the Sullivan eclipse is one observation, and the other observation is the crescent moon when you're not supposed to see it. Those are two problems with the moon, but both those
And the full
are well
moon.
known.
And the
Those are
daytime
well
full
known.
moon. Coach, I lost you, man. Is anybody talking?
No, I told you I was only saying that one thing. I was letting he because Red Cloud was asked, was like saying, you know, you should definitely observe, you should have to record that and all that type of stuff. But those two things are well known and they have simple explanations, but they're just basically illusions.
I always model shit. I went and got a real globe, you know, and I always model shit. Like I had to check the umbra penumbra. I took the fucking I took and modeled it, man. I scaled it off and I walked down the road with the fucking with a little picture of the Earth, and I got a ball that scaled perfectly, dude. And I got a lot of kids, so I had a lot of balls to choose from. So I scaled it almost perfect, man. But I had to go way down the fucking road, and I had to use 2 lasers to get the width of the sun. But one of them went out, dude. But I want to redo it. But to try and see the umbra penumbra. And what was funny is I made a video out of it too, but it's kind of old. But it looks, dude, it looks so weird. The laser and the ball blocking the fucking laser light. It looked just like an eclipse, bro. It was funny in real life, dude. It was eerie looking, dude. It looked just like an actual eclipse, man. It was cool.
But how can you mimic the sun with a laser?
Yeah, that's where you went fucking way wrong, bro. That's the opposite of what you need to be doing there.
Well, I was just trying to mimic the size. Like if the size of the sun, you know, I couldn't really scale that, but my idea was to spread the 2 lasers out to and walk down the road like about, you know, it wasn't like a quarter mile, but it was a ways down the road, man.
That's the point. In this scenario, the sun is much bigger than both the moon and the Earth. And so
that's why I have them closer together, bro.
I know. Hold up. The problem with trying to recreate the umbra penumbra, that works specifically because the object that's giving us light is coming from a size that's bigger even than, you know, the whole face of the Earth or the whole face of the moon. So
right. That's why I spread my lasers out way bigger than the face of the Earth, bro. And the divergence joins them. You know what I'm saying? It was a decent scale job. It wasn't perfect, but it didn't matter because one of the lasers fucking went out anyway. But look, I tried to scale the fucking selenium. You know, I got my globe out and all that, and I'm trying to just scale just to see if the fucking angles could work the way that people tried to show me, like if the sun was angled fucking in the moon, and I was like, man, you know, maybe, you know, it's not really working with string line straight distance, but if I said the distance is further, maybe I might be able to get the angle. But then looking at the video, the fucking shadow came in from the wrong side as if that shit worked, man. It's a model killer, bro.
But wait, Coach, what did you say the explanation was for seeing the crescent moon when you're not supposed to?
Well, I didn't say what it was, but I'm saying it's a well-known illusion. But I think that's the Terminator line illusion, and it's just it's a trick of perspective that does it.
Okay, and then the selenium, same thing, optical illusion.
No, that's not an optical illusion. That's I said that, but that's actually not an illusion. It's just refraction. It's like the same reason why you see Chicago when you don't usually see it. Now you see it, and that's the same thing with the moon and the sun. We all know that when the moon and the sun are on the horizon, or when they're below the horizon, that it's moves slower. And we say that happens because it's not moving slower. It's just being refracted upwards.
Yeah. Are there any other possible explanations?
I'm sure there are other possible explanations. I never heard them, but
can you think of any other possible explanation why the eclipse wouldn't match the model?
Well, I mean, in our case, it matches the model, but I can think of other reasons.
No,
I guess,
it doesn't, bro. No, it doesn't.
Yeah, it doesn't match the model. So is there any other options? Like, is there any other possibilities as to why it wouldn't match the model?
But why are you saying it doesn't match the model? If it matches the model of refraction of where it's supposed to be, it's like 1 degree or half degree below where it's supposed to be.
It doesn't matter, bro. If you got the sun and the moon fucking above you, you're not standing on top of the ball. And even if you tried to refract it, the shadow couldn't possibly come in from the top, bro. If I'm standing on top of that ball, there's no angle you could reach, even from below it, that's gonna get the shadow coming in from the top, man. It's not possible.
Maybe you could use stellarium to model that out.
Well, actually,
is there any other possible explanations as to why these observations don't match the model?
Stellarium don't work, bro. Stellarium don't
match the model. They do match the model.
No,
Stellarium uses refraction, bro.
It's a geometric impossibility. So just
there's verbal evidence or what's the word when someone sees something? There's observational or whatever, circumstantial, whatever you want to call it, testimony. There's individuals' testimony that something doesn't match the model, but we need
No. This is a well-known and documented observation. So thank you for your completely unrelated response. But what I'm asking is, I understand that your model has an explanation as to why it appears that something happens that debunks the model, and it's just optical. But is there any other explanations as to why what happens doesn't match the model?
You're reiterating it doesn't not match the model.
You can't even think of any other possible explanation.
If you could provide evidence that it doesn't conform to the
If
model.
the moon is coming down if the moon's coming down into the Earth's shadow, the shadow couldn't be coming from the top. I tried to model it with a globe and string lights, all that shit. Don't work, bro. Trust me.
It definitely works on a globe, but no. But what's his asking? That's why I answered. I told you there probably certainly is other explanations, but because I've never heard them. Nobody here's bringing them up. So yeah, there probably is other explanations, and maybe they're better for all we know, but they're outside the reach of any of us at this point.
So can anyone think of any other possible explanation as to why the observations wouldn't match the model? It seems like a really simple question. No one?
Yeah, the model's wrong.
Yeah, why can't they say that? Why can't that come out of their mouth?
Because
that question is malformed, man. As I told you,
it's a gotcha.
No. It's not a gotcha because this doesn't prove one way or the other. So it's not a gotcha. I'm asking you to be intellectually honest for once in your life. It's not a gotcha.
That's a gotcha, and then that's ad hom.
How is it a gotcha?
It's a possibility, bro. It's an honest possibility.
Let me respond. First of all, you need to stop using the word ad hom if you don't actually know what it means.
If I'm talking with your assessment, that doesn't mean that I'm dishonest, which is what you're implying.
Hey, listen, buddy. An ad hom is when someone's argument.
I'm not interested in that.
I think I was talking, but hey, who is this guy? Who is this guy? Stop
to say
interrupting
that
so
you're
much,
wrong
man.
because you're lying is an ad hom.
Okay. I didn't present an argument as an insult. Okay, so I did not present an insult as an argument. That's what an ad hom is. I didn't say you're wrong. That's also another lie. Me telling you that you're lying when you're lying isn't an ad hom, nor is it my argument, nor am I even
this
making
is rhetoric. This is what you
call who's this little gamma that
this
can't...
is what here we go. I was wondering how long it was before I heard you say that.
Yeah, you're a gamma
Austin, I
male
thought you'd
because
changed. I was wrong. Bye.
Well, you're acting like a gamma, right? I'm not even making an argument. You guys are just ridiculous, though. So I'm not making an argument. I was asking to see if you guys could be honest, right? So we have an observation that geometrically does not match the model. Now, that means if what we're seeing is actually where the bodies in the sky are, then it wouldn't match the model. Now, I understand that your model has since come up with an explanation that they're not actually where they appear to be. I understand that. That's all great. I'm asking you guys, is there any other possible explanation why the observations don't match the model? How is this me making an argument?
That was the point, though. I'm not saying you're making an argument. I told you that it's very possible that there is other explanations that we don't know about for some, because we don't know about them. But what you're saying, though, about it not matching the model, and that, and so is there another explanation for why it doesn't match the model? But it does match the model. There was no ad hoc explanation made after the fact. Like that was, we always had the same explanation.
Okay, so the answer, of course, that you guys don't want to say is we have two options. One is it's not actually where we see it, and it's just refraction, therefore the model stays intact. Or option number two is it is where we see it, and that would debunk the model. Do you agree?
Yep. We already understood the sun as being out of position because of refraction. I'm not sure if people were confused before knowing that. So like I said, it slows down at the horizon, so they know that it's if they know that you're going to get the Solennal eclipse, then if they know that's going to be refracted, I'm sorry, then they know you're going to get a Solennal eclipse. So I don't think that it's.
Is the light from the eclipse? Is the light from the eclipse coming in above the Earth? If I'm standing on top of the Earth and I see the sun on one horizon, the moon on the other, in the moon's setting, okay, is the is the light coming from above the Earth or below the Earth?
Yeah, the light's if it's gonna be perpendicular to the Earth, so it's gonna be perpendicular to your up or whatever. So it's gonna be on the whenever it's eclipsing, there'll be a part on the center axis of the Earth. So technically, you shouldn't be able to see it. However, it's being refracted upwards. So at that moment, if you're in the right spot, both objects are exactly where they need to be both be refracted above the horizon.
Right. So if it's been refracted
So the
upwards,
moon's
you can
moving
just
into
test
shadow, right? The moon's moving into shadow as it sets, correct?
You can look at it on Stellarium and
Just a
set
simple
yourself
question,
off
bro.
into space, and it'll show you what happens.
Yeah, you can look at it on a computer program that reifies what I'm actually supposed to be debating, and then that proves I'm right. What a very valid contribution to the conversation.
So the moon's moving into shadow, right? The moon's moving into the Earth's shadow. It's as it sets, right?
Yeah, that's right. Well, not as it sets. I
If
mean,
it's
just
moving into the Earth's shadow, how does the shadow come down from the top, bro?
Oh, it's just
it
magic.
It can move. It can move into the Earth's shadow from either direction. It's not. There's no rules against which
That's
direction.
why I asked you: is light coming from above it or below it? You even raised the sun and said that it's coming in from perpendicular, which would be above it. And even if you refract the sun, bro, how much are you refracting it, man? Because they can surveyors and cosmologists consider the horizon 0 degrees. Okay, and if it's 1.5 suns above the horizon, and I mean, just how much are you trying to refract this thing? But no matter what you do with it, if it's moving, if the moon's going down into the Earth's shadow, the shadow's not going to be coming from the top, bro. If I'm looking at them both from the top of the Earth, the rest of the Earth's got to be below me, right?
I've got a legit question. Is the Selenalian eclipse at sunset or sunrise?
It's either
sunrise.
Whenever an eclipse occurs, there's going to be half the places that are going to experience it are going to see it at sunrise, and half the other places are going to see it at sunset, and it's going to be the people all along the Terminator.
Yeah, I thought I saw it at sunset.
That's a good point, dude.
I saw one recently at sunrise.
Yeah, it happens at both. But so is the refraction like? So do we never see the actual sunset? It's always just the refracted sun.
I don't know if there's no hard number, but the most consistent number is a half a degree out of position by the time it's at the horizon. So I would probably say that, yeah. I mean, I don't imagine anyone's. Maybe on some freak coincidence where refraction was such that it gave you the observation as if it weren't being refracted, but I bet you that's probably not really been experienced.
So to maintain this idea, then if the Earth's a globe, we never see the actual sunset.
Well, we don't see it unrefracted.
So the actual position, we never see the actual position of the sunset.
We just say the sun presents through refraction. It's still there.
But we don't actually see the actual position.
It's like the horizon deal.
Why is it that you don't understand words, or you're just being dishonest? Which one is it?
No, I mean, you're trying to word it where it sounds jacked up and it's all an illusion, but we see the sunset through refraction, which causes the sun to actually...
Which is by definition an illusion, Howard.
No, it's not an illusion. It's there. It's a real deal.
Well, no, we're not seeing the real deal. That's the whole point. That's why I said, do we ever see the actual position of the sunsets?
And people describing their reality to the best of their knowledge and the way they know it is in no way dishonest. And I wish you would say
No, what's dishonest is when I say, do you see the actual position? And then you say, oh, well, we're seeing the actual sun. Yeah, but it's not the real position. Then you're literally trying your best to not answer the question honestly, bro. That's called being dishonest.
I said we see the sunset through refraction. That's what I said, exactly.
You said we do see the real sun. It's really there. I said, so do we see the actual position? So you're not answering the question because you know the implications of it.
I don't know if it was difficult to understand the meanings of it. We've talked about it enough that I would think that it would just kind of be given that you would understand what we're saying.
Well, I understand that you're answering my question. Yeah, I understand it very well. There's a difference in actual and apparent positions, right?
Yeah.
Right. And so when I ask specifically about the actual position, if you then conflate it to the apparent position, which is literally the opposite, then that wouldn't be an efficient response, would it?
I don't think that you could be accurate in being definitive on the sun's location setting on the horizon because of refraction.
Okay, so is it always the same?
No, I would
So the
say
refraction
it's not.
changes?
Well, it depends on the conditions of the day, as Rakia says.
Okay, so it goes from like, what did you say, 0.5 degrees? What's like the range?
Kosho is probably more versed on the particulars and the numbers than I am. That's just I just have a general idea of the.
But yeah, I only know the general rule for the sun. I mean, for anything on the horizon as well. And that's when typically you see the things are the most refracted, and especially because those two objects are probably the furthest objects. So they're probably being seen through more atmosphere than anything else you've ever seen through the atmosphere. So they would, stands to reason they probably refracted, consistently and probably more exaggeratingly. So yeah, half a degree is consistent.
Thanks for letting me know the other guy. Anyway, thanks for letting me know that stellarium's not a geometric model.
So then what about when we see the lunar eclipse where the sun is not above the horizon?
Yeah, then you don't. What do you mean?
Is the sun not being refracted up then?
No, if you're in a position where you can't see the sun during the eclipse, and I mean that's most people.
Yeah, so the sun doesn't get refracted during those eclipses.
No, there's gonna be people. So during the eclipse, there will be a straight line going from the sun to the moon, and it'll be intersecting the Earth. And the people who are perpendicular to that line are going to be either sunset or sunrise, and so they're going to see. What are you saying? Yeah.
So wouldn't the eclipse have to come at a different time though? If the sun was being refracted on the horizon for some people, it'd have to be at a different time, right?
Yeah, that's people have different times. That's right.
Okay, but when I seen the stellarium, it was with the sun coming up. It was like 6:20 in the morning, and it was with the sun coming up and the moon setting. So the moon setting if this moon setting going into Earth's shadow, going down into Earth's shadow, the rest of the Earth underneath my feet, then the shadow couldn't have came from the top, man. I'm sorry.
But wait, my question is, what's the? Oh, sorry. Go ahead.
Well, I mean, this is very, very quickly. I don't want it to turn. I actually don't want you to respond to this, Brian. But the Earth rotates. Okay, that's one movement. The moon orbits around the Earth into and crossing the axis and whatever. So these are two totally different things. So the Earth rotating and the moon setting or rising and the moon moving into its position are completely unrelated. And so the
the rest of the Earth's underneath me, though, right?
Which direction it's coming from.
Okay, but the rest of the Earth is underneath me, right? If I've got the sun and the moon on the horizon, the rest of the Earth has got to be underneath me, right? Where else could it be?
Okay, so I guess you don't have an answer.
I know. I didn't even know if he had. I don't get to what the point was. The Earth's underneath you. That's true. I don't understand where he's going.
Well, the moon's above me. The moon's above me. Okay.
Now, Witz's question was: is the normal lunar eclipse is refraction happening there?
Well, I haven't got to ask my follow up. I'm just setting you guys up for you to. So how long is what's the time difference, right? So if the sun really sets, but it's 0.5 degrees lifted by refraction every day, then what's the time difference? How much longer do we think we see the sun after it's actually below the curvature of the Earth? Like how long does that take?
It slows down to somewhere closer to 11. So instead of 15 degrees per hour, it's like 11 degrees per hour. So if I would assume, since you're getting an extra half a degree, and there's 11 degrees per hour, it's probably something like that. I think it's like two. It's 2 minutes extra. That's what it is. That's right. No, that's right. That's why the night and day at the equator is 12. What is it? 12:50 or 12:56. I'm sorry, 12:08 and 11:52, something like that. And that time that it's the time that it's not perfectly 12:12 is because of refraction. So
So
it's
how
like
many
3
minutes, man?
like I said, 8 minutes. It accounts for that
Okay,
8 minutes right there in a given
8
day.
minutes. 8 minutes. So whenever I look at my weather app on my iPhone, it says the sun sets at 7:38, and I watch it set at 7:38. It actually set at 7:30.
No, 'cause when I said 8 minutes, I meant for the whole day. So if you're just talking about sunset or sunrise, about 4 minutes.
Okay, so if I see 7:38, then it actually set at 7:34.
Yeah. I mean, this is why they on Ramadan on the Burj Khalifa they have to have specific rules depending on what part of the building you're at.
Ramadan and Burj
Oh,
Khalifa. What the
bro,
fuck? What are you saying?
please let me finish
Yeah.
this. This is awesome. Have you seen what's happened yet, Kosho? Do you have any idea what my next question is about to be? It doesn't matter. Let me just ask it. It doesn't matter.
Well,
So,
yeah.
okay, so here's the question then. So during a selenilian eclipse, if I see the sun above the horizon for more than 4 minutes, then that refutes your refraction explanation, right?
Well, no.
Oh.
Yeah, because that's assuming that the moon and the sun are the same distance from Earth, so that the angles that you see them are the same. So what happens is, 'cause I was just doing the math actually, and when they're both not be able to when you see the sun or the moon on the horizon, they're both a half a degree out of position. So by the time they're below the horizon, both of them, you should still be able to see them. You should be able. That means that you're being able to see half a degree below where the Earth is. And if you actually look at our distances to the sun and the moon, by the time they're both at that perpendicular place, the sun is actually not even. It's like 2 thousandths of a. Is that 2 thousandths of a degree below the horizon. So it still has a lot more to go before you can't see it anymore.
Hey man,
What?
so you just said it would be 4 minutes, and so if I see a selenilian eclipse and after the sun sets, it looks like the sun's in the sky, and it sits up there for like 15 minutes, that would be impossible on your model.
What you're talking about during the middle of the eclipse, like right when it's directly in front of it, is one, and two, the two angles. So like I said, the two angles when they're perpendicular, one is 0.9 degrees and the other one's 0.002 degrees, and so you can actually move both of these around, and they'd still be able to see them in the range. Like the sun has a much bigger range than the moon does, so
The
I'm not
moon is
exactly sure.
literally
I'm not sure
irrelevant.
how many minutes.
The moon's irrelevant.
How is the moon irrelevant? What are you talking about?
We're not talking about the moon.
Well, if you can see both the objects, then you're talking about both of them.
No, we're just talking about the sun. No one's talking about the moon, so please stop bringing up the moon.
Well, there's people who can see the sun during the entire eclipse. So, in order to see a selenilian eclipse, you would have to see both objects.
That's not the point, though. Are you not getting the point? Does any of the other Globers want to try to answer? Okay, so maybe I'll try again. So I just asked if it's 0.5 degrees, and so we never see the actual sunset. We're always just seeing the refracted magical sun. Well, if it's 0.5 degrees and roughly 4 minutes of a difference, right? So that means that the sun set and we see it for 4 minutes longer, but really that 4 minutes is just an optical illusion. Then if we see the sun for 20 minutes, then you got a problem, don't you, Kosho?
No, that 4 minutes that you just described again, as I just told you, with those angles I gave you, it doesn't. It's not. You can't transfer the math over the same way. It's not going to be. It's not going to be that you can see it for only 4 minutes at a time. Like I've measured it before, but I've also seen that yeah, you're right. Sometimes the eclipse starts when the sun is above the horizon, the moon's already above the horizon, but the sun's well above it. It's because their angles aren't going to be equal because the sun's much farther.
Well,
So
the lunar eclipse can't happen while the sun's above the horizon, though.
Yeah, they can. It happens for most people on the Earth. The sun's still above the horizon.
You can't see the sun and the moon up in the sky. It's geometrically impossible in the globe Earth model. It's very simple. So your response is that we're not seeing the real sun. We're seeing the magical fake sun. So if we're seeing the magical fake optical sun and we never see the real sun ever in the history of mankind, and we've never seen the actual position during a sunset, which is what you have to say. Okay.
No, those are
Yeah, it is.
complete straw.
No, they're not.
I've never said you never seen the actual sun or anything like that.
Yeah, you never see the actual sunset. It's always being lifted up 0.5 degrees.
You see the actual sunset. What you're trying to say is you'd never actually see the position of the sun during the sunset. Like it's
Yeah, hence
actual
the word
That's
actual.
your claim.
Yeah,
Do you
but
not know
that's
what
not
the
saying that's not. But you're saying you're not seeing the. You're not actually seeing the sunset. You are actually.
Yeah, do you not know what the word actual means?
Yeah, whenever you see somebody swimming in a pool and you see them refracted, they're actually a little bit somewhere else. You're still actually seeing them. They're
No,
just
you're
being
not seeing the
refracted. They're in different positions.
actual position of that person, are you,
I agree.
Kojo?
I agree. You're not seeing the actual position, but a second ago you said you're not seeing the actual sunset.
Well,
that
that's
was
what
his claim.
we're talking
Here's the
about.
claim,
buddy.
though. Here's the claim. The claim is with the sun and the moon on the horizon and the rest of the earth's below my feet, that the sun is not really there. Therefore, the moon's getting a shadow. But if I can see the sun and my solar panels can measure fucking watts, and then why is the moon not fucking seeing the sun? Even whether it's there or not, how is it getting a shadow when I'm not getting a shadow? My solar panels ain't getting a shadow. The rest of the earth's under my feet. The angles don't work. I mean, it's a good try, bro, but there's no way to make it work in reality.
I mean,
This
I
is
would
very
say,
simple.
yeah, I would say you don't have to go to eclipses. I mean, just the moon phases themselves, and how they're caused on the globe model, don't jive with reality. I mean, I've seen crescent moons during midnight, which would be impossible. I've seen full moons during the daylight, which would be impossible, given the geometry, like simple geometry of the globe Earth and how moon phases are caused according to that model. That would be impossible. That would be given refraction, given everything, like whatever ad hoc explanation you try to push in, it doesn't work.
Was it
I don't
noon?
need.
Was it noon
Yeah,
when you saw the full moon?
not exactly noon, but just daylight. During the daylight, that would be impossible.
What time would you say it was? Like 1 p.m., 11 p.m., 11 a.m., or would you say it was pretty close to right after the sun came up, or pretty close to before the sun went down?
No, I'm pretty far away from like sunrise. close to midday. Yeah, close
Yeah,
enough.
I've seen the full moon in the daytime right around lunch. I actually have it documented. That was actually at
It's
NASA's
even
launch
worse
facility.
in the morning or the evening.
I like to see those pictures.
Okay, I got you. I did it with my
But
P900
just,
at NASA's launch facilities.
I just want you to be clear, though. You said a full moon, and you said midday, and so I'm assuming midday. You mean
Yeah,
2
it
p.m.
doesn't even have to be a full moon. I mean, close enough.
Well, no,
to
it
full
does have to be
moon.
a full moon for this claim to sound unbelievable.
No,
If it's not a full moon, it's no longer
Close enough.
unbelievable.
Well, given the way you understand how the phases work, right?
I do.
So let's say a 98% full moon. That would be like enough, like to consider it as a full moon according to its position and viewing it during the day, like a
Yeah,
midday.
I'd call it a full moon. That's right. I'd call it the
Yeah, given the angle, like it's angles, correct? I mean,
Yeah, but what's your my point is that I'm just doubting that this observation is just taking place. Like I said, if it's something different than a full moon, like not 98%, but something maybe it's getting close to a full moon, and you're seeing it closer to lunch or not at dusk or dawn, then that's not something I'm saying is unbelievable. I'm saying a full moon.
yeah, you still need
during
refraction
lunchtime is
to
unbelievable.
explain it, correct?
No, I don't think that's explainable by anything. I've never heard of somebody. Unless the only thing that explains that is if you're at some extremely north or southern latitudes. But other than that,
Yeah, but how can there be a full moon with daylight, bro? It just on its face, it's messed up, right?
if you're close to sunset or sunrise, then it's not that crazy.
Not that crazy. We every time we see something that debunks the model, we just have to say the R word, and that means what you see isn't real.
Oh, as I told you a second ago, the sun, but based on our model, being at its distance, from that distance, whenever it's perpendicular to us, it's 0.0002 degrees below the horizon. So it's barely it can move a lot more and still
No
be
show.
visible to us. So
You're
it's
saying that hold on, you're saying the refraction is allowing us to see the light for the full moon. It's the refraction's allowing us to see a shadow during an eclipse. I mean, what the fuck, dude? What is it? All this refraction's casting shadows. It's casting the light we need to see during certain circumstances. I mean, come on, man. It's a
Wait, Coach,
retake.
Coach, real fast, before I go look for this observation, so you agree that if I show you an observation I made where I saw the full moon in the sky during the day just after lunch, it debunks the globe?
No, I never said it debunks the globe. I said I don't have an explanation for this. This is not something I don't think has happened. You said this is in Florida, and this is
Yes.
right after lunch, and lunch is about, so we'll just call it 1 or 2 p.m. We're not talking about 5 or 6 p.m. and something that's almost a full moon.
No, it's a full moon, and it's maybe it's 2 o'clock.
Yeah,
But
like
I don't want to
we'll
go.
see.
I'm not going to go dig through my whole thing, find that SD card from a year ago for no reason. So if I go get it and drop it in here, you're going to admit it debunks the globe.
I'm not saying it debunks the globe. I'll be completely surprised. I have no explanation for it.
Kosho,
It doesn't make sense.
nothing.
But why would I say it
Yeah,
debunks the
nothing.
globe?
Yeah, nothing debunks the globe. Correct.
No, that doesn't debunk the globe. Debunking the globe is like actually like proving that.
Yeah. What?
If that debunks the globe, then how many godforsaken things debunk the flat Earth? You know what I mean? Like this is that
Wow.
one thing doesn't debunk the whole model.
Okay, and also to clarify though, so you said that it would be 4 minute difference. I'm wanting to know how long do we have to see the sun up above the horizon during a stellar eclipse before the refraction excuse doesn't work? How long?
I told you you have to do some calculated math here because the angles between both of them when they are both perpendicular. Let's say you are in the perfect position of them being eclipsing it at the exact time where they're both perpendicular to where you are. The angles would be 0.9 degrees and 0.002 degrees. And since the sun has 0.002 degrees and it's already there, that means it can be a much wider range from there, and you still see it because you can see it until it's half a degree out of position. So, yeah, I wouldn't know what the actual number during the stellar eclipse is. I just know what the number is during,
Do this math, Coach. Do this
extra
math.
length you see that sunset or sunrise.
Do this math on paper, not in a calculator. I mean, well, you could do it in a calculator, but draw it on paper. Okay, draw a baseline. The moon on one side, the sun on the other, just above each horizon. Okay, but from the middle of the Earth, draw a baseline underneath the sun and underneath the moon, and then scale the distance. And tell me how much higher the moon would be above that baseline at just a degree or two, degree and a half.
I just did. This is what I just explained.
It's far fetched, bro. That little.
I literally have the picture in front of me because I just did this.
That's a fetching step.
This is wild, bro. Like this is like some religious talk, man.
Yeah, it's being recorded. That's the beauty.
Yeah, but I mean, that'd be weird if it wasn't explained perfectly by like things were already exist. Like if we just made up a fraction and the sun and the moon being at a half a degree out of position at the sunset, then that would be like us following a religious thing. But these are things that are already in our model.
Yeah, because it's been in your model since 1666, bud.
Yeah, I don't see how people just glance over the fact that every sunset, the sun has already set, but you see it perfectly shaped round above the horizon.
The eclipse don't. The moon don't, bro. The moon
but I'm talking about
shadowed.
I'm talking about the sunset. And their model has already set, yet you can see the top portion in perfect symmetry above the horizon. Like it's refracting up without distortion. It's not a funny shape. It's not. Get a solar filter and you can see half of the sun still up above the horizon, yet it's already set in your model.
Yeah.
So crazy, man.
Yeah. Left
Actually
lane said,
does.
yeah,
I
no
don't know.
problem.
Yeah,
That's
yeah,
how
yeah.
refraction
Yeah.
works.
Dude,
Yeah,
NASA
oh
could
yeah.
say that
Funny.
fairies carry the sun, and left lane be like, yeah, for sure.
No,
What
but
I
we
think
know
is
that's
funny
how
is that we
refraction
see the
works.
sun, but the moon don't.
Yeah, I have a picture where the moon was right at the horizon. It was I would say a full moon. I don't know. You know, it might have been like y'all said 90, 95, 98%, whatever. It's hard to tell. But the sun hasn't risen yet. But the sun is still in the sky. Like it's strange how that happens. They say, well, the sun is so far away, it's under the earth and shining or to the side or but this looked perfectly across from each other. Like, I didn't have anything to measure it with, but I mean, I'm looking at the sun, turning 180 and looking at the moon, or looking at where the sun came up. It's going to come up in a little bit, where it did
Yeah.
come
That
up.
works perfect on the globe. Works perfect on the globe, Rock. Yeah, duh.
Yeah, right. It's globe, right? I mean,
Automatically
but
globe, no matter what you say.
I don't see that very. I've only actually seen that once. I can remember it like it was yesterday though, because I was like freaked out about it. I don't even know if I was, thinking about flat Earth at that point. I was like, "How's that? How's that?"
Magic.
But the sun setting every day, and being refracted back up, but not distorted. It's a tough one, man.
And I mean, of course, to act like people aren't like logically founded to ask these questions as if they're not just so open and closed, obvious answers is pretty wild,
If you could just get in front of the whole population and just tell that one thing, people would start questioning more, right? Because they have no idea that the sun has already set, but is being refracted up every day.
Yeah, only
No matter what
anti-flat
the
earthers have
condition.
even heard that.
Yeah. No matter what the conditions are, it's being refracted up where you still see it. Now, how does that make sense? At what point did the bottom not, was the bottom of the sun not refracted up? Like, it's I don't know. I can't get my mind around that.
Like, at what point do we
That
just
sounds
tap
like
out
crazy.
on the delusion?
It's not something only flat earthers. I mean, this is how I learned it even. So this was the paradigm in which they described it. I mean, they do it all the time on science shows. They try to try and make it seem the cool. They try to make every little thing seem cool. Like you're not actually seeing the sun's actual position because it's a little bit lower than that. And then it's also true that you're actually seeing the sun 8 minutes ago because the light takes 8 minutes to get to you. They always say stuff like this, but these are just facts about the way our model works. I mean, it
Okay,
does.
No, it's
They're
a
not,
fact.
they're
what
not
am I
after. They're
missing?
not
Scientific
after stuff.
experience. Yeah.
Can another glober tell me, at least out of their mouth, that they agree with what Kosho's saying? So during the Selenilian eclipse, we have the sun and the moon both above the Earth during the eclipse, which is a geometric impossibility, of course, because the Earth has to block the sun and cast a shadow onto the moon. It comes from the wrong direction, but that's a side note. So what the answer for the globe is, well, the sun actually isn't above the horizon. It just looks like that. It's actually below the Earth, being blocked by the Earth and casting a shadow onto the moon. So then when I say, okay, so what's the degrees? Around 0.5 degrees. Okay, so the sun's being lifted 0.5 degrees. How much time would that delay? Meaning, how long would I think I see the sun when it's actually below the Earth? Roughly 4 minutes. Okay, so if I see the sun up above the Earth for 25 minutes, then that would be impossible on the globe, right? Can another glober answer?
Crickets. I know it's going to be crickets.
That is decapitation of the globe. I don't care what anyone's got. I don't care how many degrees you say. It's 0.0 degrees. Where's the moon? I'm not sure. None of that works. That doesn't matter.
Listen, that just makes you sound lazy, then, dude. Because
Oh, come on,
it's
Coach.
seriously it was all laid out. It was like nobody like you could also do it and come to the same conclusion, I'm sure, but I didn't get to that conclusion because I made up those numbers. Those are the actual angles that they are when they're both supposed to be perpendicular. And so that explanation alone shows you that the sun being not even a 2,000th of a degree below below its actual position or below the horizon. I'm sorry. So when it's perpendicular and it's already halfway there, like where it's on the other side of the Earth than the Moon, it's only 2/10,000ths of a degree below where it's supposed to be. So it can move a lot more than that and still be visible. So it's going to be a lot longer than 4 minutes. I'm just saying I didn't calculate the exact time because it's a weird off balance relationship, but I don't think it's just 4 minutes.
It's a guy on
When
the
we
internet
joined the eclipse,
rambling on, saying anything he wants. Like, it doesn't matter what you say, bro. You can just say whatever.
may I draw it out for you? It might make more sense, but you just understand
Yeah.
that 0.002 degrees is a lot less than half a degree. Okay.
But you said it was half a degree. You said that during the stellar
No,
eclipse, it's because the sun's lifted half a degree. That's what you said.
what I'm saying to you is that that's what you already know, that when the moon and the sun are on the horizon, like when it's the bottom is touching the horizon, that on average on most days that it's already half a degree below it. And so if you saw the stellar eclipse and the sun was on your horizon perfectly, then sure, I'd say that's about how long it would last. But the eclipse could be happening for you and the sun could be much higher. So I'm not saying that both objects are only going to be in the sky
If the
together.
sun's much higher, then it has to be lifted much higher because it still has to be down below the Earth in actuality, though, right, Kosho?
Yeah.
Sure, but I just like explained to you the 2/10,000ths of a degree that it needs to be below its position for it to be on that halfway point. That's a lot of allowance, so it can move a lot more than that, and be a lot higher above the horizon.
How much can it move up? More than half a degree. How much can it be lifted up?
Well, no, but that's if it's on the horizon. It can only be half a degree out of position. That's not what I'm talking about. I'm talking about during the moment of the eclipse, when both objects are being eclipsed, or both objects are being eclipsed. The moon may be refracted and may be above the horizon, and the sun doesn't have to be. The sun doesn't have to be on the horizon. Like
The sun and the moon wouldn't be refracted the same, right? They're entirely different. I mean,
no, they're refracted just about the same.
so they have the same light output that bends through the medium.
No, they have about the same refraction. Yeah, they're both about half a degree out of position.
Even though the light output's completely different and they're completely different distances.
Well, they're going through about the same amount of atmosphere.
But it's different amounts of light, though. Different amounts of light, though.
Yeah, but I mean that's not what's dictating how it's going to be refracted. It's the amount of
The
atmosphere, the
refraction
gradient.
starts when it gets in our atmosphere.
Yeah, that's how it works.
Okay.
So how high up in the sky can the sun be? That's what I'm saying. So if the sun's 5 degrees up in the air, okay, 5 degrees above, then that's in actuality it's down below the Earth, right?
5 degrees, or you mean half a degree?
Well, no, okay. So you say that it's half a degree because I asked you, is it if it's every day? So what you guys say is that every single day, the sun is actually half a degree off optically, right? It looks like it's a half a degree higher than it actually is every single day, right?
When it's on the horizon, yeah.
Okay, so how much can it be refracted up above the horizon?
So that's what I'm saying. Oh, you mean okay? You're saying how much is its position incorrect? Is that what you're saying when it's above the horizon?
That's what this
So
whole
when it's above the
conversation
horizon,
is about. So
yeah, when it's above the horizon, it's a lot less. But I think it stops getting, like when it's above 45 degrees or 40 degrees maybe. Oh, no, when it's above 35
You gotta be
degrees,
exhausted,
there's
bro. You really do.
there's no refraction basis. I think it's like less than 5 arc seconds.
so if I
Before
saw
that,
the sun 35 degrees in the air during a selenilian, it would debunk the globe.
no.
So basically, what you're
I
saying
just
is
told
nothing
you
can debunk the globe.
two thousandths of a degree. All right, so let's see how many arc seconds it is.
So the sun gets refracted the most at the horizon, and it's 0.5 at the highest, right?
Yeah, that's right. Well, no, I wouldn't say the absolute highest, but that's a good average. Yeah.
So the higher up above the horizon, the less refraction. So it goes down from 0.5.
Yeah. That's right.
Okay, so if it's up in the air, up above the horizon during the selenilian eclipse, it can only be lifted less than 0.5 from its actual position.
Yeah, exactly. Yeah, that's what I said.
So if it's more than 0.5 degrees up above the horizon, it debunks the globe.
Yeah, but like I told you, it only needs to be 2/1000ths of degree whenever it's it's at that perfect perpendicular position. So a half a degree, if it's half a degree at sunset and it's only, I don't know, a fourth of a degree, 10 minutes before that or something, It's still the 2/10,000 of a degree is what I'm talking about, or 2/1000.
If it's
So
more
sun's
than
a long
half a
way.
degree above the horizon, it debunks the globe.
No
Yes, even with your bullshit refraction excuse.
bullshit. I'm talking about where it is whenever it's if the sun if the sun's if the Earth is blocking the light from the sun to the moon, and you can see both of them from that position. If you're perfectly on the on the middle point, the sun is not a half a degree. It's not half a degree below your zero, your what do you call it, celestial horizon. It's only, like I said, 2/1000ths of a degree below that. So it's got a lot more distance to travel. And so
Yeah, do it.
because of that,
Okay.
that's only if it's on your horizon. If it's not on your horizon, it's somewhere above that, or sorry, somewhere below that. Let's say it's further below your horizon.
No, it's above it
And the
though.
moon.
So
Yeah, I know, but that's what I'm saying. And the moon is above your horizon. Then the sun can be lifted such that you can see it, because it doesn't need to be lifted that much.
well, it needs to be lifted quite a bit because it stays up above the horizon for over half an hour. Yeah, it debunks the globe. Did any other globers agree with Kosha, or you guys want to tap out on this one?
And no, they're not going to say anything. I don't think it's pretty complicated. But Kosho, I mean, honestly, you sound like you're really struggling on this one. Am I right? I mean,
Yeah,
there's
it
a lot
sounds
of.
like you guys don't want to address the angles. I mean, I could show you a picture,
We're
but
being
you guys
pretty
will just
civil
announce.
about this and the
You
thought
guys will
process,
just
and you
announce. You
sound
guys
like
will just
you're
announce
struggling, dude.
that. You'll just announce that. But we'll just address it then. Address those angles,
Trust
Rakia,
what?
and
How the
address those
sun
angles,
can't be
Rakia.
refracted up enough to make our point, what we're saying about this eclipse, like
Yeah,
incorrect?
I'm saying that for it to seem impossible, then that would mean that half a degree wouldn't be enough to make the sun go, to that halfway point
And you're
between
acting like the
on the Earth.
horizon is some
And
set
it doesn't
spot
need to go
that
half a
happens
degree,
every day in
because
the
it
same
it
spot,
only
which
goes
that.
2/1000ths of a degree. So
Did
it's
you hear what I
perfectly
said?
reasonable.
Yeah,
Yeah,
right.
no, I was still
2/1000ths
speaking,
of
so
a degree.
no.
Oh, calm
Yeah,
down,
we
man.
heard
Calm down,
you were
man.
still saying the same thing about the 2/1000ths of a
Yeah, I know
degree,
you
like
haven't addressed it
for
yet.
the 10th time.
Yeah, you
What's
haven't
there
addressed it
to
yet.
address?
It's a non sequitur,
The
Kosha.
point?
Yeah, it's not even. I don't
Kosha,
get
I've
it, man.
explained this. I've explained this pretty simply, right? So, you're saying your model's saying that the sun gets lifted up 0.5 degrees every day, and so no human alive has ever seen the actual position of the sunset. Okay, cool story. So we'll rock with your fantasy delusion, and we'll pretend that no one sees the actual sun. You can use a solar filter, you can use infrared, you name it. Okay, so we'll pretend that somehow we never see the actual sun, even though we literally can use solar filters and infrared. And so then we're going to say that really the sun's down below the earth, completely obstructed by the earth. That's why it casts a shadow onto the moon. But it looks like the sun's up above the earth, right? So if it's higher than 0.5 degrees up above the horizon, right, it debunks the globe.
Right. And so if you were a student and you never heard about this before, and somebody just told to you, and first of all, as a student, you understand the distance to the moon because you're using our model where the distance to the moon is set, the distance to the sun is set. Okay, that's fine. You're also using the thing in our model where there's refraction occurring that is making the moon look a little bit higher than it is, making the sun look a little bit higher than it is. But that's fine. Now, knowing that, wouldn't you say that if the sun and the moon are a maximum half a degree out of position at the sunrise and sunset, then all it would require to do is that half a degree perfectly account for seeing something at that position. Like if you were to take something at your celestial horizon is at the 0 degree, and you were to lower it by half a degree and then extend it to the distance of the moon and the sun, wouldn't you just have to those points that they extend to, wouldn't they just have to be below where the sun and the moon are supposed to be during the eclipse? Because if that angle is greater than where they are, and it's allowing them to both be visible still, then it's not impossible at all. And that's what I'm saying. That if you don't understand that 2/1000 of a degree is much less than a half a degree, which is already allowed by the sun, 2/1000 of a degree means that it's well within that the angle for you to see both of them.
It's
Which
way
means
higher than
crazy.
way higher than 0.5 degrees off, bro. How is it that you don't understand this? Can any of the other Globers jump in and admit that they don't understand it? Because I know Kosho is one of your guys' best warriors. You know, he would actually have to bleed
Oh,
out before
shout out to
he
Koso
conceded.
here all day, every day.
I got to give it to Kosho. He would have to start bleeding out before he ever conceded. But can any of the other Globers that were just jumping down my throat while I was driving here, can any of them admit that they don't know the answer?
It's...
Yeah.
All I can do is make this picture to see if you get it, but that's all I can do.
Oh yeah, it's probably definitely that.
Continue on. Hey, push on, Kosho. I commend you, man. I mean, you spend
Well,
a
I
lot
think
of
you're gonna
time
get
doing
it,
this.
Rakia, but I'm
Yeah, I
saying
know
maybe
you don't.
my
you imagine in your fantasy world that I can't get anything. You automatically
I
put
don't.
me in that position.
I would hope both of you guys get it.
Hey, do
I'm
you get,
expecting Wish to
Kosho,
get it.
that the horizon isn't in the same place every day?
Say it again.
The horizon isn't in the same place every day?
The horizon isn't the same place. Yeah, if you're at the same position, yeah, the atmosphere is going to do different things on different days. That's right.
Correct. So if you stand in your living room, you have a shot of the sunset, and mark on your window where the sun is that day at the horizon. Do it the next day and the next day, and do it all year. It's hardly ever at the thing. You know what I'm saying? It moves around.
It's fluctuates. That's right.
What if the
Right.
optical horizon is more than 0.5 degrees above its actual position?
Yeah, just that. Yeah.
Yeah, that's just the average, as I told you. So
But what if the
sometimes it can
horizon's
be
optical
slightly
position
greater.
is?
It can be slightly.
But what if the horizon's optical position is more than 0.5 degrees higher than its actual position?
Well, since the moon and the sun are much further than the actual horizon would be, or the distance on the ground that you further see, I think it would be unlikely that it would have refraction that far exceeds the sun and the moon that's coming from the same direction, the same visual column of air. I think that it would be bizarre to see that refraction more than the thing that's going through that same air, but more of it.
Okay, so once again, if the optical position of the horizon, so the apparent position, well, of course, apparent horizon is painfully redundant, but anyway, if the horizon optically is 0.5 degrees higher than its actual position, and the greatest that the sun, the greatest, differentiation that the sun can be observed is 0.5 degrees above its actual position, then if we still see the sun above the horizon, that would be impossible on a globe, right?
Yeah, what you said was anyway, or true to what anybody else said, because nobody said that half a degree is the maximum. So that's the average. And as I was saying to you, if for some reason there was a day where the horizon was doing something more than that, above the average, then the sun and the moon, which is going through that same column of air, is going to be experiencing the same refraction, but more of it. So I don't think that you're going to witness more extreme refraction somewhere closer.
What's the most it can be then? If it's the average 0.5, what's the greatest it can be? 1 degree.
I have no idea what the maximum is. I know it's above half a degree. It could be fairly close to it. I wouldn't think it's too much further from.
This is getting really crazy, man.
I mean,
left lane. You
the
were
maximum
jumping
is?
all over me earlier. Left lane. Do you got anything to throw in here? Since you're so much smarter than me and I'll get it.
I wouldn't jumping all over you. I would just wish we wouldn't call each other dishonest so much.
Well, I think when I ask point blank close-ended questions and I never get an answer back, I kind of think that's intellectually dishonest. I'm not taking personal attacks. I'm not saying that you steal from people and all this stuff. I'm saying that it's intellectually dishonest tactics. Okay, but anyway, do you have an answer for what I'm saying?
No, I'm following along, and as far as all the numbers and whatnot, I don't know those. And y'all are talking about a half a degree and 2,000ths of a degree and things like that. And I'm trying to imagine how that would affect the sun and the moon on the horizon. Yeah, it's kind of difficult really to pinpoint it. And we're just talking about the sun and the moon being refracted such that you can see the eclipse at the horizon.
Yeah, so this is the problem, right? The way you guys look at it is you're like, we know what's going on definitively. So whatever we observe, all we have to do is do a mathematical equation to show the difference, and then that explains it, because all we have to do is say, that's what it's doing. And that, of course, is not actually sufficient. And I'm even going beyond that, and I'm showing that even with your reification and your presuppositions, and I play your game as if this magical refraction always saves the day with its cape pawn, its refraction cape comes and saves the globe. Even if I play the game with you, you still can't have the sun further up than 0.5 degrees for over 30 minutes. It debunks the globe.
That's your problem with it. You're playing their game.
I think it's funny to destroy their own paradigm within their bullshit.
It is, but you shouldn't even
Couldn't
give them
couldn't the
that.
sun
They have
also
nothing.
be couldn't the sun also be in different conditions lower than its actual position?
Uh-oh. That's a great question. I love it.
Yeah,
Can
that
the
is.
sun be
Say that again.
lowered? Can the sun be lowered by refraction optically?
Can light bend down or not?
Light does bend down.
So the sun can be lower optically than its actual position?
I would say that would be a very rare phenomenon. I wouldn't say it was impossible to happen, but certainly it wouldn't happen that way.
So you think the sun would be in the sky, but we wouldn't see the actual sun in the sky, but we would see the apparent sun down below it in the sky?
No, yeah, I wouldn't say that.
That's crazy, bro. That's so crazy.
Well,
man.
It is. I say I don't think we would see that. I
Well,
agree.
it depends on how magnified the sun is at the horizon. Its rays, if you will.
This is up above the horizon, man.
How many degrees?
It can be way more than 0.5 degrees. Selenilian eclipses, the sun can be way above the
Oh
horizon.
yeah, they can explain that one. They can't. That one right there just kills. Yeah.
I know, but it's so funny to hear them try because this is the anti. I wouldn't even call Kosho anti-flat earther, but he's like the MVP. Like NASA should hire Kosho. I'm being dead serious. Kosho does better than NASA.
Because he's not already on the payroll. But a while ago he was and more so than normal. I mean, it was tough though. Scattergunning. I mean, you know, I give him. I mean, I couldn't do it. I couldn't do what Kosho does.
Like I bet Kosho might be kind of scrappy in real life. Like I'll give him that. I'll give him that. He's a fighter.
Keeps us cool. He turns in those hours, man. You got to respect that.
Dude, I'll even give Kosho this too. I'll say this to all Globers. Your position is much harder than ours is because you guys have like a confinement that we don't have. You guys have to say for certain things. Like you can't fall off your script, right? Like you have each answer given to you and that has to be the answer. And so it's much more difficult for that side of the debate because we don't have to make up all these dogmatic scripts,
Right. Yeah, I took a while back a break from it just to see if I can formulate a bias that I had towards the globe. Hopefully to get the globe to be real. And yeah, it doesn't work.
Yeah. It's like, bro, it just too many things don't work. So a lot of us just decided to step away from it. And that's all we've done. Where's your model? That's like, you still haven't got it, bro. You still don't understand yet. We've detached from the model that has no viability. It goes no further than that.
The fact that reality is our model should be the end of that story, right? Like, that's how I look at it. I'm living in reality. Like, I'm living the model. I am the model.
Yeah, I know you're a model, man. I've seen pictures of you. But even even the Globers have to admit that, like, within their paradigm, the world presents itself exactly as we claim it is. So you guys have all the burden of proof. You have to substantiate curvatures where you don't see it, and you never see the actual curvature. You have to substantiate that we never see the actual sun, but we're falling backwards during a sunset. You have to substantiate that the sun is up above the horizon much more than 0.5 degrees for over half an hour, but somehow it's actually down below the Earth during the eclipse. I mean, we could talk all day, but the point is that you guys have to explain these things. We don't have to. We see the sun move in the distance. It disappears. We see a local parallel reflection of the sun on water, just like it would if the sun was more local, right? So, and it changes based on how far away it goes. That wouldn't happen on a globe. The local reflection of light on water would not change relative to how far it moves in the sky because it's 93 million miles away. The reflection would not change. The interception of parallel rays with the water would remain the same. It's just like a million different. In fact, the whole ocean should be lit up. Why would we see specific thin, straight parallel line from the sun on the water?
Yeah,
Have
no
you
matter
seen
what.
the line? I have a line coming towards my boat and over my reel. Like it's on the water and then it comes over the top of the rail of the boat and over the reel. I'll post it. I post it all the time and I don't make comments on it, but it's something that is pretty hard to replicate, right? Like
You realize every sunset on a globe should move away from our feet, and it should be at some point halfway to us, like reflecting to a halfway point somewhere out there on the water. You know, yeah, I want to see that picture, Aki. That sounds cool.
Well, the amazing understanding of it is how light behaves over curved surfaces, and it should be oblate. It should be that's where their oblate portion is at, because it should be chubbier and have a weird distortion wrapping around a sphere, because the water is a mirror, basically.
Yep, exactly. Now you can debunk the globe by, after it rains, just go walk through a parking lot. If there's a puddle, it debunks the globe as soon as you see the street lights in the parking lot reflected perfectly. Yeah, you don't understand it, Hugh? You want me to explain it to you, buddy?
That's the first thing you go with, Austin. You okay?
A lot of,
well, you said
Never mind, Austin. That's all right. Don't get triggered.
I thought it was a reasonable response that when you said
the reasonable
what,
response is no. That's not a reasonable thing to believe. It's a puddles. No.
Okay, so do you know why I said that, or you just preemptively disagree?
It's just. I don't know if it's worth responding to.
All right, well, maybe
anyway, so I shouldn't probably respond.
Well, maybe you can rebut it once I say
everything.
Exactly.
All right, cool. It's called a specular reflection, my man. Hey, my man, it's called a specular reflection. Any convexity or concavity of the surface of the water would eliminate the possibility of a specular reflection. Do you have a rebuttal?
No,
they deny everything,
I do
bro.
have the interesting point that the sun doesn't get much larger at noon.
So you got no rebuttal
as it goes overhead, because
that's
it's so
called.
Close, you see.
Hey, bro, that's called a non sequitur.
No, it doesn't matter. I was just pointing that out because you were saying about how the sun debunks this and that, but the sun does not, or the moon, get much larger at noon, and then at sunset or sunrise.
I wouldn't expect it to.
Given that it's much closer than claimed, it absolutely should. And flying over a disk or whatever you.
Well, should it? It never gets within.
No, we don't.
It never gets within 4,000 miles of us.
Yeah, so
it never gets within 4,000 miles. Why would it grow if it never gets close to us?
What you don't understand is that you have the same exact situation on your side because you claim the sun's way bigger and further away. Well, we claim it's smaller and closer. So it doesn't actually change there, Hugh. You know that, right? It's the same thing.
If you try to model it out, it should change a lot more than it does. But
No.
you can't. I think you probably have tried to model it out and haven't been able to. But if you did try to, then you would.
Why doesn't the sun change angular? Why doesn't the sun? Yeah, but it's much smaller there, Hugh.
That doesn't matter. It still would have to follow perspective.
What do you mean it doesn't matter?
At sunset, it would be 6,000 miles away. That's twice as far. The sun should be half the angular size.
Why would it be? What? Why would it be
6,000
6,000 miles away? What are you talking about?
It doesn't. No, it doesn't work.
Well, hold on. It only lights up little local clouds. If it only lights up local clouds, how is it so big and far away like y'all are saying? If it's just lighting up just the clouds right by it. I mean,
just to remind you,
everything works.
This is his response to specular reflection, by the way. Just so everyone remembers, he jumped in. I asked him about specular reflection. His response was that he thinks, because he doesn't understand it, that the sun should change, and says it doesn't change size, then the Earth can't be flat.
Well, I want to ask a question. Are you looking through more of a gradient or denser atmosphere through the horizontal versus the vertical?
You're looking at denser atmosphere, and that does what precisely? Can you quantify that? Have you done a scientific experiment that follows a scientific method to quantify that?
Oh, this guy cares about the scientific method now.
I've always cared about it. That's why I'm not a flat earther. Because
Okay, what's the scientific method? Hey, what's the three
convinced because it doesn't follow the scientific method in literally anything it claims.
What's the three constituent parts of a scientific experiment?
No. Okay, so have you followed the scientific method to prove that the sun changes in size because it's on the horizon or it's going through denser medium of the atmosphere?
Yeah, so when we're looking
that?
at the sun, it's just the first step of the sun. Buddy, when we're looking at the sun, it's just the first step of the scientific method. That's why I wanted to make sure you even knew what it was. But you don't.
That's why I'm not a flat earther.
Okay, so what's the three constituent parts of the scientific experiment since you're so intellectually superior to flat earthers?
The question remains, well, the question actually should be, why haven't you followed the scientific method and given us a reason to believe that the sun gets larger as it goes through a denser medium?
So, first of all, I just explained to you why it doesn't go by the scientific method. Do you remember what I said?
So, here's the other question: is do you have any intention of ever doing that?
So you literally don't answer any questions. Is that what we're doing with?
Well, no, but you've got to ask better questions, dude. I'm just asking about the difference in the sun's size. That's what I'm after. I'm not after gotchas. I'm just asking about the difference in the sun's size.
Hey, is your name?
Do you have any reason to lead us to believe that the sun gets larger as we view it passing through a larger?
What's that got to do with the scientific method? What's that got to do with the
And he's
scientific method?
avoided like 5 questions and asked 10 so
No,
far.
no. You
Nice
asked
job.
the question in relevance to what was brought up, the scientific method. So what's that got to do with the scientific method?
It's just the same rhetoric that we get from our side, y'all, and we're just asking the question back.
Whatever,
at least you
dude.
answered it
We asked
right.
him one simple question, he wouldn't answer it.
I answered it right there, Left Lane. I said it's just the first step of the scientific method, so it doesn't adhere to the parameters of scientific experimentation at all. It's not even possible. So would you like to try to answer the question I asked him about the specular reflection, or are you going to duck it also?
Yeah, I mean, it's whatever he wants it to be. Like he has to establish what he means. He's not even doing that. Definitely not so.
I would think that a sun that's 3,000 miles over my head at noon and 6,000 miles away at sunset, the sun should appear to be half the size at sunset.
No, you're not at eye level with the sun, buddy.
You just heard other people say this. That's the only reason you say it. You don't even know what you're talking about.
I just said it a while ago.
Because you've heard other people say it. It's just one of the globe earth talking points.
That's just perspective. I mean, the rule of perspective thing.
Well, if you use perspective,
way.
if you're doing perspective alone, Left Lane, I even talked to Doofus about this. If you're about 33 degrees above the horizon with the sun, it's about 6,000 miles. Just with perspective, not saying where it's actually at. He got 62 though, but I got 6,000.
Yeah, 66,200, something like that.
Yeah, so Left Lane. How can you have a specular reflection if any convexity or concavity would immediately eliminate that as a possibility?
It's really big.
Good answer. I like that one.
It's so
Really
big it doesn't have any convexity?
Yeah. It's
Sounds
hard to
like
see.
a Glober excuse. It's
So
really big.
when I see the sun's specular reflection for like 50 miles, that's not big enough to have any convexity?
You're not seeing 50 miles across the surface.
Am I not?
What?
Because I'm pretty sure I do it all the time.
What?
Yeah.
Oh, come on, Left Lane, don't do that now.
Left Lane. So you agree if I see it 50, if I see a specular reflection for 50 miles, it debunks the globe?
No, nothing debunks the globe. What
I know, that's why I always ask it like that, though, because I know they can answer it. Hey, Left Lane, if I see a specular reflection, hey, Left Lane, if I see a specular reflection for 50 miles, then you would agree it debunks the globe?
It would, yeah.
Oh,
wow! Good talking to you.
We're getting somewhere. We're getting somewhere.
Dude, are you gonna change your tags or what?
No, I want you to show that. I want you to show the specular. I want you to show me the reflection of the sun across the water, and you can see it for 50 miles.
Okay, and then you'll become a flat earther.
Well, I can't say that.
Oh!
No, there's too much.
He's not allowed to say that.
I think he could do that from altitude.
You
I don't
might
think you could do that from sea level.
Wait, so if I rise up above the sea, then all of a sudden the Earth isn't convex?
Yeah, yeah. According to extremists.
Wow, yeah, that was crazy, man. You're like Aristotle or something. You're too profound for me. I don't get it. Can you enlighten me, extremists?
No.
This is crazy.
No, it is great. I think people
This
are
would
learning.
be this would be like played back over and over on a loop.
It should be. This is people learning.
2022, man.
Yes,
You got it
2022.
wrong.
You think the Earth is flat, and you think, yeah, no.
Do you leave the house without a helmet,
Triggered.
bro?
Hello, triggering him.
I'm not. Why would I be triggered, bro?
Dude, the first thing you did is call me a gamma. You just so cheesy.
Okay,
Uh-oh,
just
you got
just to
him.
clarify. So we'll clarify what happened then, right? So I jumped
Here
in
we
while
go again.
yeah,
Okay.
but see, the reason I
Almost
called you a
triggered.
gamma was because like 4 times in a row I tried to
Hey,
call you
deaf
deaf,
and-
and yeah, I tried to calmly talk.
No,
And,
is Geo in here?
oh man, this guy. So the only
Wow,
reason I
listen
said
to
that
this.
was because
No,
every
so
time I
Geo's
was
not in here, so that's why
Are you going to interrupt really like this and say he's triggered?
yeah.
Yeah, it's very personal when you guys.
Yeah, we're laughing, dude.
Uh-oh.
Guess who we're laughing at?
Yeah, no, yeah.
Yeah.
Okay, so
you.
Hugh, just so you know, I try not to insult people, man, and I've actually gotten significantly better about even
Yeah,
saying
you
it.
have, dude. I complimented you. Remember that?
See, only triggered people impulsively interrupt.
I did compliment you the other day. We
Yeah.
were getting along much more
Can't
than we
shut up
otherwise.
now.
Guys.
You
I've
won't
learned
be
as
able
well.
to shut up now.
I mean, sometimes you gotta watch out for people that are too nice.
Yeah,
I'm too nice because it's my personality, Don. That's a flaw. I sound
that
sycophantic and I sound
You're faking it.
condescending.
You're
Oh, no,
faking
no,
it.
watch out for you.
It's true. That's I've experienced that before.
Okay, just so you know, man, the only reason I called you a gamma was because I tried to calmly talk like 4 times in a row, and every time I started talking, you just talked over me very disrespectfully, and so I shouldn't have called you a name because the creator said, "He who does not bridle with his tongue."
No.
Hey, he said, "He who does not bridle with his tongue, his religion's in vain." And actually, religion in Hebrew is about giving, to the less fortunate or whatever. So basically, you can give all the stuff in the world, but if you can't bridle your tongue, it means nothing. And so it doesn't really matter what it doesn't really matter what you do. It doesn't justify me ever, calling you a name. So I shouldn't have called you that. But when you get the full context, right, it's like you interrupted me like 5 times in a row, very disrespectfully.
Is there a
First
button in that
second,
verse?
the first second I came in here, you wouldn't let me talk.
Austin, is there a but in that verse?
Yeah, it says, but when Hugh is interrupting you 5 times,
Then
he's
it's
pretty
okay.
clearly demonstrating gamma tendencies. That's the Witsit translation.
Witsit 119.
But
Oh no, man! Jesus definitely called the Pharisees the children of
Yeah, he
the
did.
devil.
He did.
He didn't play. Yeshua.
Yeah.
He
So
was
what
not.
what happens is what typically people do is they take that one part that when Jesus did that and use that to justify calling people whatever they want.
Well,
So we shouldn't. No point should do that. That's
well, gamma male is just
let's not do
a
that.
characterization of male behavior. So I mean, it's not like you don't have to take it as a personal insult or something. You know what I mean?
I don't. But it's just funny. It's just we can have fun. I know there's a lot of water under the bridge here in our history, right? So, but we can
Hugh,
still have a laugh.
do you agree that if we see a specular reflection of the sun on the water for 50 miles, then that debunks the globe?
I have no idea. Maybe not. I really don't care. I don't know.
If I saw something from 20,000 miles away, would it debunk the globe?
If you could actually provide some evidence rather than saying debunk the globe, if you could provide some positive evidence of flat Earth, that would be impressive. And Geo did say earlier that we're in the early days of this, right? So you still,
early days
could happen. The early days of flat, it's only been going around like what?
Forever.
Since 20.
It's an archaic model, according to fucking
2015?
YouTube.
Yeah, according to every YouTube, every YouTube stream I've ever done, it's very archaic.
It's the current iteration. And by the way, guys, I actually need to say that I don't agree with YouTube doing that.
No, you believe in free speech?
I don't either. Yeah, I don't either agree with YouTube censoring, if you can call that. It's not really censored, but you know what I mean. It
Why
amounts
not?
to censorship.
I mean, it's a private entity
I don't
that
think
can
that.
do
I
what
don't
they
think that's
want.
right. I don't think that's right, and I think
Oh,
that's
do you think there's right
immoral.
and wrong? Immoral? Where do you
I
get
think
your
that is it.
morals?
I think that's immoral. Yes.
Where do you get your morals? What's moral and immoral? Where do you get that from?
Well, if I do something to how can I put it?
Yeah,
What's
is it
what's a
subjective?
libertarian?
Is
There's a
it
libertarian. No, it's not subjective. There's a libertarian definition. I can't even remember what it is. But Whitsitt
you
was
can't
right.
remember what it
And
is, but
Whitsitt. But hold on. So I don't call you Whitsitt. I didn't mean to, Austin. So earlier exchange, I apologize for what I said. Okay.
Apology accepted.
Thank you.
Yeah, but you didn't answer my question. Though. You apologized to Whitsitt.
He did apologize to me as well, but he said, "But I'm sorry, but you are a bastard."
Do you think? Do you believe in right and wrong?
Yeah. Hold on.
Good and evil. Do these?
Yeah.
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 Huge
Right, wrong?
changes. I mean,
Well, what's your measure of good?
Oh man, my bad. Go ahead.
Yeah. What's your measure of good or bad or whatever?
Well, could I be a pain in the neck and ask you the same question? What would you say is a definition of right and wrong? Well, the standard.
Yeah. Okay. So in my case, I believe in a creator. So whatever the creator says, right is right. Whatever he says is wrong. Now let's turn that around to you. What do you believe is right or wrong? Where do you anchor your beliefs?
I anchor my beliefs in the creator.
And
so, for example, being a human, I make mistakes and I say things I shouldn't say. I get angry and I get upset, or I just get triggered. That's the word now, right? Everyone gets triggered. So when that happens, I check myself afterwards. I again become insane, because I think getting angry is a state of being insane, right? You say things you don't mean, you go insane temporarily. So you say things you don't mean, and then you can check yourself afterwards and then go back and say, hey, look, I did this stupid thing. And then you can carry on.
Yeah, that's how you learn, right?
Yeah, I mean, otherwise you harbor resentment, and that doesn't do anything but hurt you. And so I've learned, but it's taken, let me tell you, the way my brain is, it's taken a long time to get to this point where I can do that. Oh, I've got an awful personality in a lot of ways.
Well, I think if anyone's being honest, it's difficult for everyone to do that.
Yeah, it really is. It's hard because you just, I don't know Austin, I've never met him. But so it's easy to sort of just see him as an adversary, but it's very, very easy to do that. And I do it all the time. This is actually a good test. It really is. And I'm glad I'm in here, because it's a good test. It's a good way for me to check myself and then say, you've been a butt, you've been a moron, and you're sounding, how you check yourself. How do I sound to other people? It's good. It's good training,
That's actually the main reason I come in here, to be honest.
Yeah.
Would you say right and wrong are objective realities rather than subjective?
Mostly, yes. But it's hard to determine which, I mean, you should not kill or commit murder, but should you defend your family? If your child was threatened, would you?
I agree.
Well, that's why there's a difference in kill. There's a difference in kill and murder.
Yeah,
there are definitely gray areas, but yeah, as you put it, I mean, there are established, we all agree, murder is wrong in a sense. Right. Even an atheist would agree.
Even an atheist.
Yeah. But
hey, Hugh, I got a question for you.
Yeah. Oh, by the way, before you say that, Ricky, I'm really sorry. I was rude before. Yeah. I was really rude before. I'm sorry, man.
Yeah, no
Honestly,
worries, man.
I'm really sorry.
A lot of the times
I said it and then immediately regretted it. So
yeah,
I'm
no
sorry.
problem.
Thanks, man.
yeah, don't take this the wrong way, but how much did Kocho pay you to save his butt? I'm just joking. Yeah, I think.
I'm glad you brought that up, Rakia, because I posted a picture that even you should probably be able to understand.
Oh, even me. Yeah, I was joking, Kocho, but
Coach, we were having a kumbaya moment.
the values there.
Even me.
You decided to bring me up for some reason, so yeah, the value right there, the 181 is slightly
Yeah.
bigger than the 180.
Yeah, I'm gonna look at it, man.
So then
as
the
soon as I
fact that
get
it's
a chance.
bigger, the
Thank
fact
you
that it's
for trying to
bigger
help
means
me.
that it's capable of doing the one that's less than it.
If
So
you drew it and
that's
posted
the
it,
angle.
there's no way I can
181,
understand it, Coach. I'm
181,
not gonna waste my
a
time.
181 angle is the angle that you are typically allowed when they're on the horizon, and the 180.9 is all that's required for you to see them during an eclipse. So
Awesome, man.
because
Great
it's
job.
bigger,
Hey, thanks for your time,
because
bro.
it's bigger, it's perfectly
Thanks,
reasonable.
Captain Save a Globe.
Thanks for your effort, man. Appreciate it.
I mean,
Duly noted.
the claim was that. I mean, you doesn't even respond to it. That's what was crazy. You just claim victory, but you're not responding to his
It
answer.
wasn't a claim. It was a question. Kosho, calm down.
No, I'm the one who made the claim about the about the angle, but nobody addressed it.
That's all handy, bro. So okay, so the sun's a little bit lower, and the Earth is dropping into the fucking in between the sun and the moon. Okay, I'll give you it's a little bit lower, which allows the Earth to drop into it, which still don't explain the shadow coming down from the top.
Man, that was already explained, man. Those are two different things. Those are two different phenomena. One is the Earth rotating. One is the moon coming from some other direction, whether it's above the plane or below the plane. These two things aren't related. For that reason, there's no rule that when you actually see it coming, even though the sun appears to be rising because the Earth's rotating, right?
You have to lower
It's
the sun, though, bro. If you have to lower the sun by using refraction to get the fucking the Earth to cast even a tiny bit of shadow on the bottom of the moon, okay, you're having to use refraction to get the sun lower, okay, not to get it higher to come the shadow to come down from the top, bro.
Okay.
You can
So
use
if
both
the
of
Earth,
these uses
if the sun,
separately, bro, but you can't use them together.
yeah, if the moon's setting, right? The moon is setting, the sun is rising. It's morning time, right? Are you going to see something? And now let's say that's happening. Let's also say that the moon is entering into the orbital plane. It's intersecting that orbital plane from above or below. It could do either one of those two things. However, the moon is only rising. So the moon's or the setting. I'm sorry. So the moon's setting, yet it could be coming from above or below. Doesn't that tell you that depending on whether or not it is coming from above or below, you can observe two very different things because both there's no reason that those things contradict each other.
You're exactly right. Kocho, can I ask you a question? How much did Hugh pay you to save him? Get it?
He knows I'd save him anytime if he ever needed saving, but
What do I say being saved from?
Why does that sound so sus?
What?
So if refraction is so the sun is too high before the refraction, right? The sun is too high on the Earth's horizon. So the Earth that I'm standing on, the rest of the Earth is below me. The sun is too high before you refract it, correct? In other words, the moon's getting all of the sun's light because it's too high, right? Before you refract it.
The moon's getting all. I don't understand what you're saying by that.
In other words, no shadow on the moon. No shadow on the moon.
When it's being refracted, it's actually a little bit lower than wherever it actually is.
Right. In other words, without the refraction, the sun would be too high, so therefore no shadow on the moon, right?
That would be too low. Why do you say it'd be too high?
It'd be too low. Okay. No, I'm talking about
the refraction. The refraction has nothing to do with whether the Earth shadowing the moon or the sun.
Yeah, but I'm asking you a simple question. Before the refraction, why is the moon getting no shadow? Okay, I'm asking you a simple question because the light is because the sun's too high, right? You have to say that it's lower, right? So the sun is too high, and that's why there's no shadow on the moon pre-refraction, right?
Yeah, you might have to restate your question. I don't understand what you're saying.
It's a simple question, okay? So if there was no refraction, okay, if there was no refraction, there'd be no shadow on the moon, right? Because the sun would be too high. It's going to be hard for you to mind fuck yourself out of this question, but you know,
I think
you
what
work
you're
on
saying,
it.
I think what you're asking if you see the same exact thing that you see. You see what
No,
exactly
I'm
what you
asking
see.
you if I'm standing on top of the ball.
I know. Listen. The reason why it sounds confusing is because you're saying if you didn't have refraction, it sounds like you're saying where they would be in their positions they would be if there was no refraction. But I think what you're saying is if you get the same observation you get, but there is no refraction, so it's actually in the position it appears to be in. Then yeah, you wouldn't think that it was actually intersecting. Like the Earth wouldn't be in between the two objects.
So the sun is actually lower than we see, right? And that's why the eclipse. So without the refraction, it would be too high, right? And there'd be no shadow on the moon without the refraction, right?
The refraction with them appearing to be in the same position, then yes. It's just that you're asking it in a weird way.
Yeah.
So, without the refraction, sounds like the position that it's in, if there were no refraction. But what you're saying is, if those positions were consistent, the same way they are now, but refraction wasn't a thing, so those are the actual positions. Then yeah, they would both be less than 180 degrees, and not enough. You wouldn't be able to see them. I mean, you
Yeah,
would. They
because
would. The Earth
they
would be
both be too because the sun would be too high for the moon to get shadowed. But then you use refraction, okay, which moves the sun down enough to start a shadow, right?
It's the way you're saying it is weird, but yeah, because of refraction, even though it's down, it appears higher. Right. That refraction doesn't bring it down though. I mean, so that's why the way you're saying it is kind of weird.
Yeah, I'm just trying to work out in my head how the shadow then comes down from the top if they're both above the horizon, whether refraction's happening or not. I'm seeing the sun's light. My solar panels are seeing the sun's light, but the moon ain't fucking getting all the sun's light. I mean, and it's higher than I am. So it's just baffling to me, bro, how everything's getting the sun's light except the moon, which is higher than me.
It's not because it's not flat.
It doesn't matter if it's flat. I'm picturing a globe with a line drawn through the middle being the horizon. I'm trying to give you the benefit of the doubt. But I'm on top of the ball, though. So the ball's got to be underneath me. So if the moon is 1 degree or 2 or 3 degrees, it's way up, actually, because even that small angle over 200,000 miles, that puts it a way big bit higher than me where I'm standing. Okay, so if you got to refract the sun to get that shadow to get it, but I'm still seeing that light. I'm seeing the sun's light. My solar panels are seeing the sun's light. All the flowers are seeing the sun's light, but the fucking moon ain't seeing the sun's light. Then you're saying the shadow's coming in from the top? Like, what the fuck? So the top of the moon can't see the sun's light? Like, I would almost buy it if you said, well, the sun's lower than you think. So the bottom of the moon is getting blocked by the Earth because the sun's actually lower. What's that got to do with the top of the moon? You know, nothing about it. So everything sees the sun and gets all its light except the top of the fucking moon, which is even higher than the bottom of the moon. It just tall. It's a mind fuck. Sorry.
What's wrong with getting your mind fucked every once in a while? Did you see my pictures, anyways, Brian? The one that I made and the one I'm posting.
Oh shoot! A shadow casting a shadow. Refraction casting light, casting light.
How much moon? How much?
It's just like you're right, Ryan,
Much of
that
the moon should be
if there was no refraction and you could see both of them above the horizon, then yeah, there wouldn't be enough. It wouldn't be enough space for the Earth to be between them. But there only needs to be a little bit of angle. Go ahead, man.
Yo, what up? How much of the moon should be hidden by Earth curve during its stellar eclipse?
How much of the moon should be hidden by Earth curve? Sometimes all of it. I mean, it depends on where you are when you're seeing it. Depends on
It's a stellar.
Yeah, I know, but there's people who are seeing the solar eclipse like the right. It's like the eclipse is occurring exactly when their sun is setting. You know what I mean? And some people are experiencing a solar eclipse when, it's not completely in the shadow, stuff like that. So
There's no set them out. I thought you had to be at the top of the ball, and then the moon and the sun had to be doing a straight line in between
yeah, but if you
Earth.
think
No?
about it, that's only happening for like a split second, but the eclipse is like hours long. So you could be, especially when it's going through the umbra. It could be. There's a long range
Yeah,
of
but
time where enough people are going to be able to get solar eclipses. Like it's not an exact moment. You have kind of a window that you can observe it.
One of the things I've said about this in terms of this idea of it refracting or bending is that it isn't changing its position in the zodiac, meaning the degree of the sun. Let's say the degree is at 4 degrees of Gemini. Let's say when the eclipse happens, it's not slipping into 2 degrees of Gemini or 6 degrees of Gemini. It's not changing its actual geometric degree position in the sky, but it would have to for what you're claiming to happen to be happening.
No, Gemini moves exactly the same way the sun moves.
So Gemini
it's
warps along with the sun. The whole thing's bending and warping.
Yeah.
Well, then if that's the case, the rest of the zodiac would get thrown off, and that's not happening either.
No, but it's not that it's getting thrown off. That's just the way we normally see it. So it's like if the moon was right next to Betelgeuse, it was right on the edge of the moon, and the moon was being refracted, so it was right on the horizon, but it's actually a half degree below. And then you should also be able to see Betelgeuse, unless there's too much glaze or whatever. Let's say you are able to see it. It's going to be right next to the moon in the same way. It's not going to be in its actual position, and the moon's the only thing refracted.
I mean, I wouldn't judge too much about what we see going on in the sky because we know sometimes we see things and we know they're not happening, right? Like the star
Hey,
trails at the equator.
I would disagree.
Do you know about the star trails at the equator?
I see. Like anything I can observe is happening. Basically.
Really? Did you ever see David Copperfield make the Statue of Liberty disappear?
I mean, that's your interpretation of what's happening. What's happening. What's happening is happening. Your interpretation of it can.
That was all refraction.
That was all refraction.
Kosho,
there's things we could see happen, and we know they're not actually happening, right?
Jeremy, he's drawing the moon like it's got parallel rays too, man, and he's drawing the moon like he's acting with the sun, and it's
Like
almost parallel, but it ain't. Kosho, if the moon is a degree and a half above the horizon, that puts it 6,200 and something miles above my feet in free space. So how?
Yeah, I mean, are we talking about David Copperfield, or are we talking about like the moon phases, like the sun? What are we talking about? Like when I see the sunrise, that's the sun rising. It's nothing more than the sun rising. Are you saying when I see the sunrise, I'm seeing something else? It's not.
I'm saying shit's going on in the sky that's not actually happening, like star trails converging and diverging, for instance, at the equator.
Like the sunrise, is that not actually happening? The sun is not rising.
It looks like it is. If you want to give a geometric position to it, that'd be another thing.
You both got good points.
I mean, is that how we're establishing if it's actually happening? The geometric position? Is that the deciding factor if it's actually happening or not?
For something like the sun or the sky, I don't even know how you know if it was actually happening.
I agree. Yeah.
Imagine if you were on like
but the Globers, though, hold on, Coach, though, this is the devastating part. The Globers, though, they want to say, yeah, we see the star trails, it's convergent, divergent at the equator, but we know it's not actually happening. So they're like boxed in.
Yeah, and they have exact measurements. That's the problem.
Yo, check this out for a second.
Like a moon phase. Like a new moon has to be in a certain position and a certain angle from your viewing position. So if you let's say see during a nighttime see a full crescent moon during, let's say, midnight, that would be impossible on a globe. No matter where you stand on a globe, that would be geometrically impossible.
It depends on what sort of crescent you're talking about. But
crescent, waning or waxing, whatever it may be, the angle from which you observe that moon phase on a globe would be impossible during that time of day. Like a let's say midnight. Midnight would make it impossible. There's no way you can see it. I mean, if you bring in refraction and all that shit, not even I'm waiting to hear an explanation how you would see a crescent moon during midnight on a globe. What would be the explanation?
Can you see a 3/4 or 1/4 phase moon during midnight? The answer is yes. You can see that easily during midnight.
That's not the question, though.
Yeah, I know it's not the question, but this is the point of why I was saying it depends what crescent you're talking about, because anything less than that, anything less than a 3/4 or 1/4 moon,
okay,
it's going to be
you
somewhere in
want
that.
me to be specific? Okay, so a new moon, plus or minus, I'll give you 5%.
Yeah, it doesn't sound like you'd be able to see that at midnight.
I have. I've seen it. I can give you pictures of it.
Sure.
Hey, you guys agree that, or Kosho, let me ask you, how do you have a specular reflection when specular reflections are impossible with any concavity or convexity to the surface?
Why are you saying it's impossible? Why do you say it's impossible?
Because specular reflections require a flat surface. If you have any convexity, it immediately distorts the image.
Yeah, but it doesn't that depend on the actual, the actual curvature compared to what you're seeing. Like same thing with a round mirror. Like a rounded mirror, it's going to distort it a little bit. But your rear view mirrors, or the side mirrors, or whatever, they're slightly rounded, but it doesn't completely distort the image. It makes it like slightly bigger or smaller. So
No, the mirrors themselves are flat, actually, bro.
I thought they were slightly rounded.
No,
slightly what is it? Convex.
Mirrors are not flat.
Okay, and is there any distortion, or do you get a perfect reflection? And what is that like? Specular reflection? Bro? Specular reflection, right? Requires a flat surface. If it's convexity, it distorts.
Well, I mean, you get a specular reflection on a slightly curved surface. It doesn't have to be perfectly flat.
I was going to say define specular reflection.
Yeah, a reflection on a flat surface.
Define. I mean, okay.
Okay. And we get specular reflections all across the world in many different ways. Some of the most beautiful pictures ever taken. And if the Earth was a ball, the surface would be convex. And it actually gets worse and worse the further away that you're observing something from, right? Like if you see specular reflection of the sun's light all the way to mountains that are 30 miles away, I mean, there should be tons of convexity.
Distance makes it worse. They try and say that it's almost flat, but distance negates that. You're right, Austin.
Yeah.
I'm still not sure what you mean by specular reflection.
Imagine if you're focusing a beam of light, right? And up close, you want to a concave glass, right? So up real close, the focal point would be, just a few inches or whatever if it's real concave, real curved. But the straighter that you get the glass and mirror it, the further away that the focal point's going to be. So if you have a glass that's just barely curved at all, and you mirrored it to get the focal point, you'd need a way longer distance. So we see these perfect reflections over long distances, which say that it's not curving at all. We're getting perfect reflections over lakes with mountains in the distance, even greater than 30 miles, really. But so that negates the fact that you're saying the water's barely curving. The fact that it's curving negates them observations over distance. That's the
Yeah,
claim.
specular just means like mirror. Like specular means like properties of a mirror. Like like a mirror reflection.
It's like when the moon comes up on the horizon over water, and that reflection that comes to your feet.
Yeah, that's one example. Yeah.
That plane. If I can catch one for 50 miles, you're gonna think the globe's debunked on that.
What?
You can't use the ISS.
There you go.
No
Game
no
over.
doubt.
It's
Game
over
over.
distance.
miles is
It's
easy.
such a slight. It's such a slight change.
Those mountains are like numerous miles away, my man.
Yeah,
I
but
just
the
posted a
horizon.
picture.
If you take a patch, just go on Google Earth and take a patch like 30 miles wide and then zoom right out and just see it in perspective. It's just this tiny little dot on the Earth. So
But you
I
just-
wouldn't. Yeah, it's very, very slight.
Of course,
You
this
can give
light's
it
not going through
measurements,
the
dude.
literal amount. What?
Google Earth don't match
But if-
reality.
That's the other thing.
If in your bathroom you had a deviation from one end of your mirror to the other end of your mirror that was half a degree, and you expect that you expect to not be able to see reflections anymore in that or any of these other observations, there would be little notice of that.
Yeah, it's
Do you
such a
see
slight
Do you
deviation.
see Geo's meme?
Yeah.
Okay, so how far away do we need to get before that happens on the globe?
That it's curving like that.
Well, that
I mean,
you
that
don't
looks
get
like
that you can't get a specular reflection. Period.
I mean, you'd have to be. Let's think, because 1 degree would be 69 miles, right? So, I mean, what sort of
But any amount of curve is going
how
to break
extreme does
that.
the angle need to?
Any amount of curve is going to break that. You guys talk about boats being going over the curve. Well, then the sunlight would be hitting that curve. Let's say where the hull of the boat is that you think is being hidden, and it would break that reflection. But it doesn't.
Correct.
We see it all the way through.
Good. Game over.
Dun dun dun.
Game over. Why would you think it works like that?
No.
Because that's how reality works.
Okay, go so.
It's not how reality works. Like I've seen even like a ball, like a glass ball. Okay, so that's like extremely curved, and you can still see things reflected on it. You can
But
see
it's
things reflected
distorted,
on.
though.
It's 60.
Yeah,
but it's,
depending on how extreme that angle is.
it is just the amount of distortion over the period over the distance you're talking about is minuscule.
Yeah, but the sun is observer dependent. So if you've seen the sun reflecting like in Geo's meme, and then it got hidden. If you go up in that very spot high enough to see the sun, you'll see that reflection again. It ain't like it's gone for the Earth. It's the sun's viewer dependent, like a rainbow. It's just different for different people. I mean, maybe not like a rainbow, but if it's the actual positioning of the sun, you shouldn't be able to see the reflection if you go up. It should be dark for that spot, period. But like I said, it depends on where you're at is what you see. If you see a hot spot in the middle of a lake, 10 miles away on the other side of the lake, if you had a mirror, a magic 10-mile mirror, you're not going to see that hot spot from the other side of the lake because the sun's going to be at the mirror's back. The sun is observer dependent, bro. I don't know why y'all can't get that.
Yeah, let me read this for you, okay? So reflection off of smooth surfaces such as mirrors or a calm body of water leads to a type of reflection known as specular reflection. Reflection off of rough surfaces such as clothing, paper, and the asphalt roadway leads to a type of reflection known as diffuse reflection. Whether the surface is microscopically rough or smooth has a tremendous impact upon the subsequent reflection of a beam of light. Whether the surface is microscopically rough or smooth has a tremendous impact upon the subsequent reflection of a beam of light. I'll drop the link for you guys.
It's like looking for a specular highlight on like a ping pong ball versus a golf ball or something.
No, those are both balls.
How does that work on water? Because
Yeah, but when I go back
ocean is
up, when I
not
go
smooth.
up in the air to see the sun, all of a sudden the fucking reflection just comes back. I mean, how's that work? Thought that area of water lost its light, and the same thing with the local clouds. If it was as big as y'all say it is with the parallel rays, the whole horizon cloud should be lit up, not just the ones right in front of the sun. They should all be lit up, but the sun is viewer dependent.
Good game. GG, fellas. Show good sportsmanship. Shake our hands.
Yeah, me and Austin's 1-0, man. I'm keeping record from here on out.
Are you guys not going to line up and shake our hands, man? Show good sportsmanship, man.
Yeah, good game. Good game.
Good game.
Good game, asshole.
Fair enough. I'll take that.
I got a little test for you guys. I found this online. It just tells you how to do this test. And I think all you need is a spoon, so I would just say check that out and then we can do good game. We'll have a good game. I'll do it too.
Oh, man. Here, I'll give you another. Do you guys have a preference? Do you want Harvard or Yale? Do you have any preferences?
Yo, how you guys doing today?
Pretty good.
We doing pretty good today.
Yeah. I got a little bit of breakdown, but like, I was thinking about like, it's just, I know.
Yo, this guy.
Okay. Yes, I got some excellent information. What?
This is gonna be.
Here's my thought. Oh, here's my.
Yo, bro,
idea.
are you just drunk or are you high and
No,
drunk?
no, I'm not high. I'm not high.
No,
I
that's
give you an example.
I want to hear what you guys say. I want to hear it.
I give you an example. Why in the world, without no governments,
This guy's lit as fuck.
This dude is litty, bro.
What? Without no governments, we can do anything we want.
Dude, I don't think I can talk to you unless you take another shot of tequila. That's the only way.
Take the socks out of your mouth.
That's funny.
That's not sucking.
Dude, this guy feels the earth spinning.
Yeah, if the earth was spinning, he'd already fell down.
No.
He's feeling Coriolis force.
What happened without no governments? Like, government is gone. It's like it's peaceful, like peace, like unity for all.
That was
I'm
your
in the South.
profound
I'm in the
idea.
South, man. I'm in the South, and we have governments, but we got them in check, man. They're still here, though.
Hey, Richard Glue, how many fingers am I holding up?
I vote Mercy mute. We shouldn't be making fun of this guy. We should just mute him.
No, they're not muting.
I ain't even mad at you, bro.
Nope.
It was Shabbat, man. You're allowed to have a few drinks on Shabbat.
Absolutely, but we should mute.
Just say the Earth's a globe. Just rep that side. You know what I'm saying?
The earth is flat.
Oh no!
You asked for that way too.
How dare you?
Can't represent flat while you're freaking messed up, man.
So, Kosho, how did the specular reflection sting feel?
I didn't know. He posted a freaking
A
like he
spoon.
said. I wouldn't have known it's a spoon if he hadn't told me.
right now.
Dude, you went Matrix on us. It's you are the spoon.
Yeah, I think
spoon's
that
not really there.
This might serve to be a great test for you guys to actually, instead of just claiming something, you just like test it out. Like, oh, wait a minute, what's wrong about that? You know,
I can test it out pretty easy. You can just go look at a circus mirror. Why does the circus mirror make you look so crazy?
Well, they're distorted purposes like that. But we're not. We're talking about angles that are much. Well, they do convex and concave, you know, off and on. So it's like you get like a weird distorted version of yourself. But we're talking about a slight angle that's not doing both things. So you wouldn't expect it to be some, funny thing like that. You might expect slight distortion, but as Hugh said, the distortion is completely, it's going to be, it's going to change with the degree of the angle.
Gotcha. Why wouldn't the whole entire ocean just be lit up evenly if it's from 93 million mile away parallel rays?
Usually is lit up when the sun's out.
But why would you just have the single line straight? Why wouldn't the entire ocean be evenly distributed with light?
I mean, you could ask the same thing about a glass vase, a rounded can. I mean, the whole thing's obviously, you can see the whole thing, so it's lit up, but there's like a specular highlight on it. It's not, I don't know, it's just weird that it's only strange in this instance, but you see it all the time. Like a water bottle, all sorts.
Oh. So if the sun is 93 million miles away and all the light rays are parallel, there would be no preference as to where the light was distributed on the Earth.
Yeah, well, they're not completely parallel, but I don't think that's what's happening anyways when you're seeing it. I think it's the angle of incidence between the sun and your eye that's going to determine where that specular highlight is.
Okay.
That's why when you move, that position moves.
Hey, Coach, if the sun was more local, what would the reflection look like?
Jeez, I don't know. I mean, it would be
just say it, man. It look exactly like
I know
what
the shadow.
Yeah,
Well, the shadows would be different. They'd be angled.
What?
Be angled. So I'm trying to imagine what that would do with a sort of specular highlight. I'm not sure if maybe it'd be much brighter, perhaps. I don't know.
It would look exactly like what we see. You can literally just replicate it. You can just get a laser and replicate it.
Yeah, if it was the shadow would change 1 degree after 69 miles. If it was 4,000 miles up, right?
Actually, I'll give you a picture. I was staying at an RV park and it had a pond and it had light poles all around the ponds, and it looks exactly like the sun. And of course, the light poles are like 15 feet maybe up above the ground. So local light would look identical to what we see. Here, I'll drop the picture for you.
No, I was just thinking. Sorry, I was talking to someone, but yeah, if you have you ever seen like, 'cause I play in Blender and stuff, and you can have like a really bright light, or I'm sorry, not as bright light, that's further away. No, sorry, a really bright light that's further away, and a very very bright light that's smaller and closer, and you'd be receiving about the same amount of energy, I suppose, but the light that's smaller and closer, it would be much brighter on the surface. Like, it would be much more glare. I mean, that's what the image is.
What about
not to distract, but just because I was looking through my pictures and I saw this, I took this while I wasn't driving, because that would be irresponsible. And as you can see, doesn't that clearly look like exactly what the sun does in the sky?
Not exactly, but it does look like a light in a camera, sure.
It looks like the light's going down away from you, but all these streetlights are the same height, right?
Sure, but I mean those are just lights. I mean they don't look like what the sun looks like, but they do look like there's a similar effect, especially the fact that it's in the atmosphere, it's in your camera.
All right, so
I mean,
you
a
do,
candle
so
would
you
do
do
that.
agree that that's what would happen. That's how the sun would set over a flat plane.
No, that's how the sun looks like. I mean, the light looks like that. That's what light looks like in the
Well,
atmosphere.
when people say, "Oh, how would the sun ever set over an Earth, a flat Earth?" So you agree that it could occur. This precisely.
Wait. I don't understand how's that related to it? Because I don't think that those lights are setting at all.
Right.
I don't know what you mean.
Well, you see how
Hey,
the distance of
take away the glare of that first.
Or just picture how fast they would move towards the horizon as you get away
Take
from
away,
them. They
away
would get
the.
close.
Sorry.
I just started speaking, right? All right.
Yeah, I'm sorry, man.
So, yeah, as you move away from them, they would drop quick. But as you get further and further, they start to slow down. Like they would never get past the horizon, right? But the sun seems to make a pretty constant speed in the sky.
Bacon, take the glare away from that first light, and why ain't the other lights changing in angular size?
Sorry?
They are.
Take away the glare of the first light and look at the row. Why ain't they changing in angular size?
Because they're further.
Yeah, but it's obviously something we don't see with the sun. Or when it's
Yeah.
closest to you, it's the biggest and brightest. But at the end of the day, it's super small and
Yeah,
close
it's
to the
bigger
horizon.
than that. It's bigger than that, so like it's 32,000 miles in length.
I was just making a point that lights don't shrink in angular size like terrestrial objects. We always get that angular size question. It's like, dude, lights, especially lights that ain't nowhere near us.
Well, what this
It's like it is making an English sign.
Well, also that's
32,000.
assuming that the sun is a particular size and that it's a physical thing that would apply to the same factors of angular size that we experience on Earth. That's a large assumption.
Here's what they try to hold us to. They try to hold us to this. So that the second light, let's say, we'll disregard the first light because of the glare. Just do that for me, okay? For this example, the second light, let's say it's 300 feet away. Okay, the next light that's 600 feet away is supposed to be half the size of the 300 feet, and then the 900 feet or the 1200 feet light is supposed to be half or a quarter the size of that. It's just not what we see with light. So when they ask us this angular size shit, the sun never gets within 4,000 miles. So y'all are judging it like it's up close, and then when it doubles in distance, we should see such and such amount. That's not how lights behave. Period. Not even terrestrial, much less the sun.
Yeah, I mean, what if the sun is more like a wire, where when you run electricity through a wire, the thickness of the wire and what it's made out of will change the conductivity? So what if the environment between us, the atmosphere, the ether, whatever term we want to use, between us and the sun functions like a wire in that same way, to where the actual potency of the sun, the way that it's viewed in our sky is going to be unique depending on what is between us and the sun, and that can alter and change throughout.
Or a focal point, Gio. Or a focal point where it's observer dependent and everybody sees it pretty much for the same focus. So it's going to be the same size wherever you see it because it's a focal point that's observer dependent. It feels like a fucking focal point, especially summertime here in Florida. Fucking unbelievable.
Yeah. It does seem like an opening in the heavens. I was just making the wire connection because there's a way in which, like, the way that it views the way that it views in our sky, the size of it, the apparent size, and the way that it like emits its colors seems to vary. So between us and the medium, like what I'm saying is that assuming that it's just a physical object up there and that it would just function exactly like angular size is a large assumption. Whereas if it's functioning in a way where there's actually a medium between us and the sun, and there's a way in which the sun propagating through the environment is going to alter depending on its distance from us and depending on all of the conditions in the environment, to where it could either be magnified or not magnified in different environments that would create the variation, and therefore the regular angular size type assumptions are not applicable.
Oh, we didn't bring up the light poles as a viable explanation.
Like sometimes when the sun sets, it magnifies, and other times it turns to a tiny little circle.
Magnifies?
Yeah,
When
depending
does
on
it ever
if you're using a
magnify?
camera or not.
Yeah, man. I mean, the sunsets by the ocean, the sun will grow as it sets, larger, larger, and larger in size.
Yeah,
And the
it
glow
looks-
of the sun and the way that it's emitting in the environment, at some point turns out to where it's like massive on the horizon, the entire system. Whereas other times it fades to just a tiny little circle and ends up even down to like a pinprick it fades to.
Yeah, that's,
Yeah, but
that's,
that doesn't that
that's
only
in
happen on
place-
camera?
That's very true in places like Africa.
Yeah, exactly. Oh, even Hughes knows that. There you go. See, a lot of those guys will deny. A lot of the guys will deny
Yeah,
it, you,
no,
but
they get
you
massive sun at
know,
night.
yeah.
One
Isn't
second,
that
what do
true?
we mean
Yeah,
by
the
saying that
sun's
there is?
massive.
Where you can see very far.
Yeah, the sun.
Why do-
Yeah, go ahead.
I was just gonna ask you, why do you think the sun gets bigger in sunsets like in Africa or something? Well, why would you think that's the case? You? Mic check.
Sorry.
My problem is with the smaller one. I don't think people witness that in outside of a camera.
Yeah, I mean,
What you have to do is look at it through a solar filter. But it's
Right.
not consistent. That's the point. Really, is I think we can probably agree on it isn't consistent. Sometimes it looks small. Sometimes it looks massive. I only say that about Africa because I had I had an uncle and aunt that lived in South Africa, and they said the sunsets were amazing because the sun was just massive, and they did experience that in the UK.
Yeah, but that's like a human perception. That's not the angular size of the sun. That's just because the sun is closer to things that we can see. Like when the sun is out in the sky, there's nothing around it. There's no reference, so it looks smaller.
I don't know why the African sun is so massive.
It isn't.
No, it's not actually massive. It just looks like it. There's a lot of haze and stuff. And the other thing they said is that sunsets, it'll be really, really light, and then all of a sudden it'll turn dark inside 10, 15 minutes. We in the West, we experience it going slowly to dark, but apparently there it just goes for 10 minutes. That's it. It's dark.
Well, like it's the same for the moon. When the moon is at the horizon, it looks huge. But that's just an impression. If you measure the angular size of the moon, it's the same as any other point in the day. It's not actually getting
you
big.
need a lunar filter.
No, you don't need a lunar
You don't
filter.
even need a
That's
lunar
the- Yeah, that's
there you go,
that's
Jerry.
that's the advantage of the moon. You don't need filters at all. You can measure the
You
angular
can use
size of the moon.
You need a drinking straw.
Drinking straw.
Hey, there's a picture by the way that I was looking for. So you guys, I don't want to interrupt you guys. Go ahead.
Yeah, I think there is space for you to join now.
All right, I was just saying, you guys agree that a local light source would look exactly like we see the sun. I couldn't get an answer, so I showed you guys. I have a video. And I have a picture, and clearly the reflection of the sun looks just like those street lights on the pond, right?
It's similar, but here's the thing: is that I think
That's virtually the same. I mean, you said similar. That's
Exactly the same.
on some. Okay, on both our models, the sun is more than 4,000 miles away, and it's going through a massive amount of atmosphere. So, if we take those things into account, I don't know. I'm not going to say that it's a yay or a nay. I'm just saying, it goes through a lot of atmosphere, and it's much brighter, and it's well lit during the sunset.
Well, I got them side by side right there. So
Wasn't the looking through the atmosphere when you're looking up not as much of an issue as when you're looking horizontally?
Yes, I stated that.
Because you're
earlier.
not looking through the thickest dense portion. You're just looking directly
But
up.
if you look at the bottom one, it's very light outside. Obviously, it does look similar there. You're right.
yeah, I mean, you can look at the video too. So actually, I thought it was pretty funny too, because like the fountain looks like the toroid that would be in the center of the Earth, because of the electromagnetic field. So we have, this is speculation, but in the idea that it's a naturally occurring holograph due to the polarization of the electromagnetic field, we could have apparent positions of the sun all over the Earth. And yeah, I just thought it was interesting. Circular pond, toroid in the middle, and then you have the local reflection of the sun all around it. But anyone that can say that they don't, why would the sun set if the Earth's flat? Well, there's the street lights, and whenever I say, wouldn't the sun reflection look the same? They're like, no, well, there's a freaking demonstration on a small scale. So objectively, if the Globers are being honest, they say, well, yeah, it would look just like that if the sun was local over a flat Earth, but it's just an illusion. There is a globe anyway.
You said something about retro reflectant. I don't know if I heard that correctly.
Nah. Nah.
No, I was thinking about corpuscular rays and anti-corpuscular rays. Would that would make sense with a toroidal field?
Oh,
Actually.
yeah. Like so with the sky.
Yep.
Like the stars. Yeah. Everything makes sense on a flat Earth. Let's just be real.
The sun doesn't work on a flat Earth.
Oh, very profound. Please do not overwhelm us with all the substantive specificity.
Can you give me the rough? Just you can even guess it. The size difference. If you could imagine each tropic as a circle, the Tropic of Cancer and the Tropic of Capricorn. If you could imagine them as a circle, how much bigger is Tropic of Capricorn? Just guess compared to Cancer, and I'll explain you why the sun can't work.
What model are you using? And what model are you using here?
The mainstream flat Earth one, the azimuthal distant projection.
How does that debunk the Earth being flat?
By the way, I want to give a disclaimer. I'm just pointing out this whole. This isn't for me to say this other model is correct. I'm just sharing this example.
I don't claim a model that would be ignorant.
All right. Well, how much bigger is the Tropic of Capricorn? Tropic of Cancer, if you had to guess.
I would probably need to know. I would probably need to know how big the Earth is, whatnot.
And you don't have that radius, so where's that R value?
Majority of the Southern Ocean is not even explored, so your map can just get burned up for all.
Check this out. The on the flat Earth model, the Tropic of Capricorn is almost 2 times as large as the Tropic of Cancer. If you were to consider it as like a circle, almost 2 times as large. For flat Earth during summer for the northern hemisphere for like America, North America, the sun is closer to the Tropic of Cancer, spinning around the flat Earth. When it's winter for North America, such as September, the sun's going to be more near the local sun is going to be more near the Tropic of Capricorn.
You want to answer? You ready for the answer?
So
you're strawmanning us with the model, and you're strawmanning.
Relax.
Well, your point's
in
relevant.
a full 24 hours, the sun goes from point A and it comes back to point A, a full circle.
Wrong.
You've got a major issue is during winter, for example, for northern hemisphere, the sun's going around the Tropic of Capricorn. That's almost twice as much, a little bit less, but almost twice as much the amount of extra land that this local sun that's not that far away up in the sky has to traverse.
Let me interject. I like to interject.
That's all right.
Okay. Let me interject.
If you guys got the point, I'll go on mute. Thanks.
Well, what's the completion of his point? Hold on. So you're saying that the sun? Are you trying to say that it's still a 24-hour day, even though it's making a larger circle?
Yeah,
like, what is your actual point you're making?
So to finish off the point is we don't observe the sun moving twice as fast or almost twice as fast in the sky to account for this extra distance it's got to traverse.
Have you measured that? Have you measured the subsolar point tracking upon the Earth?
Mute. You guys can discuss it with each other. I'll probably be back in 10 minutes. I'll be able to answer questions.
Wait a minute. I like to interject.
I was just wondering. He made the claim, but he doesn't have any evidence for it. He's just saying that it doesn't.
So just think about it.
Okay, just making clear on that.
He just read it on Google.
Think about staggered running in like Olympic races. Why when track athletes, when they start a race, why initially when they start the ones on the inside of the lap, they start ahead.
Well, of course, yeah, that's because they're racing. So if you have like the arm of a clock, like the hour hand, the outer part of the hand is going to move upon the face of the clock very quickly, whereas the inner part of the hand will be moving upon the face very slowly. But that whole hand is still making, one full rotation.
Kind of
around
like
the
a
face of the
wheel,
clock.
right? Kind of
Yeah,
like a
so it's a
wheel
difference
with
between
both.
rotational speed and ground speed. Yep.
Here's the breaking of that analogy. Imagine the center axis of that rotation, right? And imagine somewhere in your neighborhood. You're basically saying in a full rotation you could run around your house in the same amount of turns as one where you could run around your city. It doesn't work.
If you had one big arm, that would be what it
complete
would be.
the
If you had
circle in
one
the
huge
same-
arm that was centered at your house and it went all the way out to your city, then it would be that way. Yes, the outer edge is going to be covering more ground and making a faster ground speed, whereas the inner part will be making a slower ground speed and a smaller circle. But they're the exact same rotational speed. So all it would have to do, the sun would just be continuing its cycle and just making larger swaths of space upon the Earth. So there's no contradiction in that.
I know you don't. I know this information isn't conducive to your belief system. Do yourself a favor and try to hear me out. Try to break your current withstanding belief. If it's true, it can hold.
Okay, so
listen. The sun is local. The sun is local.
Glory, I've been responding very specifically to what you're saying. So there's no avoidance of any belief systems or anything. I have just logically and empirically broken down how that rotation works in my understanding. But of course, you can still continue if you think there's still some problem with it.
Well, I just like to interject real quick. Even in your own model, there's a periapsis. It's the highest velocity, right where the Earth.
What's its own model? Let me stop you.
Hang on. The globe, heliocentric model.
I don't have any model. I don't even live on this world. I'm not from this planet.
What?
Yeah, he's been pretending. He's been pretending to be a.
Isn't this glory?
No, I don't have any models. I'm just sharing you guys this information.
Do you understand there's observed 3-degree shift in the sun? And
I'm sharing you this information. It's very, very fucking
Hey,
simple.
do you need to get muted?
Help
Because
me
you're
help
interrupting
you.
Well, there you go. There's the information.
Can
You're
you help
interrupting
me
everyone.
help you guys? Help me help you.
Well, stop interrupting us then.
The concave Earth, right?
Hey, let me destroy your whole entire argument. So, actually, we don't have a model. You're strawmanning a model. You're also strawmanning solidity, and the sun is nothing more than an apparent location due to the polarization of the electromagnetic field. Each observer perceives it different relative to their position. We are not in any way claiming that we know there's a solid ball of anything traveling around over top of the Earth. Thanks.
Well, what's funny is how they always say, well, the sun needs to travel much faster than Capricorn, right? But even in their own model, the Earth at the periapsis gets closer to the sun. Therefore, that's the highest velocity. So it's similar. Just reverse engineer it.
It's not similar. That's like a 1 in.
It's
what
a
is
weak.
that? That's like a 3%. That's like a 3% change.
Yes, but it's a weak argument.
Yeah, 3%. The speed that the sun would be changing is a lot more than 3%. I think it's like it's almost 100%.
Yeah, nearly double.
What doubles? What doubles?
The speed of the sun around Capricorn on a flat Earth.
Dude, all it needs is the illumination. The circumference of the light needs to traverse more of the plane of the Earth. That's it.
Did you guys not even hear what I just said? Like, Left Lane, you just jumped right in and said it like it was a home run still. And Kosho, I just debunked your stupid spoon thing. There's the spoon. I did it.
One second. When the Earth has highest velocity, isn't that when the sun is moving? I wasn't finished. Isn't that when the sun is actually traveling the slowest in the sky?
The sun isn't traveling fast or slow. It's the polarization of the electromagnetic field given it's an apparent location relative to the viewer.
I'm talking about relative to the viewer. That's exactly what I'm talking about.
Apparent
Isn't that
due to the polarization?
Yeah, I also don't think the sun is traveling, right? Obviously, that's not what I mean.
I just have to make everything rhyme. Polarization, apparent location.
Yeah, that's not what I meant. Why are you saying that?
Well, because whenever you say that the sun has to go,
never mind. I don't care.
Okay, well, when you say the sun has to travel a certain amount faster, that's called a straw man because the sun's nothing more than an apparent location due to the polarization of electromagnetic field. It's a naturally occurring holographic projection. And if that's the case, which I'm not claiming I know it is to be the case, but there's a lot of evidence that shows that it's definitely possibly the case, then your entire point about how it has to travel faster is a straw man.
I didn't even say
I agree
that.
with you, Witcher.
Should, I
agree.
didn't say
Go ahead.
you should travel faster. It wasn't. It can't be a straw man if I was asking Don a question.
Dude,
Well,
it's your model.
I think
It doesn't make any.
I think
doesn't
all
make
Glory
even-
had originally brought that up. I think he's back in the chat. I don't know if he wants to try to clarify. He was talking about that, and then I was saying some of my viewpoints on it in terms of the rotational speed versus the ground speed. I don't know if he had any further. Like, I don't know if you're back, Glory. I mean, was there anything further with that, or are you just saying that you don't have any measurements of it changing speed, but it would have to on that kind of layout with it going around the North Pole? Maybe he's still muted. But Austin, I was going to actually ask you, I mean, do you think it's going in a circle around the North Pole, or like, is that your current thoughts with it, or do you think it
I think that it's possible that the source of the sun is in the center, and yeah, it appears to go in a circle around the North Pole, quote unquote, because it's just closer to the center of the toroid, which is what projects the sun.
Right.
Sorry, I was muted. Yo, you see that GIF I posted?
GIF?
The thing?
Yeah.
All right, bro, check this out. I know there's two suns here. One of the sun, the sun closer to the North Pole, that's circling directly over Tropic of Cancer. That's where the sun is for North America around, say, like June. Around June.
Right. Yeah, I got
All
you
right.
on that. Yeah.
All right.
This looks like a decent little layout. Yeah.
All right. The other one is directly going over Tropic Capricorn. That's where the
Right.
sun is for North America around December, around like Christmas time.
Right. And summer for the South. Yeah, I'm
All
with
right.
you.
I completely hear you. I see it, and the GIF shows it. They are clearly rotating at the same rate, the same 360. It doesn't matter, you know. It is there, but pay particular attention to pay particular attention to if you were to just look at the amount of land, the amount of ground distance the outer sun is covering in the same time as the inner sun. It's literally covering like 2-3 times the amount more land.
Yeah.
Which means, so if someone in Australia would be or looking at that sun moving overhead, they would necessitatively see the sun moving faster over their head to account for the extra land that it's doing versus one in see what I'm saying? So
yeah, have you thought about it whether it's at a different altitude as well? Because that would
yeah,
also
I have. So this is the last thing I want to leave it with. I've thought about it. The sun being whether it's local or not local, the sun just being a fucking shadow reflection from some other thing, the sun being a physical thing, a non-physical thing. The simple concept, speed equals distance over time, it doesn't work. Because there's 3 variables here. The speed equals distance, which is the amount of measurable distance it's covering, and time, which is 24 hours. The time is the same, but the distance in this variable is vastly different. Like
Well,
how much different? It's Kosho actually made a graphic for the numbers were there, but it's almost 2 times. You know, so like one particular counter, one may try to counter to this is they're gonna say, no, you know what? The sun actually does deviate in speed from the sun actually does move a little faster in Christmas time than, you know what I'm saying? But that amount of speed is minuscule. It's like it's a very small amount. It's like not even 10%, less than 10% increase. Where our issue here is at least 80 to 90%. It's almost 2 times the amount.
Right. So the way to measure this, which I brought this up originally or before when you first brought it up too, there's something called this. It could be called a subsolar point, which would be the point like the GP of the sun. So one way to actually measure this, and really the only way, well, one of the only ways to do it to actually get it to be concrete, would be to take subsolar point readings, you know, every depends on how far you want to go, whether you do it every quarter mile or every 10 miles. I mean, there's different size scales. But if you were to make actual points upon the Earth of the subsolar point as it's tracking upon the northern versus the southern, like you're talking about, and then actually make those physical measurements on the Earth and see how the sun is actually tracking upon the Earth and the actual distance at which it's traveling. And you are correct. If this is the case of the sun circling the North Pole, then we would have a larger ratio in the south than in the north. But that doesn't mean that the day would be any different. It's still 24 hours for them. And the speed wouldn't be any different either, because it's still, in terms of the sun moving over them, because it's still making one cycle every 24 hours. So they're still going to have a day, a sunrise and a sunset. Although, and there are actually differences, like, for example, twilight, like after it sets for people in Australia in the south, the twilight is considered how bright it is after the sun sets. That fades very quickly. Like after the actual sun sets, there's almost no twilight. Now that would fit with it being on the outer rim like that, to where when it gets that far away, it's so far away, the light just dissipates right away. Whereas in the north, we get a very long twilight. Like the actual sunlight will set and there'll still be tons of light in the air for, sometimes even an hour or 2 hours after the sunset, there could still be light. And that would make sense with it being on the inner rim, where it's closer and it's hanging around longer. The light's hanging around longer versus the way it does on the outer, like on the southern.
Well, right. That's why I, mentioned Corey Kells earlier before, when his Mark's device and how he was tracking the subsolar or the survey, right? And how he got more than 80 degrees in 3 hours. It's supposed to be 45 degrees, because you times 15 by 3 and you get 45. You get 8 pieces. That's 24 hours. I don't see why nobody's really talking. I mean, Glowbusters talked about it once time, or shared the video.
Yeah.
Who you gonna call? I don't absorb actual location. That's a straw man. I think there's tons of evidence that it's not the actual location.
What do you mean,
So-
like the sun?
Yeah.
What would that be? What would that be? What's your evidence that it's not the actual location?
Like the appearance of second suns, for one.
Oh my!
That's what I've been looking for actually too, and I found out that it actually has been observed.
Yeah, with a polar, like using polar filter. So, and then we have you can actually replicate this as well. So, like when you say "oh my," cool man, I actually have demonstrated it with the sun and the moon, and you can create a holographic representation with the polarization of a filter, or even like certain types of reflective surfaces. Polarization results in an apparent location. So, like a naturally occurring hologram is 100% viable, because we know for a fact we have tons of polarization in the sky because of the electromagnetic field.
How do we get energy from a hologram?
Because the light itself gives you energy. Because the sun's apparent location is an excitation within the medium. So, do you get that?
Yeah. Well, no. A hologram, the way I know it to be, is a projection. And so you got to think, well, where is it being projected from? Where's the projector?
The center. Okay. You know the place that it's illegal to go to?
The North Pole? It's
Yeah,
not
you can't.
illegal.
You can't
can
fly
go
within
anywhere.
500 miles of each direction. So.
That's not true.
Okay, well, it looks like you've been in this conversation for way too long not to know that.
Oh, I'm not aware of any restrictions on the North Pole. It's just not somewhere that you necessarily want to go, because there's nothing there.
It's illegal to travel within 500 miles of each direction of the North Pole. You cannot fly there. It's very simple.
No.
So if I drop the FAA saying it, you'll admit you were wrong?
Do I?
If I drop the FAA saying it, you'll admit you were wrong?
The Federal Aviation Administration.
Yeah.
Not a lawmaking body, though, are they?
It's enforced. Yeah, FAA makes rules about the sky. You didn't know that. You can even fly a drone certain places.
Brian, can you mute? Oh, or that.
So you can't fly within 500 miles of each direction of the center, man. Nothing sketchy about that. Earth's definitely a globe. So how many coincidences do you guys make yourself just like amnesia on,
Preponderance of evidence.
It's
All right,
funny
you
how there's no data there in the center or in the southern center.
That's
Like,
right. There's not.
no
We don't
data.
even have, dude. We don't even have a 9-degree zenith angle measurement at either location. Totally normal.
All those things aren't true though.
Okay, can you please drop the 9-degree zenith angle measurement of the North and South Pole?
The South Pole for sure. The North Pole's over water.
Drop the 9-degree zenith angle of the South Pole, please.
All right, give me a second. 'Cause I'm in the middle of doing something else, but I'll post it. That's from that guy Richard Schwartz, whatever. But I think we'll see in his videos. But I'll post.
Yeah, 9-degree zenith angle, and then you have to show me the sky as well. I mean, I'm not just going to believe a story that you say. So
Yeah, I mean, Howard,
Sky?
if you don't think there's any restrictions to the North Pole like that, then it would be conceivable that somebody could just go up there and simply take footage of it all, right?
I mean, yeah, but who's gonna go to?
Well, why does that never exist? And if it never exists, then I guess you would think that in this lifetime, it seems like we should be able to get up there, right? It doesn't seem too hard.
dude, a time lapse from there would be the most famous picture in the history of mankind.
It's over water. But people do
it's right
take
there.
time lapses, and they take
Check that out.
they take what do you call that? Images of the sky moving right beneath the south celestial, or the north celestial pole. There's not directly right beneath it because you can't be there, but you can be within 20 miles or so. But
What'd you say that again? You can't be
people go
where?
up there on people go up there on like tourist trips all the time. There's dudes who will sleigh you up there on like dog sleds.
What? Hey, say that one more time though. You said you can't be what? Where?
You can't be directly beneath it because you'd be over the water. You could be on a boat and doing it, I guess, but unless it's frozen. But it's not there. There's not land right there.
Yeah, Howard, one of the things I have with the one you just posted, that geographic South Pole sign clearly is graphically inserted. So that part of it's very sketchy. Like, why are they inserting a graphic sign that clearly was not part of that's definitely a composite image.
No, I don't have that video, but that is actually clipped from a video.
No, because you wouldn't be able to get the time lapse like this with that in the way. Have you ever taken time lapse?
Yeah, they show it all in the video of where they were at and how they did it and everything.
You can't take a time lapse with this in the way, though. Have you ever taken a time lapse?
Oh, why couldn't you? The sign's just sitting still.
Okay, so you have taken time lapse?
Why would that be a problem for a time lapse?
You can't have obstruction, certainly not with reflection of light. It throws off the entire time lapse. I take them all the time. You can have no light whatsoever intersecting with your camera in the sky, or it messes up the entire time lapse and smears it across the screen.
Well, that's what we're talking about.
The reflection of the light on that sign right there would smear across the screen in a time lapse.
You're talking about
It depends on how you make it, doesn't it?
You're talking about an overexposed image. That's not overexposed. That's just time lapse.
No. The reflection of that light would smear across the image. I take them all the time.
Yeah, but I mean, if you do it computationally, that doesn't happen. That's just if you do that with exposure, sure. But
we
if
know
you're doing
Glovers
that,
don't actually take time lapse. Come on now.
how is that relevant? That's just how images. One second. If you just get the maximum of each channel value of each pixel, right, across the whole video, that's what you get. You're not gonna get anything oversaturated just because you're doing that. You're gonna have that's gonna happen if you're using with long exposure, as Howard said. That's not the only way to get an image like that.
Oh, how else do you get it?
Just explain. You can do it computationally.
What does that mean?
In your computer.
So this is a computer-generated image?
No, you're just getting the video that you recorded, and you're combining all the frames, and then you get something like that.
Is that what they did?
That looks like
that's exactly what they do, Austin. And I hijacked your picture of them streetlights and made a 50-second video. I just posted it in a live stream.
Yeah, I had to take that while I was driving. So hey, can you drop the video on the source, please? Because I take time lapse all the time. I know that this was not taken like with long exposure time lapse. So you did it on a computer. So can you drop the video and source, please?
Yeah, I don't
I'll
have
see
the
if I
video.
can find it.
Oh, that's inconvenient.
Oh, I saw the video quite a while ago. I think Bebo posted it.
Oh, you say it doesn't have the video.
They
Let me
take
see if I
a
can
time lapse
find.
for like an hour and then project it over like 12 hours or 24 hours and shit.
Yeah, that's cool.
I was gonna actually mention something before when Austin was mentioning like the sun and the moon being projections. I was gonna say that that in my mind also links to the a lot of these ancient legends talk about at the North Pole that there's actually another sort of sun, like a center sun, and that center sun is like it only glows and lights up the center region, so we can't see it from where we're at. Now, possibly the northern lights are even connected to that, but if there is like another sort of sun there. That lights up that region, then that would make 3 of those main. So you have like a center sun, and then you have the sun we see, and then the moon. And if the sun's at the center, or if that one is at the center, the sun and the moon, if they're circling that, then they're always in relation to that one in the center. So if that one is essentially a projection of some sort of those, or at least connected to them, like through kind of synchronicity and through the ether, then that would make sense. And then also that starts to get into the concept of the lunar eclipse, where you have the sun and the moon are opposite each other, and then that center sun would be in the middle in that scenario. And could that then be polarizing the light between them to create the effect on the moon during the lunar eclipse?
That's what I was thinking. It was a polarization, man. Is everybody seen that Russian video of that airplane? You could see the airplane window and the guy doing a recording. It's a short video, like less than a minute, but man, if it's a fake, it's a hell of a fake. But you see a hole that, I guess from that height, that hole would probably have to be a mile or two.
I seen that. I seen that.
I mean, that looks weird. You see like a sun down in there. It looks so fucking real,
It's
man.
like a tornado looking. It looked real as fuck.
Dude, that reminds
It's
me
a
of
big
that.
old hole, like a giant sinkhole 2 miles wide with a little, with the atmosphere kind of and water falling over the edges. Almost how they describe, like Mercator and them fucking described it, man. With a glow from down under there coming, man. That shit looks so real, dude.
That shit
It's
looks
baffling.
Dude, it reminds me of that Mason video with the disc where he had the black sun
Yeah,
as
yeah.
above so below. Is that what you're talking like that? Have you seen that?
No, but that's exact. No, this is an actual video. It's a Russian video of a guy in an airplane. It says he's flying over the North Pole, and that's what's there. It's a fucking big giant hole. It's something. I'll try and find it and post it, man.
Yeah,
It's
I want
fucking
it. I
crazy.
want
Yeah,
But
yo,
it
look on
describes-
BitChute.
You never seen that, Don? Jeez Louise,
No,
brother.
I've never seen it. That reminds me of that Mason though when he did that CD, and there's the black sun underneath. It's as above, so below, and that's where we get actually the eclipse and all that stuff.
It's exactly like that. It's like a real life version of that.
The gravy is that he even claims the distance to everything, and it's the CD-ROM, for example, is made with the exact metrics, like 33 millimeters, whatever it is. Yeah, it's really crazy.
Yeah, with that 33, dude, everything's with that 33.
Because it's the sun. It's because that's what the Mason in the video claims. That's the sun's distance and size. 32 miles wide, like 32-mile diameter, and I can't remember, 3,300 miles or something like that. But if you look at the CD-ROM, it's like the same metrics, and of course that shows you the same thing with the center, right? Having the hole in the center.
That would explain why there's data missing, though, in the southern and in the north.
Yeah, and most of it's missing in the southern oceans, which I think is where there are just huge pieces of land.
Right.
I don't even think we need to go. I think it's possible there's more land beyond what we think is Antarctica, but I do not think that that's even needed to explain the motivation for the lie. Like, dude, when you really look into it, the Southern Ocean is like unexplored, bro.
I think it's possible as well.
Yeah. Like, I definitely think it's possible. I have no idea what Antarctica is, what the full extent of the Earth is, but I think within the Antarctica, there are huge areas that are unexplored. I mean, when I say I think, it's very, very easy to fact check that. Now, like, what is there? I don't know. I'm not making any claims. Dude, it just gets crazier the more you look at it. It's like there's stuff all around us. There's stuff at the center, and there's stuff in the Southern Ocean. I mean, areas that aren't even technically forbidden from exploration. And, like, no one ever goes there because there's, like, no real reason to go there, right? Like, because, I mean, there'd be no efficient trajectory to go anywhere. Like it would be no efficient travel path. Like it would not really make sense to go there. So no one goes there. And actually, typically, it's much harder to navigate the further south in the ocean you go. It's also way less opportunity to be saved were there an emergency. Like basically, no other ships close to you that you could contact to help. So no one would just go there for no reason. So that's the stuff I'm kind of interested in. But the problem is, it's really hard to log your miles. And it's hard to completely navigate. Thirdly, you're just basically aimlessly hoping to come across land. And then in the theory, like what would happen if you did find it, right? So,
well, you got Point Nemo down there too. You know, I think they have to have clearance, like the certain airplanes or boats and ships. They have to have like clearance to be able to go.
Yeah, and I mean they'll just turn you around in terms of their military. I mean it's actually in I don't know exactly what that more information is on the one from that new documentary, The Next Level. In that one, like there was actually footage of these guys getting turned around by a huge naval ship.
yeah. Isn't that crazy too? Like, dude, think about this. Like, how do you hear that, know that, and still not think anything weird's going on?
Dude, the one thing I noticed though, even when I talk to like average people that think the Earth is still a globe, they still think they will admit that something funky is going on with Antarctica.
Almost everyone knows that, but like, dude, even the mainstream like Ancient Aliens, which is obviously the government. Like, obviously, Ancient Aliens is just the government. It's very obvious. Even they make sure to address something's going on in Antarctica because it's just so obvious if you look into history. So that's what's crazy is that, dude, I traveled to the U.S. for that very reason. Like, not let the Glovers tell it, like, I just love attention. No, actually, I had to get talked into even doing this publicly. Like, no, I don't like being the one crazy guy on the mic. In my whole life, I've always heard someone on the mic or a bullhorn and immediately, like, got infuriated that they were doing that. And it's just not, but anyway, I went out there because I couldn't reach anyone on YouTube, but I would have, like, famous people hit me up, like, DM me, and say they'd see my stuff, love my stuff, whatever. I'm like, what's going on? Like, how am I reaching this dude that has like 3 million followers and I have like less than 10,000 subs, you know? And I'm just like getting mad. So I'm like, I want to go out into the world, you know, because they can't censor that. And then and the reason I wanted to go do that was I want to see really how many people even have heard the true flat earth position. And just so everyone knows, it's basically no one.
I posted the video, by the way.
So, like, even the Glober should admit that's pretty crazy, right?
Right, and when they often think that, like, oh, the world, everyone thinks the Earth's a globe, and they think that that's like a strong position, but in reality, 99% of people actually just have no idea. They haven't even thought about it for a second, and they don't even know much about the globe anyways. I mean, they would say, yeah, it's a ball in space, right? And then, of course, that's about all they would know. It's a lot of most people. But then there's some that are going to, understand it either to some degree or a greater degree, depending on, their awareness of it. But that's only a very, very small percentage. So the potential for a huge shift to happen is always possible because most people really haven't even made up their minds yet at all.
Right, and you can see how the powers that be feel like they're still they never stopped winning because, the vast majority of people have never even heard the true flat earth position. So, like, they still feel like they're winning. And to kind of prove the point you're saying, that's the reason I did that $100 game. I didn't do the game just so, like, hoping that people would interact. I mean, that was part of the reason, but it's like, I just wanted to actually know. I wanted to know, and since there's money on the line, people will guess the best they can think of. And, dude, how fast does the Earth spin? Like, okay, dude, for one, the first question, whoever doesn't know, is just like, how many times does the Earth spin every day? and then I'd say, like, how many times does the Earth rotate every 24 hours? You know what I'm saying? And I would look at the crowd, and I got to where I'm really good at reading people and crowds now, like reading where they're at. And dude, majority of people don't know that answer, and the vast majority of people are very uncertain with themselves about that answer.
True.
I couldn't think of an easier question. Can anyone think of an easier one? Like if you're going to ask a
what
question
is
about
the
the
answer?
model, how many times does the Earth supposedly spin every day?
Yeah.
Once.
Yeah, it's pretty.
Yeah, it's 1.003 actually.
Oh my gosh. Okay, so the point was.
Well, Bacon, you're literally 1 in a million for even thinking that.
Yeah.
Whether that's even the case or not, I don't know quite where you're getting that. I mean, because there's also the equation of time to where that changes. So there is no one speed of it. It fluctuates and changes all the time, technically.
What do you mean? A sidereal day changes?
Got
Yep.
Wait,
Yeah, you got that wobbling
1.003.
effect.
That's
No,
one of
the solar day does the solar time,
Oh yeah, sure.
which is
But we
connected
don't.
to your rotating Earth. That's your
Yeah,
rotating
but we
Earth in your
don't.
model.
We don't use the sun to mark days. We use our clocks and calendar.
But why don't you use the sun if we're just spinning?
Because the
It
sun
would
doesn't
always
make
be one.
Yeah,
If I was
no,
like a
because
caveman
it's not a constant.
if I was a
Because it,
caveman, hey man, if I was a caveman, I jumped out and I looked at the sky, wouldn't I? And I'm like, oh, and I was a smart enough caveman to be like, actually, I mean, when I say smart, I mean like crazy enough to say, actually, the Earth's a ball and it spins, and the reason that we no longer see the sun is because I spin away from it. So every morning I take an
sounded
epic
like you're gonna make
nose.
a question.
Every morning I took an epic nosedive. Right. Next time you look at the sunrise, bro, just really soak in that you're taking you're basically skydiving and taking a nosedive towards the sun.
But you're going to ask something.
Have you ever thought of that when you looked at the sun?
When I what?
Have you ever thought of that when
How you worded that? Have you ever thought that you're nose diving when the sun sets? That's funny.
Crazy. Like nosediving during sunrise, and then you're falling backwards. Which I've said that one a lot.
Wait a minute. Michael Jackson did. Maybe that's why.
Yeah,
There you
Bacon,
go.
like
There's
when the
evidence.
sun's setting, do you think that the whole Earth is like that you're tilting backwards through space?
I don't think of that. Every time
You
I see the
should.
sun setting.
But do you think that's what's happening? Like your spatial relationships, like who you are, what you are in the universe, like do you really think you're moving through like that's actually happening and not that you're just stationary within the coordinates that you're in with the sun moving away?
Yeah, that's what the evidence points to.
The evidence points to the sun. I know it's stationary and the sun's moving away. I know, but I'm saying, how do you? Why would you believe that you're falling
I
backwards?
said the opposite.
See what you did there.
That was smooth. Dude, you should think about it, bro. You should wake up and look at the sunrise and just think about it. Like
I don't wake up that early. When
well,
I
you
wake up,
should.
the
That's
sun's
what I
already
just.
there.
I know, but you should just wake up.
But I can watch sunset.
Well,
That's fine
well,
by
check
me.
it. That was the end. So you should just for one day, right? Because you've done all this. You've looked at all the depths of the theories. You've convinced yourself that there's enough evidence to keep the globe alive. All right.
Well, that's
So
what I
what you
found.
should. Right. So if that's what you found, then the next step is really what actually fully broke me. And that was I went through an entire day where I actually thought about everything as it pertains to what you see in nature and what the earth is. So
Oh,
my
I
suggestion is what you should do.
do that often when I'm looking to the moon, for example.
Okay. So my
Mainly
suggestion, when
mainly
you
during
look at
the
the
eclipse.
moon, you think about how it's going around the earth over 2,000 miles per hour. And if it was spinning 1/4 a mile per hour faster or slower, you'd see the rest of it.
No,
Do
I
you
think
think
of
about
like
that?
it's actually something that is like there, being there, and it's pretty huge and it's falling around the earth.
No, what I'm saying, you have to think of, I'm saying, okay, but think about what the model claims. So it claims that the moon is moving over 2,000 miles per hour, and that if the earth was spinning less than 1/4 a mile per hour or faster, I mean, slower or faster, you would see the rest of the moon. Have you ever looked at the moon and thought about how it's actually moving 2,000 miles per hour
That number
around
is
the earth?
meaningless to my intuitions. It doesn't make sense for me to picture that.
Okay. Have you ever looked at the moon thinking like, wow, this is spinning while revolving around the earth? And if it was spinning 1/4 a mile per hour faster or slower, I'd see the rest of the moon.
I posted that video in live stream. Anybody wants to see the hole in the earth?
That's something called tidal locking, so that doesn't happen.
Oh my gosh! I'm just saying, if you ever thought about it, you just look. Well, I'm saying when you look at it, think about. Okay, well, my real suggestion is this, right? So one day, bro, you just wake up and you go look at the sunrise. Okay, and you think about, wow, I'm falling towards the earth, effectively having the most epic towards the sun, effectively having the most epic nosedive ever.
I'm just cracking up over here, dude. That is so funny.
That's just to start your day, dude. That's to start your life-changing day. And the point is, when you get to see the sunrise, you maximize the amount of observations you get to make this day. That changes your life.
You're on the biggest rocket ship through space that you've ever known on this huge ball, and you are just the way you describe the nosedive as an epic nosedive. It's just funny thinking of the huge globe and diving into the sun.
Dude, you're going 1 million miles an hour.
Where do you think Michael Jackson got the idea from?
1 million miles an hour? What's that?
The
galaxy. Technically, the galaxy's carrying us 1 million miles per hour. While we're going around this thing that we're nosediving towards, 66,600 miles per hour. And our nosedive.
What's up? 1 second. Which speed is that? The orbital speed?
Mm-hmm.
All right.
Just a coincidence.
And all that time, hundreds of billions of miles a year, and all that time we looked through that little hole at the Guidestones, and there's Polaris. Get that little fucking hole. Imagine that, man.
What I don't get is if they buried a time capsule, at the Georgia Guidestones, then why would they build something that would actually not remain accurate? Why would you spend $1 million on it?
It's been like that for 40 years, dude.
And it's got a time capsule buried there.
Yeah, but just because it's not going to point at Polaris doesn't mean it's not going to point at the celestial North Pole or whatever.
So
it should move a third of a degree every fucking 20 years, or every 30 years.
Yeah, for the position in the celestial sphere, but not the celestial sphere, but the actual stars, but they'll still be pointing at the celestial North Pole.
Yeah,
which will always be Polaris.
It's not Polaris even now.
I think it's a third of a degree every 70 years, actually, man. But it should be noticeable in a lifetime.
It's not the same
noticeable in a
Polaris
every 2 seconds.
Isn't 90.
What?
Polaris declination is not 90 degrees.
That's crazy, man, because when I went to the Georgia Guidestones multiple times and I looked through that hole, guess what I saw, man?
Oh, nice.
Guess what I saw, man? Guess.
Yeah, I'm guessing Polaris.
Yeah.
Does that mean
the actual
Polaris declination must be 90 degrees?
You can only see one star, and it's perfectly in that little hole. You'd have to experience
I challenge you to perfectly.
I'd imagine that you'd probably have to experience it prior to your challenge. But that wasn't my point, though. My point was that being there multiple times, and even taking a time lapse, there's a time capsule buried there. Okay, so I'm talking about the totality of what the Guidestones are. Okay, and so what they are is they are a capstone at the top with Babylonian cuneiform, and then it breaks off in these different languages. Similar to the story about the Tower of Babel, and all the languages were broken up. You follow me? Not a coincidence, of course, and then donated under the pseudonym R.C. Christian. Then we have the list of the, let's call it the New World Order. And dude, this stuff is very impressive.
I'm not a fan of interrupting, but if you're speaking to me, I have no idea what you're talking about anymore.
Okay, so well, I'm just building it all for you. It's very expensive, impressive stonework. It has a time capsule. It would be rendered useless. You cannot see the star in there. You're acting as if they built it not to see the star, but if you actually go there and look at it, you know 100% that clearly what it is for. It's incredible. You're like, how does that even work? It's so insane, bro. You look through that hole and bow, you see Polaris, and that's all you see. It's so crazy, man. It's so crazy. It's like you see Polaris, and that's what you see.
Yeah, but it will always point at the celestial North Pole. So, regardless how further away from the celestial North Pole Polaris moves, it's not going to matter. It's already, isn't it already
Oh,
like
that's not true, man. That's not
7/10
true.
of a degree?
It's supposed to move a third of a degree. It's either every 30 or 70 years, but they say
it's
it'll
just one
be
degree every
recognizable in
72
one
years.
lifetime, bro.
Yeah, it's
What is
1
it?
degree every 72 years. That's right.
So that thing
well,
is
it's already
going to
been
be
40.
rendered.
It's already been 40 years. It was put
Yeah,
up in the
it's
80s
not in
or
the,
something.
it's not in the middle.
Coach, that's precession of the equinox.
What do you mean not in the middle? There's no
how do you know it's
Exactly.
not in the middle, man? If you've never
That's
been there,
how fast Polaris moves.
It's the hole is the middle.
how do you know it's not in the middle if you've never been there?
Because I measure it on a normal basis.
You measure the hole without being there.
I can measure. I can measure the angular. The angle that is in the sky, and I can measure its position over the span of 2 or 3 seconds, and its position changes. The position of its GP.
Well, just to clarify, I do agree that if you want to get hyper specific and technical, there's an area even like Polaris makes the tightest little vibrational movement around dead center that could exist.
It's a circle.
That's why we use it. That's why we use it to navigate, because it takes the tightest circle imaginable around the actual center of whatever the force field that moves everything in the sky is. I mean, everything moves everything,
so
puts
you
everything into
changed your
motion.
claim now, right?
Hey, Whitson, have you
No,
ever
I didn't
heard
change
these
my
talk about
claim.
Yeah, it sounds like you do because having the
I've been
tightest.
saying this for years, bro.
No. Having the tightest
Yes,
circle and
years. I've been saying this for years.
Having the tightest circle and being in the center sound to me like two different things. And you're claiming the first one now.
Okay, well, I'm claiming
Austin,
the
have you ever
accurate
heard
one,
me
and
talk
I've been
about-
claiming it for years, bro.
I have a friend who did a time elapse with North Star with Polaris, and he did it 6 months apart, and he got the craziest thing. It was like a total eye of Ra. It had one line at the top, and then it had one at the bottom, and that did a little divot, just like they draw the eye of Ra. It was like a little.
I
But I
believe
want to
that,
say
bro.
something
Yeah.
Bacon real quick. Bacon and
So
Coach
6
show.
more months,
If
it'd make us.
this moves 1 degree every 72 years, and it's been there for almost 40 years, the sun is a half a degree, right, in size. Okay, so it should be spinning a circle already since they put it up, bigger than the hole that you even see it through, man. It should be spinning a little over half a degree circle, man, and it's
It
a
does.
way tighter circle than half a degree. It's like a fucking
It's
almost like
barely
spinning in a circle.
anything humans try to talk about Polaris's movement is ridiculous, and it's not even worth addressing. And its benefit is that it is how we know where the center of the sky is always, forever, till the end of time. Because it's going to always be right.
I measured all
In your worldview, that's not the case. I agree, but time will just decimate your worldview, as will the Georgia Guidestones, which cost hundreds and hundreds and hundreds of thousands of dollars to build, and not for no reason. And it's clearly
Didn't they
built
follow
to
the North
stand.
Star to get to Bethlehem and shit? Like back in the biblical days, they followed the North Star to get to fucking Bethlehem.
They're going to try to say all this kind of pseudoscientific nonsense and then bury it in fake history about how they used to say it was something else, however many fake made up years ago.
The Bible doesn't say
It was
anything about
named.
Polaris.
Hold on, it was named hold on, Polaris means pole star. It was fucking named that by the damn Greeks, bro. How is it fucking moving if it was named the pole star by the fucking Greeks 1,000 years ago, bro? What the fuck? Why do y'all still keep pull that shit? Like it's moving so much, such and such.
Okay,
Let me
so
take a look at Stellar.
you agree that this thing would not show Polaris over time? The Georgia Guidestones.
Yeah, it's not going to be there for a couple hundred years. It won't be there.
Gotcha. So that sucks. They're dumb. So anyway, back to the point I was trying to tell this guy about. So you just wake up one day, right? And then you go look at the sunrise and you're like, whoa, I'm effectively free falling in the most epic nosedive ever right now towards the sun. This is super cool, man. Radical, bro. And then you start the rest of your day and you watch the sun throughout the day. Not literally just sit there and watch it, of course, but you get it. Then, I don't know, you have all kinds of crazy stuff that'll happen on this flat earth. Like, the moon will just be in the sky sometimes. Maybe that'll happen for you during the day. So look up at that moon that you can see during the day and think about how, wow, people supposedly walked on that thing. And if it was spinning any faster or slower, we would see the rest of this ball. But forever, it just always looks like that and looks super still while it's still. But it's actually spinning. It's spinning and revolving. What's up?
That's the most common orbit. It creates like a resonance. So most of the orbits in our solar system are like that. Most of the orbits in the moons in our solar system, I mean.
That's very convenient, isn't it, Kosho? Because we're actually just looking at cymatic patterns of energy introduced into a fluid medium that illuminate. So anyway, let's look at this pulsating orb and be like, wow, we can't prove it's a solid or a sphere, but let's pretend it's both of those things while it's spinning and revolving, and then it just coincidentally looks just like it wouldn't. So anyway, I'm just trying to say, you should look at the Earth for one day, actually thinking about it. In fact, if you make your itinerary tactically, you can really crush. Like, let's say you go to Niagara Falls after sunrise. Actually, let's just watch Niagara Falls at the sunrise, or sunrise at Niagara Falls. So 2 birds, 1 stone type thing. Wow, dude, I'm nose diving towards the sun while this gigantic waterfall that creates so much electrostatic charge that the boats literally run off of that, charging their batteries, floating around it. And
I might do that.
And this Niagara Falls here is actually tilted backwards, and it is falling upside down in space while I free fall towards the sun.
One thing I'm not gonna do is, I'll be seeing a solar eclipse next year, and when I'm looking at it, I'm not gonna see like something exact size of the moon going in front of the sun and making everything dark, and think, well, I have no evidence that that's actually the moon covering the sun. That's not something I'm gonna do.
Okay.
Okay, maybe you should make
the moon approaching it.
Yeah, you can't do that, but this is perfect. Make that the day you're going to change your life. So what time is this magic solar eclipse that you're going to go to? And I say magic just because I just know it's hypothetical.
Time of the day?
It's a habit. What time? Do you have any idea? I mean, I wouldn't be surprised. I'm not going to hold you down if you don't know the time, but just throw a time out there you might think it is, or we can rock with any time.
Yeah, let me take a look. I can look right now what time.
All right, perfect. Because
real quick,
if we can get a solar
check out
eclipse on this day, your life's really going to change. What's up?
Check out the thing I just put in the live stream, the turning paper where it arches, stays centered on Polaris. See how he's turning that? Now you'd have to think that, I brought this up in here before. You'd have to think that then the Earth is rotating, right? Keeping all of those stars centered inside that archway, right? So their excuse is it's the angle, right? And that could still happen because the stars are so far away that you can still have that angle, even in this place in Nevada, and then also in Georgia. They're both keeping that. So it's almost like you'd have to think they're right like 90 degrees to the star, the way the rest of the Earth would have to rotate. You see that?
Wow.
How could it be rotating to keep that in place 3 states over, across the country, or even, many places across the world? How is it that they're kept in place and still accessing, rotating with that in place. You know, I mean, it has to be because they're so far away if it was a ball, but it still doesn't even make any sense. Intuitively and logically, it doesn't seem to add up.
It's still so cool though because, bro, I know they cut that circle just big enough to where Polaris never gets outside of it, and that's why it's the size that it is. I don't know, Globers, you got any answers for this? Just what he said.
Polaris makes a circle that would have a diameter that's a little bit bigger than a degree. So
the Earth spins. All right. So whenever he comes back with the eclipse, we'll add that in there. But anyway, so the overall
It's
point
3
of it
p.m.
was 3.
It would be 3 p.m. local time. Yeah.
That's perfect, bro. Perfect. I'm not even joking. You should do this.
No,
You
not
go
3.
to
It's 5 p.m. 5 p.m.
where's that?
Brazil, northeast.
Okay. Nice. So you got waterfalls in Brazil, right?
I go what?
Waterfalls.
Yeah, I have huge ones in the city I live in, actually.
Nice, dude. Waterfalls are dope. So on the globe, the Earth is spinning. That waterfall's spinning, tilted back, falling upside down in a way, right?
Oh, you know, down is more or less.
Yeah,
towards
that's
the
why I said
center.
in a way.
Yeah, so no problem there.
Well, I mean, it's like if you
Anyway,
would pop up off the Earth, you'd see the waterfall going down, falling upside down in space. I mean,
well, except that if I was in space, I wouldn't have like a notion of down, right? I would just be.
well, you'd be looking at the Earth, knowing what down was relative to your sides. Jeez Louise, the pedantic, bro, my man. When you look at a
I could have
powerful
any
waterfall,
orientation I wanted, it would feel the same, right?
okay. Do you think that waterfall is tilted backwards?
Tilted backwards. What do you mean?
Like it's tilted away from you.
That is a good question. Do
Anyway,
waterfalls tilt?
Yeah, it's got to be tilted backwards, my man.
That should be like the name
you
of this
gotta
song.
save.
What
You gotta
tilting
save your question
waterfalls?
for tomorrow.
Where are the
I'm beginning
tilting
of today.
waterfalls? We got to get Demox started on tilting waterfalls.
Why would there be
We should
tilting
remake
waterfalls?
that song. We should remake a song called "Tilted Waterfalls."
Anyways, you guys have a good night.
All right, whoa, before you go, bro. Here's the deal. What my point was to you. So basically, it's like just wake up, look at the sun. That means you free falling, skydiving towards the sun. It's really kind of a crazy thing. Think about it while you watch it happen, and then look at the moon or whatever else you can see. Look at the sun throughout the day. Say you see a solar eclipse. Just really think about, okay, the moon I can't see all of a sudden perfectly. It blocks the sun, and it's coincidentally 1/400th the diameter of that, but it just happens while this is all spinning and the moon is also spinning. And okay,
Yeah,
and then finish your day looking at a sunset, which are beautiful, and most people, I've seen many of them. And I really encourage people to throw the sunrise in there because no one even thinks about what that means on a globe, much less have they actually experienced life thinking about it. And no one even looks at the sunset thinking about it. Look at the sunset, watch it, and you're going to be like, bro, we're clearly standing right here waiting on the sun to optically go down. We're just standing here, waiting. Or the sun is sitting there, and we're free falling backwards.
Okay, and I'll make my recommendation of life-changing day. Right?
And
So
also,
when you're seeing the sunset,
just real quick, Bacon.
I want to hear.
Just so you don't waste any time.
Yeah, hold on,
Dave.
Let him respond.
Okay.
I want to hear Bacon's response.
Yeah, I mean, just when you're looking to the sunset and you see like half of the sun above the horizon and half of the sun obstructed by it, you picture that on a flat surface, right?
Yeah.
Oh, that's all. Good night.
Damn.
Hey, Bacon, just so you don't waste time.
Wait, what did he say? I didn't actually.
Bro, I've already done that, right? I mean, come on, man.
Bacon,
I
say
did
it
it
again.
5 years ago, 7 years ago.
I said, look at the sunset, and when the sun is half above the horizon and half below the horizon, try to picture that over a flat surface.
I did that 7 years ago.
Yeah,
and know that it's not really there.
Yeah, I mean, I guess
get the full thing and picture. Zoom in on it, and you'll see it again.
Yeah, you can just take a laser on your table, see the exact same thing, and that was. I mean, come on.
It doesn't look like a laser, but
Yeah, it does. The laser bot disappears from the bottom of my man. You'll get a half
Alright.
circle.
Have a good night, guys.
All
Wait,
right,
Gio
bro.
has
Try to
something to say.
look at the Earth and think about it.
Okay, bye.
Oh. Okay. I'm just saying to all the Glovers, has any of the Glovers that are in here actually done that? Like looked at the Earth and thought about everything? Actually thought about it while you observed it?
It's not really a way of looking at it. Doesn't make sense though.
Oh, I agree. That's my point.
Well, what
No,
I was
I
going to
just mean
say to
like
what Bacon was saying, that yes, when the sun is getting cut off halfway, that does look like it's over a plane to me. Because what I experience, I'm on the Earth, the sun as it dissipates, the inverse square law is in play. So light and the heat and the infrared, all of it is fading, which makes sense in terms of a local environment. And as it's fading away, due to perspective, it is going to converge at the horizon point. So yes, it is only just moving away, in my understanding, over a planar surface. But because of perspective, it will essentially meet with the horizon and will have that exact precise effect over a planar surface. I can understand why it would work on a globe idea. I really can. I mean, that works on a globe, I guess. Well, it actually doesn't, because the sun would have to be local on a globe for that to actually work. The 93 million mile thing with the inverse square law and all that doesn't work at all. But if you made it like a local sun on a globe Earth, it would, it might
Just
be
make
that
the
way too.
heliocentric model local.
Well, do you know? Have you guys ever paid attention to how they do the model when they do it in a little lab setting or classroom or whatever? They get the ball and the moon and the Earth, and they're real little and they're local. Like, so all you have to do for them.
Right, you're right. That is how it is. You're right. Yeah,
just
all
make it like a mobile. Yeah,
all those
totally.
like mobile, all that stuff has local suns. It makes more sense that
Close,
way.
very close and local. Very, very close and local. Definitely not the 65-mile space they would need.
That's
You know, if they have to
Yeah.
give up the distant sun, they may even try that and then just like redefine it with like an electric sun type heliocentric model.
Yeah, I think we can patch their model way better than they can. I'm not even joking.
It's like a
Well, I gotta ask you-
coincidence.
I gotta ask you guys-
It's like a coincidence. Cocho, is it a coincidence to you that when we see the sun
Hold
and the
on.
hot air balloons and weather balloons,
Brian,
it
that's
looks,
coincidence,
it doesn't look
Brian.
round?
Well, we've been seeing all the holes and faults, and we've been fixing it. I mean, we've advanced their model to just be more dissolved into instability.
And we actually
I have a
advanced their
question.
model literally because NASA responds to flat Earth, including literally Globebusters and Jaren for years. Like literally, I don't care what any Glober has to say about it. NASA literally puts out content relative to what flat Earthers are doing.
Yes.
Fantastic rhetoric, but I have a
And that
question.
distant sun having the little tiny planet block out all of the sunlight so well that it seems like a pitch black night. You know, their best answer to that was what, Kosho? That you can
No, I
only see
wasn't
so
listening.
far,
I
so
was
that's why.
waiting
No,
to
if
the
you,
rhetoric
how's the
to
little
stop.
planet block out all of the sunlight? You know, like if it's that far away and that bright, you'd think we'd have like sunlight rays coming off the side of the planet. You know, when you think about like how powerful it'd have to be, you'd almost see like a little bit of like bleeding in of the sunlight to your side. Either way,
I have a
you
question.
understand what I'm saying?
I was, like I said, I was just waiting for it to.
Kosho
you
had
guys
to
are going
zone
on
out
about
there.
this,
All right, Kosho.
Yo, that was the cognitive zone out, bro.
What about
No, I was waiting. You guys were just
Oh,
you
he
guys
got
were
the
just
mic,
on
dude. He
a
got the
rhetoric spew for a whole minute. I was waiting for
no
it to
time for
finish.
the Flat Earth to Sun Society.
He's
right?
focused on
But you
challenging
doesn't
us
say
to
that
something he
about-
can't answer.
I got a question about what you guys
It was
said.
answered. Your
There we
question's
go.
probably
He
answered.
doesn't
You
say
just
it
have
about
to
aliens
This
or
is a bit more
reptiles
rhetoric.
or anything.
just listen.
All
Your
right, let him
questions
go.
will be answered.
Kosho gets
let
the
him
mic
go.
to say whatever he'd like to say.
No, if you guys want to do more rhetoric, that's fine. I was.
No,
Don't
spit
mind me
us
if I
some of
was
your rhetoric.
engaging, but
Let's hear it.
no,
Drop
it's a
it.
question. It's not rhetoric. I just was I was wondering if you guys are aware how much of the Earth, proportionally, like how much of the Earth is lit up at any given time.
Can you demonstrate that on your in the lab?
About 60%.
It's actually an inconsistency. It's interesting you bring that up, Kosho, because on a globe, what would it be on a globe? And what is it in reality? Because there is an inconsistency
With
there.
light bending on a mirror ball?
Then-
Huh.
Hold
let's
on,
see.
Demon.
Well, it should
It
be
depends
half
on where
their
you're.
ball, but it changes actually throughout the year to where it's not always exactly half.
It could never
No,
be
it's not.
half
It's
the
not.
ball.
It's not really any exactly half. It's always a little bit more because it.
Well, let's just
You
put
know,
it
it
like
sneaks
this:
past. It
the
sneaks
place
past
on
the.
Earth that gets the
We gotta,
most
we gotta let
sunlight.
Kosho answer though. We gotta let him like get his
My
words
bad,
out.
my bad, my
I'm
bad.
just saying we got
I'm
the whole
next.
gang. We got the whole gang ready. You
Yeah,
know.
yeah, you're right. I'm next with a quick comment, Kosho.
It's always a little bit more than than half, but just a little bit to account for the amount that sneaks past. Well, you know, after sunset, you know, that barely you know, tiny amount. But that's kind of my point, though. Is it's whenever you think about that fact, it's not really a question of whether the sun is small and local or big and far. The fact that
Yeah, it is.
it's lighting up half of the earth.
Let me put it to you like this, Kosho. The place on Earth that gets the most sunlight of any other place, and while we're closest to the sun in the heliocentric model by a few million miles, is the coldest fucking place on Earth.
What's the highest the sun gets there?
It's 24 hours a day, dude. Should it matter?
And
Nothing
what's the
grows there.
highest it gets?
93 million miles away. What do you mean highest it
Tell you
gets?
what, when the sun's 23.5 degrees here, Kosho, even for just a few hours, it's hot as a motherfucker in the summer. And they're 3 million miles closer, bro. And they get sun for 24 hours a day at 23.5 degrees. It'd be a fucking oven, bro.
Hold on a second, though. At 93 million miles away, you know how high it gets.
You're roboting, Demok.
Yeah.
Okay.
What about the 6 months that it doesn't see any sun?
I'm good with that, but like I said, in the morning you go to grab a piece of steel here when the sun's 23 degrees above the horizon. Go to put your arm on a hood of a car. It ain't happening just after a few hours, bro. Much less 6 months, dude. Come on, man.
One of the things that kind of goes along with this makes me think of it. Okay, if you had a little marble, little globe, okay, and then you had a light source that was heat, light, whatever you want to say, with the sun, the life-giving sun. What they claim is that the little bit of tilt is going to cause the season, right? So they say, oh yeah, the way that the light hits it when it's tilted a little bit, just that little bit of tilt is going to cause it to be freezing, frigid winter in the northern, like Canada, northern Russia, where it's absolutely freezing. Meanwhile, it's a hot, sunny 100-degree day somewhere else, on the beach, on the ocean. And so just that tilt causes all this, the most dramatic season changes. However, what you'd have to do to recreate that on a small scale is take a little marble and take it up close to a bonfire. And once it gets warm enough to the bonfire that it's like a 90 or 100-degree day, it's pretty hot and pretty sunny, you then have to tilt the marble a little bit next to the bonfire and get it to be freezing cold winter on that tilted side. But of course, we know that the way that the bonfire would hit it, the heat and the light, it's going to hit it evenly, and it's going to, heat up that whole thing evenly. But they try to claim that, but they try to claim that just that tilt. So to recreate that, it would never happen because there's an actual inverse square law of infrared and of light. So there's an inverse square law of heat and infrared heat, and that dissipates accordingly, and it doesn't change due to a tilt like that from a heat and light source like that.
Then you make it where if you shrink and leave that marble toward the fire, the higher you go, the colder it gets. The closer you get to the fire, the colder it gets, and then you go down in the ocean.
That too.
And the further away from the sun you get, the colder it gets. So just everywhere you go, it gets colder.
And then you also get sunburned. You get sunburned more at higher altitudes as well.
If the marble is like a mirror ball also, I'd love to do this experiment and see how it's only 50-50 dark and 50-50 light. I'd love to see this perfect line of dark and light on a sphere anytime.
Well, they have those like 2D images of it, but yeah, they never really have a. But Kosho, remember that night? I don't know if you're still here, but remember when you were trying to come up with a way to explain that, and you gave it your best shot?
Explain what?
How the tilt of the Earth, like how if you tried to recreate that on a small scale, a little marble next to a bonfire, you could never get it to be winter on one side of that tilted ball due to the inverse square law of heat and light and the way heat and light works that we can actually empirically validate in this world. How would that all of a sudden change in outer space to where that tilt is going to cause the dramatic season changes that we see?
It does create a vast difference. I showed you, especially, I mean, I showed you the picture, but I think in the picture, I'm trying to remember what the ratio was, but if
So
you
you
take a
try to say
square
that
meter,
the angle of
if,
there's
well,
more light
well,
hitting it. Yeah, yeah.
yeah, well, yeah, well, no, it's the same amount of light. So the same amount of light hitting,
A
say, the
larger
center
area.
point, the subsolar point, a square meter. If it's that same amount of energy is now, further north where it's being shared across a much greater, uh, surface area. That same amount of energy is now, like I said, spread out. So a square foot of land there is going to, be substantially less temperature or less energy.
Coach, I'm gonna show you a video, okay? Of I'm gonna get my son to hold his arm on the hood of the car again. I'm gonna wait till the sun gets about 20 degrees above the horizon, and I'm gonna see how long my son. I've already made this video once. How long he can hold his arm on the car, the hood of the car, when it's about 20 degrees up. Okay. Now you're gonna tell, and he's only gonna be able to hold his arm on there for a couple seconds, if that. He's gonna be like, ah. Okay, that's how hot that motherfucking sun is at 20 degrees here. Now, if we were 3 million miles closer to the sun for the South Pole's summer, 3 million miles closer, if my car was parked there, you telling me it would burn his arm? Dude, you're not thinking realistically, bro. I
That's
know you
Florida,
got
right?
good arguments and a good model and all
Well,
that, but
let's
you're not
just
thinking real, bro.
rhetoric part.
Well, the
Because at
principle.
the South
Let me
Pole,
just say
that
real
sun
quick.
is that.
Well,
Go
I'll
ahead.
just,
Respond to me.
sorry, I didn't mean to interrupt you either, but I just want to say,
No, it's not you.
because actually the principle, I want to back Coach a little bit. The principle that he's saying is a valid principle in certain ways. Like if you have a hose of water and it sprays out, like imagine a hose right at the entryway of the hose, it's going to be like a much stronger hit of water than out when it spreads out. And so that's just another way of describing sort of the way he's describing it, where if the tilted globe, like at the equator, let's say, you're getting like the most kind of concentrated of that, heat and light. And then when it's tilted, because of the tilt, it's being spread out more. So I was just making that analogy of like the faucet and the hose. But I mean, that's first of all, assuming that light does that. Secondly, where would you come up with any way to empirically validate that light hitting a sphere just at an angle like that is going to cause the really dramatic temperature changes and season changes? You still haven't quite
Solar panel.
validated that.
Yeah, all you'd have to do, like I said, whenever you strike a solar panel with perpendicular to the way, so it's pointed directly at the face of it, you're going to get a different energy than if you're pointing it 45 degrees at it. And that's because that same I guess you'd call it like the same area of light from the source as it reaches the whatever you're using, solar panel or the surface of the earth. That same amount of energy is going to be consistent regardless. It just depends
That's
on
why.
it just depends on what angle it's hitting it at to determine how much of that energy is going to
That's why
be
I'm gonna
imparted onto that
do it
same
at
surface.
20 degrees, bro. I'm gonna have him put his arm on the car after a whole all night of darkness,
All right.
and before the sun even gets to 23.5 degrees. I'm gonna do it at 20 degrees. I've already done it once, but so if you're saying it's the angle, if after just a couple hours at 20 degrees, or no, at no time at 20 degrees, it's coming from 0 degrees, working its way to 20 degrees. It already burns his arm. If you're saying it's just the angle, then at the South Pole, after 3 hours, it should be at least close. But since it's already cold down there, I'll give him that. But if it's just the angle, then after 6 months at that fucking angle, burn my son's arm at 20 degrees after fucking a few minutes. Okay, dude, it's not
Hold on,
reality.
Brian.
Not
It was
reality. I'm
impossible to
sorry.
respond to you last time you said this. You just try to catch a break for a second so I can respond this time. I'm just asking you. You're in Florida, right? And do you recall what the temperature was outside before the sun came up that day?
That's why I said I'll give you a month. How about that? To
I'm just
equate
asking.
to
was it a cold night or was it
it's
what was the
probably
temperature
about
before the sun came up?
75. Probably about
Okay,
75,
so
and then about
there's your
90.
answer, dude.
Yeah, I'll give you a month then. I'll give you a month of total sunlight at that same angle to make up for them 3 hours and make up for that temperature difference. Oh no, I'll give you 2 months. How
Do you
about
think it's
I'll give
going to
you
reach?
4 months, Coach?
Do you think it's ever going to reach 75 degrees?
It should get close to it instantly. I'm telling you, if it's just the angle, bro, the angle, and now that same angle in the winter here, fucking it's cold, bro. If it's not just the angles doing this, dude, I'm telling you, man, it's fucking.
Oh yeah, exactly, Brian. No, you make a very good point because right. So when the sun, when the sun sets, it is spreading its light out over a larger area, let's say, and of course we feel that it is cooler a bit and it is more distant, but that effect is in a local range, and that angle of that doesn't change as much as it does. Like what you're saying is what I was thinking, like when the sun's rising and setting, it's making that angle change and it gets a little cooler, but it doesn't just turn into winter, whereas when the sun decline, like the declination changes over the season, when the sun is like further away, it also is at a different angle, but clearly it's also at a different distance locally, making that heat change is what it's making me think of. Whereas that angle doesn't correlate with it's like, otherwise it would become winter every nighttime.
Not to mention, what about all the mountain ranges? What about the mountain ranges that are getting fucking 90-degree sun? The mountain ranges in Antarctica are getting sun coming from directly fucking above them, right? If it's an angle, okay, if it's just the angle and not the atmosphere or any of that, the mountain ranges that go on for miles and miles that are sloped, they're getting direct
Hemisphere
sun.
too. Hey, so check this out, dude. What's the duration of the sun being at 20 degrees that day?
Bro,
After
you
it was
just mentioned
75
the solar
degrees,
panel.
it was
I brought up the
75
mountain
degrees.
ranges,
Hold on,
right?
Brian. 75 degrees outside, and it was 20 degrees in the sky for the whole day, or maybe for a split second. So I think only for a split second. In Antarctica, when it's 20
I'm
degrees in
talking
the
about on
sky,
its way up, dude.
it's
On its
only
way up
20
there.
degrees in the sky. It doesn't get more than that.
And what I'm telling you is that's hot enough to burn your fucking arm, bro.
It's not, dude.
It doesn't correlate with the inverse square law and the way that light and heat actually dissipate that we can empirically test in our world. Meaning what I'm saying is that the globe model doesn't correlate with that. What we actually experience is the exact same inverse square law function that we get. Like if you take like a heat lamp and you put it close to your arm and then you pull it away from your arm, something like that, where it's definitely hotter the closer you get. If you get really close, it might even burn you or whatever, but as you go like an inch away, 2 inches away, 3 inches, it dissipates. And at some point, once it gets far enough away from you, it's not even affecting you at all. So that there's an inverse square law of how that functions with infrared and the way that infrared penetrates matter and essentially creates the heat that emanates from within it. And so as that fades away locally, that there's a ratio there. And what we experience with the Earth and the sun is just a larger version of that, to where it is like a heat lamp, and the distance that it's moving away over the Earth correlates with the same inverse square law of like moving a heat lamp to, close to your skin or away from your skin. So in that sense, it actually functions in the physical world as a close and local light source, and doesn't correlate with being 93 million miles away.
And the globe was slaughtered.
So when your son got burnt on the car, do you think that the car got hot because of the radiant heat
This
coming
is
from the
just it,
sun,
Kosho.
or do you think
In the
it
wintertime,
was the convective heat from the air?
well, I'll let you decide. In the wintertime here, when the sun gets up to 23 degrees, even 25 degrees, I'll give it an extra 5 degrees because it was a little colder in the morning. But it feels great to lay on the hood and sprawl on it. You're like, oh God, it's so warm. It feels so good. And I mean, and the sun's supposed to be 3 million miles closer, but the sun at the same fucking angle is now barely warming the fucking hood, but enough to where it feels great. It's not the fucking angle, bro. That's not reality. I know, like I said, I know you got a good model, all this mathematics.
You hear my
It's not
question,
reality, bro. I
You're
promise
answering
you, it's
something
not
different,
reality.
and then you're adding rhetoric to the end, but you're not.
Well, you would agree that if it's not reality, it's no good, though, right?
No, I didn't hear what you said just there, but
You would agree.
again, I was going to ask Brian the question.
Well, I'll ask the question again. So, you would agree, right, that a model is no good if it doesn't actually match reality. I mean, regardless of how many different intricate aspects of it have been theorized. You just agree on the basic premise there, right?
No. Yeah, sorry. I was. Yeah,
Yeah,
what you said about the model. Yeah, a model
dude.
is. I heard your question. A model is as good as as it can. It's as good as it is comparable to reality. So if it's
No, it's not.
explaining reality 100%, then that's great. If it's not explaining it,
My question was close-ended though, and you went out.
just give me a
It's like the
second. Sorry.
creator or something. Hey man, my question was close-ended.
So
Do you know what
why you got a
close-ended
second?
questions are?
That's a pretty honest globe answer, though. But the problem
I
is
said hold
when
on a
the sun
second.
actually
I said
feels
hold on.
good, the sun is 3 million miles closer. When you lay on it, it feels great, and you barely feel the warmth. Same
Yeah, no,
angle.
I was going to respond to that in a second. But which it
Yeah,
had
all
said
right, good.
no.
Yeah,
Yeah,
I'm sorry. I wasn't trying.
I
I
was
wasn't
trying to
trying to
respond back. I said
distract.
hold on a second. I was doing something.
Well, I got
But
a
yeah, the
plastic
sun.
jar over here.
Hold on. What you said about the model. It's as good as it is. Depicting reality. So if it's not depicting reality at all, it's not good at all. If it's depicting it 100%, then it's that model is the 100% describing reality.
Yeah. So if it
If it
doesn't
gets
depict
pretty
reality,
close,
falls
then
under
it's
zero.
pretty close. I mean, it just
sorry.
depends. If it's
Your model
if it's
falls
the
under
best
zero.
model that you have, then it's the best.
Your
Gotcha.
model falls under 0% of any reality. Zero.
It works 100%.
Yeah, like
Zero.
my question was a close-ended. Like I think that Glober Kryptonite is close-ended questions because
You asked, yeah,
Yes,
you
it
asked
is.
about how good is a model. If it's not
no, I didn't
if
say
it's
how good
not
is the model.
perfectly.
I didn't say how good is the model, bro. I said a basic intellectual premise that you should have breezed right through agreeing on. It should have took less than 5 seconds. So when I say you agree, like, bro, you agree that a model is no good if it doesn't actually match reality.
And I went ahead and I explained the nuance and
Just say
not
yes,
answering
man.
that because I wouldn't say, oh yeah, I agree with that, or no, I don't agree with that. I'm telling you that there's nuance in what you're saying because
No,
no
there's
model's
not.
going to perfectly match reality. And does that make it not good? No, no,
Yes,
it
it
doesn't make
does.
it not good.
Maybe my
It makes
question
it
should
totally
be
not
more
good.
specific. Like, you agree a model has no actual value if it does not actually and accurately represent reality.
And I agreed with that. That's what I said. I
Just say
said, yeah,
yes, though,
I
right?
agree that
Simple yes.
the more accurate it is, the better it is.
Okay.
If it's not
Can I
accurate
ask you
at
a
all,
question?
then it's not good at all.
So, what does a plastic sticker ball do for you? You think that's a good representation of air and water and dirt and sand and reality and cities and stuff? You think a plastic sticker ball? You really think that thing you call you? I mean, you call that your model?
One of these days, someone's going to teach you what's meant when we're talking about modeling here, but that's
Well,
not
a
what I meant.
plastic sticker ball is the
That's not
globe
what I
in your
thought much it meant
classroom.
either.
What else do
Yeah,
you have for your model?
yeah. Take
What are
that
you
plastic
talking about?
sticker ball, throw it on a vacuum, spin it with water bending to it, please, bro. Like, why wouldn't you want to do that? Don't you? I wanted to do that, and that's why I'm a flat earther, bro. I'm not even
Me
joking.
too.
I'm
love
not joking at
globes.
all, dude.
I love spinning 3D globes. I want to make one for my hat. I want to put one in my car. But I can't because they're fake. It sucks. It really does suck, Kosho.
I literally
So
wanted
a
to
model
try to make one. Why don't you want to do that?
a model is not a physical object that you hold in your hand, not in the context we're
So
describing.
how is it have anything to do with
When we
reality?
use model in the context we're using it,
You
we're
just said a model
describing
that matches reality.
which I mean Democ,
Something
don't
you
do
can't
that,
hold
man.
in your hand will never match
I'm not
reality,
gonna
buddy.
communicate with you like that, dude.
I don't even know who you're
It's not
communicating with. You're
at
not
all
communicating with
entertaining.
me
Okay,
anyway.
but to be fair, let Coach finish. But I mean, yeah, answer the question honestly, bro.
Yeah, I was just trying to.
But it's not conceptual. We're talking about physical, bro. So like,
Yeah,
come
I
on.
know. You guys are talking about a physical model as if that's what's meant when we talk about model. But then you guys are completely
So you're talking about your
misunderstanding
imagination.
what's meant when we say model. A model
Well
is
then,
simply a description. It's a description of some aspect of whatever it is you're talking about.
right. Let me say your
But
most honest answer for you to save us time. Okay. So it's basically impossible to physically demonstrate an actual model on the Earth due to scale and how much the Earth itself would affect everything. In any attempt to try to get water to bend convexly or to adhere to the exterior of a spinning sphere within a vacuum suspended. The suspension alone would be impossible based on scale because we're on a magic spinning ball. Like, just say your honest answer, man. Jeez Louise.
Because you guys don't understand the definition of the word that you're using, I have to change what my answer. You guys are talking about a
No.
physical toy model
You
or
said
something
the
like
word
that. That's
model.
not at all what
So what do
when
you
you ask
mean?
about the that's not at all what's meant.
Show us your model then. Show
So
us
wait.
the
So
model
Kosher,
first.
so
Hold on, wait.
I've already
Wait a
acknowledged
minute.
the confusion here. One's conceptual, one's physical. So I've bolded down. Everything beyond that is dishonest sophistry, bro. I'm saying, okay, just say you don't have a physical model. The model itself is limited to conceptual.
Well,
Oh sure. You're
Yeah, I mean,
asking
I
me
would
you're
say
asking me if I have a
it
physical
starts
you're
with
asking
you
me
know what?
you're asking me if I
Just
have
a
a
second. I think
physical
that the question.
demonstration. A
Can I
physical you're
offer
asking if I have
something?
a physical
I think.
toy or something like that to show you. That's not
What
what a
do you call
model
a
is.
model?
Right. Hold on. Wait.
Hold on,
This.
Demond.
Oh
Hold
wait,
on.
Kosher,
Wait.
are you
This
saying you
might be a
can't
better way
physically
of
model
wording the
something,
question.
Kosher?
Wait, Kosho, this is a better way of wording it. I think a better way of wording the question. If
I'm
there's
not really
something
worried about
about the
wording it
model,
differently, dude.
wait,
I'm worried about
hold on, wait.
giving the answer I've been
I
trying to
know,
give.
but I think that makes it confusing the way it's worded. Like
It's not
to get you
confusing
to
though,
agree to
dude.
it. No,
Yeah,
no,
it's
not
not
for you.
confusing.
Well, Kosho, if
Not
I'm
for
telling
you.
them not
I'm
to
just saying.
interrupt
Wait a
you,
minute.
man, come on.
Let me reword it, please. If
I
there
mean,
is
he's in the middle of
something
interrupting me,
about
but
the
fine.
model, so if there's something that we know for sure about the model is impossible, makes the whole model impossible, the whole concept, the general basic concept of the model impossible, then the model's no good, right? If there's
Yeah,
something that
that's
we
sure.
know happens that totally contradicts it.
I would agree. I would agree with that, but that at all
Okay,
wasn't what anybody said. That wasn't what.
Yeah.
Hold on, dude. There's no
Let him go.
point in doing that, dude. Just wait for me to finish.
Mm-hmm.
Nobody had said what you just said right now, and you're once again talking about model in a completely different way than they were. Okay, because they're
That's
talking
what
about
I'm saying.
physical. They're talking about physical models like a toy.
Okay, well, new perspective.
When you asked
Respect,
me the
man.
question, I was assuming you were asking in the context of I
Yeah,
don't know the things
fair
that we're
enough,
talking
Kosho,
about, which
because
is a
Kosho was
description.
Kosho was responding to the question asked to him, right? And I mean, in addition, I will say, like, my bad if you had been interrupted, and then I was like, "Hey, don't interrupt," because that happens to me a lot too, and I hate that, bro. Because sometimes once you let someone interrupt you and you still yield the floor, but then they go too long, you're like, "Now I'm interrupting because you interrupted me to say this." So I get that. Long story short, my question is still very valid. So, like, you can physically model things, right?
Oh yeah, you can physically. You saying like physically model things? Yeah, sure you can. Yeah.
But you can't physically model the globe.
Like
Right, right. But the problem with that criticism is,
Just scale.
yeah, sure. There's things that you can't, minimize and shrink and put on a physical model in a classroom or something for the globe. That's true. But when the alternative is, there's no other description of the Earth, flat or otherwise, that even attempts to depict the Earth accurately. So
Reality.
not just the physics involved in it, not like the
Reality.
atmosphere sticking to it, but even the layout of it. So
A sandbox.
Well, Kosho, you want to know the real red pill here? You're just gonna have to accept it, dude. We actually don't know exactly what the layout of the land is. Period. We were lied to about the land. We do
Bullshit.
not know
All of us.
the layout of the land. No one
All
here.
of us. That's why you have secret Department of Defense locations. Nobody knows all the land. You can't.
you guys
100%.
claim you don't, but
We
you
do.
can't claim no one in here does because there's people in here who understand it to
Draw me the
they they,
middle
they,
of
they
Antarctica right
understand
now.
they understand what longitude and latitude lines actually represent.
No,
I
they
know
don't.
what that
And
is.
what they definitely and their definite
They don't
positions.
exist.
Hey,
Point them out
Kosho,
on the
but
wall.
if you have different locations with longitude and latitude coordinate systems, but the actual accurate proportion of the layout of land itself is wrong, are you saying that those things are mutually exclusive? As in, you're saying that you can't have locations that have. Or my bad if I went out. You're saying you can't have locations that have coordinates.
No.
And also simultaneously not know the accurate layout relative to one another. Is that what you're saying?
I'm saying in this case, that is true. In this case, that's true. In this case, you can't. Those lines aren't just representative of positions on the ground. They have definite definitions, like definite reasons why they are where they are, and
Okay, so I couldn't
it's not just because they're arbitrarily placed there.
I couldn't model my city as a sphere. it'd be pretty hard for you to figure it out. If I modeled my neighborhood as a sphere, you'd probably figure it out pretty quick. My city, it'd take even longer. You'd have to go to the outskirts, and start doing measurements. But if I model my state as a sphere, you may never find out. My country is a sphere, dude. You could, dude model his kitchen as a sphere. But I mean, you're talking about something the size of the Earth with giant oceans in between down south. It would
Yeah,
be easy to fucking
but
You're not talking about great distances between flat lines and curved lines in your model either. It's only like 10 feet over 69 miles. I mean,
yeah,
this would be impossible to prove. You could
but
never
coach,
pull chain and get a distance that exact. It's not
but
And
possible.
every city's laid out with Euclidean geometry, so I mean, it doesn't really work anyway.
but
Would
coach, to
never be
get right to the point though, you need to know where you're gonna start from, right? To map out any type of Cartesian coordinate or any coordinate system, you need to know where you're gonna start in the center. You need to know where the center is to start it, right?
You could start from wherever you wanted to start from, but sure, you could start from the center.
You see how closed-ended questions are
No,
closed-ended questions
I'm answering that as a no. The answer to your question is no. You don't have to start from the center.
Okay, so you wouldn't need to accurately know where the center is to create an accurate coordinate system of the Earth.
I'm saying you don't have to start at the center.
Would you
Knowing where
need
the
to
center is,
know?
knowing where the center is just as important as knowing where something else is.
Well,
And
why
of
do you
course,
go
it'd be
from the
easier to start.
outside surface sometimes and then the center? You go from the outside surface of supposed surface of sea level when your Earth's like a potato, which
But
makes no sense. I don't know how
Ro,
you
my
could have sea
point,
level on a potato,
I don't want
but
my
not
point
the
to get,
center.
I don't want my point to get lost because we don't have to get into the weeds. I think flat earthers get into
No,
the
they go by
weeds more
both.
than they even need to, because if you're going to create a coordinate system, you're going to draw them out and proportion them relative to one another, coming from proportionate to one another, coming from a central point. So if you do not accurately denote the center, if the center is not accurately denoted, you cannot create an accurate coordinate system of the Earth. This is just objective. So if I
Right,
ask
because
you,
even in
do
the
you need
go
to
ahead,
know
sorry.
the central point to accurately map out the Earth with the coordinate system? That's a yes or no question.
It's
And the
just
answer
no.
is yes.
No,
Okay.
it's not, dude. You could have people. Let's say you had infinite amount of surveyors, okay, and let's say that each person could measure, I don't know, 69 miles in every direction.
That's
And they
what
can
we
only
do.
they
That's
can only
exactly what's
measure
going on Earth.
that's great, Brian. They can see the horizon at 69 miles, and they can measure using surveying techniques to see how much it's curving over that range. And each person can do their own little section. When they compile their data without knowing the center of the Earth, they're going to end up with a sphere just by doing the surface.
Okay,
Dude, you're
man.
crazy. They add curvature corrections, but Kosher, how come they use the center? They use the azimuth angle from Polaris, even south of the equator. They still use the fucking azimuth angles from fucking Polaris.
Yeah, well, that's not the center, first of all, and second of all, by the way, I just wanted to clear up that it's much easier to use the center, and when you're making
Well, we
mapping the
have to
surface,
Well,
but
why don't they
we
use
not
sigma
use the
necessary.
Octantis, bro? If
center
it's in
for our
if it's in the southern hemisphere, why wouldn't they use sigma Octantis?
we don't need to ask random questions. It doesn't matter. The stuff that we supposedly use for the globe, dude, okay, it needs to be accurate in the center because we're drawing lines out from the center. Everything else is sophistry, man.
So
They use angles
I'm
from
not sure if you
Polaris,
guys.
even in the
I'm
south,
not
dude. They don't
sure.
even
Hold
use
on,
sigma
Brian.
Octantis.
Hold
It's
on, Brian.
crazy.
I'm not sure if you guys are aware of this, but if you look at the what's it called, the almanac, and all the stars that are in there, let's say there's 50, 60 stars in there, and if you look at their route in a given day, all of them will stay to a consistent latitude. All of them, and also all of them will do roughly 360 degrees and end up roughly back where it started, and so it'll do roughly 15 degrees per hour. All of them will do this. Okay, so
Okay.
this is not based on, and these are perfectly
That's
around the
why I'm
same
asking you,
latitude, all
Coach
of them.
Code.
So
That's why I'm asking you.
these aren't arbitrary lines that you could just place arbitrarily, and then
Exactly,
change them
bro.
wherever.
That's why when I
Both
asked you why
north
they're
and
using
south.
azimuth from Polaris, bro,
Both
he'd
both
be
north
pointing
and south.
down and fucking like for what you call it? What's that southern fucking
I'm
star?
not gonna attempt to speak with you,
A
man.
crux or fucking what you call it, crux? It should be pointing down if it's fucking accurate. I mean, why are they using azimuth angles from fucking Polaris in the southern hemisphere? That's insane,
Because it's
dude.
in the center, bro. So, like, here's the deal, right? If I'm in the military and I want to get the bad guys and I want to map out a coordinate system to find the bad guys, I literally create a Cartesian coordinate system from my point as the center. That's how we can map things out. Now, Globers run around in 2022 assuming that we know every square inch of the Earth perfectly mapped out. And we all thought that before we heard about Flat Earth as well. Because that's how the lie was packaged and sold to us. That the whole thing was a foregone conclusion. What the Earth was, what it did, and exploration of it had already been sewn up. Truth of the matter is, that is not the case. We do not know the accurate layout of the land. We do have observations in the sky that we can try to use to formulate relative locations. But we need an accurate central point to accurately map out the land in all directions. We also need like hyper-specific measurements relative to those locations. And we need to be able to travel in any and all directions. Any and all directions, consistently
Hindenburgs and
documenting
hot
it.
air balloons. That's why they took them down, Hindenburgs. That's why because you could literally try to do that with those. Once you get up too high above the clouds, you can't really see any land or anything underneath. So really, that's why they give you footage from a lot of planes when you only see clouds, but the other planes are cut and you can't see anything but where it's going in front or inside the plane, or like they never give you footage of everything. Like you can never see anything but like garbage. It's weird.
Dude, every time I walk up to it, I like take a flight and I'm getting off the plane and I ask the pilots about how it's super flat up there. They all like instinctively in a split second without any hesitation say, "Oh yeah. Yes."
Right, that's how physics work. Everything we have in physics class is a flat gradient. I mean, I've never seen anything else. That's why I want them to go to the physics class. I want them to go to the science class. I want them to go there. But most of the time, what they do is they'll switch it. They'll switch it to the outside surface, literally. And then they think that they can tell stuff from the surface of the water. That's another way they fool you, because at one point in time they're going from the center supposedly in their imagination, and then another day we're going from sea level, right, which is the surface. You see what I'm saying? They switch up.
Check it out. Every single person I've asked, I've asked this to a growing amount of people. Still not that many, but every person I've asked if I had a 10 or 20 mile line that I could pull exactly tight and straight in a 10-mile body of water, and we held that line directly on top of the water, and you're on one end and I'm on the other, and holding it right on top of the water, and in the middle we pull it down 3 feet, and we pull it tight. What's going to happen to the middle of the line? Every one of them says it's going to come up to the surface if it is infinitely tight. And I almost wanted. I only told one of them welcome to flat Earth, but I was joking. But everybody else I didn't say that. But everybody in their minds don't picture that line going down, even with a 20-mile string line, because nobody's thinking about a globe. Not pilots, not surveyors, not anybody. When you ask that question, they're thinking about the line tightening up and being flat with the fucking level water, because that's how we simultaneously were living as globe earthers. We were picturing everything flat and string lines straight. They just had us duped in our imagination with a cartoon ball, but we're beyond that now.
Think about this. Every kid, when you have them draw background or anything, they don't draw it round. They draw it flat. Every horizon's flat in the most, pretty much all the kids' pictures I've ever seen. And where's the edge? It might sound weird, you guys, but where's the edge of the ball? Where's a part where you can look your face and see no land in front of you? How come that
don't have
spot doesn't
edges, dude.
exist? How come it's only
sunrises,
thousands of
bro.
miles?
Sunrises, dude. You're nose diving at that area when you watch a sunrise.
No, I mean the edge of the ball. Not when they say, okay, you're standing here and you look 3 miles ahead and that's the curve. Why can't we ever stand on that spot where there is no land ahead of us and look to where there's only stars underneath and stars ahead and stars everywhere?
You have to tilt backwards
No,
and
no,
look
no.
up to be, yeah, bro. The globe, the size they claim, you have to. You standing is not the good analogy. I don't know. Get some height, and then it's a good. That's why I always hear a question. I hear what you're
You're the
saying.
highest point on the ball, Witsit. No matter where you put your finger, it's the highest point off the surface.
Yeah, of course.
No matter where you put it.
Of course.
That means you are it.
Yeah, like I'm saying, like your question where you say how, like, why can't you put a camera on the bottom and bottom of something flying and show me the time where there's no ground under the rocket or whatever plane?
Yeah, horizontally flat. Yeah.
Yeah, like I think that gets breezed past, but it's like they can't answer it honestly because that's what should happen.
That's
that is
exactly
actually
what
what
should happen. You should
I
see
answered
that
it for, I
bottom of
answered
that
it for him, man. I
lead.
made him a whole simulation for it. Because you can do
Do
this.
it in real life.
This can be done, but
It's your
it would have to be a craft so
Dude.
fast that it's going 18,000 miles per hour.
Well, so the
And
ISS should be able to pull this off.
That's a nut, dude. You just said a whole bunch of cartoon stuff. Kosho, we don't need a simulation on a computer. We need the dirt and the rocket simulated in real life.
18,000 miles per hour, Kosho. You know that math's just a construct and that it can actually be a detriment to intellectual productivity?
I didn't know that, man.
You didn't know math had a detrimental aspect to it if misused?
I didn't realize I was only using math. I thought I was also using physics and using math as a tool
Physics
to
where?
describe the
Natural
physics.
physics
Because the physics actually tells you that things fall
Physics
down.
where?
Things fall down. That's what it tells you.
Physics on the Earth tell you can go 18,000 miles an hour?
Yeah, I'd be able to get a full thought and it makes sense, but
Well, you could probably go in the lab and show us where you got something going 18,000 miles an hour and we would go home.
Can I be the interviewer and ask Kosho a few questions? Kosho, you've heard my my acknowledgement of things falling down on the Earth, right? Probably many a time. So, do you think that I, as a person holding the position the Earth is stationary, flat, electric, can adequately explain things falling down on the Earth?
Not quite, but I mean that wasn't my full thought either. I mean that was like the first half of it.
My
Obviously things
question
fall
just stands
down.
though, so.
Yeah, no, but I
I'm
said
the
things fall
interviewer,
down.
bro. I'm
You're running
interviewing.
What the fuck falls
It's
down,
just
though,
because
man? I gotta
Democ
ask.
jumped on what I was saying.
What falls down?
Nothing
Walk
technically
outside.
falls down on the ball, but Kosho, I'm asking you a question.
No,
I'm
I'm
the
saying
interviewer.
nothing falls down ever. You walk outside, nothing falls down. You got to
An
get something to
acorn
fall down.
falls
You got to
down.
add energy. That's my point. You got to add energy. Nothing falls without adding energy.
An acorn falls down.
Yeah, the sun grew the tree up from a seed, and a lot of energy per acorn. But anything else, just a little bit of energy, right?
That's not the point, though, man. Like that, but like,
It's
okay, so
ground.
acorn falls down to the ground. I wonder why it's called
Yeah, but nothing grows up without energy. Nothing comes off the ground without energy.
Why is it called the ground? Why is it called the ground?
Electricity, baby. Positive,
Why is it?
negative,
It's
ion.
literally called the ground.
I don't
The
deny the
ground,
electricity, but I'm just
as
saying.
in like the ground of all grounds. It's the ground.
I don't deny the electricity and the effects, and I like this. You know, I like the story and all that. I've even contributed to that. But in reality, though, nothing's falling down without energy to get it up in the air in the first place. Period.
The
Ever.
magnetism that surrounds everything is what gets it to ground or gets it up.
Same thing with temperature.
The helium matches the same potential that ground is. That's why it repels away. You understand that?
Yeah, I do. And the same thing with temperature. The temperature never goes up without adding energy. Pressure never goes up without adding energy. And
so like Vincent's saying, the big G is our fucking dirt. It's our ground. That's the
yeah, that's the actual G. But Kosho, man. So do you understand that I objectively can explain downward acceleration on the Earth like hyper specific and with provable, tangible, objective, indisputable facts?
Sure, go ahead. Go ahead and tell me how a let's call it a what do we have here?
I can
Let's
too.
say a
F equals
ball
WG. I mean
why don't we
WA.
say why don't we say a tank made from krypton, okay, and it's filled with what's that stuff? Uh, helium, right? And it weighs 10,000 pounds. This whole mass, whatever the hell this is.
A
And
gas
why is
weighs
that? Why is that going
10,000
down?
pounds. A
You'd have to
gas weighs
compress the shit out of it.
So just to get your thing, you're not talking about the Glober kryptonite of closed-ended questions. You're talking about Krypton.
Yeah, krypton. Yeah,
Okay, and
krypton, maybe
so
another noble gas and helium, all collected together in some sort of tank. And
okay,
what's giving this weight? What's making this go down?
what's making it go down? The tank.
Yeah, right.
That was so
What's making
complicated.
it?
Okay,
Yeah,
so
so why
check
is it
this.
way more?
I'm
Why is
gonna
it way
explain it.
more with those gases? I know, but that's what I'm saying. You said you were going to
You
explain
have
it, and
more stuff with it. You have more like volume and pressure inside of it, and it's all electrostatic. So every gas that you're naming is electrostatic. In fact, with the noble gases, you can take magnets by them, and they'll turn all kinds of different colors. You can do this with neon gases as well, of course. Like they'll just change. Magnets change them. They're intrinsically electrostatic, all gases. So that just feeds my point. All of it feeds my point, which is why I've specifically tailored over the course of the years my point to where that's the case. So the Earth is the ground. That's why we call it the ground, and everything is electric. Everything that exists is electrostatic, really dielectric. Okay, and so when things fall down, that would be incoherent dielectric acceleration, and it is not specific. It's non-specific, as in like it doesn't have some preference, right? Like that, it's not so strong it creates preference. It's almost negligible, but we can't even say it is in today's world because they're so diluted. They actually have ignored it in entirety, but it's just the natural resonance. So it's not this overwhelming point specific coherent force. It's the opposite of that. It's non-specific, incoherent. It's just the resonance of the matter. The earth is the ground. If something falls down, it's dielectric acceleration. So what is gravity? That comes from gravitas, which means heavy or weight, as in how heavy is something? What is its weight? Okay, well, that's when something goes down. That's the only time we even try to measure anything called weight. We use a scale. That's pressure, push down on the scale, downward pressure, effectively, right?
F
So,
equals WA.
and so when things go up and down, many flat earthers will say that it's due to density. They are not wrong, of course. An honest glober has to say that is, of course, the prominent factor you have to take into account in the physical world if you're going to do something, and the medium, the density of the medium that it's in, right? But then most flat earthers kind of stop there. So, like, what if you want to ask what is density? And this is the type of questions that your model has asked, of course. Then the answer is the charge gives a piece of matter its density. And that is testable and provable, and the correlation and the proportionate nature of charge and density is provable, and it's just objective. It's like, so no matter what anyone says, that's just an objective. We're just going to write that down in our notebook because we're taking objective notes.
Yeah, there's
Okay,
no way
so-
to get around the electrostatic principles at some element, man. But
I'm
I
gonna
wanted
respond to your
to.
response, but it's real difficult.
Yeah, go ahead, Coaster.
Oh,
and then I
Coaster,
got
what you got?
something else after that.
Well, to look at a couple of things, I asked you something, and you did kind of tell me you're going to give me a hyper specific description of how it's interacting with whatever your description is, but you didn't. You said that was intrinsically electrostatic, and that because there's an incoherent dielectric acceleration, which if it's incoherent and it's somehow having an effect on the charges in this matter that's intrinsically electrostatic, well, that's the part that I'm asking about is what's this hyper specific way in which this encounter is taking place? What is it about the this incoherent dielectric acceleration?
Give me a chance
What
at that.
effect is it having that gives the krypton and the helium make the tank weigh more going downwards?
Okay,
How
Coaster.
is it happening?
If you have a liter of helium, you pressurize let's say 10 liters of helium into a 1 liter tank. Okay, that's relative pressure, right? That was a question.
It just seems like something so different than what he said that it seemed like I think he was.
Yeah, well, I
more-
was going to say if you take that same helium in a 1 liter bottle and you draw a vacuum around it without even adding helium, the pressure inside it is going to go up. All the pressure is relative. And here's what I was going to say. I mean, that's about his pressure question. But about the other question, I was going to say that F equals WA, which works on Earth. That's force equals instead of MA, which they have to use if they go somewhere besides Earth. But here on Earth, F equals WA, and they try and say A is 9.8 meters per second due to gravity. I say it's 9.8 meters per second due to disequilibrium, whether it be electrostatic, with the density and all that. But so everything is in equilibrium when you walk outside. Nothing goes up without energy. Pressure doesn't go up, temperature doesn't go up, matter doesn't go up, nothing goes down. Everything's in equilibrium, and nobody's yet to give me one example of something moving without energy being added. So that energy being added, whether it be to heat something up, to pressurize something up, or to raise something up, or pull something down, nothing moves without energy, period. So everything's in harmony, everything's in equilibrium. You take something out of equilibrium, okay, it's going to want to go back according to its density. Okay, so the force is what energy we use, whether it be the sun growing the fucking acorn up in the air, whether it be you digging a hole to make a hole underneath something. You're not doing it without energy. Everything's going to go seek equilibrium, and there's no getting around it until somebody can give me an example of something moving without energy. Then to me, it's all equilibrium, man. And that's the way nature works on every level, every aspect.
Yeah, so Kosho, you asked me a question, and I've already answered your question, which was that the relative pressure based on electrostatics will affect the weight of the tank. So seems pretty simple. That feeds my point because the tank's electrostatic as well. The tank is on the ground. It's the ground.
Yeah, no, I'm asking about the relationship with the electrostatic charge that's intrinsic in this material. How is that having any interaction in
right?
Like
Okay,
what
so,
place is it having this interaction?
So all that stuff within it is going to increase the overall electrostatic charge, right? It's not. So if I introduce a bunch of gas into the tank, it's not going to increase the electrostatic charge overall.
If there's zero charge. If everything you're introducing has no charge, then I don't see why it's going to increase the charge.
Literally nothing that you're introducing has no charge.
Well, they're neutral, so the charges balance out. So there's not a net positive or net negative. So there's nothing.
So it balances out, meaning that there's charge there.
Meaning that there's if there's positive charge there, and you add negative charge, you now have a neutral charge. There's no charge if those charges are equal.
Then it's not a neutral charge if there's no charge.
Yeah, that means the same thing.
No, see, there's a resting electrostatic potential. There's a resting potential. There's the intrinsic resonance, the vibrational resonance is electrostatic intrinsically. So no matter what you add to the tank, that is going to be also introduced based on what you're adding, proportionate to. Now you have this tank that's electrostatic. Now if you have two incoherent magnets, which is just electrostatics, dielectricity, they'll still stick to each other. It's just super weak. And the more you add the incoherent magnets together, the weaker it gets. So actually, like, the strength of pull is inversely proportionate to its quote-unquote mass. Right?
Yeah, all the surface
That's
of this
the Earth. That's the Earth. The big incoherent mass, that's the Earth. It's the ground. It's huge. Okay, so it's not this crazy thing pulling us down with extreme force. It's nothing like that.
Nothing like that. In fact, the primary factor is the pressure being pushed down based on the positive energy seeking the negative surface of the Earth. And there's a pressure that pushes down. Nothing pulls us down. There's a pressure that pushes. And by the way, that's basically what relativity is saying. That's why relativity, that's part of relativity's big update. Because the gravity well effectively pushes you down in your mind. If you can think about it, the gravity well itself, right? It's not, the Earth isn't actually pulling you down.
I'm gonna try to respond to one of the points at
And,
a time.
and water, nothing's pulling us down in water. It's all
Right,
relative.
the point from before you brought up relativity, you're talking about the incoherent, the dielectric acceleration that is a surface. I'm not sure if you're aware of this, but the fact that it's an incoherent dielectric, whatever the field is that's causing this, if it's incoherent in nature, that means that the surface is not going to be positive or negative, and it's going to fluctuate depending on where you are along the surface. As you move along the surface, you'll sometimes have a positive charge, negative charge, and so you might be attracted to it, repelled depending on your charge. So there's no consistent single charge like positive or negative.
No,
we're incoherent.
I think you're skating past it, but actually, I don't think you understand it. So I don't think you're skating
Yeah,
past it.
I don't agree with him, but
Have you ever seen an incoherent? Have you ever seen an incoherent?
He said
field?
that incoherent magnets only attract; they don't repel, bro. So I don't agree with everything he says, but I understood, and that you said
I
that like you
understood
didn't
what he
understand
said, but it's like he didn't understand what I said, though. Like,
yeah, that's what I mean.
Yeah, like,
I
dude, my man, incoherent mass has an attractive force. Every single mass that exists has intrinsic, as in built in, because this place is clearly designed.
Yeah, but y'all sell that gravity
electrostatic
bullshit to those fish.
attractive force. So the matter itself has an attractive force. All intermolecular forces are attractive and electrostatic in nature.
That's not how charge works, though. It works. The only charges that are attractive are the opposite charges. It's not charge in general.
So you're saying that all intermolecular attractive forces aren't electrostatic in nature?
No, what I'm saying to you is that the charges that are attractive are the ones that are opposite. If they're not opposite, they're not going to be attractive. And an incoherent surface is not going to be but just positive or just negative. Yeah, so it's not going to be just attractive.
Well, I didn't say incoherent surface. I said the Earth is the incoherent mass. The surface has a slight negative charge. The positive that builds up further away from the ground will go down to the negative surface of this incoherent mass. Therefore, we have a downward pressure, all measurable, provable, objective.
When you have an incoherent mass like this, like an incoherent dielectric,
There's no downward
or
force,
incoherent
dude.
magnet.
Y'all quit
Okay,
saying there's a downward
hold
force.
on,
There's
dude.
no downward force.
Yeah, that's great, dude. I didn't say that at all. So just hold up for a second. Fuck was I saying? Oh yeah, right. You're saying that it's an incoherent mass or an incoherent dielectric acceleration, or an incoherent magnet for that matter. What that's describing is the coherency of the poles. So the charge, whether it's going to be completely polarized and have all positive on one side, all negative on the other side, or if you have incoherent, which is going to be it's going to be incoherent. There's not going to be any single direction to anything, so it's not going to be just attractive. That doesn't make sense for charge to behave that way. Charge is only attractive if they're opposite. They repel if they're the same, and if it's incoherent, it's going to be a little bit of both, depending on where you are.
Incoherent
magnet. Yeah, but incoherent attracts only. You see, you know what he's talking about with the magnet example, Kosho? You can take all these magnets, and even equal charges attract when you're talking about incoherency, bro. You jumble together a bunch of magnets, all they do is attract. That's what he's describing.
Yeah, they attract only.
They don't, though. The thing is, if you were to go along the
Oh my.
surface
Yes,
of one
they
of those
do,
incoherent
bro.
magnets,
You've never
if
seen
you
that
were
or
to go
tried
along the
that?
surface,
I have a
if you were
bunch
to
of
go along the
magnets right here.
surface
I'll
of
show you.
if you were to go along the surface of one of those incoherent magnets, you would see that you would not be able to travel wherever you want to go because some of those places, depending on your charge, you're going to repel against it, and some places you're going to attract. You're going to attract to it.
No, it's only attractive. So it's okay to not know things, but this conversation started because I said, Kosho, you do realize when you said that all things put down, that I have a 100% objective, irrefutable explanation for downward acceleration on the earth. I wasn't just saying that. I'm not just super arrogant. I'm not like have this overly inflated ego. I have tactically positioned myself at this point in the conversation so that I can 100% say that. Incoherent
Yeah, right.
magnetism was attractive only. It's super, super, super weak. One would think it wouldn't attract. That's wrong. Incoherent magnetism does attract. In fact, it's also counterintuitive in the fact that the more you increase the mass, the weaker it gets.
Right. So you don't think that if something was near the surface of incoherent magnet, and it was able because I don't know if you know this because the way incoherent magnets are usually put together, like in the case of like buckyballs, for example, you have these balls that are all going to have different poles in different directions. So you clump them together, you're going to get poles that are all in different directions, and that's why
For fuck's
you're right.
sake, dude.
Together, it's going to be weak, and it's going
You
to
really gonna make me go pull a
it's going to
video
have
up?
charge in all different
Well,
directions.
yeah,
And
they're
what
right.
happens
It's right.
what happens if you had something going along the surface of this thing? You would notice that in some places it's going to repel, and some places it's going to attract, depending on the
No.
charge of the thing that you're
You're not
using to
understanding,
reverse.
Kosho. As you do that, you're right. The reason it's incoherent is because they all go in different directions. That's what incoherent is. Coherence, everything going in the same direction. Okay? Now, they're all going in different directions, so it's incoherent and it's weak. But that totality, that mass, attracts. It keeps on making the bundle get bigger and bigger as you introduce more incoherent magnets. It's attractive only.
So you don't think there's any repelling at all happening
No,
there?
no, not at
No,
all. You can't repel.
first of all,
with a-
repel and attract are both misnomers within the conversation of magnetism. They don't even belong in the conversation. They are not accurately describing it at all.
Okay,
But
well,
anyway,
how does it? How's
Kosho, you
there any
can't repel.
electromagnetic interaction if there's no charge involved? And if
how is
there's
it
charge
repelling
involved,
if it's attracting, Kosho?
yeah, I just told you positive. I mean, like charges will repel, opposite charges will attract. That's just, I mean,
That's not how
So can it
incoherent
basic
repel
shit
and
works.
attract at the same time, Kosho?
No, this mass, which is incoherent, is going to have different parts of it that are going to be doing different things. This is why I'm telling you, if you're moving along the surface of this thing, and some places it will repel, and in other places it will
Austin, I
attract.
would answer the same
It
way
has
if I
so
hadn't
many
seen it with my
different
own two
poles
eyes,
in so
bro.
many
So
different directions.
your intuition is going to make you think that. So I give them
I know.
that.
I have
But
these things here with me right now. It's not an
okay,
intuition. It's
so show me a big group of incoherent magnets grouped together to make an incoherent mass or big grouping. Show me it repel, Kosho, anywhere in that mass.
I just told you when it would repel. Try
For
putting.
fuck.
Here's what you do: have this incoherent mass and put a magnet on there, and see that you can place it in some places that it will not want to be in that place, not in the orientation you've put it. It'll want to flip
Not
over
with a big
and go
jumbled
somewhere
up
else.
bunch of shit.
Even then,
Oh man, I'll cite this for you, man. Here's part of it. Like, just because it's incoherent, magnetic mass noise field is always present in any magnetic coherency we artificially induce in a part of its matter in order to magnetize it, i.e. aligned unpaired electrons, quote unquote, has no effect and is integrated to its noise field. Further, its magnetic noise field is instantly integrated to the much stronger magnetic noise field, i.e. gravity, incoherent dielectric acceleration of the Earth. Really, it's just towards the ground. Zero Gauss chambers will not disprove my empirical evidence. There's no material to stop and shield against static magnetic noise. I mean, this is Hellenic Mediterranean University, 2019. Incoherent magnetism always attracts and never repels. You can test
saying,
this.
Jay?
Prove it.
No, I mean I've tested this plenty of times. That's what I'm saying. But what were you saying, Jim?
This is like all twisted up, man. These concepts are being spun crazily in my
Okay, well then maybe you can
personal
enlighten me what
opinion.
quantum magnetism is.
Let's start with the electrostatic thing, right? So the intermolecular attractions and stuff between molecules are indeed electrostatic. Those arise from temporary or permanent dipoles that occur in atoms and molecules, right? Those dipoles are separation of charge, be it partially or a complete charge. When they are interacting with each other, and they are, you can say, neutralized, right? They can't do anything else at that point. And these are occurring on the scale of nanometers, right? A hydrogen bond can occur from 2 to 6 nanometers usually in something like water. Van der Waals is like 3 to 8 Van der Waals interactions, nanometers. So we're twisting this all up into something that it's not.
Okay. So everything is electrostatic, man. The Earth
You
is
sound
called.
knowledgeable, dude, but I don't think you debunked anything you said. Even
No,
though I
that's fine.
still don't completely agree with him, but I like hearing it. But I just, I know that the force is the force is always pulling something out of equilibrium. It's always the real force. The pseudo force is it coming back down, kinetic energy. That's with anything. Like I said, that's how
Yeah.
nature works as a whole.
Exactly, but in addition to that, everything that has equilibrium has an electrostatic resonance.
I'll say what you're saying could be like the slight bias for whatever you want to call it to cause the entropy, but you can't call it a force though, dude. It's not a force. Even in their model, it ain't a fucking force. You know what I'm saying?
Intermolecular interactions.
Well, yeah, I'm not.
What I
No,
was
there's not some magical force pulling things down to the Earth or anything like that. It's just that electrostatics is a force and everything's electrostatic, but it's much more about equilibrium. But the thing is that if something that's electrostatic falls down to something that's electrostatic, I mean, dude, that's electrostatic acceleration, and it isn't point specific. It doesn't actually care. That's why things go up, and etc. It's just that things that have greater density, which is about its charge, that's what holds it together. And if you were to turn a dial and strengthen it, it would pull it in tighter and tighter, or make it more compact, which is what density is. Okay, and that's where you get matter, is to have that electrostatics.
You could even say if you spread things out, it would the attractive force could get weaker or whatever, or if it was less dense. But Witzy, you should say this. So you should say to some people who like to talk about it in mathematical terms, tell F equals WA and the acceleration. So you would claim that the acceleration is 9.8 meters per second due to fucking disequilibrium due to the electrostatic fucking bias or whatever, however you want to explain it. And they can't really debunk that. They can't hog the 9.8 meters per second just by saying due to gravity. I'm not arguing little g is not empirical. I don't like the way they name it and say due to gravity and try and hog it like, oh, it's ours. Our model claimed it first. Bullshit. We've been fucking able to measure the speed of things that we lift up in the air. Measure the force of them falling back down, but it's all related to the energy we put in them to take them out of equilibrium. That's what we'll get back. So F equals WA, force equals weight times acceleration, which is 9.8 meters per second due to disequilibrium, due to the energy you put into it, bring it out of equilibrium. That's how I'd put it.
Yeah, like I'll say this, man. I dropped a link, man. Look into it. Try to do it yourself. Try to think about what quantum magnetism is, and this always ends up going full circle to how, quantum fields is where the field of quantum has been forced to go. Now, parts of quantum are still in denial, but it is 100% only viable to go to the quantum field theory in all aspects to have any breathing chance.
But I asked him this, Coach.
Can I? You guys have touched like 20 different points. Can I respond?
Yeah, real
now?
quick. Answer one question. It's all yours. Or two real quick questions. What's the force that cools things down after I heat it up? And what's the force that depressurizes something if I pressurize it? What's the force that depressurizes, that equalizes shit? We'll just say that.
The
What's the
first
force that
thing.
equalizes things?
All right, JAce, you have roughly 700 things to answer. Are you ready?
Right. All right, Brian, I'll get to your thing second. Let me start off with this. So, when I do crystallography, right, what I'm doing sometimes when I'm doing this is I'm measuring the distance, the strength of these electrostatic things you're trying to spin, right? And these are over distances of nanometers, angstroms. They're very small distances that these things occur. And per interaction, so if you have ice, per each hydrogen and oxygen atom of the H2O molecule, they will participate in one electrostatic interaction that they can donate their electric charge to. They can accept electric charge from multiple atoms, but they can only donate their electric charge to participate in one interaction. So you have to, and to get them, like if you wanted to use that charge that they have to do something, you have to free it from that interaction, right? This is the whole thing between electric potential and like current and voltage and stuff. If the charge is being used already, it has no use to you. You have to free that charge.
Okay, so do incoherent magnets always attract and never repel?
No, I'm talking about electrostatics, right?
That's what that is. That's my point.
Go
Bam,
ahead.
bam. That's a good one there. That's a boom. All the molecules, all them atoms you're talking about, they're incoherent. They're jumbled,
not.
and they form bonds, right?
A lattice is held together because these electric charges are participating in intermolecular interactions.
Yeah.
Says Jimmy Neutron.
It's the founding. It's the founding.
Crystallography.
It's the foundation of everything that you've ever looked at because it's the foundation of all matter.
Yes, I study math.
Yeah, but I could give them
study
that though, Austin, man.
biomolecules.
I could give them that because like the lattices could be them jump, on a molecular level. Y'all could both be right. On a molecular level, the lattices could be sharing what you call it, and structure.
Oh yeah.
To stay bonded, and then you still be right because on a whole, all them things jumbled together, making up the whole entire ground we walk on or the water we swim in, is could be the the incoherent.
Well,
Jason, put together.
Jason,
He's got to admit that all them crystals put together, like separate crystals and stacks or sand or all the shit he's talking about, water, they're all jumbled up together. They're in a specific structure, but as a whole, they're all jumbled up, right? Which would make them incoherent, which could make them attract.
Okay, so all the molecules are intrinsically held together with electrostatic attractive force. But my point is that if I say like incoherent dielectric acceleration, you know what I'm saying? Like, and you say, I'm not talking about that. I'm talking about electrostatics. Like if I say incoherent magnetism and you say, no, electrostatics, the answer to that is those are the same thing. So we need to use a Socratic method to have any type of intellectual exchange. Right, because I do not adhere to the modern, higher levels of academia, pseudoscientific misdefinitions.
So go ahead, define what you mean then.
Okay, so incoherent magnetism is electrostatics. If you say incoherent dielectric acceleration, all you're saying is electrostatic acceleration. Dielectricity is electrostatics, and electrostatics is always attractive, does not repel. Everything that's intrinsically holding matter together is an attractive force, and that's electrostatics. Any type of matter that falls down to the ground, which is also electrostatic, is incoherent electrostatic acceleration. And so that's the whole point, is all phenomena that can be tested, observed, manipulated, and in any way demonstrated prove that everything is intrinsically held together with electrostatics, and all type of equilibrium sought is based on an electrostatic relationship inherently, or more so intrinsically.
Hey, I just thought of something, man. We could come up with big. They got big G. You said that the incoherent force is a lot weaker than the electrostatic force, right? So just like Coulomb's law is way fucking stronger. So look, we can come up with a big ES, and 10 times or 6 times 10 to the fucking 18th, the same as big G. We just come up with the electrostatic. We have the regular Coulomb force, and now we have the fucking incoherent Coulomb force, which is big G.
Possibly hear from Jace's response, possibly.
Yeah, just the inherent problem with that. Like, right, there's a half truth in there, right? The interactions that hold molecules together and the that bind molecules with each other in intermolecular interactions, they are electrostatic, but these interactions act only over a very small distance. They don't act over these distances you're trying to extend them to. It just doesn't happen. Any kind of experiment you would do, these are over angstrom distances, right?
Okay. What distances am I trying to extend them to?
You're trying to extend this to macroscopic objects falling to the earth.
Well, that's why I said it's not point specific. So no, there's not something pulling down the object. That is crazy talk. That's pseudoscience. I'm not saying that.
An object in the air, like a ball or an airplane, is held together by intermolecular interactions. The ground also has intermolecular interactions, but the interactions in the ground cannot affect the interactions of the ball or airplane in the sky through electrostatic interactions. They don't act over that distance.
Of course, it's way too weak. And that's why you could never invoke this to explain the planetary movement of the bodies in your model. So when what's the guy that literally sounds like he's slow that works for NASA? Oh, Don Pettit. Whenever he did the space, like the little electrostatic space needle orbits demonstration, he had to get the charge on there. He can't actually use electrostatics though. For one, even in his demonstration, the bubble goes around and then hits the needle and pops, right? Which demonstrates the problem. They try to act that just happens really slow. But secondly, you can't use electrostatics, of course, because it's nowhere close to strong enough to make the planets move, like what you're saying. See, I am not saying that I'm just going to take your belief of gravity and replace it with electrostatics. No. We're completely scrapping the trash that is the modern relativistic claim of gravity. That's just completely not viable on its face. The matter that ends up falling is electrostatic. The air it falls in is electrostatic. It has a density based on its electrostatic charge. The air has a density based on its electrostatic charge. In fact, there's positive that continues to go up, positive energy, and then it's going to create a downward current towards the ground that has a negatively charged surface. That object that's electrostatic just falls down. It's being held together with electrostatics. It's falling down relative to the density relationship, which comes from electrostatics. It's falling down with a downward current or a downward pressure, if you want to call it a bias, towards the earth. It's falling in that same direction because of its density relationship, and then it's falling to the ground. Everything in the entire scenario is 100% electrostatics, and no, it's non-point specific. That's why things can go up in whatever direction. That's why a helium balloon, or I take a balloon and I rub it on my head, it sticks to the wall before it goes down. Not a helium balloon, any balloon, right? It's because it's not point specific. It's relative to the attractive force. The only time that it's going to pull
I got to interrupt you, man. You're forgetting that we forgot to tell him it's a Gaussian fucking surface. So in other words, there's a ceiling. So it's like a capacitor. And in between is the fucking plane. So we're in between two Gaussian surfaces. The charge up above is opposite to the charge down below. And that's very important. Sorry I interrupted.
Yeah, it's just basically downward pressure, though. It's not like the globe in everyone's minds have kind of been tainted, if you will, where they just kind of can't help but think of it in this paradigm of the globe where everything's being pulled down omnidirectional. But nothing's being pulled down. Everything's being pushed down to the ground, and that's why it's called the ground. That's literally why it's called that. There's no way it's a coincidence that it's called that. Everything's pushed down to the ground. like that object is not being pulled down by the ground. But the point is that if you put something on the ground, the electrostatic charge will then act as an attractive force. It's just super, super weak. So I agree with you that it's not going to affect a plane and pull it down. It's actually the electrostatic environment the plane flies in, where there's a downward current towards the ground that would create any type of slight, almost negligible bias. But you cannot say it's actually negligible because it's actually what the plane's made of itself.
But right, so the issue with that again is that these charges are tied up. They're already tied up. We can't we can't just take electricity out of the air, right? Usually we have to use a motor or some kind of mechanical device to use the electric potential that's in the air, right? So what you're saying goes against all of that. It's like special pleading that in this one case,
No, it doesn't.
that we can just harness the electric charges of the air molecules, and it just doesn't work.
What do you think
like
we're doing with
What?
what do you think we're doing with what you call it with just by moving a coil around copper and all that? You think we're creating energy? No, we're
transferring it.
Transferring
You're
it,
making a
man.
magnetic
And it's a
field,
Gaussian
and
surface, so the charge is already there. And he could show this too, man. You can make things heavier with a or make things lighter. You can make little wood chips fucking float up with one of them generators. What do you call them? Voltage generator things?
Van de Graaff.
Yeah, I've seen them make little iron filings go backwards, dude. I've
yeah,
seen them
these
attach.
are
I've seen
mechanical
them attach
devices.
a helium balloon to a little clip and reverse the voltage. I mean, exaggerated the voltage and made the helium balloon get heavier and drop to the ground, dude. This is demonstratable shit, dude. You might not like it, but you should listen to it.
In all those cases, you're either manipulating the charge of the object, like I'm saying you would have to do, or it's using a mechanical device that is manipulating charge.
No, Jace, we use the mechanical device to transfer the energy that's already there. That's why if I use a Corona motor and sit on the ground with a string tied to it, the higher it goes, the more energy that comes down the current, the faster the motor moves, the higher the string, because it's within the air. There's energy in the air. We're not getting energy out of nowhere. We're not magicians. We don't make electricity out of nowhere. Energy cannot be created nor destroyed. We simply transfer the energy. That's all we do. We harness the energy. Okay, well, that's all around the plane.
Device. It's the device that's transferring the energy.
Okay.
Objects aren't doing that, though. Like, I could drop something, and it's not transferring the charges from air molecules. It's just falling.
Bullshit. You ever put water next to you just watch water fall and look at the charge you can get off it. You could get fucking little mini lightning snaps just from running water.
What does the string do then, bro? So the downward current goes down the string, right?
Isn't the string moving through the field?
The downward current of the earth on the earth goes down the string to eventually run the motor.
No, but you said it was as the string was going up.
The higher it goes up, the faster the motor will go. So the string's not mechanical, right? It's just a string.
I mean, I was just thinking it's moving through the charge, but I was going to say that Jace was saying exactly what I was saying about the charges in helium, for instance. If they're neutral, because then positive negative charges are accounted for with each other, then that my ultimate question was, what is it about that neutral charge? You know, that it's not giving any. Its charge is not available for any of the interactions.
Oh, sure. He attributed it to the device, bro, and also just gave an example of no device at all, just a wire up there, no device. That guy. All right, sorry, go ahead.
Yeah, don't skate past my point though, Coach. So like, the string is not mechanical; it's just a string. The higher you let the string go in the air, like as in the longer the string is, right, the faster the motor will go, because that's the more energy you got. The string is transferring the energy. It is not mechanical, and the higher it goes, the more energy there is to transfer. So you agree with that, correct? Because you can test.
I'd have to.
Yeah, they can't disagree with shit that is empirical.
Right. You can test this. Like, you can prove it. So that what that proves is there's a you need a current to run a motor, right?
Yeah, at first I thought you were talking about something moving through the air, but you're talking about it just being long.
You need a current to run a motor, right?
Sure, yeah.
Okay. So you have a motor on the ground, and then there's a string attached to it that goes up in the air. The current from the air will go down the string and run the motor. It's an electrostatic motor. It's called a corona motor. What that proves empirically is there's an electrostatic downward current towards the surface of the Earth, on the Earth.
Yeah, it's interesting.
Ever
I'm
so
trying to find out,
slight.
is this
Ever so
string
slight.
stationary, or is it moving up?
The string is just tied to the motor, man. It's just attached to the motor. The string's not going anywhere. It's tied to the motor that's on the ground. Again,
I never
this
seen it with a
empirically.
string, but I seen a guy do it with just a teeny little wire, and he took it up with his drone, and the drone hovered. I've seen a guy do it with what am I talking about? I've done it with with a few helium balloons, and but I tried to get a headlight to work. I couldn't, but I did measure resistance, and I had volts, so that's current. But my fuse blew in my meter, so I couldn't literally tell you the current. And it wasn't much, but there was current.
And it's not much, man, but that doesn't matter at all. Doesn't matter at all how much it is. It's the fact that it's there. And they try to hijack the effects of it being there, and they make up all kinds of stories about gravity. The next thing you know, we're in a second law of thermodynamics violation, vacuum Narnia, where things are revolving around each other. So I am not going. It's there, and it's just objective. And everyone should be like, I wonder why I didn't know it was there.
What,
Oh shit, dude! We should all know that. You're right, bro.
Right, but you're talking about the potential that's in the atmosphere, the charge potential. I didn't hear. I didn't hear what you said. But you said that we should agree it's not there.
We should all know there's a downward current towards the Earth. Yeah, that seems like a very valuable piece of information to understand where we live. I wonder why no one knows. I wonder why no one knows an empirical, testable, provable, repeatable, verifiable, unfalsifiable fact.
People, I mean, I thought that was. I've always heard that the ground was had more negative charge or whatever. Like that's why lightning can. Well, actually, lightning comes from the ground, but
it does both.
That's what
It actually does.
That's what that's what I always thought.
But it doesn't matter. Yeah, negative goes to positive, positive goes to negative, but the positive is going to go down to the negative. The positive is much stronger. So the positive goes down to the negative, which is the Earth, and we have a downward current. We can measure it. We can literally harness energy from a motor with it. So there's an electric downward. Yeah, because the positive keeps increasing as you go higher above the Earth, right?
Oh, you're just talking about in that case. I thought you meant like in general.
Well, in the actual case of the Earth, yeah. So there's a downward electric current on the Earth. Now, we all know electrostatics is stronger than gravity even claims to be. So, like, on the smallest scale. Now, of course, we know they claim that it flip-flops. Like, when you get big enough, it flip-flops or whatever. But, even when you get as big as a scale as, like, a baseball, they try to hijack it. No. Baseball's electrostatic, falls through the air that's electrostatic within the air that has a downward current towards the Earth. The Earth's electrostatic. Period. Point blank. Objective. You can make additional claims and say there's something way weaker than this. I promise it's there, but you need to say it with your chest out. Like, say what your claim is. Flat Earth has been misguided.
I was trying to read about this thing real quick, but what were you saying?
Just in general, the Glober needs to stick their chest out with some pride and admit what their claim is, which is that, I swear there's something else there. We just can't actually tell because this thing that's stronger is there. They need to actually absorb their true position. And I promise, in fact, it's just so magic and elusive and not detectable on this scale. But it is actually the fundamental thing that makes everything work that wouldn't work without it. So, I mean, just know what your claim is. Don't be coming at me sideways. I think Flat Earth has been misguided. They don't even talk about this. This is like a sword sharpened, ready for decapitation. There is no rebuttal from a Glober. They can just say, oh, I don't think it matters. Oh, I didn't know that. Oh, let me change the subject. Oh, let me drown it in sophistry. Oh, well, I promise gravity's still there. You just
We
didn't
gave
know
you
it.
fair. We gave you fair rebuttals, dude. I don't
No, not
understand
you.
what.
I
But
have no problem with either one of you guys. You're two of my favorite Globers. I think that you're two of the more honest people. I try to give that to both you guys. I'm not like gonna lie. I'm just saying I'm sorry. It's over. Nice playing with you.
I appreciate that, but that's why I was confusing what you were saying because I guess I'm just not. Because I mean, I thought it was fair what he said about the charges. I mean, it's what I said. If they're neutral, they're not available, right?
Is there a downward current on the Earth? Is there a downward
Uh,
current towards the Earth?
yeah, but I don't think that's. I think isn't the actual difference, isn't it like extremely small?
Yeah,
Doesn't matter.
the device,
Doesn't
right?
matter.
The corona. You're talking about a corona motor.
Yeah. No, actually, I'm talking about a downward current. That's what we're talking about.
No,
Yeah,
but what you're going to say is how we can see this is using this corona motor device, right?
That's one of the ways. Yeah. Brian named numerous ways. So we're talking about
Go
how
ahead,
there's a downward
Brian.
current.
Rename them.
Okay, he's talking about how you could take helium balloons and tie wire to helium.
Yeah, iron filings, dude. Just by changing the voltage, man. Just by reversing the voltage, of a Van de Graaff generator, you'll make iron filings. And if you scale it, dude, that's like bigger than Mount Everest if you do the fucking math. And but any material, paper, fingernails, skin, fucking wood, metal, plastic. There's no material.
It's not any
So
material.
you can literally show a reverse if you reverse the field, or you can make something heavier by adding to the field. It's
Because
a good argument, man. I've seen it.
a Van der Graaf generator adds or takes away charge.
Yeah.
Yeah, I'm talking about if you have two
object.
Gaussian surfaces, bro. Two Gaussian surfaces, like a capacitor.
But right. So the big distinction here between these examples with these devices and just objects falling in airplanes and things like that is
Nothing
that
falls,
these
bro,
objects,
without
there's
energy
nothing
added to it.
transferring charge from these
doesn't
objects
matter.
like these devices are doing.
Strawman.
That's the big difference.
But doesn't matter. So you're effectively strawmanning me for pretending that that's somehow relevant to what I'm saying. Does the object dropped within the air on the Earth and the environment that the object drops within has a downward electric current toward the Earth?
No,
Yeah, but what is that?
objects just being
You said
dropped
no,
don't.
dude. My man's. Are you dropping it somewhere other than the Earth?
What do you mean? Of course, you're dropping it on the Earth. Right?
Okay, so then it's being dropped within a downward current towards the Earth.
Is there a harmony?
No,
Is there a harmony where nothing moves at all? Is there a harmony on Earth where
As I
everything
just said,
stays
these
still?
devices that you're talking about, that you're trying to use as examples, are not examples of dropping something to the earth. They are not. These devices are transferring the charge. They're doing the claim you're making that an object just dropping to the earth would do.
Straw man, Jace.
How is that a straw man?
Okay, listen, dude, listen. The electric downward current obviously results in pressure because pressure mediation is everything. So, the downward current is obviously going to affect the pressure mediation whenever the system that we live within is seeking its equilibrium. Well, that downward current, I'm not saying that the object has to start running a generator in the air. I'm not saying that it has to start sparking and turning onto lightning. These are all strawmans. I'm not claiming anything about a transfer of energy within the matter. No one's saying that. What I'm saying is, the object's being dropped within an environment with a downward electric current towards the Earth, the same direction that it's falling. That's just objective.
But here's what I was asking you the whole time. I understand this what you're claiming, this field having this charge in the atmosphere. That's fine. Okay, but how is this? What in that is like where's the mechanism that's allowing this to communicate with give any material that's neutrally charged, and it's like it's charged that's intrinsic to it is already being used up, and what way is it communicating with these material?
It's
Through
not
density,
sentient.
man.
It's not.
Through
It's not.
density.
It's not sentient. It's not sentient. It's not communicating anything. But if I had a container and I was like blowing down on it, creating downward pressure, and I drop something, it's going to fall a little bit faster. It's going to ensure the direction of what's falling because I'm adding downward pressure. That's what the downward current does. Because current results in pressure that is mediated relative to the energy or input or direction of the energy. Right? Just objectively. So we have an Earth that has a downward current down towards the Earth, a downward pressure. That object's falling down within that. It's just objective. Everything's objective that I'm saying.
I say this: when you walk outside, everything's in harmony. So nothing's moving, nothing's going down, nothing's going up. Everything's in harmony. When you put energy into it, then you're bringing it out of harmony, man. And
There's
it's
a
gonna want to
bias.
go back.
The bias is based on electrostatic resonance. It's measurable. There's an electric field with a downward current. That's what the bias is. If you can't acknowledge what I'm saying, you're strawmanning me.
Well, right. So these things you're talking about, then, they aren't in support of this other idea you have. These are two separate things you're saying.
No, because the electric downward current creates a downward pressure. Do you agree?
Sure.
Okay, well, the object's falling within an environment with downward pressure, creating the bias.
How? What is the mechanism?
Electrostatic downward pressure.
Entropy, man.
Those are
Entropy.
just words, though. Like,
Okay,
what's
so the air
physical
itself
way?
has pressure being mediated down because of the electric current in the air. The object's falling in the air, right?
Yeah.
So it's
of
falling
course.
within an environment with a downward electric pressure, which is way stronger than gravity even claims to be, measurably, provably. I cannot use gravity to run a corona motor.
Yeah, gravity's just a word.
That's another issue, right? These
It's just
things don't have the value that electrostatics have. They're two
Right.
distinctly different values.
Yeah, one's actually real, and tangible, and provable, and strong, and can be utilized to harness energy.
Demonstratable.
One's fake pseudoscientific glue to hold together an idea of omnidirectionality on a spinning sphere in a vacuum.
Yeah, can I ask a question about gravity? To the other gentleman?
Go ahead.
Gravity, okay. Is it? I mean, is it the time and space warping and bending? Is that what it is? What can we bend or move or work or like manipulate with time or space in a lab? What is that we can manipulate with time and space in a lab? Like what material? Can we bend diamonds and rocks with it?
It's just math, bro, to make their bullshit work. It's just math, so they can have an instantaneous reach out across the fucking solar system in the galaxy. Just mathematical bullshit.
Well, simply put, electrostatics is the real thing that's here. There's a downward electrostatic current, and everything's electrostatic, and everything's about electrostatic equilibrium. Everything can be boiled down to those two words. But to make the heliocentric model even like a postulation, you have to have something much stronger than electrostatics. It would never make these gigantic bodies move around each other at this distance. So you have to come up with something else. Now, this is not actually testable or even measurable or provable on this small scale, but if we apply it out there where it's way stronger and there's nothing and it overtakes gravity due to these immense masses that we have to invoke, we can say that this magical force takes over and is able to make the planets move around each other, etc., because electrostatics couldn't do it. So the force we do have here that we can prove and tangibly utilize, it's not strong enough for the heliocentric model. So something else must be introduced. And that's why we have the pseudoscientific idea of gravity and the conflation between big G and little g due to the person that's confused and doesn't even understand it. And then they just don't acknowledge the intrinsic electrostatic resonance that causes everything.
Right. So the point I was getting at before, the issue is that current is the flow of electric charge. And the big difference between the examples being given is that there's either a mechanical device or an electrical device or some kind of device that is causing the charge to flow, causing the current. Whereas an object falling in the atmosphere has nothing to cause a flow of charge. It's just an object falling in the atmosphere. It doesn't
Yes, it does.
charge or
Yes, it
uncharge
does. That's
when it
exactly
hits
what it
the
does.
ground.
The atmosphere is
Yeah, you
energy,
can get
and it's not an
measurements of
atmosphere.
that and prove your case.
So how
You're
come when
free
you
to do
how come
that.
when you change the charge of things,
Dedicated
they'll
heat.
change their gravitational quote unquote direction when you change the charge?
What do you mean?
Well, there's a lot of different cases that's the case. Are you familiar with like the ballooning spiders?
Right. Right. If you have a device that is changing the charge, we're talking about a different thing now.
No, we're talking about physical objects and charge and so on. And you were trying to say that there's not a correlation between them, but there is.
No, I was
Empirically,
saying
measurably, observably,
I
repeatedly, verifiably.
was saying a device that causes current, the flow of charge, is not an example of an object falling through the atmosphere and trying to say that there's a flow of charge there, a current causing that to happen. They're two distinctively different things. One case, you have a device, be it mechanical, electrical, whatever kind of device it is, that is making the charge flow. In the other case, an object is just falling.
And the object is electrostatic, and like he said, you can change the direction of things by manipulating the charge.
Yes, I don't deny that. If you change the charge, if you have a device that causes current to flow, there will be effects.
So there's a relationship there intrinsically.
Yeah, it's like charges attract or repel, and unlike charges attract.
Listen, the military knows this shit. They harness this shit, and until y'all catch up, man, it's like shit's never going to advance. They're going to hog all this technology until it's demonstrable shit, dude. It's a Gaussian surface. There's a ceiling, and we're in between the negative and the positive, man. It's easily demonstratable, explainable, equatable. I mean, why are
Okay.
y'all in such denial of
Well,
shit?
just say no, but just say okay. That still doesn't answer the question of how that's gonna interact with. Let's say you have, I don't know, like I said, a mass of helium, some sort of active, but let's just say it's there, it's in the middle of the air, and you're holding it, and you let it go, okay? Whether it's in a vacuum chamber or wherever. So maybe helium is a bad choice. Some other noble gas, okay? We'll use neon gas, okay? It doesn't matter though. If you have this here, right, and it's sitting in the air, then what is it about the air or the field or anything like that that's interacting with this neon that's going to compel it to do anything?
No one
But
said
to
it
interact
would
with it at all.
intrinsically.
It has to do. It has to interact with it in some way,
Are you
right?
saying that it's not electrostatic? Those gases aren't electrostatic?
I'm saying if they're neutral because the charges are accounted for, then I don't see where the interaction is going to come from.
It's not about the interaction. I'm not claiming a compelling interaction. I'm not claiming a compelling interaction that's a straw man, but just because you say that the charges are accounted for, that doesn't mean that there isn't an intrinsic charge there, which is the entire point. And then the relationship is going to cause effects within the seeking of equilibrium. Gas goes in any and all directions, seeking equilibrium. Intrinsically, that is also electrostatic acceleration, proving it's not point specific. It goes in any and all directions.
The
This
electrostatic
doesn't answer
interactions, right? Say you have a diatomic gas molecule, the covalent interaction is on the order of 1 to 2 angstroms, right? So this isn't going to affect large scale objects. And if you have just an atomic gas like helium or neon or one of the noble gases, the intermolecular interactions, again, they're on the scale of no more than 10 angstroms.
Non sequitur though, because I'm not saying it's really strong or something.
But you're saying it is a sequitur, right? You're saying these electrostatic interactions are responsible for things we see. But when we measure the value of these electrostatic interactions and the distances they act at, they don't correlate to what you're saying.
Yeah, see, that's again, you're basically strawmanning me inadvertently. Like I'm not saying anything other than there's a downward pressure towards the Earth because of electrostatics. This is objective and testable and measurable.
How?
Okay, so you can take a corona motor, tie a string to it, and then there's a downward current harnessed in the air. Everything's electrostatic. Lightning, clouds, everything. Rain, bumblebees, everything.
Did we not just go through this whole thing?
Well, it seems like you're not understanding. There's a downward pressure. So if it's falling within an environment with a downward electric pressure, that's the thing that sets the initial bias. The rest of it is settled with the fact that that object is more dense than the surrounding medium. The density is based on the charge because density is compactness of matter. So the compactness of the matter relative to the compactness of the matter of the medium will determine its direction, and that acceleration is electrostatic, and it goes down within a downward electric pressure that's measurable and provable.
But again, the measurement device is what's making the current, right? It's what's making the charge flow. It's a different situation.
No, it's a
than
wire.
in-
It's a
in
wire.
the atmosphere.
It's not making it. You can't make energy, man. Like you can only harness it. It's a wire. It's just harnessing the energy that goes down towards the negative surface, and that's what makes the motor go. The motor harnesses the downward current.
It's like water. You can't get rid of the flow. Like when water comes and a flood and all this, and the water comes, you can't get rid of the water. It's always going to come. It's always going to be there. But you can redirect it away from the area that you want to stay dry. Right? The same thing follows.
Yeah, good analogy. Because everything's within. Also, everything's within water. Actually, electricity would be the ripples in the water.
Yeah, I personally think water is electricity. I mean, I know it's a weird way to say it or a weird thing to say, but it's kind of, I mean, with all the words that, I'm just saying, basically it's potential. The air's potential and the water's potential.
Electricity is like the movement in the water, like the ripples. Like if you do a rock,
between.
Yeah, if you do a rock in a pond, the ripples are all like the physical phenomena that we observe.
Yeah.
The water would be like the background. Electricity is coherent. Like if you had a vortex within water, that's an idea, somewhat of a coherent. What we call electricity, like a whirlpool. Anyway.
So, do you know that a corona motor, like all the ones that I know, right, they have electrodes and they're ionizing the air molecules. Some of them have a leaf on top, and some of them just have regular electrode wires, right? So they ionize the air. It's a device that ionizes the air, right?
Does it move?
Then
Does it get more
current
energy?
can flow because it's stripping electrons off of air molecules. So now current can flow because now we have a separation of charge. Right?
Okay.
So it's not an equivalent situation again to
what?
Two
Equivalent
objects falling in the atmosphere.
Does the motor turn faster when the string goes higher in the air?
Yeah, it's ionizing air molecules, man.
But why does it go faster the higher it gets?
Because the conductivity of the electrodes, the wires that you're using.
Why does it get higher why does it get stronger the higher it gets though?
voltage.
From what I understand, right, it's because the longer the distance, the more they can be accelerated in this conductor. The charges, as they flow through, electric charges
Less
can be
resistance.
accelerated, right? So now they're implying more momentum and energy into the device.
Wow. So actually, there's just more energy higher. We have equipotential increase. We have an electric gradient on the Earth. So the higher you get, the more electricity there is.
Yeah, that's I explained the mechanism of that because what is energy, right?
Uh-huh.
What
Okay.
does it mean to have more energy
It's not
higher?
about
It's
it
what
just
I
has
said.
long. It's not about how the string is longer, so it has a longer distance to travel. No. There's more energy up higher.
Yes, it's
Okay.
about the charges being accelerated in the conductor.
Yeah,
you're
and
pulling more
positive goes
ground.
to negative, right?
The energy
exactly.
increases with the velocity.
Does positive go to negative?
Yeah,
Goes to
So,
ground.
so there's positive.
unlike charges are attracted.
Yeah, so there's positive charges that increase the higher you get, and it goes down to negative or the ground. Okay, cool.
Sure.
So there's an electric
I
downward
don't
current.
disagree with any of this stuff, right?
You can't.
Yeah, but it's not. This is not what you're trying to say it is, though.
Okay, well, how about you get specific?
Okay, so give me the mechanism of an object. Let's say a ball, a baseball. So I throw a baseball and it travels up and it comes down. What is the mechanism via this thing you're talking about that makes the ball go up and down?
Your hand.
Yeah, it's well, yeah. You introduce energy, but the point is that it's relative to your energy input. You're asking why it ultimately goes down. Well, then it's because it's more dense in the air, and density is about electrostatics. And electrostatics, so it's incoherent dielectric acceleration. It's not point specific. That's why you can make things float with the Van de Graaff generator. But in the scenario that it's going down, which is all you Globers like to talk about as if it's some magical thing, when it's going down, it's just also incoherent dielectric acceleration. Before you would even get, before the ground would like, in your minds, how we've been taught, right, and brainwashed, like it's like before the Earth would pull the object down, you would have to like sit it on the ground, bro. Like it's so weak, right? You have to be like, you have to touch it for there to be any type of interaction, right? And it's super, super, super weak. But that's not the point, though, because the object's more dense than the medium, and that medium that it's in has a downward pressure being pushed down on the object, much higher than the object. No matter what height you drop the object from, the pressure continues to increase above that. And so it's always going to go down. So if that object starts going down, it's falling down with the downward pressure, right? So if you were to throw something up, it's going against the downward electric pressure. It's nothing to do with gravity pulling things down. That's pseudoscience.
Right. You created a resistance when you threw it up against the medium, and now you have kinetic energy going into that ball. And what you did was made a magnet. Now it's going to go to ground.
I know I'm explaining myself thoroughly at this point.
Even Einstein described gravity as
You did give a mechanism there, right? And I'll accept that, right? I'll accept that. That's fine. But
cool.
But I will say these machines are a slightly different situation. It's kind of the same principle, but there is a machine involved that's transferring charge. But nonetheless. So right now you have a mechanism. So the next step, right, is you got to gather data and experiments and things if you want the idea, to be
Solidified.
substantiated. Yes. And I don't expect you to have it right now off the top of your hands, right? I'm just saying, right? For
the first step actually would be to manipulate that independent variable to substantiate that it's the causal agent of the effect. That would be the first step. So we can do this by manipulating the charge. And when we do that, we can change things' directions, i.e. weight, because you can't weigh something unless it's sitting on the scale, right? So we manipulate that variable. We change directionality. So now, can we manipulate the variable of the Earth's electrostatic resonance? No. I mean, I'm not gonna say we can't affect it at all. I think that you certainly could kind of try to affect it, but no, obviously, it's not testable in that sense.
So do you see how we feel now when you tell us we have to turn gravity off?
Well, but this is a difference, right? Like, this is different, right? So I can actually make something orbit with electrostatics in a demonstration. So I can do way more than you can do, you know. So that's kind of all we're asking for. Is like
You
anything.
can make something orbit without strings or any kind of thing connecting the two objects.
Yeah, just electrostatics.
Okay. Do you have an example by any chance?
Sure, I can get a vomit comet, start falling down, take a needle, like rub it on the blanket, get a lot of static electricity, drop little water droplets as I'm falling down, and you will literally see it orbit around the needle. Now, that's an expensive test, but I'm down to do it. If any of the Globers want to fund it, I think it only costs like a couple grand to do a vomit comet. I'll show you guys a more viable mechanism for your... It's not really viable, though, because it's not strong enough.
Right. So, me, if I was to go about this, and I was saying the air had this downward pressure, that's what I would just want to directly measure that. Right, because then it's undeniable. If I say there's a downward pressure and I can measure the pressure, then it's undeniable.
Yeah.
Yeah. So that personally, that's just where I would start. I would form an experiment around that.
Well, yeah, but you agree there's no way to have a downward electric current without downward pressure.
Yes, electric current will cause pressure in the direction it's flowing.
So all I have to do is measure the downward current. And we've done that.
Yeah, but like I said, right, we gotta have the situations have to be fitted to your claim. You can't go outside of the claim you're making and measure something in a different situation and claim it explains this other thing.
Well, it proves that there's downward pressure there because there's no viable alternative to there being downward electric current other than there's downward pressure.
Yeah, the pressure occurs when the device is ionizing the air.
The pressure is just always there, period, right? Like
that's what you should measure.
Okay, well...
that device is not ionizing air, dude. Quit saying that.
No, it's easy to measure it. So, did you know that the Earth actually has a gradient of gas pressure?
Gas pressure is different than electric pressure that you're talking about.
Yeah, it's different. But if they're both present, how would they be unrelated?
Because gas pressure is due to the kinetic energy of the molecules when they strike you, the ground, or each other. They exchange momentum. And that's
Correct.
what is the pressure.
Yeah, correct. And all of those exchanges are electrostatic.
No, momentum exchange is not electrostatic.
Okay, well, if the thing that's in momentum is electrostatic, then it's intrinsically electrostatic momentum. See, I'm sorry. I feel bad for the opponent. It's like, I'm sorry about it, but yeah, I have the answer all question because it literally answers all the questions. There is nothing that is not electrostatic. Dude, you're just going to have to be honest about it. The globe will never make strides until it acknowledges some of these things.
There
I can't make strides anyway, of course.
molecules that are exchanging momentum.
Yeah,
right?
yeah. Electrostatic.
The electrostatic charges hold them together, but they are not the exchange of momentum. That is due to their kinetic energy, which has absolutely nothing to do with the electrostatics of the molecule.
Well, that's where you're wrong because you can't have kinetic energy without something that's electrostatic. Yeah.
The molecules are held together by electrostatics. That is not the exchange of momentum. That comes from their kinetic energy, which is due to their velocity.
Their movement, yeah.
Right? Ke is equal to the momentum divided by 2 times the mass, right?
Right, and that's dielectric velocity. I mean, electrostatic. Same thing, but... So, okay. And I was trying to tell Nathan Oakley this, man.
Mass
But he
of
wouldn't...
the object.
Yeah. So electrostatic acceleration, though. Like the velocity of gas particles. It's the elastic velocity is electrostatic, man. And it just the kinetic energy that comes from the motion is much stronger than the very slight, damn near negligible downward current that results in a bias. But nevertheless, it's all intertwined. So
that's not how it works, though.
Just saying that doesn't
how
mean
do you not see that this isn't a valid way to reason?
You mean, why don't I see how this isn't what we were taught? Or you mean you have a sufficient rebuttal? Because those are the only two things I can even hear right now. I don't know.
The molecules have collisions with each other. They have a cross section when their kinetic energy is of specific values. They will collide either inelastically or elastically. If it's an inelastic collision, they can exchange momentum. So their initial velocity going into the collision will not be the same as their velocity coming out of the collision. This has nothing to do with any of the nuclear interactions or any of the electrostatic interactions. It's purely the velocity, the momentum.
Yeah. See, that momentum, that movement, right, is 100% described as electrostatic. It's just like we were talking about when I have downward acceleration. Well, it's electrostatic acceleration. Okay? You can say it doesn't matter. You can say it's not related, but you're wrong because it's in our little objective notebook where we're taking notes of the phenomena. It's the first thing we have to write down. I'm not claiming that it's doing something that results in a net effect. That's a straw man. I'm saying that the very mechanism itself is electrostatic. We have a downward current on the Earth. We also have a gradient on the Earth. Now, we have a gradient for many other reasons. It's not as simple as the electric gradient. I am not claiming that it pulls the gas down. That's something crazy Globers would say.
I think you've got it just kind of, it's twisted, contorted.
Well, I'm the middle ground that the CIA
Electrostatics,
didn't want us talking about. That's what
a
it is.
gas molecule, right? So say we have like water vapor or something like CO2. The electrostatics are the bonds that hold the carbon atom to the oxygen atoms. That's the electrostatics, right? And its kinetic energy is not dependent on the charges interacting with each other. The kinetic energy is dependent on its momentum and velocity.
Which is relative to its density, which is relative to its charge, which is electrostatics. Everything is. So, I mean, I have this fix-all. It's not a fix-all because I'm giving you hyper-specific. I just rebutted your point, but yeah, it comes back to electrostatics.
How did you just said things, man.
Okay, so
you're just
does
saying
gas
it's
disperse relative to its
electrostatics. You're not
density?
giving any like mechanisms or
Okay, here's the mechanism.
values for these things.
Density, man. Does gas disperse relative to its density?
Sure.
Density is intrinsically relative to electrostatics because density is defined as the compactness of matter. You agree?
Yeah, the average density is a formula, and if you really want to get the real density, you do crystallography, you measure the unit cells, and those are held together through electrostatics.
Right. So density is electrostatics, and yeah, okay.
It's the result. It's a property.
Yeah, for sure.
A value.
Yeah, sure. I was just being lazy.
But the point is that the compactness of matter, i.e. density, is relative to electrostatics, and the dispersal of gas is relative to electrostatics because it's relative to its density. And the dispersal of gas, or more so, the kinetic energy is relative to the dispersal of gas. So summed up, the density or compactness of matter is relative to the electrostatics. The dispersal of gas is relative to the density of the gas. The kinetic energy is relative to the dispersal of gas.
No.
Therefore, it's all electrostatic.
No, the kinetic energy is relative to its momentum and its velocity.
And that's relative
just
to
a fact.
That's relative to the density. That's why it's moving where it's moving, how it's moving. That's why it's dispersing the way it's dispersing. That's what causes the motion, man.
No. No.
Okay, so the density has nothing to do with the motion of gas? Momentum for what? What's the momentum?
The gas moves in all directions.
Doing what? Seeking equilibrium, right?
Yeah, if you have a chamber with, one side has less pressure than the other, it'll equalize.
So it moves in all directions seeking equilibrium. And it seeks its equilibrium relative to density. Well, density is relative to electrostatics.
But the density is constantly changing in a gas. I could sample a gas at one instant, the density will be one value, and sample it at another instant, and it'll be another value.
That's right. That makes my point stronger. You're manipulating the density by manipulating the charge because you cannot do it without doing that.
But the gas atom, there's charge in being manipulated. Those bonds have a strength, and that value doesn't change.
If the density changes, then the value changes.
How?
Well, because intrinsically, and it's not really about the value, I'm not talking about the mathematical construct, but the strength itself has to change because the strength being increased will increase the density because the density is proportionate to the electrostatic pull, if you want to call it that. Force, attractive force, charge. The density is relative to that. So if you manipulate the electrostatics,
the measured values don't change. That's the problem. The enthalpy of the bonds in a molecule.
Yeah, of course they don't. Of course they don't. See
change.
what the charge pushes them further away from each other, right? Or pulls them closer together. It doesn't not that it changes the internal resonance of the molecule. It just either becomes more compact or less compact based on the charge. And the gas disperses relative to its density equilibrium, right? So it's trying to find its equilibrium based on its density. Its density is based on its charge. If you manipulate its density, you're manipulating its charge, and that's all there is to it. And so the momentum itself is based on it trying to find its equilibrium. That's why it's moving. And its fluctuation is relative to a variance factors, right? The primary one is the density, which is electrostatics. I don't need gravity for anything. In fact, gravity is not needed to explain anything.
The charge is constant.
But the compactness of the matter is not. But the compactness of matter is not constant.
But still the charge is constant. So you're not manipulating the charge. We're not adding gas, right? We the enthalpy of these bonds, we can put them in a box and no gas gets in, no gas gets out, and the charge stays constant.
Okay, so can we manipulate the density of something without the charge changing?
Yes.
Okay, so then the compactness of matter isn't relative to charge.
The compactness of matter, the density, is just the way it's arranged.
And it's relative to charge.
Yes, that is due to charge. But this has nothing to do, right? Because the atoms arrange themselves at distances, because like charges repel and opposite charges attract. So they have interaction energies. Enthalpies is what it's called. And it causes a distance between these two charges, right? This has nothing to do with the kinetic energy when it's moving.
It does, though, because the reason it's moving is because of that.
How is the charge that's static, right? They're with each other. If this charge was being used for motion, the bonds would break apart.
You're asking me how the kinetic energy that comes from the motion is based on its density?
Yes.
Because gas disperses relative to its density. Jeez Louise, man. Come on,
What
bro.
does that mean, man? Like,
Okay, well, gas
gases
disperses
have a
relative to its
density.
density.
They have a density, right? The kinetic
Yeah.
energy has no dependency on the density.
No. The kinetic energy is a byproduct of.
That's what I want you to explain. Like, how?
Okay, so that's why hydrogen goes higher. It's less dense. The omnidirectional dispersal of gas seeking its equilibrium is based on its density. Density is based on electrostatics. Therefore, the gas is seeking its equilibrium relative to the surrounding electrostatic environment, including the fact there's a downward current on the Earth. And gas is constantly being introduced at the surface. We have a cycle prominently coming from the surface. We have tons of gas coming from underneath the surface. We have weather patterns that dissipate relative to the pressure, which actually also help affect the dispersal of the gas. But it's all the kinetic energy, the motion itself, is electrostatic in nature. There is no way around it. It's just like the only way you can even get to talking about kinetic energy.
I do at least like that this is a method. This is a model.
Yeah,
This is a model making many testable claims, and I think that's impressive because I don't often hear that from Flat Earth. So I like that much of it.
Yeah. It's all testable, man. That's what's beautiful
I
about
will
it.
say it's been tested already.
Okay.
What would be the
So
criteria for falsification?
You can manipulate the charge of something and see if it actually will affect its direction. And if you cannot manipulate direction with charge, then that would, in theory, eliminate the idea that charge causes the direction or acceleration. Yeah. But when you manipulate the charge, you can change direction. Like if I take a balloon and I rub it on my head, I introduce the electrostatic charge, it'll stick to the wall.
So essentially it might be like, can I measure if there is charge in this thing and if that influences moving? And so if I was able to show that regardless of how much or how little the charge was, there was a certain object I couldn't get.
Yeah, the balloon sticks to the wall.
I'll go do that now. Right. But that's looking for objects where it does happen. What you want to do is go, are there some objects that no matter how much I influence their charge, I can't get them to do anything interesting, go up, stick to a wall, make my hair stand up, that kind of stuff. Like I've got a screwdriver here and I don't. Yeah.
Yeah, you have to find something that's not electrostatic. And you're going to have to then start invoking things on the subatomic scale, which come from misunderstandings. You actually can't invoke those either, but you're not going to be able to use any type of matter that exists in the whole world that's not electrostatic, thus affected by it.
So it's unfalsifiable is what you're saying?
No,
So
it's falsifiable. All you have to do is find one piece of matter that exists that it's very falsifiable, just like... Because my claim is that everything that is material is electrostatic. So, like, all you have to do is find one thing that's not. It's very falsifiable. I've opened myself up quite a bit, actually.
The existence of matter, though, is again, it's a different thing than how that matter gains kinetic energy. Because, right, I don't need any kind of electric charge to give something kinetic energy, to give a molecule or atom kinetic energy, right? That's what thermal energy is. I can increase the temperature with thermal energy, and the kinetic energy will increase.
Yeah. So you'll manipulate the
charge.
pressure of the environment, and it's going to move accordingly. But you can't have kinetic energy without
electrostatics because you can't invoke anything that is matter without invoking electrostatics. It is not that I'm not saying that electrostatics equals kinetic energy. They are two different things, but you can't have kinetic energy without electrostatics. If you can, feel free to prove me wrong, but saying that the charges balance out is not doing it. It still has a resting electrostatic potential. It's a charge that's intrinsic. So there is nothing that can be invoked. You're going to have to go to the subatomic scale, where I will obviously be parting ways with you once you assume these characteristics.
I could easily go there, but we don't need to.
Yeah,
Spend
let's
my
pseudoscience,
whole life
man.
at a particle accelerator, for the most part.
Well, I don't think you were looking at nothing. I just think that the way they kind of taught all of us to interpret what you looked at is wrong, right? So it's like I don't think that anything you did was useless or anything. I'm not one of those people. Like I don't want to throw quantum mechanics away. I think it's a beautiful thing in lots of ways.
Yeah. But, right, so everything, the atoms and molecules are held together via electric forces, electromagnetism, electrostatic forces. That does not mean that kinetic energy comes from electrostatic forces, because it doesn't. As I just said, you can put thermal energy in and the molecules will start zooming around. No electrostatics involved.
Well,
Right.
it is involved because what's moving around is electrostatic. So.
Yeah, they're electrostatic. They have electric charges. No one's denying that.
Yeah, you can keep the same electrostatic charge, manipulate something else, and increase kinetic energy. That's why I made it clear I'm not saying they are synonymous. I'm saying that, the kinetic energy can only ever be a thing with electrostatics.
Yeah,
like
no one denies that.
Well, that's
At least
a
no one
lot of
I
Glovers
know
do
deny.
Yeah, maybe if you're talking about people with credentials and actually intelligent people, then yeah, you're right. Probably no one would deny that. I have a bunch of denials here on the corner of the internet that I never get with when I talk to real professionals. Which is, I get why you can, it seems painfully obvious, some of the things I say. But if you saw it from my angle, you'd understand why I feel the need to break this, to say these painfully obvious things.
No, I hear you. I had to do it before as well, so.
Yeah, I'm sure you actually have. I don't dispute that. And I've learned some things from you. Like I was talking the other day, I was telling Zanuck that obviously splatters have taught him things. And I admitted I actually invoked you. I can't remember what it was, but so yeah, that's cool. I think you're supposed to come to impart and to learn.
Yeah, I hear you. I appreciate it. I've learned stuff from people here and at other servers and stuff, and I can kind of sound like a dick sometimes. I don't mean to. No hard feelings.
Nah, yeah, good. Just conversations get heated, but so yeah, the gas. Okay, so we have a gradient on the Earth, and most flat earthers don't address this part either because they just are constantly trying to get the Glober to acknowledge the antecedent relationship they're talking about to have gas pressure, and then oftentimes they're just like gradient. But yeah, we have a gradient on the Earth, a gas pressure gradient, and we have gas constantly introduced to the surface, and then it basically divvies itself out from there and seeks its equilibrium relative to its density. Density is, like we agree, and it's subjective. It's based on density being the compactness of matter is relative to its electrostatic charge. And things are going in all directions. Like the downward current that's on the Earth is so weak, bro. It's not going to stop gas from doing anything. The kinetic energy of gas is much stronger than electrostatics, right? So I'm certainly not saying there's some magical transfer where they dap up and it pulls the gas down. No, that does not happen. Gas has no directional preference or bias. It goes in all directions because the kinetic energy is so much stronger than the downward current of electrostatics.
And I get flack from flat earthers for this, of course. Which is insane. Blows my mind. Yeah, it's just testable and provable, man. So now you guys know. And you guys got to admit, like, you take a Van de Graaff generator and you make things float, that's pretty crazy. And if you're thinking, like, if you're trying to, like, be logically profound and really ask questions like questions that everyone thinks they know the answer to, like, what is weight? Like, if you really want to, like, what exactly is that? Like, I'm going to put this on the scale and weigh it, okay? Because it's pushing down the scale. That's how I weigh it. So if I want to figure out what is weight, if I can change the weight, right, then that would be a good start to figuring out what weight is. And we can make things levitate. So obviously it doesn't weigh anything at that point. So an intellectually honest person in their objective handy-dandy notebook is going to write down that when we manipulate the electrostatic charge of an object, we can make it float or alter its direction. This is just in our handy-dandy objective notebook. And now we can close this, sit it down until we make our next. There's no reason to argue about it. It's just to say that weight is unrelated to charge is patently absurd because the objective handy-dandy notebook cannot coincide with that assertion. Maybe I'll make a Blue Clues parody. It's mail time. In a world where there is no sufficient globe or rebuttal.
So what globe? Anyone can answer this. Globers or flat earthers, right? What would you say is the most sophisticated, or i.e., accurate model for what mass is? The Glober model, not a flat Earth model. Flat Earthers can answer the question, but like what is the Glober's most accurate or sophisticated model for mass?
Mass, you mean like just a object, or like mass as a property of an object?
Yeah, the property of an object, I'd say.
I don't know. That's kind of complicated. I mean, it's pretty much whatever you want, because it would. I'm not sure what you mean.
I mean, I understand what he means. I was trying to think about it.
Right, it's a good question. It's something I hear all the time, and some of the I get why some of the Globers say certain things, but just inside, I'm just like, yeah, it's not right. But
Yeah. Oversimplification, typically, man.
yeah, exactly.
Yeah, I don't have an answer off the top of my head. I'm not sure.
Well, I just refer to, what Einstein said about it, or at least what Max Born said in his book on relativity. It's a measurement of like the resistance to inertia or acceleration, and it's relative to the system that it's in.
Yeah, pretty unsatisfactory, in my opinion. Like I haven't. Okay, so like to answer the question within the Glober paradigm is one thing. I've never even actually thought of that. But even beyond that, just to try to answer it in general, is also I have thought of that, but I don't even know what I would settle on exactly right now either. I think that the concept is certainly worthy of keeping in our pocket, if you will. Like I don't agree with just dismissing the idea.
All right, it's a good question. It's perplexed many a people for centuries, right? First, they came up with the whole idea of gravitational mass and inertial mass and all that. Then, Einstein came along, and Planck and Born and Heisenberg and all those guys. Then, like Feynman and Schwinger, people like that came along, and Murray Gell-Mann and all them. They expanded upon it. Sorry, it's perplexed a lot of people.
Ken Wheeler, don't forget about Ken Wheeler.
Ken Wheeler's smart, man. I'm just saying.
He's way smarter than John Wheeler.
I'm not familiar. Joshua, what's your answer, man? What's your favorite Glober definition of mass? Preferred, maybe the word.
I mean, I don't mean to be difficult, but it's I would say instead of having a favorite, I think there's they're all describing the same thing, but you're going to use different ones depending on the relevancy of what you're talking about.
Yes, that's the problem. So you got to come up with one that's going to just work.
Well, like if somebody said, "What does mass mean?" I might give them a longer description, but if we're talking about something specific, like a lot of times people say mass is the measure of matter in a material, and even though that's not very specific, I mean there's some truth to that.
Yeah, yeah, very surface level, the amount of matter. But we all know it's much more. It's much more than that. I mean, honestly, like within the globe paradigm is a question I've never fully contemplated, just to be honest. So, I mean, I have maybe in passing, like subconsciously, but my honest assessment is it isn't a viable framework to even dissect. Like, that's my honest opinion, right? But I don't know. I have, okay, this is where it's like I'm being forced into this. I do have an overall framework that I can postulate, if you will, right? Like I think matter itself is is the background medium, like a certain resonance or vibration of the medium. You know what I mean? I think that if I'm going to try to properly define mass, I'm going to have to like address what matter is. And that's where I'm at right now. That's what I think it is. I think that due to the viscosity and density of the medium, it's not perceivable, but the material is perceivable because it's a certain vibrational resonance within that medium. I mean, this is really hard, but it's a crazy idea. It boggles the mind. It does, but that does not mean that it is not the case. So, but within the global paradigm, it's different. Good.
No, I was just saying another good one is inertia. Just describing it. Everybody else. like similarly with the inertia. But they almost have the same definition.
Electric charge is another good one. Right, that perplexed people for a long time. A lot of people just accepted the statement that it's fundamental. But is it really? Because it was. Some people say that it's not.
Yeah, I mean, I think that's a step in the right direction, like, I think it may not. Yeah, I mean, it just, I guess, when you want to tackle a question it's that fundamental to everything, like the composition of matter, yeah, then you have to really get into, like, well, what is electric charge? I don't know. It's really crazy. And, and this is my honest opinion. I know some people might want to consider me crazy for this, whatever, but, like, I feel like if I was to invest the amount of time to where I felt I really laid something out that was legit, like super legit about this, dude, it would never get the time of day, man. And so it's like, I may at one point venture down that type of path, but I'm not personally motivated to do it at this moment. Like, I know it would just never get a fair chance.
What I would say honestly is, right, there's two things you can do, right? Let's say if I was personally give you, or any flat earther, advice, if they really wanted to try to get their ideas put into either scientific literature or anything like that, there's two ways you can go about it, right? The first way, this is just my opinion, the first way would be to find a physicist, give them your viewpoint and try to have them formulate that into mathematics, right? Because that's what a lot of physics is. It's, you have these variables in mathematical equations. These variables pertain to observables, and we measure those observables and see how they affect things, right? So you find a physicist to put your ideas into a mathematical form that can then be tested. Or the second way, you can do that yourself. You can make up the mathematical form yourself and try to test it, or get it into the scientific community. But that's the only
what do you think? If I came up with a mathematical form, you think that alone would allow it to have a fair chance? Is that what you're saying? Because I think that's just a kind of an unspoken, like, I do agree. You have to come up with a new thing, so it would be no easy feat. But
I think if you found the right physicist, especially if you already did the work, the math for it, if you found the right person, they might be willing to test it and put their name behind it. Like I said, you can either try to find a person to just pitch your idea to and get the math worked out for you. That would be harder to do, obviously, because then you're asking that person to do it for you. But if you were to work out the math on your own, I think you'd have a better chance. It would definitely up your chances of finding someone to try to take it on.
Yeah, but you see that kind of, I mean, yeah, that require full detachment from any type of ego, because, yeah, I mean, I would do that though, but, like, obviously be giving them credit. It's kind of like how I have all these crazy, like, motions and stuff, and I feel like I've set all these judges up with crazy legal arguments. It's like, oh, do I let this, like, pro bono constitutional lawyer swoop in and, like, kind of take my argument and stamp his name on it? But I guess I'd look at both of them the same. Like, the the principle of it is what matters. Like, yeah, like, if it was able to get out there at all, I wouldn't care about that. But I mean, it would be kind of crazy to. I mean, Who knows though? You find something with integrity, I guess. If it really was like shown to be super valid and eventually absorbed, I mean, I guess the truth would come out. Who cares about that anyway? It's like of course a lawyer would want to take like a super good motion I wrote, right? Like I wrote like a hella crazy motion, like layered, and he could just be like, oh, well, since I'm pro se, I give it to him, and he does it. Of course he'll take it if it's actually super good, right? It's like literally that's happening to me in like numerous different things going on right now, and it's like it's the same type of idea. But I actually I think it's cool that you said that. It's an idea because I do think I could find one. I know quite a few people. I wouldn't even limit it to who I would talk to about it, but maybe that is the move.
Jace will do it.
Yeah.
I'm not in, right, man. I'm in biochemistry, right? So I'm not, and if I would have a hard time trying to get a physics idea published, right? So he'd be much better off finding a physicist to publish physics things.
Yeah. But don't you think that like the world should be like if you were able to find like this unifying theory of sorts, I mean that should just be immediately, if it's viable, and like again mathematically that's just unspoken. I mean it should definitely be given a fair chance. I don't know, man. Yeah, I do know some people. Actually, I can think of people like perfect to do it. Like people that they can't publicly say that the Earth is flat, but they know. Like they know, they just can't say it. Like they know that the Earth doesn't move, they just can't say it. So that would be who I'd be like, bro, I bet you can say it after this, because they're like my homie.
Yeah, Demonc's pretty good at explaining some of this stuff. I'm not sure how good he can write, but I would assume it's pretty good.
What do you need help with?
So about writing a scientific paper.
On what?
What mass is in all actuality, like what it actually is.
It's the amount of resistance towards the electrical permeability of the object. So the thicker the object, the more or less resistance it'll have towards the potential around it. So like if you have an ice cube in water, the thickness of that object, right? The thickness has less permeability to the electrical continuity of the water, therefore it resides upon it like a magnet, like a differential, right? So and the same thing with the helium. Once you take the plastic's more dense than the air in the definition we have from the globe. But in reality, what's going on is the weight of the plastic. Once you put helium in there, you put it under pressure. So you're putting an amount or a pressure or a weight or whatever you want to call it. You're forcing something under pressure to expand the medium. So you are creating more of a dense idea. Same thing. So it never is less dense than the air ever. The only thing you changed when you put the helium in there is the potential, right? And that potential of helium just happens to be the same potential of ground, and it goes away from it. So it goes up.
Damn, dude. I wish I
How
was
come
writing
when
that
you put
down.
air, it doesn't do that?
What the fuck do you know, man?
Are we willing to accept that the mass?
Because hold on, because McToon told me that when you put helium in something, that automatically makes it less dense as a whole. So I said, why don't we do a challenge and take some granite and put a little hole in granite and fill it with helium, and just see if that helium makes it less dense as a whole.
I gotta disagree with I think it's called MC Tune. I just call him McToon all the time too, but I think it's MC Tune. But still,
Nah,
I would
McToon
disagree
till I
with it.
die. I'll never call him MC Tune.
But My point was, and it still stands, that the ice is more dense than the water. See, because Archimedes is the one that gave you guys the weight with the water dispensation of like when he jumped in the tub, and when you see, because water's what you use. That doesn't mean water's denser than everything. All that means is that water's the thing that got displaced by the denser object. It means exactly the opposite.
Yeah, but
Water,
unless it displaces. Yeah, but what if it's the one displacing the other thing? Like ice floats on water.
yeah, because the electrical permeability. But water is a currency. It's a potential. It has an amount of electricity.
Cryptocurrency, isn't it?
No. It's not a cryptocurrency. Air has the same potential as water. That's why they fight. That's why air will not stay in water. That's why it rises. It's the same as helium. You understand? It's a magnet.
Yeah, okay.
Is air electricity?
Yes. Air is electricity rising out of
Okay.
the water. Electricity. It makes a magnet. Positive, negative, high to low, hot to cold. And if you have the same potential, like negative, negative, positive, positive, they're going to force away. The air and the water are the same potential, just like two magnets. They force away.
I'll say like the most off-putting thing I think about this conversation I've observed over the years is like the people, like I guess you'll say the globe proponents or whatever, that sit back and like while people are trying to figure out things that sometimes are like way deeper than things they've even thought about, you know, like if they think they can have any opportunity to kind of ask them a question or pick it apart and stump them, they like pounce on it. And my honest question for those kind of people are just like, well, why don't you just think about these kind of deep things yourself and you try and figure some things out. Like you try and figure some things out, right? Because even within your paradigm, it is not claimed that everything is known. And we're talking about one of the primary things that is not even agreed upon, which is mass. So maybe we should look at things a little differently, huh? It's not like if people are trying to tackle crazy physics questions, I mean, maybe you should do the same thing from within your paradigm. I mean, not try to. We have to admit, I think flat earthers are much more like likely to actually try to deeply process some of these things and figure out the answer because they've kind of broken away from the spell that all the answers are known. Now don't get me wrong, there are Globers that know that that's not the case, but and all the Globers say the catchphrase as if they know it's not the case, but they do not act accordingly. But there are some that do. And I typically try to acknowledge the anomaly.
I forget the other point now. What's the point? The point.
Well-
You said something. What was the first thing you said?
The mass thing.
Oh yeah, right. No, go ahead,
Let's-
Jace. Go ahead, Jace. You'll probably.
Yeah, let's go deeper on that, and then after we should go through electric charge because it's just as interesting. But starting with the mass, are we willing to accept that like things like the proton and electron, their mass can be measured?
Yeah, we can call it that. Sure. I mean, this isn't the idea of this is an idea of fully redefining the pseudoscience parameters. So sure, like, as long as it's specifically detailed, that's obviously not in any way material. And so that's where it gets tricky.
Can I put hydrogen, H plus ion, and a mass spectrometer and measure the mass?
Hold on. The mass spectrometer. What are you actually measuring in a spectrometer? What does that do?
It measures the mass to charge ratio.
No. How is it doing that?
Right. I'm not trying to get in. Do you accept that we can measure the mass or not? Right. I have a thing to say if you can.
Yeah. What we call mass as of now.
Easily demonstrable fact.
What we call mass now loosely agreed upon, I would say.
Okay. All right. So if we can accept that we can measure the mass of including air, you can put air in a mass spectrometer and measure its mass. But if we accept that we can measure the mass of things, right?
No, that's
Let's say we have an object that has 20 protons and 20 electrons that make up this object. it will always be the case that the masses of the protons and electrons added together do not equal the mass of the object that when you measure it.
What does
Right.
that even mean?
This is another layer deeper into the mystery,
That doesn't
right?
make
That
any
the
sense.
constituent parts,
Theory.
the masses of the constituent parts don't
The masses
equal the
of the
mass of the total.
Sometimes the energy binding them gives them mass, right? It adds mass to it.
No,
So
come on, Coach. You're on the right track there.
it's good because the interaction isn't that what it is? Because the what do you call that? The attraction. Yeah, that's what I thought. I thought that the energy was in that in the whatever electrostatics was binding them together, and that somehow adds mass to it.
Yep. Yeah. Yeah.
How
That's
would you manipulate
one
the
side of the
reason for that
coin.
mass? Probably with electricity, right, or magnetism.
That's one side of the coin. There's
Well, how could
another
you
side of
manipulate with that with time or space? That's the only other side of the coin you got. Time or space. Can you actually make a snowball with time or space? That's all you need to do. We can go home.
A snowball. Yeah, it always just brings us right back to electric charge, man. And like mass spectrometry is founded on that. Right?
one
And what else do
side
they
of the
have for
coin.
time and space? Time and space is their gravity. So if time and space can't do anything, what is all this stuff that's supposed to be doing all this stuff?
I think we're looking at the area. Let's just say the area around the charge. Like if you have like electrostatic, like a dielectric field, you know what I mean? Like it has an area to it. It displaces. See, it's interesting because now you're talking about like what does it displace? You see, I don't know. That's what I'm saying. That's why I was saying earlier. It's hard for me to think about it because it's like then you get into what matter. You have to get into what matter is, and I think to properly define. I think that's why it's not defined, right? People aren't even, asking that question because if we're gonna know how to fully understand like this quote unquote mass to charge ratio, I mean.
Does that make sense? Like, think about this with it. If you take like Star in a Jar or anything else, like you have energy already and you have these other mediums and you have certain things. But all you're manipulating is the amount of resistance in that medium, and then you get light from the liquid. Even though the liquid already exists, I know that. But I'm just saying, like, the way to manipulate certain things that are here, like I said, we can't like take it away or whatever. We control the flow of it, right? So if we can control the flow of certain things that we can, like that little liquid or whatever else, it has to be resistance because that's all you're adding. You're forcing it under resistance. That's the same thing that turns water into energy or air or anything else. The resistance.
This whole thing about mass and charge. I mean, this is just the way I think about them. But aren't they just two? They're two fundamental properties of matter, right?
You're just asking a loaded question, man.
Yeah, in a way. If you want to go deeper, you can go deeper.
What with the Higgs or something?
Well, I was trying to just get us to explore. So with electric charge, right? A similar question to what I asked with mass. With electric charge, right? Can we accept that during certain radioactivity exists, and during those processes, an electric charge comes out of some certain radioactive processes? Can we accept that?
Yeah. I might have missed part of it because I was doing something, but yeah, from what I heard at the end, yeah.
Okay. So So right, if we can, say that this radioactivity thing exists, and it's somehow electromagnetism is involved with this radioactivity thing, because electric charge is coming out of it.
Voltage.
So there's got to be some link there, right? I think that's something to explore.
Agreed. Have you ever looked into any of like some like electric universe proponents? Like
Yeah,
have you ever
I've seen, right? Like I have I know the explanations, and done some of the experiments regarding these things, but right, I'm just trying to get us to explore these things, and I have heard of some of the electric universe, and those proponents, what they have to say about things.
Yeah, like the Thunderbolts project is pretty cool. I mean, I haven't watched a ton of their stuff, to be honest, but like they just globe me to death, man. Like they just can't leave the globe out of it, man. It's painful. But they acknowledge a bunch of big things, like what you're talking about, like things that just kind of get swept under the rug, but are very clearly we have like viable avenues to explain, but they kind of just get ignored or replaced due to typically it's just always like this freaking dogma, man. It's like this scientific dogma, which should be, I mean, that should never exist, but that's the opposite of science, How dare you?
I think
say
it's
something
funny
else.
that time and space is doing all this stuff. They believe time and space is doing it, but every time you tell them you can punch a tree, wind can do this, electricity can do this, magnetism, all the stuff you name, a million things. They're like, no, 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 no. But they still can't make a snowball or anything with time and space.
Right.
Kind of odd.
Well, yeah, I mean, like, in my opinion, I don't know what they're gonna do, but they're gonna have to, like, at one point, it will be acknowledged that huge changes to the model have to occur.
It has to be. Their buoyancy is density. So the thing floating on the water is buoyant, but it displacing the water is density. How the fuck does that make sense? They're both the same thing.
Yeah,
You
but
see what I'm saying?
If you ever been on like a team, like I do hackathons sometimes, there's like a team thing where you're trying to do a challenge together, or fucking I don't know anything. Like if you're at work and you have like all your colleagues are trying to work together on a task or something. It's like the best idea at the time is going to be what you guys are doing, even though it's probably not the best idea in the world. But so far, no one's given a better idea, and it's that idea is working better than any other idea, and it's better than doing nothing. So that's kind of where we are. It's like if we have an idea of the way the universe works for some things, and it's obviously not complete, and it's always going to be evolving and stuff. And when better ideas come along, we have no choice but to accept those ones instead. But
No.
right now, these are the best ones.
Yeah, ideas all right, but the physics don't change. The science you guys keep saying changes and stuff, Kosho, that's ignorant. That has to be the most ignorant thing I've ever heard. Physics and
Yeah, I
science
agree.
have to go hand in hand. The method is a step of a method that can't change. The scientific method, science can't change in that aspect, and then physics can't change. It doesn't that we know of ever. I mean, it just doesn't change. They are what they are. So when you do
100% agree.
science, yeah, and you do physics, I mean, the person bringing you the story like back 2,000 years ago, our only problem here today is those guys' ignorance or ununderstanding, or they just didn't know. I mean, I'm not saying it's a bad thing. I'm just saying they didn't comprehend what they thought they comprehended right. So now we got to fix it because we're sitting on the ankles of midgets. Now we need to place ourselves back on the shoulders of flat earth giants. You see what I'm
Yeah,
saying?
damn straight, dude.
All right, science is always changing, right? That's one of its best
It never changes.
attributes. Reality
Prove the
doesn't
scientific
change.
method changes.
Reality is the thing that doesn't change,
You don't. What are
right?
you talking about? Reality of what?
Humans'
Hold on, bro.
measurement
What are you
devices
talking about?
and biases
Reality of
and
what? That's
uncertainties, those are the things that lead to changes.
Can you just go and can we do physics with your globe in a lab? Reality, man.
There's one reality, Denmark.
There's what?
There's one
Where
reality.
the globe
Doesn't
doesn't
change.
exist. Where the globe doesn't exist. You're right.
Oh man.
Unless you can produce one for us. I mean, the whole world's waiting for you to be the only one in the history of time to ever produce a globe for us in a physical lab or a scientific manner.
And what's crazy is that you would think like you could do it, right? You could overtake gravity. I mean, we have things that are stronger than gravity. I mean, you could just use like electromagnetism just to even show like a globe levitate spinning with water adhering to it. Like you could try to do something, right? I mean, just to see it. You would be like so famous, bro, if you could just like make a little mini depiction of the globe, dude.
Flow with it like a clock. Superconduction around the edge.
I think getting water to stick to something while you're on the earth is a lot harder than you think it is.
No, I
Even
agree.
using electrostatics, it's an incredible feat.
Oh, I agree, bro. Because I literally, this is part of my flat Earth journey. I literally thought about how you could try to do it. Like you just can't do it, man. Yeah, I was just trying to answer him. Good.
Right? There's a reason why you can't just readily do it.
Where the stuff goes around in a circle just like a clock. It's a perfect cycle. Superconductor. It's a cold bottom. So all you do is put your sandbox land, right? Your sand. That's all different ratios, shapes, heights, mountains, dips, whatever, right? Your sandbox. However it comes out, it matches Earth. And then superconduction with the sandbox on the edge. And you got your whole working model right there with it. I got you covered, buddy. I've been thinking about it for a while. That's why I always refer to my sandbox, because it's the only thing that matches Earth, and you can do physics on it.
The closest thing I've ever seen would be like a ferrofluid ball that essentially has ferrofluid that's all clinging to the ball. But
I have one of those.
I mean, that's definitely not like it's not a globe with water stuck to it, but it is kind of a spherical thing with ferrofluid stuck to it. So it doesn't behave even like the globe Earth claims water behaves, but because it obviously behaves more in a magnetic fashion.
A superconducting bottom underneath a flat sandbox can flow water, and if you add temperature, it'll do the same thing with the superconduction. The differential and the resistance, it'll have flow and everything. I'm promising you can do this with a flat sandbox. You can never do it with anything round, and you can never do it with that magnetic idea 100% exactly like that. You actually have to have natural stuff like sand and dirt and shit. That's what you need. So nature's the best way outside in the sandbox or in a lab with a sandbox. Kind of add them together a little bit. Add a little bit of gases. Get your little superconduction going around the edge of the sandbox. Have one heat source floating around.
Dude, if you could create a little replicatable globe that you could put in museums and classes, dude, you would be like the richest person from a scene. I wouldn't go that far, but you would make a killing, bro. Like that would get facilitated to the whole world.
Oh, you probably use helium, argon. Well, actually use a flat aquarium. Use a sandbox aquarium. Put sand in the bottom of your aquarium. Use like the edges just so you can hold enough gas so you can demonstrate something, because the Earth is fucking big. So you do need to contain a little bit to demonstrate this with that area of medium. Would that be fair?
Yeah. So what exactly are you talking about though? Like a flat sandbox and what?
Superconductor before, where they put the discs over the thing and they just float and they just keep going around and around and around and around.
Okay.
I
So
think
like
he wants
just
to recreate the Earth in the lab.
yeah. Like well. Yeah. Well, like the globe.
And it levitates in a clock fashion perfectly. So you got that covered, and then you put your land in the center of that superconductor ring.
Yeah, but you're not gonna make. I was talking about a globe.
It's gonna match exactly what you think it is anyway. A superconductor of Antarctica ring. The sun and the moon travel upon that, not exactly above your head where you think. The air makes you think they do exactly a little bit more than that. And it's above your head, it's a little bit of that smaller. That's all. They're just small as fuck. You can do that.
Why isn't the magnetic pole the center of the flat Earth? Wouldn't that be one thing you would need to consider? No?
We don't actually have the accurate center of the Earth mapped out. You didn't know that? Can you not accept that?
Yeah. No. I'm just a general speaking person because I'm into all models. But I've always asked the question like, why have we got a arbitrary point for the center of the flat Earth map when we should be using more the geomagnetic center?
Oh, I agree. Yeah, sorry. I don't agree with them. The maps are all distractions, and we were lied to about the Earth. So to think that we have a map is ridiculous.
Right. No. I don't like the map of the land. I was just gonna try to help, try to figure
That's
out.
why we gotta recreate it in the lab.
Well, we obviously can't do that with the globe, but we could do flat Earth. I've already thought about this though to scale, and then you have to answer the question of containment and then the layers within or how we perceive what it is, and that actually is not an easy feat. Yeah, but if you're going to integrate stars, it's going to get crazy.
Oh yeah, I guess I was just saying.
It's that I think that all these gases they keep separating from each other. I think it's all just the same thing, right? Floating in front of you, right? Fucking now that you're breathing, it's all air, and it's put into a container and then said to be something else, sold to something else by the middleman. That's how we get all of our shit. If you think about it, why else would they need a fucking container? That's me though. I mean, I don't know if you guys. I mean, that's I swear, 100%.
So once you put Antarctica in the middle and put the North on the outside.
I thought about that too. I've actually thought about both of them being in the center, and us just being stupid. Like half of the North Pole is on the left, and then the South Pole's on the right. They're both in the center. But you never know, man.
Yeah, mate. Yeah.
I thought about a lot of shit about 6 years, 7 years, whatever.
Good stuff.
Yeah, dude, we don't know where the center is, man. We can't even have like an accurate map. That's what that popped in my head in a freestyle. It's like, yo, they lied about the Earth. Like the Earth is flat. It's crazy. They ask him where the map is. Like, what are you talking about, bro? Or like, I'm trying to paint the bigger picture. They can see the background. I guess they need it mapped out. It's like, bro, you're asking a question doesn't have an answer, bro. Join the squad. We're trying to get to where we can find out the answer.
Oh, all right. So let me ask. So, like, distances, say, from somewhere like New York to Seattle, and then Seattle to Japan, and Japan to Korea, or even like a port on the East Coast to Germany, like those distances, and say like Germany to Afghanistan or Kuwait. You say those distances aren't known?
No, they're pointless. They're pointless distances. Know them all day. Thank you. We're glad you know them. They're pointless. I know the house across the street's across the street. I know its distance. It's still pointless.
Well, because those are flights I've been on.
So what? What is your point? They're pointless. What's your point?
Are those distances, are they known? Are they not?
Hold on a second.
That's a tricky question.
Yeah, if you jumped on a bird and flew around in the air, what would that prove to you? If the bird just took its path through the air, what would that prove to you, buddy?
Because right, like if I said to
Well, I'm asking you a
me
simple.
personally,
Hold on.
let me just clarify myself, right?
Yeah, I'm trying to clarify for
Me
you.
personally, if I was to say, making a map, what I would mean is the flights that anyone can take, like the ones that I talked about. Just making a map of those places and in relation to each other.
But we can't do that with Australia to South Africa or Australia to Santiago, because it doesn't go in a straight line. It just goes back down. It goes towards the pole and then up again, therefore making the length longer. I reckon it's shorter in a straight line.
Well, okay, yeah, we don't go in like the perfect straight, like we don't go in the perfect straight, most efficient paths, and we just kind of assume that we do. And I've deep dove into like verification of distances. Like, dude, there's all kinds of discrepancies with GPS. For example, like just someone that goes on a hike, like, or they ride their bike or whatever, they'll show you like, oh, GPS was off by 1.2 miles, or like it's crazy. You'll find all kinds of discrepancies. Now you're talking about like over vast bodies of water, like you like trying to get like accurate distances on a boat, damn near impossible. And we're talking about like in a plane. Well, we need to know the exact trajectory, which means we're kind of begging the question, because I mean we're talking about huge commercial planes, and they're taking whatever trajectory they say they're taking. But I'm not even to go too conspiratorial. Let's say that it's kind of like that. What way are we actually navigating? And then I would say that we are all within this like this flower of life magnetic field, basically. And so when we think we're going straight, we're actually not. We're kind of moving. We're kind of moving, and then you got to verify, of course, the speed that you go and the time. And what you find out is oftentimes flights they get there way quicker, like than they're supposed to, or like so they're way ahead of schedule, so they kind of like chill out a little bit towards the end. They always get there a little faster than they're supposed to. So yeah, I mean it's a more complicated question than just like, do we have those distances, right? I mean,
Of
actually, I
course
don't.
it is. Right. Civilian flights, they always, commercial flights, they're always going to take routes where they can divert, for emergencies, and other factors are involved. The flights I said before were military flights, right? So we weren't concerned. These were deployments I was going on to Korea and to Afghanistan and stuff. So we weren't concerned with worrying about people having medical emergencies and things like that. These were get there as fast as you can flights, right? And those distances from New York to Seattle, Seattle to Japan, Japan to Korea, along with a port on the East Coast to Germany, then to Kuwait and Afghanistan, even from Korea to Afghanistan. Right, when I mapped the time that those flights were when I took them, compared to, what the globe would say at an average airplane speed, they matched, right? They were within a range of reasonable values.
Yeah. So, well, those aren't really going to be huge differences on a flat Earth, though. The ones you're talking about. I mean, I guess I'm trying to think what the huge difference would be. Really, I'm not sure what I'm missing here, but I would of course have to actually see the path, and I would need to know all the details. I mean, if I were to just take your word that it matches the globe, well, it has a window of error for sure. And I don't know how you verified how fast the plane goes, but what I found out is planes don't just like go like a certain speed. Like they don't just go a speed that people think. And yeah, I don't know. I have to see the path. I would be surprised that there wasn't some discrepancy to the flight path itself that you don't know. Like I do like what you're saying. The military idea kind of adds more credence to the idea that it would be more of a straight shot. But I'm not even sure exactly what your discrepancy here is, because or what
Right.
you're asking.
I'm saying we could just take the overall idea I'm getting at is we could just take the continents and places that we can go to and We can take measurements of flight speeds and distances and time and things like that and make a map out of that.
Yeah. Yeah, I mean, but it's not going to be the map. It's going to be way more complicated than that, man. Like, it's not just like, oh, it took us this long to get here, so we know it's this far away. Like, that's not actually how flying planes works. It's much more nuanced than that.
I don't disagree, right?
Yeah.
That's why you take the flights and stuff and you get the data. But right, look, the military flights, like I said, we are going as fast as we could, the most direct route that we could. We weren't concerned about people having medical emergencies or going into restricted airspace and things like that. None of that was a concern for us. So it was get there as fast as you could, the most direct way you can.
Yeah.
Right. And so during those kind of processes, you can, get a relatively accurate value within a range of error.
Yeah, well, I mean, there is an error, and it's surprisingly more. Like, okay, say that we go from one side of the country to the next, or it's an area where it's like 2,500 miles. Everyone's like, we know that's 2,500 miles. No, we don't, man. And I'm not saying it's 3,900 miles of that area, that line. I'm saying it's maybe 2,300, and that's just in America, looking at different flight data, looking at different GPS data and discrepancies, and you'd be amazed how much there is. So when we're talking about a vast distance over the ocean, I know it's very hard to determine distance because it is over land, and it's certainly not going to be done in a boat. And so, yeah, you'd have to do something like military plane, and still, it's not in any way going to be perfect. And so, I'd have to know the specifics. To clarify, though, I do think that if you had all the data of all the like emergency military flights, you would obviously know much more. So, yeah, and then the biggest part is the central point, because like if you're going to lay all these land masses out based on a central point, you need to know where that is. Because now if you factor in a different central point and then you factor in these distance discrepancies, you can get a totally different layout of land, and we would never know it. And I mean, of course, in the idea that they lied about the Earth, that's how they would do it. They'd make it where you wouldn't know. Of course, some blatant things they couldn't help. I mean, they told you can't go to the center or the outside, so they had to do that.
Would you agree, right? If I was in a situation where, say, I'm a pilot and I'm told get there as fast as you can and you got no restrictions, basically, right? If I'm in that situation, I'm a pilot, right? Would you agree that on a globe, right, that route is going to be as close to a great circle route between the 2 points that you can get, right? If you want to get the fastest route, it would be as close as you can possibly get to a great circle route. Whereas on a flat plane, it would just be a straight line.
Wait, say the whole flights again. Say every stop.
No, just I'm a pilot. I'm told I got to get from point A to point B as fast as I can, and there's no restrictions. Just get there as fast as I can. If I'm on a globe and I want to plot that route, I want to figure out the fastest route, it's going to be as close to a great circle that I can get within the narrow margin, right? If I'm on a flat plane, it's going to be just as straight a path from point A to point B as I can get within an error margin.
Yeah, based on how close you get to the center and where planes fly, yeah. Well, overall, I understand the principle that you're saying.
Yeah. So I think that's that's where differences would arise, right? Because if you're on a flat plane, you're just trying to get there as quick as possible. You're just going to take a straight line, right? And it's going to be a different distance than if you're on a globe trying to do a great circle route. It's going to be a different. So, right, like if you plot a bunch of points and you have flights, right, and how the speed that they were going, either you can average it or get it at specific points of the flight, right? You can figure out the distance, because distance is speed over time, right? So you can plot how far relative points are from each other, and they're going to be different depending on if it's a globe or if it's a flat plane.
Yeah, I mean, you're going from Seattle to North Korea. I mean, not really so much, and
well,
that's just over the ocean.
It was like a 18-hour flight from Seattle to Japan, and then another 2.5 hours from Japan to South Korea.
So just northern hemisphere over water. Verification of distance would be, the difference would be trivial in the verification of distance. Just the fluctuation within. I mean, you're swimming in uncharted waters. That's my opinion. And also, I mean, you always have to factor in all kinds of things, right? Like condition that the plane was flying through. What were the conditions, and what was the elevation? What was the actual speed? But the path itself, yeah, like there are plenty of flight paths that clearly show like a straight line on a flat Earth, and they don't really make the most sense on the globe. Like I have quite a few of them saved. So this just requires hyper specificity. Like I like the idea of the military. Like if we could get the military flight data, we would really get somewhere. But like an entirety. But yeah, I don't know. I don't see the change being very big of a deal. From Seattle, North Korea, across the ocean, even like Seattle, Japan, North Korea, just right across the ocean, northern part of the Earth.
Well, these are thousands of miles, right? These aren't short distance. These are, basically as far as you can get without being on the east coast of America and flying across America and then to South Korea, right? They're in the Southeast Asia, or Southwest Asia, I guess. No, Southeast. My bad.
Well, you go.
It's not flying from New York to North Carolina. These are thousands of miles over the ocean.
Yeah, for sure. And I guarantee you, if the military flew that flight 100 times in a row, it would take different. Like if they flew that flight 100 times in a row, it would take different times every time. Like it would fluctuate from. It could fluctuate as much as like from 17 to 19 hours. Right. So it's like 16 to 19 hours, 16 to 20 hours. It's like. That's what's crazy about it.
17 to 19, maybe. But 16 to 20, definitely not. Right. Like,
more rare.
Yeah. These flights, when you're deploying in these situations, right, this is the U.S. military, right? We're not worried about airspace or medical emergencies, right? It's get there as fast as you can.
Jay, the point you're making about the straight path from one city to another is a point that flat earthers often make, or sometimes make, because if you're in your own reference frame, then you could, like if you were going from New York to Austin, then you would go, if Austin is turning west to east and you're in a different reference frame, you could take advantage of that and go like towards Florida. And by the time you got there, then Austin would be in front of you.
I
mean, the
just think
flight
a
paths would look totally
sphere,
different. We
like
wouldn't go in the.
a basketball and a table are two different geometries. And if you're flying on either of the two geometries, you're going to take different paths with different time intervals and things like that. And these are measurable things.
But the flight paths we have now aren't accurate with how you would fly if it was a spinning ball, because you would take advantage of the spin.
Right, and if the Earth isn't spinning, then the atmosphere is. Something is moving.
We're
So that just
getting
throws
into
everything
the
out.
weeds. Right. I'm just talking about the flight.
Yeah.
Well, these flight paths need to be represented on a shape that is pre-chosen. They're just points in space. You put them on any map and they'll work.
But
depending on
when you
yeah.
have a collection of them, though, as you gain more and more data points, they start to define the shape.
Yeah, there was also a Taboo Conspiracy put out a video where he said that one of his fans emailed him, and he worked for JetBlue or something like that. And he was saying that the flight paths that he actually takes are different than what they have him log in and log on to keep the globe paradigm seeming to work. That's what he said. So there may actually be some reworking of these paths that need to be documented as such. If we're talking about that kind of conspiracy, if that's actually existing, they may do that.
Yeah, most of the time the paths make more sense on a flat Earth, though, and I wouldn't be surprised if you went over Alaska, my man.
I can personally say, I was interested in seeing where we were and stuff. Right, we took off from Seattle and we went to the ocean within 5 minutes of the flight, and we were over the ocean. And once land came into view again, we landed very shortly after that. Within 30 minutes or so, we landed in Japan.
Yeah, but you had to take a nap. I mean, 18 hours, man. I mean, you would only pass Alaska on the side of it for just a second. You wouldn't even necessarily have to go right over it, but
I stayed awake. It's hard to sleep on a packed plane. It's difficult to sleep, especially when you don't know what you're about to get into.
yeah, I can imagine maybe you would have trouble sleeping, I guess, in that situation, but you wouldn't have to go literally over Alaska, like you could just go right beside it. Like you would go much closer to Alaska than you think, I bet.
Yeah, right. I'm saying from my window vantage point, we took off from Seattle. I could see the Seattle skyline, off to the side as we went over the ocean. And then there was no other land visible from the plane, from my viewpoint, until we got to right when land became visible again. We landed in Tokyo about 30 minutes after that. So, I mean, that doesn't mean we couldn't just out of sight of Alaska. It just, you couldn't see it from the plane.
Yep.
So why does every plane treat every runway the same, no matter which direction they're facing, if the globe is spinning independently of the plane?
what do you mean? Why would they have to treat runways differently?
Well, the Coriolis effect would be the Coriolis displacement that a north to south plane would experience, or if you're landing with the spin or against the spin, there might be a little bit of adjustment there. You'd think you might have to actually aim at a runway that's coming sideways at you if you're not in complete sync with the spinning Earth, which they don't even claim that you are. That Coriolis effect is something that it's like when the bullet flies and then the Earth turns under the bullet. That's going to happen to some degree with planes. No matter how much you want to claim that the winds are going to force it to match the tangential speed that it's flying over, it doesn't. You never claim that it's perfectly in sync. So there'd be a timing factor where the wheels could possibly break off if you didn't time it right. I mean, every time you come to a runway to land, it's right in front of you. It's not moving in respect to your plane whatsoever. Now that's only possible if it's completely stationary, or if there's something magical you come up with to answer that.
No, it's possible because pilots take either VFR, a visual approach, or an IFR, an instrument landing approach, and they line the plane up with the runway. What are you talking about?
Well, if the runway's moving east to west, right? Does the plane have to accelerate sideways to land on that runway?
The plane is also
You're cut out.
The plane's moving as well. The pilots are lining the plane up, either through the instrument landing system, which is the localizer and the glide slope, or they're doing it visually.
So have you gone through this argument before with the inertial and non-inertial reference frames?
Yes.
And it flies. It has a certain conserved speed when it starts. So you have to accept that it's moving sideways with the Earth if it takes off north to south, right? Because of conservation of momentum. But as it goes over many tangential speeds, if it flew many, many miles, it's not going to be in sync. It's not going to slow down and speed up to the new tangential speed with a greater circle or a lesser circle, right? It's not going to automatically be forced into that new tangential speed magically.
Of
So
course
it's going to have a difference of the land compared to the direction.
Pilots manage the energy state of the airplane. Right? It's a big thing they talk about. Right? Got to manage the energy state of the airplane. Right? So part of that, right? The airplane, we're not flying in a vacuum, right? We would agree.
Yeah, true.
Yeah. Would we agree that the atmosphere, the molecules consisting of the gases that make up the atmosphere, they have kinetic energy or velocity or momentum?
Do you mean wind?
No, the gas molecules like oxygen, nitrogen, carbon dioxide, water vapor, H2O, sulfates, things like that.
Yeah. They bond.
They move. They move with energy, with a velocity.
Oh, you mean, so what does that experience as?
What do you mean? They hit the airplane, or the airplane hits
the airplane. And what's the airplane? What kind of force is that? What would you call that on the airplane?
An exchange of momentum, right?
Momentum?
The airplane hits the gas molecules, or the gas molecules hit the airplane, and they exchange momentum.
Okay, so then east to west, the prevailing molecules is what you're saying? Because of the atmosphere moving with the Earth?
The plane, right? There's many things going on here, right? Pilots are steering the plane. They're lining it up with a runway, right? Via the glide slope or localizer or a visual approach. So they're lining the airplane up with the runway. It's also flying the atmosphere, where it's hitting atmospheric molecules, which have differing velocities, right? And these molecules in the airplane exchange momentum, right? So
they force the plane sideways.
interaction, the negative derivative of the potential energy is the time
Is
derivative
this a
of
wind?
momentum. So there's
This experience
exchange of
as a wind?
momentum.
Would you call it a wind? What would you call it?
I call it an
energy?
exchange of momentum between the
momentum
plane and the
forcing
atmospheric
the plane
molecule.
sideways to accelerate sideways to match the tangential speed. Is that what you're saying?
No, the plane flies, right? Hits gas molecules because it's not flying in a vacuum. The atmosphere is made of gas molecules. So the plane's flying through those gas molecules and it collides with them. During those collisions, momentum is exchanged. Also, on top of that, the pilot or the autopilot is lining the plane up with the runway. Right, it's keeping, while it's just in cruise, right, either the pilot or the autopilot is flying over a ground path. It's steering the plane over a path on the ground to get from point A to point B.
Right. And he might have to bank left, bank right to counteract winds, right? That can move in every direction.
You can experience winds.
And then compare those winds to the energy exchange you're talking about. Which was stronger?
Well, if you're experiencing wind, right, those atmospheric molecules in the reference frame you're in would have more velocity, right? Because that's why they're wind, because they're moving faster than just the static atmosphere in the background. That's why they're wind. So those would have more kinetic energy, right? So when they hit the plane or the plane hits them, the momentum exchange can be larger.
So if the winds are stronger, then why would you talk about the atmosphere moving the plane?
I never said anything of the sort.
I thought you said the molecules from the atmosphere, the gases, are exchanging momentum.
Yeah.
And that's the reason that it matches the tangential speed that it flies into, so it looks like the ground is stationary relative to the plane's motion.
Yeah, it's a factor of the reason, right? Also, when they're in just regular flight, they're just steering over a ground path via the autopilot or the pilot themselves. Then when they're coming up to the runway, they're using a VFR or an IFR to do the landing. They're steering the plane.
So my example with like New York to Austin, right? Since Austin is going to be spinning east to west, right? Then the plane could steer through those winds and make a different path to go to Austin that's going to be moving towards it, right? So instead of flying all the way to Austin, it could actually cut down in between Florida and Austin would be spinning towards it. It would take advantage of that spin, right?
I guess they're some people claim it's faster going one way compared to the other.
Well, it is.
But the whole thing is, right, if you cut the engines and just stop steering the plane, then, right, you're not going to keep the ground path you wanted to keep. Shut the autopilot off, cut the engine, and don't steer the plane at all, and you will deviate from the ground path. I promise you that.
Oh, really? That would be a good test, right? Why do you promise that? Have you known someone that's done that?
Yeah.
Really?
Yeah.
And they see the Earth moving below it?
No, I never
Sideways?
said that.
I thought you said you deviate.
Yes. You have a plotted ground path, right? So you cut the engines, stop steering the plane, shut the autopilot off. You won't just continue on your plotted ground path.
What's moving you then? Or is it the Earth moving below that's moving? So you're saying the plane's going straight like a missile, then, right?
Yep.
Yeah. So then the reason it would deviate is because the ground moved below the plane, right?
Oh, it would be, due to partially because of the wind, partially because of Coriolis, partially because of other things.
Right, but that would be an effective way of showing that the Earth is spinning independently of the plane's motion north to south, right? You could show that it moves east to west. You got like a camera that you zoomed in on, or several different cameras. You can do a test and show that the ground moves, irrespective of the plane's
But the
movement.
ground isn't going to be. The ground's not going to be moving. You're not leaving the Earth's atmosphere and watching it rotate. You're still in the atmosphere. You're just not going to continue on your plotted ground path. It's going to deviate.
Right. And if you used a star as a reference point and you were going in a straight line, then you could show that if you had a set course from one city to another, and you knew that if you went in a straight path, you were just focused on one star that you knew was going to be, at an angle to you every hour, 15 degrees, and you would keep your path, straight in respect to that star. Then you know that if you got to that city and the city was, 200 miles east of you or west of you, whichever direction you're headed, you could prove that the Earth moved irrespective of the plane.
I guess you'd have to really get your reference. You're saying get a reference to a star, right? And track your motion off of that.
Yeah, so that you're not using ground path at all. You go straight.
Okay. And so what are you saying would happen?
You would mimic a long distance missile over many tangential speeds. And since if you were started at like 1,000, like at the equator, and you went north, then you're flying into like lesser and lesser tangential speeds, right? And you're going to have a deviation based on that if the ground's actually moving, right? And you're going straight irrespective of the ground, then you would know how far off course you should be by the time you get to your destination based on the globe mass.
You're right to an extent. There's going to be other things you have to factor, just because there's an atmosphere and stuff like that. But I get the sentiment. To a degree, that's correct.
And if that is correct, then you could take advantage of that spin, because that right there would prove just the fact that that's able to be done. The plane could steer in any direction, especially like a jet that does like 1,000 miles per hour and has 40,000 pounds of thrust resistance and can hover in midair. It can do anything it wants, right? Fly into the jet stream, out of the jet stream. There's going to be a point where that ground is moving east to west underneath the plane when it's going north to south, and it could be shown decisively that the Earth actually spins.
Well,
if it has conserved speed and then it goes into a lesser tangential speed, you have to argue that the winds are causing the plane to automatically either slow down or speed up as it goes over the equator into lesser and more, if it went from like, South Pole to North Pole, then you should be able to have all of the readings show that the plane's going in a straight path, irrespective of the ground. It moves below the plane, and you can see that that's moving. And somehow you have to argue that the winds are making it. If it doesn't happen, then you have to argue that the winds, which move in all directions and are stronger than the atmosphere, are automatically causing this plane to slow down or speed up so that it seems as though the ground is stationary in respect to the plane's movement, which is always what we see. We never see any turning Earth underneath the plane.
Well,
it's always
there's two things to this. The thing that you would see, right, if you got the angle completely right compared to your initial acceleration of getting into the air and stuff before you cut the engines and stop steering. If you, which would be a monumental task if you were to get this angle correct, because there's wind, there's the atmosphere, right? And it's going to play a major factor at that point.
But just like
Right?
you can
So it's
follow a ground
almost
path and adjust for all
impossible.
those winds. Well, when you follow a ground path, you can stay on your ground path because you adjust for
Because
those
you're
winds, right?
steering.
Yeah,
You
but you're
stay
steering.
on the
No,
ground path
this is where you're
because
actually steering. You're steering in a straight path intentionally, irrespective of the ground, right?
you stay on a ground path because
No,
the autopilot or the pilot is steering the plane to keep
right.
it on that path.
That's what I'm saying. You could steer the plane in a straight path if you use the stars as a reference point instead of the ground. Then you'd know how many miles to your right or left that the city would have moved because you stayed in your straight path, just like a bullet. You'd be
Right.
mimicking
If
a
you're
bullet. You
steering
wouldn't.
the plane, though, you still have to take into account the distance that it would
Yeah,
rotate,
you would just
right?
mark that out.
Because
You
you're
would know how
keeping
much it rotates.
you're keeping a straight path, in reference to the star, and all of that is moving along with you, right?
Well, if you use the North Star, it would be stay in pretty much one spot. But yeah, you could use any star that keeps you in that reference frame or in that one angle that you started out at, like just in line with the runway that you started out from, and then you'd never deviate from that original path. Like say you could shine a laser beam that would be strong enough to hit the city from where you started, from north to south, right? And then you followed that laser beam to a degree, right? It's imaginary laser beam somehow that is your dead reckoning that you're gonna lock into, like duct tape on the steering wheel basically. And but you would have to actually adjust for winds to stay on that path, just like you would if you were following a ground path towards a certain city.
So you're saying we're shooting a laser beam from point A to point B, and we're going to just adjust for winds to try to
Whatever you
get
need
on
to
that path.
stay on that path.
Okay.
Even though
So
the
we're
city you're
allowed
aiming
to
the laser
adjust.
beam at, that path you're aiming the laser beam at initially will have moved 200 some miles, 300 some miles to your left or right, depending on which direction you're headed. It's going to be that much further away from you by the time you get there because you were aiming at where it originally was. That's the idea, at least. But the whole idea that the winds perfectly slow down or speed up the plane linearly, sideways at least, for it to be accelerated sideways perfectly, so that it always seems to be matching the new tangential speed when it had a different original conserved speed. That loss of conservation of momentum is something that doesn't really make sense with your flight paths and your model in general with when it comes to airplanes. It's an old argument. I'm sure you've been through it, but it's something that
I have.
still hasn't been accounted for on your side.
Right. It's all about, right, we can't make the leap from we have momentum at point A and we have different momentum at point B instantaneously, because that's not what's happening, right? These are infinitesimal steps along the way. If you want to go down to picosecond or down to, the Planck time, the momentum is changing at every instant along the way. So when you take the limit of the infinitesimal, right, that's how you would get the momentum exchanges.
Right. That's the way you calculate it so that it makes sense and that it doesn't have to be accounted for and no flight training.
It's not just how
All
you.
flight simulators use a stationary level Earth, right? All of them.
It's not just how you calculate it, right? When you're moving through the atmosphere, you're hitting molecules at every infinitesimal distance along the way.
Hey, Witsit, have you ever heard this molecule argument before? You still here? I don't know.
Well, I think a lot of Globers don't want to go into the specifics, right? I'm trying to go
They usually say
a
prevailing
level
wind.
deeper. Yeah,
Is that what they usually
what
say?
makes
Prevailing
up
wind?
the wind, right? It's really the gas molecules of the atmosphere are hitting the plane. The plane is
That's
hitting
only in one direction, though. So it might be. You might argue that it could help the plane move or accelerate sideways to match a tangential speed in one direction, but it's going in the same direction the opposite way. So you would think intuitively that it would actually speed the plane up instead of slow it down if it's moving with the direction of the plane's.
the front, the nose of the plane is hitting atmospheric molecules. All along the left side is hitting atmospheric molecules. That's how, the left and right wing, that's how they get lift. They force air molecules over the wing. So they're hitting the atmosphere, both sides of the plane plus the tail. It's all the entire plane is hitting the atmosphere at all times. Just like your body, atmospheric molecules are hitting you all parts of your body, except for the ones that are directly planted on the floor, right, where the gas molecules can't get into that tiny little
And you
space.
can't feel those molecules at all. It doesn't feel like a wind. It's just hitting you all the time. And it would move you if you were airborne, is what you're saying?
If you're traveling like an airplane with the mass of an airplane, yes.
And even though the winds are stronger in the opposite direction, it's still going to move you with the molecules.
The wind is different than the exchange of momentum that I'm talking about. There is an exchange of momentum with the wind, but we got to separate out these interactions if we want to try to measure variables and control variables. We got to distinguish between variables.
And this affects the plane's flight, right?
Yes.
And why is it that all flight simulators use a stationary level Earth?
Well, it's the same reason I teach students about the plum pudding model of the atom or the Bohr model of the atom, right? If you don't need to know all the specific details to accomplish the task at hand, you use the most simple representation to get the job done.
So are you saying that there'd be no difference in the flight simulator that uses a stationary level Earth and a flight that actually goes in the air and has to fly over a globe that's spinning?
Exactly, right. And there's no difference because the pilots are just steering the plane. They don't care about the air momentum changes happening with the plane. They just steer the plane, and the control surfaces of the plane are designed to be controlled within human limits, within human muscle operation limits. So it has zero effect on their ability to just steer the plane or the autopilot's ability to just steer the plane.
So your argument is that it's not because it's a more simple way to teach them. It's because there's absolutely no difference between flying over a globe that's spinning and flying over a level stationary Earth.
Yes, if they were in just a projectile that they couldn't steer and didn't have an engine, then Coriolis and all those other things would come into play. But with an airplane, you teach them how to fly the plane, how to steer it, how to operate the control surfaces, how to operate the thrust levers, how to perform the approaches, things like that. The necessities of the job you teach them.
So you're saying that they're not taught about Coriolis because that they have an engine and they don't need to know about it?
Well, I'm sure they are at some point, right? Like I posted before of Mentor Pilot, right? He has nothing to do with Flat Earth or Globe Earth. He has no stake in the game. And he explains how some of these effects happen in the, in the background and how they're utilized.
Have you ever considered Walter Bislin's site that talks about counting for Coriolis stuff? Have you looked at that?
I think a long time. I don't know what it says. So go ahead and inform me.
Well, it's a lot more drastic than you seem to be putting it. I don't have any proof that it is, but there's claims, that it would be a completely different situation flying in a simulator as opposed to flying over a spinning ball, and that you would have to time things, and you'd be a mess if you were trained on a flight simulator that assumes a stationary Earth and then going into an atmosphere that's moving with the Earth but not really, and then you're going to have to like time it because your plane is not going to always see and treat a land that's moving compared to a land that's stationary exactly the same. It's almost ludicrous to think it would.
Right. I didn't want to make a big fuss about it, but right. So the thing you're referring to, don't they make the other assumption that the mass of the plane isn't changing, or the weight of the plane isn't changing, right? They're making unrealistic assumptions because that's not. I don't think, right, that that's what actual simulators are built off of, right? That simplified model, right? Like if I went to Boeing and was like, "Hey, can you show me the code that was used to make this flight simulator?" Right? They're not going to show me this simplified thing that you're talking about, or do you think they would?
Well, yeah, that would be a completely different thing. I mean, like I said, you'd have to look into it and be objective to figure out if there would actually be a big difference. I understand the idea that they're following the ground path, and there's incremental Coriolis shift over long periods that it wouldn't make a difference. I can understand that argument, but if you're talking about inertial and non-inertial reference frames, there could be all kinds of issues that the globe kind of masks over by talking about prevailing winds and all of this kind of stuff. That's just I'll post this.
He's not talking about that, is he? That's the problem. You're talking past each other because you haven't defined yet what Coriolis is. If he knew what Coriolis was, he wouldn't be talking about like this.
All right. Well,
he doesn't know what Coriolis is. That's why.
I do have to go. At least another Glober can take.
No problem, man. Next time.
I was being too nice, huh?
Oh yeah, you did well, man. You didn't do bad.
Well,
have done better.
I wouldn't have done it like that. I'll leave you on this. I would applaud you to take 2 points, take the constraints or parameters of an airplane flight, and take 2 points, and actually calculate out the Coriolis force, right? What it should be, or whatever you're thinking it should be. Saying. Right?
Coriolis is an apparent deviation. There's nothing to account for.
Let me just finish the thought, right? I gotta go. Just finish the last thought, right? I would applaud you to take the parameters of a flight from point A to point B on the Earth as a globe, calculate out what the Coriolis would be, and then take the limit at infinitesimal steps, like what happens in reality. Airplanes don't teleport from A to B. They fly through infinitesimal distances at infinitesimal instances in time. So take that limit and see what the result would be. I would applaud you to do that.
The airplane doesn't need to travel for miles and miles. It just needs to be observed from a spinning platform, and the observer is spinning. looking at the apparent deviation when nothing is happening. The airplane is just going in a straight line. It's an apparent deviation. There's nothing to account for. It's the observer on the spinning platform that is observing an apparent deviation. The airplane is going in a straight line. It could be a hot air balloon. It could be a drone, a ball, anything. So no one accounts for these things. You can easily demonstrate this with a roundabout and a football and the observer. That's what you need.
Yep. It would be obvious. We would be able to prove it. We would know it for sure. There would be all kinds of different flight paths. I mean, if you invoke flight paths to support the globe, you're done for. I mean, it doesn't work.
It would be a disaster. Imagine you trying to land an airplane and the runway is running away from you or towards you or sideways or depending on where the location is. You would have to have all the airports and all the runways with the same geographical position in order not to have any deviations left to right or something like that.
Yep.
The Olympic Stadium is the same thing. Imagine you're going to do a high jump and the earth is spinning below you. I mean, it would be cheating, wouldn't it?
Yep.
Yeah, I mean, imagine throwing a ball on a merry-go-round going 1 revolution per day. It would be so hard to throw.
Well, that's why we suggest that's why we suggest hot air balloons or drones or things that stay longer in the air, like even an airplane that you can see its path for a longer period of time, still going straight, and you're still spinning, and you're still seeing more and more of the same effect. It's not like you see it once. Oh, there was an apparent deviation. Can I see it again? No, not anymore. No, yes, you do can see it over and over and over again. You just need to continue to be spinning, looking at the same thing. It could even be a tree. It doesn't have to be an airplane.
Yeah, and we're talking about the ground speed, not the rotational speed. We're talking about ground moving below a plane, starting with a different tangential speed, flying into more.
Zero, isn't it?
Yeah, it doesn't work. It really kills the globe. It's been a hard day for the globe. Have you heard this whole night? Man, it's been brutal, like absolutely brutal. Witsit really threw it down.
I wasn't till late last night for me. I mean, for me now it's morning. It's 10 a.m. But yeah, they were talking about pretty much the same thing. You know, the movement of Earth, Michelson-Morley experiments, blah blah. Yeah, we're still talking about the movement, the rotation of Earth. That's good, man. We need to talk more about it. We need to be all well spoken about these things.
Isn't that right, Gummy?
I mean, yeah, people need to learn about Coriolis. There's a lot of misconceptions about it.
There you go.
Yeah, a lot of people that get it wrong.
Okay, so we could agree that either the Earth or the space is moving, right, Dave?
Either? I mean, either or both or...
Well,
yeah, either one of...
The stars are moving or both, I guess, yeah.
Both, yeah.
Right, so
I would say nothing is static.
So if a plane is moving and has to make, like, wouldn't a plane have to make adjustments for either the Earth moving or the atmosphere?
Of course it does. It's called wind.
Well, either wind or the actual motion of either the ether or the Earth itself.
Huh.
So what I'm trying to say here,
if you don't account for being blown off course, then you're not going to get to your destination.
right?
It's quite simple.
But like the point that I'm trying to make is that any excuse that a glober has for why they don't need to account for Earth motion could be used for a flat earther when they say they don't need to account for the atmosphere in motion. So the whole thing, we don't need to account for it, therefore it doesn't exist, is kind of moot.
Yeah, I mean, we don't use it. I'm pretty sure we don't use the like that to change the flat Earth idea. Or what do you mean? I'm confused.
Well, this is more for Dave, because like if one of the two things is moving, then any excuse a glober puts forth for, you know, frames of reference, we would need to use that same excuse.
Yeah.
Right?
Sure.
I'm not sure I get what you're saying.
Okay, would you agree that the pendulum and the gyroscope both precess?
I wouldn't be. I haven't. I think there's something happening that is either mechanical or yeah, some kind of effect, yeah, of some sort. But a gyroscope is holding its rigidity in space, right? So that's making it move independently of the ground, right?
Right. So what I'm saying is that you can't really use we would see the motion of the Earth underneath the plane thing, because you just wouldn't see it.
If you're following a ground path, is what you're saying.
Yeah.
Yeah, but if you use the star as a reference point, like I was talking about, irrespective of the ground path, and made sure you were going straight in respect to that star and the angle to that star.
Can I just say something? What do you mean you wouldn't see it? If you are traveling over a surface and the surface is moving, either the surface is following you or you are going opposite to the surface. The surface is rotating one way and you are going the other way.
Right. But
you would notice. Yeah, you would see it. You would see it. Yeah, that's what I'm saying. You just need to turn around and then go to a different vector. Once you change vector, you would see if it's still following you or not. Or is it going sideways now?
Well, there's no way to know. And that's what I'm saying.
Well, if you were in the air, you would know.
I don't think you would, because you don't see it.
You don't see because it doesn't exist any movement. That's the thing.
No, but something is moving.
They've done it this many times already, man. Even for celestial navigation, not just celestial navigation, for any type of navigation, you need to consider the Earth to be flat and stationary. You know, I think we flat earthers, we are forcing too much the line. We are trying to reinvent the wheel, basically. Yeah. We are trying to see if the sea is actually level. Come on, it's in the name. It's sea level. Why we need to prove these things to the ballers? It's trying to reinvent the wheel. Why to talk about Coriolis if all the documentation tell us not to account for it? I mean, the pilots, it's everyone who navigates. You know, it's not enough to be in the Marines. You know, because if you're not the navigator, you wouldn't know. Yeah. So if you're a navigator, you must not account for it. It doesn't exist.
We both agree that sea level is level by definition, but you think level and horizontal are synonymous, while we know they're not.
Listen, sea level. You are stuck in the English dictionary. Yeah. If you go to other languages, they all mean the same thing: to conform to the shape of the Earth. Like a paddle with water, the water would conform to the shape of the ground. The Earth is not flat, it's what contains the waters within. It's the surface of the water that makes the flatness for the realm that we travel, we navigate, that we are in. We use sea level as a zero base. Anything above sea level, we measure elevation angles, and below sea level is depth. That's how we map the bottom of the oceans and everything else. That's how we need to know the height for bridges or depending on whatever is moving underneath it. If it needs to be curved or squared or whatever shape the architect decides to. We're just feeding the globers in this thing. There is the debate is over anyway. But I still have to come here.
How does sea level change from the globe model to the flat model? Isn't it just a point of reference of things above that point?
To have a level, you cannot have just one point. You need to have more than one point because level means no part's higher than the other. Yeah, so for you to have a level, something to be leveled, you cannot have just one point. The one point is the reference point, so you can level everything to that reference point.
Well,
but
in the globe model,
overall, to be level is one compared to the other. Yeah.
yeah, and in the globe model, that reference point is the center. Was under the impression.
The center. What do you mean? The center of a ball.
Yes, that's their reference point.
It can't be because it can't be.
Well, that's their reference point to take everything from there and run that all the way around. That's the impression that I'm under. Now,
Yeah, but
I
if the first point, if the first point is the center, what is the second point for us to reference to?
Well,
it needs to be on the same level, on the same reference, on the same height. From what?
The second point would be the surface of the water, and then you move along a little bit, and there's your third point.
Yeah, but that wouldn't be level, would it?
Which is also to reference to the center. That's what the model says.
I never thought the model would say that. The model that I've learned is it would depend. It will be measured from the surface of the water to the bottom of the ocean. Because regardless of the topography underneath, the water still needs to curve above it.
No, that's not that's not how they determine sea level or mean sea level. They don't take it to the bottom of the ocean, not at all. I don't know where you learnt that one. The bottom of the ocean has got nothing to do with anything in their model. That's just the bottom of the ocean. I stand to be corrected, but I don't think the bottom of the ocean has got anything to do with anything when it comes to the level.
Yeah, because they measure
even right in a flat model, the bottom of the ocean has nothing to do with level.
Maybe I didn't explain myself properly. When they establish the height or elevation from the sea, like the shore or a mountain or something like that, they start from that point.
Yeah, from mean sea level.
From the yeah. So the sea level will start at that point. That will be the first reference point. Mean sea level on this side, side of the shore. So the mean sea level is here, and then they'll assume that there is a bulge from that point, to the second point, which is on the opposite side of the beach, on the other shore. So they are saying that it's these 2 points that are leveled. Nothing to do with the center of the earth. So what they are saying, okay, this side of the shore, this point here, is at the same height or the same elevation as this other one miles across on the other side of the shore. So those 2 points, even though there is a bulge in the globe between them, they say it's level. Those are the 2 points that they're saying. Now we say that level is no part higher than the other, so you cannot have that bulge in the middle. You still have the 2 points, and none of them is higher than the other, so they need to be straight.
But I don't think they are saying that the point between A and B from one side of a lake to another side of the lake, I don't think they're saying that is level.
Well, they cannot say it's level, isn't it? Because their level is curved. They will say it's refraction, it's like bending. For whatever reason, you are seeing it straight, but it's not straight.
But I don't want to. I'm not the one to be fighting for their model. That would be a gummy.
Yeah,
a gummy point to jump
just
in
anyway,
and correct me. So the floor is yours, Gummy, if you want to correct me.
Sorry, I was doing some stuff, feeding my dog and stuff.
Oh,
I didn't listen to the full conversation.
Okay. I just totally just butchered your model.
Oh, that's even better, man. If you didn't have what I said, it's even better.
Don't worry, Banter. We're used to you butchering our model.
Well, that's all right.
I'm just kidding.
The point of contention was mean sea level, and I said that basically your reference point is the center of the Earth up to that point, right? And you're always referencing the center of the Earth to obtain that mean at sea level, or something like that, along those lines.
He's kind of, yeah, essentially.
Yeah. I told you I'd butcher it.
Yeah, but it can't be. That's the thing. It can't be from the center of the Earth. I know
Why
that you
can't
say
it
that's
be?
what they say, but because it can't be, man.
But
First of all,
just saying it can't be isn't very helpful. Why can't it be?
Yeah, if you let me explain, I will.
Okay.
First of all, there is no sea in the center of the Earth. First of all, so you cannot measure from there, from a place that there is no sea. Second of all, it's measured from the surface. So sea level or mean sea level is measured from, let's say, one side of the shore. Let's say you go to one continent, and you go to a beach, and you go to the side of the shore, and you say this is mean sea level height. Mark an X. Then you travel to the opposite side of the same body of water. Travel to the opposite side, again to the beach, you go to whatever you call mean sea level, and you do another cross. Now, your sea level is the union or a straight line connecting these 2 points from 2 sides of the shore with the bulge in the middle, which is the water, obviously. So that is your sea level. The surface of the sea having a bulge from point A to point B. That's your reference point, not from the center of the Earth.
Well, that would be if you're referencing one point to another on the surface. But if you're talking about mean sea level on its own, that is in reference to the center.
Oh, damn, I got it right.
There's a
No. Again.
Well, that is how the model is. I mean, I can't.
Level is on
no
a horizontal. Yeah, a level is on it has a specific vector. It goes on the horizontal. Yeah, and it doesn't go on the vertical. It doesn't go down to the center of anything. Yeah, level is very precise. Even though I was just explaining the globe version of sea level, because those 2 points on the flat Earth they are not higher to one another, because that's what level means. No part's higher than the other. So that's the sea level. Yeah, there is no bulge in between those 2 points. That's what level means.
So
No part higher than the other. And sea
yeah, but
level
so
means
there's
to
a
conform. Sea level means the water conform to the shape of the earth. It doesn't say sphere. You guys assume sphere because you assume shapes.
yeah, but the thing is, it is not a bulge of water necessarily. It only depends on how you view it. But if you look at the point to point, they are both the same distance from the center, and that is what makes them level.
How do you know they have the same distance from the center? Who reached the center to measure this?
You don't need to
How
go
can
to
you
the
know?
center.
How do you? So, but you are saying it's measured from the center. Who measures from the center? It's nonsensical. No one does that, man. Tell
It's
that to the kids,
related
please.
to the center.
No, man. Tell that to the kids. Don't tell this to me, to a grown man, please.
When we have a basketball, we don't need to go to the center to
Which
say that the
basketball we
surface
have? Why you need to bring a ball into this, man? We're talking about sea level.
is to show the ridiculousness of your argument. We don't need to get to the center to have something
Yeah, of
in
course not.
reference to
No
the
one measures
center.
from the center.
We can reference to the center without going to the center. The same way that we're never inside the center of a
Center of what?
basketball, but we can still
But center
refer
of
to
what?
the center of it.
Hold on a second. If I'm on the beach, I want the center of what?
The center of the earth.
How? I'm on the beach. How do I measure the center of the earth? Is there a center? Why are you assuming there is a center?
It's a measurable center.
That's why you're trying to bring your basketball in, isn't it? I'm on the ground. I'm on sea level, basically. Yeah, my feet are touching on the sea level. Yeah.
Okay.
So where do I measure this now?
Where do you measure your distance to the center?
Whatever you're talking about, I'm gonna try to establish it from the same level as the other side. So you say that now I need to measure both distances to the center. How do I do that?
So again, you don't measure to the center. You make a reference to the center. If you measure a curve implies
I'm not
a
measuring
center.
any curves. Wait. I'm not measuring any curves yet. Okay? I'm at sea level in one side of the shore. I've already been on the other side. And now you say that I need to reference the center. How do I do that?
So if you if you did a genuine measurement from one shore to the other shore, and they're far apart, then you will have measured a curve, and a curve implies a center of a sphere.
What do you mean I measure the curve? No, I haven't measured any curves yet.
Well, that would imply
I
that you
just
did
told
do
you.
the measurements. Yeah.
I just told you I have a mark for sea level in one side and I have a mark for sea level on the other side.
Yeah. Well, if that's all you have, then yeah. Right
And
now,
how do
you
I?
don't.
Now you say there is a curve in between. What I mean, how do you know there's a curve in between?
It's a measurable thing.
Is it?
Yeah.
1 point, 2 points. Shortest distance is a straight line, man. No curves.
Shortest distance in within like Euclidean space. Yeah, that's fine. So that's a
What do you mean
straight path.
Euclidean space? What do you mean Euclidean space?
Unobstructed, just point to point.
How do you know you're on a non-Euclidean space?
Unobstructed point to point. No, what do you mean unobstructed? It's water connecting these 2 points. Hello?
Yeah. No, Gummy Bear, how do you know that you're not on a Euclidean surface?
Let's go. Listen, Gummy Bear. Let's say that you put your bath running, yeah? And you're on your bath, you put 2 points. You mark 1 point here, you mark 1 point there. Yeah? Now, let's say that the water reached those 2 points equally. Now, you're telling me that there is a bulge between those 2 points, correct?
Yes.
Can you show us?
Yeah. Just cut a chord line and you got it.
What do you mean a quarter line?
From point to point.
Why do? Hold on a second. Why would I need a chord line? Wouldn't I need just a line? 2 points?
No, because
A line?
if you want a bulge, it'll have to be a
I don't
chord
want
line.
the bulge. You are the one who want the bulge and talking about the bulge. I don't want the bulge. I just want a line. I don't want a segment of a line. What are you talking about? 2 points I have. I mark the sea level in one side. I mark the sea level on the other side. I put a straight line connecting these 2 points. Yeah, just not touching the water, but nearly there. Just going parallel to the water surface. You telling me there is a bulge? Can you show the bulge?
If you're drawing this line so that it follows the surface of water,
I'm not
then
drawing. I'm not. No. I'm not drawing.
yeah.
No. I'm not drawing. I put the actual physical line from one side and on the other side. And I'll measure the height between that line and the surface of the water, and the line and the surface of the water again on the other side, and throughout the whole the whole lot. Yeah, I'll come on my boat. Yeah, and I'll measure the height from the line to the surface of the water, and we'll move on. We'll
What
make
is this
sure that
line?
line is going straight. It's a line, a physical line. Could be whatever material you like to.
Is there any material that doesn't bend under stress?
Well, it's not going to bend upwards, that's for sure. If it bends, it's downwards. If it bends, it's for my benefit, not for yours. Yeah. You will never have. Listen, that line will never bend upwards ever. If anything, it's the other way around. If you want to invoke way in the middle, it's gonna do banana shape. That will support me, not you. So why you support with the shape of the line?
So
You needed that line. You needed that line to be curving the other way, but he's not going to curve either way anyway.
So what I'm getting at is what's required for this thing that you're talking about is a perfectly rigid straight line that doesn't bend in any way, so that you can refer to it. That doesn't exist, and so you cannot refer to it
What do you
as
mean
a
it doesn't
physical
exist?
object.
What do you mean it doesn't exist? I'll refer you again to your bath. You have your 2 points with the water connecting these 2 points. Can you put a line? Yeah, from not the exactly 2 points. Let's say above these 2 points. Yeah, and can that line be equidistant from the surface of the water? Yes or no?
If the line is a straight line,
it's a line, man. What do you mean a
then
straight line? It's a line connecting 2 points. Yeah, obviously, it's going to be as straight as it can be.
so you know a line can be a curvilinear line. It doesn't have to be straight.
Did I say that? No. Did I say curvilinear line? I can have a line rolled in my pocket. That line is not straight. I was very precise. You have 2 points. You're going to connect them with a line, a physical line. You tie up in one side, yeah, and tie up on the other side, and then you adjust a little bit further up, a little bit further down, until you are happy. Yeah, they are equidistant from one another.
When you say a line, when you say a line, do you mean like a fishing line or like a that kind of thing? Or what do you mean by line? That
What
you're
is a
tying
line?
up?
What is a line?
To
We're
me,
talking
a
about the
line
drawings,
is
are we? We're talking about a physical thing. You have your bath, you have water, yeah, and you have you have your two points, your pencil marks on the level of the water, and now you have a line above, equidistant from the surface of the water, which is a straight line from one point to the other. You're still telling me that there is something else rather than a straight line?
Yes. It would be a very, very, very slightly curved line.
It would be slightly curved line. Can you explain that?
What do you mean? It wouldn't be a
So
perfectly straight line. It would be a
does it
very slightly curved line.
So when would that curve?
What do you mean? When would that curve? Curves all the way
Yeah,
along.
because
It just increases. The
what do you mean curves all
longer
the way
you
along?
take it, the more it increases. It's not like it doesn't bend until this point and now it starts bending.
But hold on a
It's
second.
a continuous slow bend.
We missed the whole point because it was what took us here. Would you agree with me that your bath with the water and the pencil marks on both sides and and the water and the a string connecting above the water, would you agree with me if I say that that is level?
Well, I would say that the water is level, irrelevant of the string. I would say that the string is just confusing you because there is no such thing as an infinitely taut string that is infinitely rigid. It will always have a slack, and that slack will confuse you.
No, you're not. Nothing is infinite, man.
That's
You
my
cannot show
point.
me.
That is
You
my
cannot
point.
show me something infinite because it would never be done, isn't it?
That's my point. You
You
require
cannot
an
show me an infinite line because the line, if it's infinite, it will never exist.
No, I'm saying that
It's never
for your
finished. So
experiment, you
a
require
line needs to be finite in order to have it. Yeah, point A, point B. If it's a straight line, yeah.
So Gummy, in this bathtub, or on this lake, whichever we want to use, and we have those 2 points, one on each shore or one on each side of the bathtub. And instead of pulling a line, we've just drawn a hypothetical straight line, so there's no way it can bend or curve or anything. It is perfectly straight, right? In every single direction. So now we have our straight line of reference, right? So now in this bathtub or in this lake, where we have our 2 points of level on either side of the bathtub or either side of the lake that are now connected by this perfectly straight line. So now what's going to happen? Because it's not going to reference the top of the water, is it?
Well, yeah. So what would happen if you were able to do such a line? What would happen is that it would enter through the surface of the water. So in the middle of the points, it would actually be below water.
So you're kind of cutting a cord.
Exactly. That is what's required if you connect on a globe, of course, within the globe model, if you connect 2 points on the surface and you draw a straight line, so not a geodesic or like the shortest line on the
Assuming
surface,
the globe again.
a straight line, then yes, by
it's a
definition,
globe.
that is what defines a chord. Yeah.
But that doesn't really adhere to the properties.
It needs to reify that globe all the time. We're just talking about level. I don't know why you brought up the globe.
So what you said, it doesn't adhere to what? Sorry.
Well, that might adhere to the properties of spherical geometry.
Let me ask you a question. Can I ask a question?
But it doesn't adhere to the properties and the characteristics of water in general.
Well,
Can I
the
ask a question to
characteristics of
Gummy?
water. Yeah, 1 second. Just the characteristic of water is that it will conform to the forces acting upon it. So it is definitely like adhering to the properties of water.
Can you show that this water has a curve in it and where it's been measured?
I
not the
can,
properties
but
we see.
I can, but not to your satisfaction.
Only maths.
So we can show where this water has been measured curved.
Yes. But again, I don't think it's to your satisfaction, but yes, it has been done. For example, for example is the one video that I've posted before, which is where they put a water level over 1 kilometer long with 3 points, and they saw that the point in the middle was higher than the 2 points on the sides.
Sorry. So that the middle point was higher. What did they use to see that?
Hey, what's?
Sorry, what, Benza?
Oh, I just said hello.
Optic.
Oh, so
you,
yeah,
hey
they
you.
used a an optical tool. What's the word?
Theodolite.
That's it.
Auto level. Total
Theodolite is the word.
station. Yeah. Okay. So, what is it made of? The optics within the auto level, or theodolite, or total station?
They should be used over 50 feet to 200 feet at the most, but they were used to view a full mile, I believe, which was a bit silly.
Okay, but do you guys know why it's, graded that way? That kind of tool is graded up to a certain range. Any tool, by the way, that the surveyors use is graded up to a certain range of usage.
Yeah.
Why is that?
Because nothing is limited. It's unlimited unless you use water. If you use water, you can rely as long as you have a long enough trench for the water to go all the way. Yeah, you can use water as a level. Not this tool.
Okay,
This tool has a limitation. Any of these
the
tools
tool
have
is
limitations.
fine.
Yeah,
Sure,
for a short distance. Yeah.
And the tool, okay, but that's my question. How come that we can actually see whatever we want to see within an optics, right? We can look at, I don't know, the farthest photograph we ever made was for, I don't know, 200 kilometers or something like that. But they claim that when you are trying to measure with this kind of method using an optical tool, you can only use it to a certain range. Now, why is that?
You should ask the manufacturer why is that? Because
because of optical
it's an optical
effects.
tool, you know? Yeah, if it's an optical tool, it needs to have limitation.
Very good. Optical effects, which are created by what, by the way? Do you Gummy Bear
Optics,
know?
no? Yeah, that's why if you don't want to rely on optics, you trust on water.
Well, I'm trying to ask Gummy because
That's
he
how
was bringing
that's
in.
were done.
Hold on. Yeah, hold on. Let Watson Gummy have a little backward.
Yeah,
I mean,
I'm trying
so
to
there
ask
would
Gummy
be
about
yeah,
this
there
because
would be
you
two
brought in the
effects.
idea of using this kind of device, right? But this kind of device has a certain range. I'm asking you, do you know why it has a certain range of usage?
Why it has a certain range?
There
No,
is a maximum
you can
range
tell me.
for
I have
which you can only measure so far with that device.
no idea that there was a maximum range.
Yeah, there is. Especially for an
Okay.
auto level, it's very close, by the way. For an auto level, it's supposedly about, and it's even written like that, about 80 meters. So most of surveyors who are using an auto level, they are using it only up to a distance of like 60 meters, by the way. So when they are using their measuring rods, you know, that huge long sticks with the measurements on it, they only put it apart from the auto level at a maximum of 60 meters. Now that's a very short range, right? Why do they do that? Why can't you just put the measuring rod up to like, I don't know, a kilometer when it would still be visible within the auto level? Why don't they do that then?
I don't know. You tell me.
Well, it's obviously because of the optical illusions that are introduced because of the air and the thickness of the atmosphere or the air, however you want to describe it, which is, created by the density of the air, and the density is supposedly based on the temperature and, stuff like that. So the basic answer is because optical illusions created by nature itself. Every time, anytime, wherever you are.
Okay.
But that means that if you have an auto level in which you are looking into and you see that from the auto level's middle horizontal line, the object that you are watching is below that horizontal line, that doesn't mean that that object is actually below that horizontal line. It just means that it looks like that.
Hello.
Oops.
See, that's the problem. That's the problem with that kind of method. I have been telling this to people that you cannot use any optical device. It can be a surveyor's equipment, auto station, auto level, camera, whatever, because every camera, every optical device has a curved lens, for example. That's already distorting everything. And then you have the
I'm glad you're
atmosphere
telling
also
people.
distorting. And then you have the atmosphere also distorting everything. So it's at least two distortions that we know about.
So what you're saying is surveyors should never use theodolites and auto levels and optical tools.
Oh my god.
Is
I
essentially what you're
said
saying.
there is a
Your mum's not your
range
mum,
for
mate.
those. ranged for those devices. That's what I said.
Oh,
The
there's
first
there's a
5
again
times, right?
there's a maximum range, so they work to that
There's a
range, and as
maximum
long
range.
as
Yeah.
they work to that range, and as soon as you go an inch beyond it, it stops
Oh, for
working.
fuck's sake! Stop being a dick. Seriously.
By the way, yes, nobody uses the auto level up or over a distance of like 60 meters. Yeah.
Okay.
Not an inch more. Okay.
So it
Let me
stops
rephrase it.
working
Not
after an
more.
inch more.
No, it
Yeah,
doesn't
it turns
stop
off.
working. No.
Not accurate anymore.
Yeah,
It's
not
are you
like
for
that.
real?
You cannot use it for measurements. You cannot use it for the same measurements that you can for within 60 meters. Got it?
Okay.
Well,
Okay.
if your job is relying on accuracy, you'd want to work within the accuracies of the tools that you are given. You'd agree with
Oh
that,
yeah.
wouldn't you, Gummy? Okay,
But
then. So then,
Banso, wouldn't you agree? Just to clarify, wouldn't you agree that there is no such thing as a maximum of it will work up to this distance and then it no longer works? It is rather an
do you mean by work?
incremental. Let me finish. An incremental thing where the further you use it, the more error you accumulate. And there's never such a thing as a maximum. It is simply
that's
if
not
you
accurate.
use it very
there
far,
is.
you get very
There is.
high degree of error. That is the only
There is
difference.
maximum. That's what I'm telling. And it's not me who is telling you that
There's
there
no
is a
such thing as a maximum.
Look
Oh,
up
for
any
fuck's
auto
sake.
levels range. Do you want me to
What's up?
screenshot one?
Yeah, there's no such
Listen,
thing as a
Gummy, it's the
maximum.
same. It's the same as you having a ruler with 30 centimeters trying to measure something that is over a meter long.
Yeah,
and
There's
we
no.
can
It's the
happily,
same thing.
and we can happily do that to a reasonable degree of accuracy, unless you need it down to the tenth of a millimeter.
No, you can't.
Come on, mate.
These tools are made with very specific tolerances in them to give you accuracy, right?
Yeah.
Now, once you
To give
start
you known accuracy.
hold on, I hadn't finished, right? So once you start using them beyond, right, their recommendation, they can't guarantee what the inaccuracy will be at all, right? So you don't use them beyond that.
I think it depends on the instrument, to be fair, Andy.
If you do use them
No.
beyond that, if you use them beyond what they are recommended to be used beyond, right? If you're a surveyor and you use your tool beyond what it is recommended and something goes pear-shaped, your ass will be grass. You'll be sued if something goes wrong because you have not used your tools, right, correctly. That's what will happen. And they don't do it because they don't want these things to happen.
So here's the thing. So
yeah, you need to
first
do a
of
mark
all,
at 60 and then you continue from there.
Okay, so first of all, what Sub has been talking about for the last little bit has been an auto level. When I specifically said that they use a theodolite.
Yeah.
Now
Doesn't
the difference.
matter, same shit.
Let me finish. Let me finish.
Okay.
Come on.
Let him finish. Let him finish.
The difference is a theodolite is not going to have an error where it says, it's going to be off by 500 meters. No, it's
you're
off
right
by
on
an
that,
angle measurement, and an angle measurement that will be off by about 3 arc seconds over 1 kilometer. That's just a couple millimeters. And yet
me
the
ask you a
measurement
simple
we
question
see
then.
isn't within a few millimeters. It's within many centimeters. It is beyond
I
the
get that.
error margin.
Yeah.
He's
No
desperate,
problem.
isn't he?
Simple question. Simple question. If I would light a light on your window when you are inside the building and I am outside of the building and you cannot see me because I am far away, actually from the building itself, but I am shining a light on your window, and you would use a theodolite to measure your supposed angle from whatever, from the horizontal, let's say, and you would measure the angle to that light on your window, would that tell you the location of
Well,
the source
again,
of that
you
light?
don't use a theodolite inside a building
I'm
through a
asking Gummy
window.
Bear. Sorry, I'm asking Gummy Bear.
Yeah, I know that,
Yeah,
but we can all
Dross, come
take
on.
part in.
I have the exact same response as Foolish.
Thank you. Go on, Gummy. You do it. You know where we're going on this one, mate.
Okay.
Well, no, but you pretty much got it all out. You don't use a theodolite from inside a window or inside a building.
Looking
He's
for a
trying
window.
to say that
argument.
he's
But
trying
if
to
we
say
just
he's trying to say let me go on one second. He's trying to say that all the lights that we see, everything that's illuminated around us, is not where it actually is, because it's just like that light being shone on the window. We're pointing our theodolite at where we see the light on the window, not where the source of the light is. That
Yeah.
is the stupidity of the argument he's trying to make.
Buddy, we just
saying
established
refraction
that
doesn't
there are
exist.
two things.
Good on,
No, I
Russ.
didn't say that at all.
There are
Yep, you just
two
did.
things.
No, I didn't.
Oh my fuck. There are two things that, at least those two things that tell us that we do not ever see, especially over a very long distance, the actual physical thing. All we see is the optical illusion of it. Nothing else.
Okay.
That's what you're
Now
measuring with the theodolite, the optical illusion.
Okay.
That's
Now
fucked
how
up.
far off? How far off is this optical
How could I
illusion
know?
from its actual position?
How
So
could
you have
know if
zero.
you did not
So you
measure?
have
How could you
zero
know
clue. You have
if you
zero
did not?
clue
No,
of how
I'm
far off
saying
it
no
is.
one can know. No one can know
Okay.
because you didn't measure the temperature in between you and the distant object. You didn't measure the density of the air. You didn't do any measurements regarding how the optical
So
illusion
what he's
differs
basically
the
saying.
physical from the optical illusion that you actually see.
So
You
what he's
didn't measure
basically
it. You
saying is that
cannot know.
a theodolite working within its tolerance levels, within the recommended ranges that it can be used at, is a worthless
it's not half
instrument.
a kilometre.
According, actually, you can get them going out to about 500 meters, 1,000 meters, no probs. 1,000 meters.
Yeah, you can
is
daisy
over half.
chain.
Over
It's
half, and
accurate within
you
a
can
few
use a
arc
middle
seconds over a
station.
kilometre.
I almost get a fucking point out. So the problem I've
Go
got
on.
with that is just using it within the levels of tolerance that we need to use according to WhatsApp, because an inch outside that and everything is gone. So just using
That's
it
what I
within
said.
within those standards, we can
Let's
actually
just finish
I can
talking
actually
bullshit.
show that
Stop the lying,
plumb
please.
lines are not
It's
parallel to
pathetic
each other.
as fuck.
Let him finish. Please. Let Trust finish.
Well, that's it. I'm just saying, using an instrument like a theodolite within its tolerance levels in a middle station, 3 points of observation, we can show that plumb lines are not parallel.
What's his tolerance level, Joss? Quick.
About 3 arc seconds, and you measure.
No, distance. Optical distance. What's that?
I think the last set of recordings I saw for that were over about 1,200 feet.
If we do know that over a long distance all we see is an optical illusion, then we cannot use anything to determine that distant object. You cannot. You
So
have to
what
go
if-
closer. That's it. Okay.
Even though we know it's an optical illusion, we can still know by what's the word? Sorry, the
refractive index. That's how it's called. And
No,
the
it's not
refractive
one.
index is based upon the radius of the Earth.
Okay,
That's
that's
the
not what I
fuck
was
up
gonna
altogether,
say.
by the way.
I was gonna say, even though we don't know necessarily the exact deviation, we can have a good rough estimate of how much it would
From
be.
what? From what? Based on what?
On a
Based
ball,
on
of course.
observations, previous observations of known distances.
But the known distances were established with the
On a
auto
ball.
level with the 60-meter distance measurements. Don't you get it?
No. You don't.
Yes.
We didn't establish the known distances using a theodolite so that we then can calibrate the
auto
theodolite
level.
with that distance or auto level. Whatever.
I said
That's not how
the
things work.
distances were established with the auto level with the range of the use of 60 meters or 80 maybe at the very maximum. Someone has used for 80
What about a
meters, maybe.
theodolite?
Oh
A theodolite only measures an angle.
Exactly. Which is all we're using in this experiment. Like I said, within this experiment I was referring to, they used a theodolite. Yet you refer
let me
back to an
rephrase
auto
it.
level every time.
Well, that's
How does it establish the angle, boys?
Theodolite only tells you an angle to what you see, but if you know that what you see is an optical illusion, then you are measuring a fucking optical illusion and nothing else.
And
Do you
why do
get that?
theodolites have
Circle jerking yourselves.
Why does a theodolite have a much longer range than an auto level then? Can you explain that to me, what's up?
Sure, because they are usually used up to the fucking sky, through which there is way less atmosphere and density of
theodolite's used
atmosphere.
for
Then let
leveling.
me fucking finish if you ask me a fucking question, man. What's wrong with you? So there
Well,
is
because
way
they're
less
not used up.
dense
So I'm
air,
disagreeing. They're not
way
pointed up
less
at the sky.
dense air, way less dense air when you are looking upwards from your point than if you would look horizontally or close to horizontally throughout.
Which is what you
the
use a
length.
theodolite for, close to horizontal.
And that means that there is way less optical
No, because you're
illusion
using it on the
introduced.
horizontal plane. You're not using it in the vertical plane. Can't you see he's just absolutely changing the argument? He's trying to say that you point. He's trying to say you
You're not
point a
letting
lot
him
to
explain.
You gotta let him.
Vertical
You gotta
plane.
let him finish. You gotta let him finish, and then after he's finished, then if you feel like he needs correcting, then correct him. But you can't correct him halfway through he's saying something. It's not going to work.
But there are no planes, and I wasn't talking about vertical and horizontal planes at all. I was just saying that the theodolites have a little bit longer range than an auto level, because it's usually used up to look at something upwards, like in between 60 or and 90 degrees. That's why. But you are measuring something that is an optical illusion. Don't you get that? When you are measuring a far distant object, let's say 2
We're not
kilometers
talking about
away.
far distant objects, though. We're talking about objects over, say, 1,000 feet, 1,500 feet.
How much is that in meters? I don't know.
How much is that meters divided by 3.3?
500 meters. Kind
3
of.
to 500 meters.
You're not doing a single
like
shot of
300.
500 meters with a theodolite, Truss. That's a lie.
But again, all you are measuring is an angle. What do you get from an angle?
Were you not here when I explained the actual thing that started this conversation?
Again,
I know you were, because you were the one who brought up the argument against it.
Again, what do you have when you have an angle?
So
an angle.
Like
okay,
I
that's the
said,
answer. Nothing else. Nothing
so
else.
like
You
I
have an
said,
angle.
what we have established a horizontal between the two endpoints.
But
that is
how?
what we have.
That's,
by lining
for
up.
that, we use an auto level within the range of the auto level, which is 60 or 8, let's say 80 meters, not 300.
No.
Do you get that?
We used. Would you like me to describe the experiment from the setup? Because you clearly don't seem to get
You
what
don't
it
have to.
actually
We
is
already
doing.
gone through that, and I'm saying to you that when you say that you are using a theodolite, okay, no problem. But when you are adding that you have established a horizontal level, now for that you cannot use a theodolite over that kind of distance.
Okay. Well, that
Do
is
you get that?
what you just said just now shows why you don't understand what the experiment is about. The theodolite
No, you don't
isn't.
understand that for measuring from
Are you
a
gonna let me
horizontal
finish
line,
my
you are
segment?
using
No?
an
Okay.
auto level.
You
You're
gotta-
using an auto level.
The thing is, yeah, go ahead.
Go,
Brad.
Gummy. Go, Gummy.
So the thing is, you're not establishing the horizontal purely by theodolite within this experiment. You're doing so using a water level and a theodolite. Do you see the difference here?
No. That wasn't even what you said in the first place. What you said is that you had a water level and you had 3 points on that water level, and you looked into an optical device and you established that the middle point is a little bit higher or lower. I don't care which one.
Exactly.
Exactly.
That's what you
and
said.
what that means is that we've established a horizontal between A and C using a
With what?
water level and a theodolite.
Again,
Oh,
you
dear.
cannot establish a horizontal line through an optical device that is called a theodolite. You can only establish a horizontal line with a device called auto level.
Once again, we're not using only a theodolite. We're using a theodolite and a water level Do you understand how a water level establishes a horizontal?
Yeah, but you said that water is curved.
Oh, no, sorry. No. The auto level does not tell you by looking at it that it's horizontal. It's an arbitrary thing in your head once you set it up right, by the way, that it should be a horizontal line. But it doesn't show you in the theodolite that. Do you get that?
You keep skirting past the point. We're not talking about purely a theodolite on its own. We are not doing that. We are talking about a theodolite and a water level.
Again, the theodolite, when you are measuring the deviance of that middle point with a theodolite, then what did you use for the theodolite to measure the deviance from?
So we established the horizontal between the two endpoints of the water level. We line up the theodolite between these 2 points and see by how much the middle point is off.
How do you line up the theodolite in between the 2 points?
A kilometer apart.
Optically, the way you use a theodolite. What do you mean? How?
That's what I'm saying. Dear. If you are doing that, if you are doing it optically, then you should also optically establish the horizontal line, not just with the water level, but also optically. And for that, you need an auto level. That's what I've been saying for the past 10 minutes. It's you who doesn't understand me at all. Do you realize
So
that?
what you're claiming is that you cannot establish a horizontal using a water level?
Not optically.
Okay. Well then, if you don't know how a water level works, I think we're done here.
No, don't change what he's saying.
That's it.
He
That's
said
it.
not optically.
That's your best argument. You don't know. You don't know. That's it. That's your best argument, right? Okay.
It's a fucking joke. Pisses me off.
If you use a water level, how do you use it? Can you explain how you use a water level?
There's markings on the fucking pipe, mate. When the water's
For
at the same level as the other end, it's at the same mark. Jesus, have you used one ever in your life? You don't need to look from one to the other end. Jesus Christ.
It's not used like that, by the way, Gummy Bear. That's what I'm trying to tell you. The water level in itself, it's not used for optical measurements. It's used for establishing a level, obviously, but it's only used in a way that you do not look at it. You know, it's not for that, for looking at it.
But do you agree that by virtue of having the water level, you have established a level and a horizontal, right?
Not optically, you haven't established.
No, I'm not talking about optically
horizontal.
right now. I'm talking the fact that you have a water level means you have established a level and a horizontal. Correct or not correct?
Obviously.
We created 2 points.
Okay.
So
we have
your next
established.
point is gonna be the same as it was before 5 minutes ago, and I'm gonna say the same as I did 5 minutes ago. What's your point?
Yeah, it's a
So we
circle
have
jerk.
established a horizontal and a level, and now we line up the theodolite between the start point and the end point along this horizontal, and we see that the middle point is off. Once again,
you can't do that.
I mean,
why
So you line it up.
you
line it up.
Can I
by
just
looking
interject
at
quickly,
something
Gummy?
Yeah,
in the
of course.
distance.
Yeah, sure.
That we established already. That
Clear
in the
morph.
distance,
A
all you
circle
see
jerk is where
optical
everybody
illusion.
agrees with each other, and it's an echo chamber. Not what we're doing here. This is a circle jerk. Can't involve disagreement. Just because you're looking silly. Just thought I'd help you out.
No, a circle jerk is where someone's jerking
foolish.
someone
This
off,
is
and the
not
other
a
people are
disagreement.
trying to correct it.
No, that's not
Foolish.
what
This
that
is not a
means.
disagreement. The guy is using an optical device for one thing to measure, and then just claiming that the water level is also an optical device and can be used within the
No,
other
it's not.
device. It cannot. It cannot.
No, it's the same way as I can use a spirit level to establish a horizontal, and then I can use a laser to establish a horizontal. Both are co-witnessing each other, so one can calibrate the other.
Over a kilometer.
No, but at each point we can. So we can use the level of the theodolite, make sure it's aligned to the level at that point of the water measure, And you can actually see that. So it's a co-witnessing thing. So the thing I wanted to bring up to WhatsApp, what do you think of the instrument that I've just put all the details into the chat for? So this is by a company called
Photo
Sokia.
station, I guess. Right?
No, it's
it
not. It's a
didn't.
laser theodolite with a 600-meter range.
Cool. So
So
what can you use
it's measuring.
for?
Well, we can measure whether plumb lines are parallel to each other over that range. Then.
Okay, cool. But what is it actually saying in the manual that this device can do, and the range is for within this
600
device?
meters.
No. I'm asking what that range is for. Do you understand me?
Yes, I do. I will go and find out from the operator's manual, which I kindly posted for you to have a look at, so you could answer your own questions.
100% sure, almost 100% sure that it's gonna say that it's for angle measurements. It's gonna be 600 meters, the range of it. Since it's a fucking theodolite, by the way.
Yeah, and if I can do an angle measurement accurately over 600 meters, then I can measure deviation from plumb between two fucking points, can't I?
Okay, then I'm gonna rephrase altogether what I said before, because it seems like you are just trying. You're not. I'm not being too clear. Okay, let's phrase it that way. I'm not being too clear. So when you are measuring an angle, all you have is the angle itself, and then when you are claiming that that angle could be used for any measurements regarding anything else than the angle
is a
itself,
measurement.
But that's what I'm saying. That for using that, it's okay. But when you know that when you look into the far, you have different distortions due to the camera lens, or the laser digital theodolites lens due to that, and then for because of the atmosphere also, then you are just measuring something that is an optical illusion, and that's it.
But why are they saying it's got the ability to measure angles up to 600 meters then?
You're using the
if they're not taking that
incorrectly
into
for
account.
something that it wasn't even created for.
No, according to this, I'm using it to manufacturer's specifications, which is what someone bought out earlier. So, and that's exactly what theodolites do. They measure horizontal and vertical angles. I'm cool with that.
And horizontally, they recommend them between 40 and 120 meters.
What do you mean they measure horizontal and vertical angles? And what? What does that mean?
So
they have angles, okay?
Yes, because you can use it to measure it from a site post A to a site post B to get an angle between those two site posts from point A.
You finish circle jerk and dross or what? You want to get yourself a curtain?
And they say like horizontally, a working distance of anywhere between 40 to 120 meters maximum. That's horizontally.
Oh, there you go, Dross. Jeez. Thanks for posting that manual.
120. So I was wrong, by the way. I'm gonna admit that I was wrong with the maximum 80 meters, because we can show at least one device that is up to 120 meters.
That's not for auto level.
This one I'm looking at is a theodolite, and it says a maximum of 120 meters horizontally. Okay.
Yeah, and that would be with certain climate conditions.
Gummy Bear and Foolish is in full in their rights to ponder me or whatever they want to do, because I wasn't right about the exact range. I said up to a maximum 80 meters, but it's actually not 80 meters. It's way much more. It's 120.
Beautiful.
Yeah.
Well conceded. Now, Dross and Gummy, are you going to concede as well?
Which is still way shorter than a kilometer.
Well, so he conceded, which means we won, and now we end it here.
What I found funny was Gummy Bear to bring
the cheap win.
Gummy Bear to bring the water level. I found that funny. He brings the water level to establish his horizontal, but then he says that water is not horizontal. Oh man!
So you don't understand how you can establish a horizontal with something that's level?
Yeah, you don't. You don't.
Okay. So
Yeah.
your argument
That's
is
what
you
listen.
don't. You don't.
Water level is what we use for long distances. You know, that's how we use drains. You know, for long distance. That's what we use. Water.
So okay. So
These
do
guys are
you
funny.
realize that if you pick two
Uh-oh.
points on a level curve, they will establish a horizontal with respect to the middle of those 2 points?
Of
Do you
course, but
understand
that's the
this?
only point. That's the only reference
Exactly.
point that there's a horizontal. Nothing to do
So
with the
we
two endpoints.
have established a horizontal, which is what George just said that you couldn't do. So think you're agreeing with me and agreeing that George was wrong. Thank you.
What's that? I missed that. I missed that.
On a
Can you say
ball,
that again?
you have a horizontal between two equal altitude points at point C in the middle, if that's in the middle. That's the only horizontal point with which this line is truly horizontal. At no other point along the surface of that curved surface is that line going to be horizontal.
That's fine.
So points A and B, which are the fucking important ones, it is not a horizontal line, is it? It would be angled down.
Is a
At that point,
We
this
have
becomes a
established a
conundrum to them. By the way, this is a conundrum to them at right that point. Flowmorph, yeah, you were very right about that, because it becomes again a conundrum when you think about it that way. That there are different horizontal lines, but you are always measuring the same. When you are having a closer object and a way farther object, those are still the same horizontals. No, they are not. How could they be if the surface is curving?
Exactly.
That's why we say it's horizontal with respect to a position.
I know, it's all about
no, you are
reference
measuring it
frames
from your
with you guys.
position. You are measuring it from your position. Your position is the same.
Not
The
a
distance
reference
to
frame.
the object that you are measuring to that horizontal is changing, but then the horizontal's angle are changing every time that you are measuring it. That's a conundrum. Don't you get it?
We don't measure to a moving object to establish horizontals. What are you on about?
Yeah, that's what you did. You said that you had 3 points on your water level. You had the first where you are standing, you have a second one, and you had a third one. You are measuring to the
They're all
third one at first, and
they're
then
all
you are measuring the
stationary.
middle one. Then you are measuring it to the middle one.
No, incorrect.
That's what you did.
No,
That's what you
incorrect.
said you did.
Incorrect. Would you like me to explain it again so you can get it right this time?
So you didn't measure
No, because
to
you're
the middle
still
one.
optically looking over 500 meters to try and verify this point C. And clearly the device can only go to 120 meters. So,
Yeah,
you know,
because anything
you're already
beyond
way
that,
out of whack.
anything beyond that, of course, just stops working. It just doesn't work anymore. It's not like
it
the
disintegrates.
error.
No, exactly. It dissolves.
Exactly. It's not like it's an error
It
rate.
gets less accurate and you can't rely upon it. That's why.
It's not like it's an error rate that is knowable. It's not like that. It just stops working. It's just poof.
Oh, so you just apply maths, do you, after that and go, based on curvature, it's about here.
So
and a refractive index,
so
and
if we
etc.
say,
etc.
If someone tells me, don't use this theodolite over 1 kilometer because your error margin is going to be over 1 whole centimeter, and it's like, okay, that's fine, but when I used it, I got a result that showed a deviation of many centimeters, tens of centimeters.
When you are using
And
the
so,
theodolite,
let me
your
finish.
error cannot
Let
be a
me
centimeter
finish.
because you are measuring angles.
Let him finish. Let him finish, and then
It's not
correct.
centimeter.
And so,
Okay.
even if you would recommend me not to use it over a kilometer, the error margin is still way lower than the result I got. And I can still be sure of the result I
And
got.
yet you couldn't do anything practical with that unless you could verify the error margin. Now, please tell me how you would verify the error margin over a kilometer.
By using it, or what do you mean? By how do you verify the error margin? Do you know what makes up
how do you
the
know
error
you're
margin?
out?
Do you know
How do you know you're
what
out? How
makes
much
up-
you're out by?
Yeah.
Let him answer. Let him answer. Let him answer.
He's not. He's not answering.
So by knowing what makes up the error rate, what causes the error, you can then use deductive logic to know what would happen at a different distance.
Please
Do you
describe
understand?
that.
So not a
That's what I'm
measurement then.
interested in. Please
So not a
describe
Not a
that.
measurement,
measurement,
just a guess.
calculation. Thanks.
So any time that you use a theodolite in a sort of distance less than 120 meters, how are you validating the error margin of that instrument, Planamorph?
You're relying on the manufacturer's calibration of it and the use of that tool within its design, i.e., the humidity level and etc. temperatures.
And is that given as an absolute value at there, or is that given as an error margin between 2 points?
Well, look at the manual.
I'm just asking you. You seem to be an expert on this.
An expert? You're the expert, Just shit.
No, I'm not.
It does with even
Apparently,
within the
you can use
100
them
or
for 500 meters.
600.
Even within the 100 or the 120 meters, you have, by the way, an error margin. Of course, you have. Yes.
So again, the manual that I put through there has a maximum. That theodolite has a maximum distance of 600 meters, and we can do reciprocal zenith, and we can do reciprocal zenith angles going up a slope. So if the problem's the fact that you don't like the fact that if it's a sort of angle of 0 degrees, so it's level with its leveling, then fine, we'll fucking stick stakes up a mountain up to 1,000 feet. Don't give a shit, mate. Get the same fucking result.
We'll go and do it then and show you.
Plane Surveyor's already done it. That was the laugh about this.
Okay.
And he did it in much shorter distances than that, and he used a middle station, and he still got really, really cool results that showed that plumb lines are not parallel to each other. It seems to conform with the curve value of the Earth. You almost got my point out before you started there. What's up? You almost did it this time.
So
Go on,
do you have an example from someone not in the YouTube realm and this debate realm?
Yeah. I mean, Main Surveyor had a session on.
I asked a very specific question. Do you have an example of someone that's not in this realm and not in the YouTube realm, right? That isn't attached to this debate whatsoever? That would be a far better example, I would think.
I think the problem you have with that is everybody who starts to get in this discussion would then be involved in this domain, wouldn't they?
Well, no, I don't know.
So I'll happily say from my personal experience, I've done the ranging to geostationary satellites as part of my job.
Right, and I would say that if a tool has a tolerance level, an error margin into it at X amount of distance, right, you can't then use that tool greater than that distance and then just extrapolate through mathematics what that error may or may be. You can't just make it up.
I wouldn't want to use it for what I call extreme accuracy. No, I mean, that's why we have level 1, level 2, and level 3 surveying methodologies.
So
foolish if that was true.
So if you're looking at something that's only over a kilometer, right, and your tool only has a working distance, let's just grant your 600 meters. You can't then go, okay, then this is what it's going to be over a kilometer, because you've got no idea, because it only gives you a working range of 600 meters with that example.
Yeah, and
that you posted.
Well, that's why I like Whitsick versus the Main Surveyor's example, because he did his measurements over 1,200 feet with a middle station.
Okay, but Bansal, can I just quickly ask Bansal? So if the accuracy on 600 meters is within arc seconds, which meaning a couple millimeters over that distance, why do you think that doubling that distance is somehow gonna make the error margin increase 10 or by 1,000 fold? Why would you think that would be true?
you don't know what the error margin is going to be because the manufacturer hasn't given you those guidelines whatsoever. So it's not what I think, dummy. It's what the manufacturer thinks.
Okay.
How
So you
far you
think
can
it's,
use
but
those
that
tools.
means you think it's possible that it's got an error margin of 1,000-fold more.
Oh my God.
I would refer back to the manufacturer and what they recommend that their tool is used within. Now, if I use that anything over that distance, I've got no idea what that error margin may
Gabby,
be,
let me rephrase it to you.
and neither do you.
Let me
I
rephrase
know
it
it's
to you
less
because you
than
seem not to understand.
1,000-fold.
Gummy Bear, let me rephrase it to you. If there is a range for any kind of device that we are talking about right now, that's because you cannot calculate for a more distant measurement. If you could measure, if you could have any kind of calculation for an error above, like let's say 500 kilometers, then there wouldn't be any kind of range. Do you get that?
I think the problem I have with your argument there is, effectively what you're working on is a similar sort of principle that firearms work on, which is minute of angle. So, I'll have a minute of angle, which is pretty much the same kind of thing, except it's arc seconds of angle, of variation when it's coming out of something like a theodolite versus the minute of angle coming out of a decent rifle, or a half minute of angle coming out of a decent rifle. Yeah, it's a cone. It's a cone of accuracy, and as that cone goes out, the possible amount of variation between your maximum and minimum results increase. So what you have to understand,
vaguely phrasing what you said is true, but when we are talking about the exact measurements, then if we had any kind of calculation for those errors that are introduced due to the longer and longer and longer measurements, then there wouldn't be a range. There would be a table that tells you that if you are looking at this far, you should use this kind of calculation, and then wouldn't be a range.
Okay, so there's a difference between saying that the calculations make up for the error and saying that the
There
calculation
are no
can you let me
calculations for it.
finish a single sentence, please? So what we're saying isn't that you do some calculations that solve for the error. That's not what we're saying. We're saying that over that distance, you'll still have a big error, but we know that the error is within a specific margin. And we notice that while our error is within a specific margin, the actual measured result is 1,000-fold of that margin. So clearly it isn't just a margin thing or an error thing. It clearly is something different because the margin only accounts for a 1 in 1,000 parts of that result.
Okay. Again, the problem with this is that there are no calculations after the certain range that is given by the manufacturer of the device. That's why it doesn't exist. That's why there is a range for it.
Sorry, I actually put in a link earlier on. If you go back, comparison study of accuracy and distance measurement using optical theodolites, and that is shown beyond just their standard sort of distances. So again, I think it's not something that hasn't been done. It's just something that when you're doing standard surveying, depending on the type of surveying you're doing, you're either working on relatively short distances or you're working on much longer ones.
All those markers, all those markers still end up connecting parallel to the plane that was made at the highest elevation. That's how surveying works.
And surveying shows that plumb lines are not parallel to each other.
No, that's the optical device that you are using, and it's due to optical illusions that I've talked 30 minutes ago.
That's within the tolerance limits of the device itself, as recommended by the manufacturer.
How do you know? How do you know that when you are measuring the differential angles of the plumb lines, you are not actually measuring an optical illusion, but the physicality of those plumb lines? How do you know?
Because now you're basically saying that theodolites don't work.
Now
Is
I'm
parallel
asking a
within the error
question.
margin?
I haven't said
No,
I
that's the
haven't
whole
said
point.
anything. I didn't have any claim. I was asking you how do you differentiate in between an optical illusion and the physical measurement over that kind of distance?
And I replied with a statement saying, so now are you saying that the odd lights don't work?
So you won't answer the simple question that I had. Great. Okay.
So you're going to
No,
pigeonhole.
I'm showing the fact that what you're trying to say is that we have a whole bank of instruments that are used to build lots of stuff, bridges, roads, skyscrapers, measure the land, work out who owns what, all that kind of shit. Stuff involving money, which people tend
Are
to
you
get quite
talking
anal
about
about.
terrestrial photogrammetry? Because terrestrial photogrammetry, in which they are measuring buildings and their heights and their widths based on photography, but that's also within a distance of 100 meters of the camera from the building.
I'm sorry, but when they measured the height of Everest, they did that using triangulation and trigonometry, and
They use trigonometry and in that
and they got to within feet of the most accurate measurements we have today, and they did that from over 80 miles away. So what
Height
the
from
fuck
where?
you're talking
That's great,
about?
80 miles, and they were supposing that the 80 miles distance over that distance is that the plane below that mountain is a plane, straight.
No, it's a deviation from mean sea level.
What?
Boy.
No, if you use trigonometry, then you can only use the trigonometrical functions if you have a real, Euclidean triangle with straight sides.
I've used the
that's
adults
fine.
professionally. I brought this up in another debate previously to try and show the Globers what they could do. I've instructed them where they could go get newer equipment, newer theodolites and measuring meter sticks, all of this stuff. There's markers all over the entire world, down the highway, in every city, on the sewers, take your pick. You can go get a theodolite and you can go back and you can go over every single marker all across the entire freaking world. And you can measure all this stuff. All of the lines that go to the zenith straight above the meter stick and the theodolite are parallel in all the planes that are made, depending, no matter the elevation, they're parallel to each other as well. That's how this works.
No, in fact, it plainly says that plumb lines are not parallel to each other. That is a basic foundation of surveying. It's in every fucking fucking surveying manual you go into. It's in every
Peer
fucking
reviewed.
college course
Because
that
there
you
is
go
only one
into.
person who did that. There is only one person who did that plumb line deviation, right? That guy is called Jesse Kozlowski. Who
No,
peer
Main Surveyor
reviewed
did
what
it as
he did?
well, and
Okay, then it's two.
George did
It's
it as
two
well.
guys. Let's say
So
it's three guys who has been in this arena altogether. Who peer reviewed them? Who is not in this arena and is and can verify that what they
Yeah.
did is true
Yeah,
and
cool.
okay.
And when you tell me who verified the claims to the Earth being flat, who's outside of this arena, who's
Don't
verified
deviate
that
the
the
topic.
atmosphere
I
has
had
to
a
be
simple
contained,
question.
who's outside of this arena, who says that gravity is some sort of made up trickery, who's
We're not
outside of this
talking about
arena.
gravity.
So
We are
please
talking
give
about
me
just Kozlowski's
examples
measurements.
of this independent peer review that you demand as a standard of evidence for any claim ever made by Flat Earth.
No. I'm asking because you guys are telling me that that guy should be trusted. Why
No,
should I
I'm just saying
trust him?
these are examples. You can make your own decision
No, again,
whether you decide to
why should I
trust those
trust him?
results or not, and you can look at his methodology and see if they're reasonable. And you can also employ your already present bias to say it can't be true.
And I can also present my experience in life that people lie. It's that fucking
Everybody
easy.
lies.
Well,
I don't
there's
know
a
what your
bit of
point is there.
though. No isn't a rebuttal, and I've done this professionally, using zeodolite, setting out markers, getting ready for commercial construction, not small shit. So no isn't an answer. It's baloney. And to say somebody else has, oh, well, he said this. Okay, appeal to consensus. Congratulations. Go get the theodolite and measure it out and show me your results. Until then, no is not a rebuttal. What I said stands.
Cool. So you've studied surveying.
I've done it.
No. Have you studied? Have you been taught it?
Oh my God. Dude, all right. I'm so done talking to you because you don't ever fucking listen.
Yes, you've done it. The same way as, I could go out and I could do brain surgery on somebody. If I haven't had the education to do it, then I may be able to do some of the practical stuff, but I may not understand the theory that sits behind it. Hence, I'm asking you, have you ever studied surveying? Are you a qualified surveyor?
Don't give anyone brain surgery, Druth, please.
I promise I won't. I really promise I won't. It would be like a fucking, be like a Japanese sushi chef with a hatchet.
Look, I already explained where you can go get them. You can go to a pawn shop, good pawn shop. They have newer theodolites that come with 3 lasers. They level on 3 axes, so you get a true everything.
Yeah, are you a qualified surveyor, sir?
Again, we don't making this personal, so leave the ad homs and shit out.
Not an ad hominem.
Bro, this has got nothing to do with me.
Can you address the argument instead of his qualifications?
I told you where you go get them. I told you months ago over in the other science versus pseudoscience how they work and how to use it properly. Now, you're trying to question everything I've told you, yet you haven't done any of it. That is nonsensical.
I will take that as a no, sir.
And you don't need to do it to understand it either.
And this is one of the reasons why. So this is from a surveying course book from Fresno State University. Because fortunately they publish a lot of their shit online, which I do love them for. Which is showing you your vertical, which are not parallel to each other, your horizontal, which is tangential to your level surface.
It's a diagram.
That is what is taught to surveyors.
Yeah, but that's wrong though, because you need to establish the height of something. You need different points to measure to the same place to have the same angle. That would mean that the other lights wouldn't be. They need to be parallel to the point that they are observing, man. What you're saying is nonsensical.
But the problem is though, right, is I've taught them how to use a theodolite and the meter stick. I've told them how to do it. I've told them where the markers were in major towns, along the highways and everything. I've told them. None of the Glovers
If what he's saying is true, the same surveyor wants to establish an angle to whatever reference point, and he moves to sideways. He cannot. Once that he has his tool calibrated, pointing at the same angle, the angle cannot be the same. If what he's saying is true, he's not going to be 90 degrees again.
That would also hold true on a surface.
It holds true all the time because you can move around and you always be 90 degrees to that place.
I'm showing a fucking huge degree of patience with you guys today.
Good on you, Joss. Thanks, mate. You're a legend.
It's
not really. I haven't seen
Thank you for your service.
I mean, you can feel however you like, but so far I haven't heard you say anything that's different from anything you've said in the last 5 months. It's the same crap.
Yeah, the same crap because correct answers don't change, Cuddles.
If plumb lines are never parallel, then why are there 2 types of surveying? Why does one type not need to account for curvature while the other one does?
Because of the
one begs the question of a curvature. That's why.
No, because it's called the square root of fuck all factor.
Now, when it's called planar surveying, and planar surveying, everything needs to be, plumb lines and level lines. They need to be perpendicular to each other, and they do need to run parallel.
And they are perpendicular because of how you set up the theodolite.
If I'm building something like a house and I'm setting out the foundations for the house, yeah, the curvature
You
of
would
the
use
Earth,
planar
or
surveys for
oh,
that.
for fuck's sake, I'm gonna fuck off because this is just getting stupid.
Let him
Nah,
go.
I'll catch you
Have
later.
a good one, man. See you, bud.
It's the same old crap, dude. They're always pulling out one silly citation from one guy who's never actually done this shit to say, "Oh, well, all this shit's wrong." Okay, go do it.
You're going to need
Prove.
to start with a flat plane. That's the
Maybe
problem.
so, but you got to let people finish their sentences, guys, and then correct them.
That's fine. I did. You got 4 other people wanting to jump
There
in.
was a question. There was a question by Jerry. What's the difference between both types of surveying? One is planar. That's what I was pointing out. If you're
They're
going to do a
both,
house, you need to use planar surveying.
bro. They're both planar. Normal surveying done on job sites, construction, highways. It's all planar. There is no other form. Geodetic is planar and regular surveying with the theodolite is all planar. There is no change. He just keeps saying that there's change without showing the evidence. Somebody said it. Good for them. That's a story. Do you have measurements that prove what he said? No? Okay. So I'm going to take that. I'm going to throw it in the trash because of Hitchens' razor.
Yeah, geodetic surveying needs R. They don't have R.
No. Because geodetic surveying uses straight lines all the way across.
Yeah, but they are based on the radius of Earth. They need a radius.
Drop all that shit, dude. Drop the Fantasyland shit. Geodetic and regular surveying with theodolite are both planar. Period. There is no deviations.
That's ridiculous.
Yeah, I know that. It's only when they put in a piece of paper they add R to it.
That's what I said. It's just a drawing, nothing else.
That's what I'm saying, though. He ignored the fact that the theodolite is literally leveled on 3 axes. 3. To make sure that when it's set up in one location and set up in another location, those 2 zenith lines, straight up and down that you get with the plumb bob, guess what? They're parallel. That's how
Yeah.
it works.
And not just that, that's how they do it. That's even better than that's how it works because they claim that that's how it works, but all they have for that's how it works are drawings, right?
Right, they're trying to say deviation, but I've never found deviation doing surveying. And the largest pad that I did surveying on is 300 freaking yards. It's huge. It's a huge ass medical building that we were doing.
You understand? I hope you guys understand what I've said. If you are using a theodolite, for example, and you have a post, let's say a lamp post, and you are trying to put it completely plumbed with a theodolite. Yeah, you're using a theodolite to establish its plumb, and you are happy with it. Everything is fine. Now you move, let's say, a few meters to the left. Yeah, you're gonna calibrate again your theodolite. You're gonna aim at the same post. The post, if it's true that what they say that they don't run parallel, when you aim at the post needs to be deviating.
Yeah, they should be deviating, but they don't.
Because
so that's the problem.
there you go. Because you are aiming at the same reference point. You move again, and you establish your vertical, you horizontal again. You calibrate your tool, and then you aim at the pole. You know, it should be deviating from every single angle. And it's not. So when they say it's not parallel, I mean it's nonsense. Because you need to establish your plumb line and your horizontal before you even use the tool.
Yeah, by the way, man, Gami said like an hour ago that equidistant. I heard the word equidistant. I love that because if the Earth is not actually, even in their model, it's not actually a perfect sphere, then that means that there are radii. That means radius is the multiple tens of radius is radii. There are radii. That means that nothing is equidistant, right? Am I right about that? Do you get that? That they are using day in and day out the word that level is equidistant from the center of the Earth. It cannot be if the Earth is a non-perfect sphere.
It's a pair. Pairish.
Yeah, yeah, I hear you. But nothing is measured from the center of a sphere. Nothing. There is no sphere. There is no sphere to measure from.
Yeah, the deepest we drew was like what, 12 kilometers?
8 miles or something.
Yeah, 12 kilometers. And apparently that's what we are allowed to go.
No, that was just what the technology did.
Yeah, but yeah, on that area there was no restrictions. But if you want to drill anywhere else, that's as far as you can go. So I heard. I'm selling the fish for the same price that I bought.
Yeah, I just don't think you can go much further. They did try. They tried a couple of times. I think they got 3 holes, and each time they came into trouble. I think there's 3 holes within close proximity. I think the first one failed at about 6.5. The second one failed at about 7 something, and then they got to the maximum, which was about 8.
So yeah, no one measures from the center of anything. Not when it comes to Earth.
Well, that's the thing. I've been asking that for a while. Who directly measured this so-called radius? And they're like, "Oh, well, they did." Okay, directly? Well, they ran on a boat. Okay, but what does that have to do with the straight line from the surface to the center? Nothing. You're running around
they
the
measured
surface.
something.
Center.
They
That's
measured
not
something that it's not visible, is within 5% of visibility, and it's physical, even though it was never seen.
What they claim is the Alberuni's method that says that all you have to do is look out to a certain distance and then measure the angle deviation from the horizontal line downwards, and that will give you the part of that circle, and then you have the full circle, and that's it.
Yeah, but what? Yeah, correct. What Alberuni did.
But then you have. But then you have a circle.
He used the
You
mean
see?
sea level. Yeah. Use the mean sea level, knowing that is level, yeah, to measure an elevation angle to establish the height of the mountain. So now that he has his elevation angle with the height of the mountain, he goes to the top of the mountain and he does a depression angle to the horizon, giving him a radius. But he reified the horizon as to being a physical thing.
Yeah, but
he
again,
knew that he
we have the
needed
same.
a clear day to do so, and he needed to assume that it was physical.
Also, and also on the other hand, it's coming back to the same thing that I said 2 minutes ago, that if you are measuring that kind of thing and you are coming up with any kind of deviation from a horizontal, or you're coming up with the idea that there is a curve, then that only gives you a circle again, not a geoid.
Yeah, correct. It gives you a circle. It doesn't. Yeah, correct.
It's altogether fucked up.
Oh well, let's do like they done to us. Back in the day, they didn't know better. They had to assume all of these things.
Yeah, but then Einstein and others came around and said, "Oh, you got a problem with the gravity, so the Earth cannot be a perfect sphere. So your calculations for the perfect circle doesn't work and shouldn't work." But then you have the gravity, which tells you that it cannot be a perfect sphere. That's another conundrum that cannot be resolved.
But even gravity, Even if you give them gravity, gravity doesn't mean glove on their story, because for every force you have an equal force, you know. So we need it to be flat. If every time you're pushing down, something is pushing it up, I mean, you don't have a sphere because you have equal amount of force opposite. Even on that paradigm, you wouldn't have a sphere.
No, it could work. It's just it would be the gravity would be different at each point on the surface of that geoid.
Has to be.
That's the real problem.
Has to be.
Oh, it has to be. Yeah.
I don't know. I'm gonna find something. Post it.
And anyway, all of these things have been done already. We're just emphasizing the things that has been done in the past. Some of them has been overlooked. Some of them ignored. But every time we navigate, we need to consider the Earth to be flat and stationary. I mean, I would go to the point of saying when you navigate, you don't need to account for anything. Just go as it is. There's nothing else to say. Why would you say not to account? What? What do you mean? Not to account for reality? If that's reality, you need to account for it, no? It's absurd. We use it. It's been done for centuries. Celestial navigation, elevation angles, you know, heights of mountains, heights from water. I mean, we use water for that.
Look at the canal system across Europe. Different canal systems. It's fucking.
That's a good one. Yeah, that's a good one. Yeah.
Imagine you're gonna build a big water reservoir, and you need to flood a vast area. So before the fact, everything needs to be surveyed. Imagine you were a bowler surveying that. Yeah, you're gonna put more water than the capacity of the reservoir because you're gonna account for an area above above the limitations of the reservoir itself. You're gonna say, okay, so here, you know, this depth, this much area, I can put this much water in it, you know. But if I have a bulge above, I can put much more. I mean, no one does that ever, because when you flood the place, I mean, there is no turning back. If there's a bulge in the middle, it would be visible.
Plenty of these levees fail, mate. Not just break, they just get overwhelmed. So it's possible that there's ballers on the job everywhere.
Well, I'm surprised that every single levee doesn't fail, because apparently the Earth is rotating within a bubble of water.
Oh no!
Oh yes, you've seen this. You've seen
How
this.
is? Why is it so hard to understand that there's bulges on either side of the Earth and
Yeah,
the Earth is
and
rotating into them? You just don't get it.
Exactly. It's all within the first minute of that video. We are actually rotating within bulges of water. It is absolutely no wonder we have so many tsunamis and stuff just wiping out countries at a time. It is incredible. We now know the answer.
Well, if the Earth was spinning, you wouldn't have tides anyway.
Well,
the water would go just going one way. You know, you wouldn't come back.
well, this is why we apparently have tides, because we are rotating and confined within a bubble of water.
Yeah, but you know what I'm saying. If you have something rotating, if you have a container rotating with water inside, the water is gonna go one direction. It's not gonna come back
And only
go
one
back again.
direction. Yeah.
Yeah, it's not gonna go one way and then come back the other way and then flex again the other way and so on, like we see it. It wouldn't.
I don't know, George. This is from Neil deGrasse. Like it
I
doesn't get
understand. I
it
understand. That's
doesn't
why we're
get
talking
any
about it.
better. It doesn't get any better than
He
this.
doesn't even know what fucking footballs do.
But he doesn't know what gravity is.
Have you clipped it, Jerry?
No, but there's a show there. It gets right to the point, and it's beautiful. He's the
Yeah.
gift that keeps on giving.
Isn't he? Isn't he? Like who
He's
needs
there for
Santa
that reason.
Claus? Who needs Santa
Yeah.
Claus? Right?
Yeah, but Neil deGrasse Tyson doesn't know what gravity is. From the moment he drops the microphone, yeah, he doesn't. He's saying, "I don't know what gravity is. I'm reifying something that is not valid anymore. It's been debunked 105 years ago by Einstein." So that's what he's. That's why later on he says, "Well, I don't know what it is." Next question. Of course, he doesn't know what it is. He should know, and he should be reifying it. But that's why he is somehow what I call an anti-flat earther. He's not even spewing the globe properly.
Yeah. He's part of the Flat Earth Society.
It's such a shame that everything that comes out of his mouth, then the Globers have to come in here and just say what a fool he is.
I
That's
know.
that's their
That
common
must
line.
suck, eh?
Like
Yeah.
we're talking about what is he? Is he an astrophysicist or he's some sort of whatever he is?
He's
Well,
an
he is on the
academic.
same page. He is on the same page as Don Pettit, the astronaut. Yeah,
Right.
There you
because
go.
what he's saying when he drops the microphone is the same as Don Pettit. We've lost that technology. I don't know what gravity is anymore. That's why I'm dropping my microphone.
Well, like he's the guy on talk shows. He's the guy who goes on tours. He's the guy with books, but he's also the asshole.
Yes.
Yeah, he's saying
also
we've
the
lost that knowledge of what gravity is. I don't know what gravity is. I know, as far as he's not aware of gravity being the bending of space time. Someone needs to tell him.
They must have shredded the theory of gravity when they shredded the plans for getting to the moon. Must have been in the same filing cabinet.
Yeah, the only thing they're not on the same page is, for example, he says the Earth is pear-shaped, and NASA tells us it's spheres because they show us perfect spheres. And then Neil deGrasse also says that 2 millimeters above this beach ball, you couldn't see the curvature of the Earth. But NASA says that we can see. They have live feeds.
And boy, does that curvature change in those live feeds. Fuck.
Yeah, last year after that Jeff Bezos thing, he went on TV and said you wouldn't see the curvature from that height, which is like 63 miles. And that very same day, there was goobers telling me that no, he's wrong. You would definitely see it. Oh, okay, well.
Well, the problem is we're still waiting for them to show it to us.
That's why our difficulty here, because we don't know, are we talking to a glober or talking to an anti-flat earther? It makes a difference. Because one is going to say one thing, which is what we all learn in school and we all disagree with. And the other one is going to come in just to disagree with us.
Well, yeah.
Do you see that now they're asking for proof of a flat earth rather than continuing to affirm a globe that it's not existent? They know that. They just need to justify their presence. That's why they're still around.
It's hilarious, right?
It's good to talk to them, not just about this subject. I mean, about the other subjects too. I mean, I'm sure they have plenty of things for us to learn from.
I doubt it, dude.
I know that when it comes to our realm, yeah, the information they present, which is what we've been unveiling, let's say, Yeah, that nonsense we laugh at. But there are other things that, I'm sure here and there you'll pick up something that you never heard before, and maybe something new to you.
Bruh, I can talk about law for months on end. And here's the funny thing. You don't have to be a Glober or anything to disagree with Cuddles. It's really simple. Most people haven't ever put the time to actually do fuck all. They haven't done anything. That's why they don't know anything. That's why they have to appeal to consensus and other people. I don't have
but
to have a...
that's the reason why you are put into an education system. So when you come out on the other end, you don't need to ask any more questions. Just go on with your work. Just keep your
Well,
head
see, that's the
down,
thing,
do
though.
what you're told.
I don't have to have a license to drive my car. I do not. There is no law stating that a man has to have a license. There
If
is
you're a driver, no. If you're a driver, you need to have a license.
What
If
does
you're a
driving mean?
traveler, yeah, if you're a traveler, you don't need to have a license.
Right, but that's the thing, though. They say, "Oh, driver, oh, you're a driver. You're driving your car." Right. Privately, you have private, and then you have
It all
commercial.
depends what you call the act that you are doing. If you say that you are driving, yeah, you need a license for it. If you are traveling, no, you don't need a license for it.
Look, it's the same, no matter whether it's private or public. The term driver is the same. The difference between the definition, though, is what'll get you. Because in the private, a driver is somebody who uses their personal vehicle for private conveyance, going to get groceries, going shopping, taking grandma that pie that you baked her. Commercial is public, which you're doing business. You are a business. You're engaged in business as a business.
Yeah, but that's why you need a license to become a driver. Because if you're a driver, you can only travel on registered vehicles with insurance and so on. All the requirements that it comes with being a driver.
Right, but this is the funny thing. It's the same style debate. You have people that have never gone out and done anything telling me that I'm wrong. When I've gone out and I've not only done it, but I've won in court doing it. But they'll sit there and tell me that, oh, no, you're wrong. Okay, well, have you ever gone to court? Have you ever read this? Have you ever done that? No? Okay, then what are you doing talking?
So you should be allowed to drive on the road with no license, insurance, or anything like that, Cuddles?
On the private side, which would be me, not engaged in commerce, that is correct. If I start working for ATF driving their trucks, that's a different story. I'm engaged in commerce.
Yeah, I'm not talking about the commerce. I'm talking about private. We're not talking about commerce
Yeah.
whatsoever. So
Yeah.
you think,
You don't have to...
as a private driver, you should be allowed to drive on the roads with no license and no insurance.
Well, that's the law. That is the law. In England, you don't have to have a license to get on the road. They just made their system in a way to where it confused everybody that they thought that they all had to have one. Same thing.
Sure, because roads
that
are
wasn't my
public,
question.
right?
That wasn't my question. My question was, do you think you should be allowed to drive on the roads without insurance and without a license? Because they kind of go hand in hand.
Well, you don't have to have a license.
The answer is no. The answer is no.
Yeah.
Because you mentioned the word drive. It's that word that we are stuck.
Fine.
That's the key
Okay,
word.
I will take that word out. Do you think you should be able to travel in your car, driving your car, but being a traveller from point A to point B on the public roads without insurance and without a license?
Yes.
Yeah. Personal accountability.
I disagree 100%.
Me too, by the way. You're using public roads.
100% I disagree with that.
You are using public roads that were made by the government, so you must have something,
Yeah, but
regarding
that
responsibility
only
towards
reinforces the
government.
point.
George,
That only
George,
reinforces the point.
I got this though. I got this. I just got to slow down a little. Look, I can go out there without a license, without insurance, and if I get into a wreck, to say that I don't have financial responsibility just because I don't have insurance is foolish. Because who's to say I don't have $500,000 sitting in my bank account? I have
Who's to say
financial
that you do?
responsibility.
Who's to say that you do?
Now, regardless of that, man, aren't the public roads safe?
Don't worry about
Yes.
the
Aren't the
whether.
public roads designed to be safe or safer throughout time? So they are
That's
safer and
nothing legal.
safer. So if the
That's nothing.
if the roads are safer, if they are signaled properly, there are no reasons for you to require a license as long as you can understand the signaling and respect the rules of driving.
Yeah, now see, George, you are getting into the nitty-gritty of the legal system itself, and you are right about it. But it's never written that kind of thing in anything, by the
Yeah,
way,
but
that is safe or not.
what we should be asking is
In legal
how.
terms, they want themselves to be as far away as words like safe as they can
I
be,
understand.
because
You
it's
understand.
not
They want the
defined of them.
liability.
Yeah.
That's why you need to have insurance to travel even on that roads.
But hold on. Financial responsibility has been defined as insurance, and that's not all financial responsibility is. Because if I have stuff at home that I could sell to pay for the damages to your car, I have financial responsibility. To say I don't is fraud.
Yeah,
So
kind of.
we're back to this whole arguing over consensus. Consensus doesn't matter. Consensus is baloney. The law says that I have the right to egress and ingress. That's the come and go at my leisure. That's the law. There is no law on top of that restricting what I can and can't do.
I personally don't think that I would want to take the chance of whether or not you do have $500,000 or you don't, or whether you have a fridge and a flat screen TV that you can sell to repay me for the damages that you would be responsible for if you were in the wrong. So we're saying that you are 100% in the wrong, and the accident is your fault.
People on the road
I do not want to take that chance myself, personally, and I don't want you on the road uninsured.
So what you're saying is you'd rather
Well,
all
I
of
will be in debt to that person for the rest of my life. Yeah.
And how does that help me out, George? So now out of my own personal pocket, because you're going to make a payment plan of $5 a week for the rest of your life to pay me off. How does that help me out in the immediate? That is
Yeah, but you are assuming. But you are assuming a lot of things, aren't you?
Of course, I'm assuming.
You are assuming a lot of things. Yeah.
For the worst case scenario.
So what you're saying is roads are not safe then.
George, hold on.
I didn't say anything about roads. You are conflating two different arguments. I'm not saying anything about the roads being safe or not safe. And regardless,
You are assuming an accident is going to happen. Listen,
hold on.
if an accident is going to happen, it's not safe, is it?
Regardless whether the roads are safe or not, you can still have an accident. The safeness of a road does not mean that you are not going to have an accident.
Right. But see, here's the thing. What you're missing is other laws that you've never looked up. If I get into a wreck and I cause your car damage, I can go down to the courthouse and get a bond that will cover your damages. I don't have to have.
I disagree with what you guys are saying.
Not here, you can't. Not here, you
There were laws that were made to help me in that situation if I do damage you.
Not here, you can't.
Right. Everywhere you can.
No, you can't. You can't go down to the court here and get a loan from here. You can't do it.
Well, my point is the same. My point is the same. For an accident to happen, someone needs to be breaking the rules. Simple as that.
Not necessarily.
Yeah. If you keep your distance from the cars in front of you, or you will.
Not necessarily. You can be driving along the road, George, and you can sneeze and lose control of your car. You haven't necessarily done anything wrong. You have just sneezed.
I sneeze and I lose control of my car. Well, I need to be speeding a lot, man. Only if I'm speeding a lot. Yeah.
You don't have to be
I'm going to be.
What
Yeah.
about people
Yes,
that
you
fall
do.
asleep at the wheel?
Speeding
You know,
to have an
drunk
accident,
drivers.
George. It is a
Yeah.
it's a silly argument to say that you have to be speeding to have an argument. It's a silly argument.
It's a very silly one
Why
because
people have the need to
your
go at the
tire
speed
could
limit?
burst, something could happen to your car, and it just malfunctions on the road. The
Yeah,
steering
if you
wheel
are
could lock
below
up.
the speed limit,
There's
you'll be
so many
safe.
things that happen.
I've had
Even if you're below the speed limit, you could still end up in a fatal accident.
I've had a
Like, come
person
on, get serious.
reverse into me into the car park when they're parking their car.
Yeah.
They weren't speeding. They were doing like 1 kilometer an hour, maybe.
You didn't
It's like
respect the rules of
you
parking the
don't own a
car.
car,
You didn't give
George.
enough room. No, you didn't give enough
Don't you own a
room.
car?
Yeah. But
Had nothing to do with room.
no, I don't own a car. No.
Had nothing
You don't
to do with
you don't
room
own a car,
whatsoever.
or what?
No, I don't own a car. I never had a driver license in my life, ever.
This is the problem. You got guys that have never studied the common law of their nation.
Why would I be joking?
Commercial law. All they know is commercial shit, which has nothing to do with the individual people. It has everything to do with commerce. So what you're doing is you're applying commerce on the people, which is really fraud.
I don't know what you're saying, but to argue that, having insurance or not being able to drive on the roads without insurance is a bad thing. Like, come on, man.
No one is saying that. No one is saying it's a bad thing.
That's what you guys are arguing. I mean, that's what
It's
what
up to
Banso
you
has.
if you want to do it or not. No. I'm not
Banso
trying to
asked
say.
if
I don't want to pass the message. If I'm doing that, I'm sorry. I don't want to pass that message. I'm not saying
Banso,
for
what
everyone
was the
to
question you
drop your
asked?
driver license now, and to be. No. I'm not saying that.
Banso, what was the question you asked?
I asked Cuddles.
There was a question you asked.
Yeah, very specifically. I said, does he think that he should be able to on the roads? And I had to change that word drive, and I had to use the word travel in his car, but driving his car. So I'll use his terminology. But should he be able to do that in his vehicle without a driver's license and without insurance? And he said yes. And I totally 100% disagree with that.
That's great. The law disagrees with your opinion.
I don't care if the law disagrees with my opinion. My opinion is that I think that every driver on the road should have to have insurance.
Cool. So now we're back to slavery. You've now
what do you mean we're back to slavery? The law agrees with that opinion.
I don't want to have to take you to court, right, to get my pound of flesh out of you, right, to get my property repaired. I don't want to have to go through that expense of that time, that anything. I just want to fill out some paperwork and get it all done, right, and bang, everything's fixed.
That's kind of lazy.
No, I ain't lazy at all. Why should I have to go to court if you're 100% in the wrong?
I'm not saying.
What if it's you that are in the wrong?
Hold on, George. Jesus, it's fine. I got this. It's easy for me.
I've got insurance, so it's okay.
It's fine. But see, here's the thing. You missing. I made a point. If I cause damages, I can go down to the courthouse and get an insurance bond to take care of your damages. I don't have to do it after. I can do it after.
That may be in your country. You can't do it in this country.
I'd have.
What happens if you don't have enough coverage, Bandy?
And I made that clarification.
What happens if you were driving a truck and your truck had a front wheel come off, so it's not your fault, and your truck went through a shopping center and killed fucking 50 people, and your coverage didn't cover it? Should everyone have enough coverage for the 1 in a million chance that they write fucking 50 people off?
No, because then now you're talking about having.
But hold on a second. Hold on a second. Let's put this into perspective, okay? Because not all insurances, even though within the legal grounds, not everything is the same. Let's say that I'm sure most of you drivers have moved somebody else's car, a car that is not yours, either to park, to move it slightly up or backwards or this or that, yeah? So not necessarily you are registered on the insurance of that car or you have permission even to touch on that car. Yeah, because some insurance doesn't cover other people to drive it. It's either you insure there are many ways, you know, you can insure just the car or the driver to the car, specific driver to the car, or anyone to drive the car. There are many types of insurance. So that already speaks volumes. Because if you are touching somebody's car that you don't have permission for, you know, and an accident happens, you know, and you're just moving the car. Just because you are in the driver's seat and the engine is running, you know, you haven't done anything. The guy came to you. I mean, because you don't have the license and you are behind the wheel, it's somehow going to be your fault because you were in the wrong.
And that example that you just posed there, White, right now, my third party property insurance will cover the building, and the TAC insurance, which is part of my registration, cover the people, and that has no limit.
Yeah, but that's
not
based
everyone
on
has the same.
taxpayers' money.
There you
So
go.
should everyone just be covered by the taxpayer? Should they just be reckless?
But everyone is
No.
a taxpayer.
What are you talking about? You
No,
pay.
I'm sorry.
You pay that TAC insurance, that third party person insurance, right, as part of your registration. It's already built into your
You know,
registration. Now,
I know that, but you know as well as I do.
that has no limit.
Go on.
That has no limit. That insurance, right?
Yeah, but you know as well as I do, like in major floods and things, these insurance companies don't pay out. So there's a situation where enough people might have an accident because enough people don't give a fuck or maintain their car, where all of a sudden the insurance places go broke or the government decides not to cover it anymore and people have to pay it. It's
Okay.
people need accountability, Bandy.
I'm not saying that people don't have accountability at all. Why? What I'm saying is I 100% disagree that any driver should be allowed on the road without a third-party insurance policy at least to cover someone else that they may run into.
Are you aware
Okay,
one in five
let me give you the
don't
insurance.
do that currently? And you already
Let
take
me
that
give
risk?
Sorry, what did you say, what?
1 in 5 drivers in South Australia are currently not registered or insured. So
Yeah.
you're already taking that risk on the road, Bandy, with hitting someone or someone hitting you.
Maybe so, why? But my
Yeah.
opinion is my opinion. I don't think you should be
Oh,
allowed
sure.
on the road at all without insurance. Now, whether or not people don't want to get insurance, I've got no control over that. But if I had my way, right, everyone would be insured, and it would also too be like it's over in the States, registration and insurance, please.
Yeah, registration is commercial. All of that is commercial. You're back to forcing people into commercial activities, which is also called slavery.
It ain't slavery. It's called covering my butt in case I'm in an accident.
It's called do
That's
what I
it's doing.
tell you, or I'm going to do something harmful to you. That's called slavery.
I understand what he's saying.
I would much
You guys are not understanding each
200
other.
bucks. I would much rather for
What's with-
$200 a year that if I hit a bloody Ferrari or a Lamborghini, it's not going to cost me a brass razoo other than the $200 of excess that I have to pay. That's what I would prefer. Rather than having to sell my home, sell all my possessions, and sell everything, and maybe go into debt for the rest of my life to try and repay that person.
Yeah, but you are assuming that it's your fault.
Hold on, George.
That was the scenario, George. That Cuddles or I were 100% at fault. That was the scenario.
Right, but there's other issues that they brought up, George, that you're overlooking.
I understand what you guys are both saying, but obviously, if you purchase a car and your next step is to register that purchase of that car to your name, you're gonna have to have an insurance for it and a license for it.
Once you register it, you've committed fraud, and they're committing fraud, and everyone's committing fraud. You're not supposed to register
Now,
your
if
car.
you purchase a car If you purchase a car and you don't register the car, there is no other things required for the car. The car is yours. You don't need to register. It's yours.
No,
So it doesn't require anything else.
look, there's insurance here for people who are unlicensed. You don't have to be licensed to have insurance, to have financial responsibility.
Listen, when it comes to these things, obviously, if I was doing these things, I would have at least an insurance. An insurance for the car, at least for the car. If not for myself, too, the driver. If I pass away, my relatives or whatever. But an insurance to the property at least would be the minimum that I would do, obviously. But again, a license is not required. If you're just traveling, only if you're a driver.
Right. That's the law. Now, here's the funny thing, what you're saying about laws there and laws here. Everything's under the Universal Commercial Code. Every country in the entire world has already adopted the UCC, which is Roman canon, mercantilism, the law of merchant. They've all adopted it. So the common law has already been put on the back burner, and they're treating everyone as if they're government employees. We have so many problems going on right now, it's unreal. Used to, here in the States, we had a spot on the forms, any government forms, when you were asked if you were a U.S. citizen or you were a non-U.S. citizen national. Used to, you could register your automobile with the city as private or personal conveyance only and not a motor vehicle, which is defined in the code as commercial only, not private. They took all that shit away. All of it. That's against the law. That's slavery. You're voting on a side right now for what has already transpired that has denied you your basic rights. That's a horrible thing. Now, there is a way to navigate all this stuff and stay on the private side. That's what I'm dealing with right now.
Bastards.
There are no bail bonds given in Australia at all. Period.
Oh, so you go to jail, you're under the UCC, there's no common law. That sounds a lot like slavery to me. I bet you there's fraud entangled into it too at the inception.
Well, bail bond loans do not exist in Australia like they do in the US. They don't exist here.
Well, hold on. Bail bonds are to get you out of jail.
Right. So, and you can't go down to the court and say, "Dear Mr. Court, I've had an accident. I can't afford to pay. Can you please give me a bond or a loan to pay it?" You can't do that here in this country. It doesn't exist.
No, but the victim can apply, again, thanks to other things that we pay, to victims of crime compensation and be compensated for the damages.
That is different, but the victims of crime too is limited. It is limited. They have set amounts. The victims of crime compensation.
Yeah, I know. That's another mess up. See, that's what I'm saying. The more we go down this road, I can show you everywhere where things are wrong. Because I've studied common law here and in the UK, and I'm working on a couple other countries right now. It's very simple. Everything
And how
is
many accidents? And how many accidents are sorted without going to court? How many times people agree? Because for you to go to court means that both parties didn't agree. That's why you go to court.
Right, but see,
the insurance doesn't need to be activated just because an accident happened, and we know that.
Right.
As long as both parties reach an agreement, insurance are not involved.
I've got situations I'm dealing with people right now where the insurance company, the driver of that car that insurance company is providing for is at fault, and they don't want to pay, even though the police report says that guy was at fault. It's a big mess. So now you have to take that guy and his insurance company to small claims court just to get your fucking damages for a bond that already exists to pay for your damages, because insurance is a bond.
Mm-hmm. Yeah.
Dude, they've robbed Australia of all of the common law, all the things that were good. I know. I've been watching it, and it's horrible.
Yeah, they've replaced the Commonwealth seal with the corporate fucking government one many years ago illegally. That's just been released through Freedom of Information to be verified
Right.
as unlawfully
And
done.
that's called usurpation. It's actually against the Law of Nations. The Law of Nations is a book that culmination of laws that literally apply to every country. Now, whether people agree with that or not is besides the point, because they're all based off of common rights given to man by God, period. Doesn't matter where you are, God created you if you're a man. It'd be great if they had the common law system still engaged, but they don't. They've literally gotten rid of them, which is against the law. It's a usurpation called invasion or war. Take your pick. Usurpation is an act of war. So many people have been living under slavery, they don't know what freedom is actually like. I know, I was one of those people a short while ago. A funny thing about Australia, though, is I may not necessarily need the courts for a bond. There's other companies out there that do stuff exactly what I need them to do no matter where I go. So we died, huh?
Yeah, you killed the VC.
Yeah, it's definitely flat.
Yeah, there's no curvature anywhere, bro.
Even legally.
Exactly.
It's only mathematical.
Well, that's all the UCC is mathemagic, basically. It's presumption situations based on presumptions and stories. The Silk Road expanded, bro, to the entire world. That's what UCC is the Silk Road. That's why there's police, policy enforcers, policy of the Silk Road.
Mm.
To be able to keep business flowing so that people get the things that they need.
The East Indies Trading Company, eh? Good old.
Well, like here in the States, they've made everybody U.S. citizens, but it's defined in the U.S. code, federal code, the U.S. Constitution is is an employee or property of the United States. Well, hold on. Property of the United States, isn't that ownership of people? Isn't slavery ownership of people? Isn't slavery against the law everywhere in the world? So how can I be a U.S. citizen and be owned as a free people? That doesn't make any fucking sense. That's a contradictory. It's a paradox. But people keep
Did
checking
you
that box.
believe them?
Huh?
Did you believe them when they said they ended slavery?
Yeah, that's the thing. They changed the name of slavery. Yeah, instead of slavery, slavery became different names. Sometimes it's called communism. Sometimes it's called democracy. You know, all of these other names means slavery.
In a republic, where does democracy come in? Because a republic is the form of government.
And they tell you to choose your master. Choose your master.
Yeah. Choose ye this day whom you're going to serve. You're going to serve the code, or you're going to serve the law. Serving the law is easy, bruh.
So who do you work? You're going to work for the next 4 years? For me or this guy over here?
Right, but there's a big deal. See, I can change my status from a U.S. citizen property back to the common law, which is a free man. Very simple. Under the Republic. They don't like us doing that. They tricked my parents into putting me into slavery. They tricked your parents into putting you into slavery. They've tricked my grandparents into putting my ma into slavery. I can fix all of that shit with one document. But they don't like it, because then they can't fuck with me. Then I can sue them.
Don't fuck with the Wong. Do you remember that? The Outsiders.
There's guys doing what is it? Title 18, 1943 suits right now. It's right there in black and white, especially over in the UCC, UCC 1-130 or 120. The UCC recognizes the common law. It has to. Because why? Because you can't do away with the old law and then stack a new one and say, well, this is the law we're going to go by, because that's called usurpation. It's also against the law. So everywhere there is a remedy, whether or not you found it, that's your problem. And that's how they look at it.
I am the law. I am the law.
I mean, dude, where does the government get any of the money that they have from? From the people. How do they get it from the people? They use the people, their credit that was given to them by God, the trust that was given to them as beneficiaries by God. So they're neck deep in the trust that God gave to you to use to help you, so that they can just do what they want to do. If the people of a nation, minus the government employees, died tomorrow, the government would be void. It would fall apart because it has nowhere to get its credit from.
I think that's a bit of a delusion to think that they need to have us for the credit system.
That's the thing. Without the people, there is no nation. You're missing the take.
Well, with no people, yeah, of course. But that's
nation
another 10, 30 years away, mate.
Right. But that's what I'm saying. They can't get rid of people. They can't. The books won't.
They can. Not everyone.
The books are still not going to balance that few people, bro. It's not gonna happen.
No? You think the books need balancing?
Bro, the way the UCC works is they use you. They draw off of you. You are
Yeah.
money.
But who set that up? Who the fuck set that up? And what's to say that the fucking people can't just fucking rewrite that shit? Like, come on.
They're working on it now. That's the thing. You get to choose whether or not you want to be deceived. And sure, it sucks that they took over and you have to fight. But if you don't fight, you're going to be screwed. So take your pick. Fight or get screwed.
Just don't participate, mate. That's the only way to fight.
That's
if everyone
not
did that, we'd be sweet.
Not participating is acquiescence. Your acquiescence is noted right this way. We're going to get you your uniform and your badge that you need.
Really? Crazy.
Yes.
I think only those lining up for the V are the ones acquiescing, champ.
That's what I'm saying, though. If you acquiesce, you've literally turned a blind eye to the crimes that you see going on, which makes you just as liable as the ones committing them. It's stupid to acquiesce. I'd rather go down
There's
and
a difference between not partaking and turning a blind eye. There's a big difference there.
Not really, because you don't know the rest of what's going on in the background.
And not stopping people from going and you know, choosing to do this act, this irreversible thing.
Free choice, man. It's not up to me to stop anyone doing anything. Free choice.
Right, but I mean, if you had the power to at least attempt it, is it wrong? Is it wrong to not do it, not attempt it? Like, is that what you're trying to get at, Cuddle?
Basically, if you see something going on that's wrong and you turn a blind eye, you're an accessory. That's just how it works.
Yeah, but if you're telling everyone else about it and to not partake, and it's the only way, but they still partake, then that's just how it is. People have free choice; they can do what they want.
They still didn't learn anything about what they're partaking in. That good for them.
Yeah, because it still gets onto that other boundary of like trying to bend someone else's will, which is also a no-no.
All men are created equal. All. So who's going to tell me what I got to do again? You know, show me somebody.
Because this is the point.
Telling me what
he
to
was
do.
making.
Right, but that's the thing. Show me somebody telling me what to do where it's not slavery. You can't unless there's a contract.
Or guidance, like parents, you know, they might tell you what to do. They can't force you to do it. Whether you listen or not is another story. There's no contract there, though. You know, it's just take it or leave it. The advice is on the table.
Well, that's the thing.
Your kids chained up.
You're a product of a previous contract. Two people coming together to make a baby. Now, I can run my house under communism or Marxism or however I see fit. That's my right. Now, outside of my house, I can't carry that crap out into the public. That's against the law. But inside my house, oh, I am
You're in the government's house now, boy.
What government? Show me your oaths of offices. Check them for your oaths. I need to see check them for your chain of title, and we'll go ahead and slap an injunction on you until you've actually answered the question, so you can't dismiss the case.
Whoever's got the gun, mate. The bigger gun is the GOV.
Oh, bigger guns, blah blah, afraid of death, big pussy words. God bless. Stop being
Afraid
afraid.
of death? No, it's just fact, mate. Whoever's got the bigger gun is going to rule the day. You know it.
They have
Deny it all you
because
fucking like with legal documents. Good luck.
why do they have bigger guns than you? Did you acquiesce at some point to slavery to where they could have bigger guns than you? Ooh.
No, they were just corrupted long ago, mate, and
You
acquired the
did
wealth to
that.
obtain it. That's
Nobody
all.
did. They just magically got bigger guns than you. That doesn't make any sense.
No, I just explained. I just explained how they were corrupt long ago and have acquired the wealth to obtain it. I have not. That's pretty obvious, really.
I have every right to own any gun that I want on the common law side.
Sure. Are you corrupt and have trillions of dollars, or not?
Dude, I'm worth more than trillions.
Nice, excellent. If you can access that, then you should have some, shit. What are they called? Jew weapons floating around in space, ready to laser people. But I've got a feeling you don't. Do you believe our trust is worth trillions to you? Each person's?
Well, the people are supposed to be the bosses of the government, so if you don't know how to tell them what to do, there's really a problem there, too.
Fair enough. We just had elections in Australia, and I can pretty much guarantee that maybe only 25% of people might have fucking voted for not the company, probably a company that actually won today. So, it's corrupt as hell. Who cares what goes down?
Yeah.
We're a fast track to net zero carbon, mate, now. Fuck, now.
There's
Watch
no
the price of everything.
It's a bunch of bull.
Yeah. Climate change, net zero.
They can't
Fuck
show
you
me
now.
one electron or one photon, but they're going to tell me that there's one carbon atom floating around the sky. How about you isolate that and show it to me? Well, we can't. Oh, well, then there isn't any.
This
Just a
goes
cool
to the
story.
power, mate. It might not be a gun, but they control certainly all the information. And people lap it up, but sad to say.
20-year-old cars here, dude. You could tune it, you could straight pipe it, you could whatever, and that puts out a bigger carbon footprint. 20 years. If it was such a big deal, wouldn't they outlaw 20-year-old cars? Yeah, that's what I'm saying. It doesn't make any sense. None of this shit makes any sense because it's all double talk. When my car turns 20 or 25 years old, I can put a bigger motor in it. I can put out more freaking shit. I don't have to have a catalytic converter. I don't have to have any of that crap on my car. Now I'm putting
Not
out
even a
4
seatbelt.
times as much as I was before, and it's perfectly lawful. Perfectly lawful, but we care about the environment, but it's perfectly lawful. That doesn't make any sense. It's too contradictory.
Oh, it's hypocritical in every step of the way. The oil companies were fucking pushing right against renewable energy for ages until they'd all transferred all their investments and assets into renewables, and now they're all pushing it like fuck. In fact, they are the companies that are the green companies. It's fucking just ridiculous.
But the issue I'm trying to show you is you have a company that's doing commercial business that has a restriction on them. They're trying to pass the restriction on to you. They are not a government agency. They don't have the authority. There is no delegation of powers in the fucking Constitution that company can tell me fuck all.
No, well, that's right.
The
That's
police
why they mandate things.
detectives, they're known as peace officers. They don't have any delegation of power to make fucking legal determinations on the road, but they do. But they don't have the delegation of power to do it because Congress didn't have the power to give it to them. The people retain that. So why are the police arresting people and making judicial determinations out on the road when they don't have the authority to do it? That doesn't make any sense.
Well, they've been told they do. We've got rid of all the old ones that know any better, any different, other than the ones that are happy to turn a blind eye, as stated before. and all the new recruits, just follow the line. They don't even think about law.
How do you explain it to a police officer and get him to arrest all his buddies with the citizen's arrest?
First thing you
Well, no,
have
that's
to
never
do,
going to happen. Yeah.
first thing you have to do is fix the mistake that you made, and try and get your friends to fix the mistakes that they made. They're the ones calling themselves commercial property, not me. I'm not
I
commercial
help
property
people
at all.
fix their mistakes about what they put in their mouth. So
I,
that's my input.
I am not a U.S. citizen. However, I do own one, and I know how to use it.
I hope you can cash out on your chattelage one day, mate.
And law kills it for most people because most people just like being, oh, well, it's just too much work. It's too much problem. Everything's fucking work, man. Peeing is work. Pooping is work. Brushing your teeth is work. Like, get over this whole work shit. Everything is work.